Welcome everyone to ViteConf. It's finally here. I'm Sarah and I'm joined by Matias. Hi, Matias.
Hey, how are you doing, everybody? Very happy to be here. Thank you so much, Sarah, for joining here in the second ViteConf ever. And yeah, I wanted to start, I want to show Vite t-shirt.
There we go. Now it's official. Now the conference can start. We've seen the shirt. Can people get that shirt? I think I saw there was a giveaway.
I think we should print more. We don't have the Astro swag that I see people with the bags and the hat. I think that needs to happen.
Gotta keep up. Gotta keep up.
Yeah, we wanted to start thanking everybody that made the conference possible. We are almost 40 speakers in the conference.
Wow.
So yes, thank you so much for all the work that each speaker put for their talk, and they are going to be together with us in the chat discussing with people. So yes, thanks so much. And also for all the communities in the ecosystem that are here discussing with us and also helping us with inviting everyone. And thanks also to the StackBlitz team for making this conference possible, for hosting it for the second time and putting also a ton of work to make it happen, and to all the community partners. So yeah, a big thank you to everyone involved in making this possible.
And before we get started, a big thank you to you, Matias, and the entire team that you worked with. Organizing a conference is a huge event, and I know how much work you and your team have put into this and making everyone feel welcome and the speakers know what's going on. So thank you. And
thanks a lot for the team. Yeah, thanks.
So before we get started, I would like to point out that ViteConf does have a code of conduct, and you can find it at viteconf.org/COC. So when you visit viteconf.org/COC, you can see our code of conduct. We want this to be an amazing, inclusive, fun event for everyone. We want everyone focused on these amazing talks and panels and discoveries, and I think big announcements that you're gonna hear coming up. So please do take a moment to look at our code of conduct. Please act responsibly. And if you're in our Discord, there will be mods available the entire 24 hours of the broadcast. I'll be one of them. I believe Patak will be another one. We will be there. If you see anything, if anything happens, report it to us. We're not expecting too much. I think last year went wonderfully, but we will be there. And we just want everyone to have an amazing time focused on the talks and the discussions and the connections that you as the audience will make with the speakers and other attendees.
Yeah. And last year was amazing. It was collaboration and this is not a competition. So let's try to learn from each other. And yeah, as Sarah said, we are there for you if you need us. In chat.vite.dev is the chat where we are going to be, and that is our conference hallway today. Talks are extremely good, but also having that kind of experience of bumping into each other and in the hallway of a conference is so good. And we're going to try to replicate it this year again. So go there. There is a ViteConf channel. We are all together there. And then there is one space per talk in a forum channel. So that is a more cozy space to discuss with each speaker about what's going to happen. And there is also a forum channel for Q&A that we can have with the Vite team and with everybody else in the community.
So lots of conversation, lots of connections, lots of places to chat. And I think the main place we're going is viteconf.org/live, right?
Yes. If you're not there, go there to see us, because that is going to be the main experience. If you're in YouTube, move to viteconf.org/live, because there we are going to have you're going to first see the chat on the side, and then on top of us there is going to be a button with a hair this is like per talk that you can give some love to the speakers, and you can share also. Please like invite your communities and invite everybody to like join us, so we have like a good group to watch the event together. And in the bottom, you're going to see like the current talk playing, like, and the speakers. And also like a new thing for this conference is like the run code in StackBlitz button that is there. And this is like a speaker gave us the examples repos or like starters they show in their talks. So like while you watch, you can actually like open the code online and play with it, and like if the speaker do something, like you can actually see it working. So yeah, like
that's so exciting.
Yeah, like I'm very excited. Like that is going to be like even more interactive than last year. And there is also a learn more button there. Like for example, like all the links that we have been talking about are there now. And actually, if you press the run code and StackBlitz button right now, you're going to have a Vite starter. So like you can check it out how it's working. And you have also like a Discord button to go to the specific place where the speaker is like with their own talk.
I'm going to need to boot up that second monitor for everything going on during this broadcast.
Yeah. And then like, I don't know, like I think that we should kind of like start this thing because people are really excited. And just some highlights, like there will be like several keynotes, like don't miss Evan Yu with the state of Vite and like what's next, like big announcements there. And also like what's new in StackBlitz. Like there is some really, really cool stuff that they are going to show, and a conversation with Tom Preston-Werner, and like between him and Eric Simmons, like that is great.
And you and I, Matias, people are going to see us again. We'll be on a community panel with Brittany Postma, Anthony Fu, and Tracy Lee, put on by This.Labs. We'll be talking about community, open source, rallying our contributors and communities. It'll be a lot of fun.
Yeah. Really looking forward to it. And yeah. And also, like, for the rest, check the schedule. There are like sections, like framework section, like all the frameworks are represented there, and like, testing and like native. And there is like a lot to see today. So like choose what you like. What is important today is that we are just starting a 24-hour marathon. And the idea is that it's going to be 12 hours of content, and then another 12 hours that is going to repeat the same content. But this will allow wherever you wake up to see all the full thing, because our communities are global. And so like we wanted to give the opportunity to everybody to participate live on this. So one important thing, take care of yourself. Like all the talks are going to be later on available.
So whenever you show up, you can head to viteconf.org/live, and content will be happening. And if you wanted to, you could set yourself up and settle in for 12 hours of content. What about the speakers? Will they be interacting for the entire 24 hours when their talk is up?
Yeah, there were mainly when the talk is up, like maybe like some in one of the half, because like also the speakers are in all the world. So like for some is going to be their talk in one of the half at like 3 a.m. in the morning. But like the idea is that like it's going to look really different from like several parts of the conference. Like there is going to be a lot of people coming in and out, and it's going to be very fun like it was last year. So yeah, let's enjoy together, as Sarah mentioned before. Let's have fun. And we kick off by introducing now Eric Simmons, CEO of StackBlitz, and from then on, Evan Yu and the rest of the conference. So thanks a lot, Sarah, for being here with me again. And thanks a lot, everybody.
Enjoy. Let's start watching.
Hello, everyone. Welcome to ViteConf 2023. I'm really excited to be here with all of you. And it's been a while. The last time that I was here with you all was just about a year ago at the first ever ViteConf in 2022. And boy, has the Vite community and the project and the adoption grown an incredible amount over this past year. Last year at ViteConf, most of the open source projects that were building on top of Vite hadn't even released their 1.0 versions with Vite as the central bundling tool within them. And fast forward to today, SvelteKit and Astro and Nuxt and all these other tools have released their 1.0s and their stable versions where Vite is really powering the core of those frameworks. And as the Vite ecosystem has grown and it's been adopted by some of the world's largest companies, it's being used in code bases and places that wouldn't have been even possible to dream about a year ago. And that means that it's time for Vite to evolve into a new type of tool. It's one that's going to be able to serve companies that are both the largest in the world and some of the smallest, scrappiest startups as well, open source maintainers and everything in between. What that really means is that it's time to lay new infrastructure and new partnerships and new bridges and new collaboration in the ecosystem and within the Vite tool itself. And that's really what this year's ViteConf is all about, is about how we build Vite and the Vite ecosystem to scale into the future. So Vite is not just a tool that's used for a couple of years, but it's something that's going to power web development throughout this entire decade and even into the decades beyond. So I'm really excited to have all of you here and have some of the biggest and best, brightest minds in the community coming and giving talks to talk about how Vite is going to be playing a huge role now and into the future for how we build the web. So with that, without further ado, I want to hand things over to Evan Yu, the original creator of Vite and the core maintainer of Vite.
Hello everyone, welcome back to another ViteConf. Today I'm here to talk about the state of Vite, what's been happening, how things are going, what's going to happen next. Let's dive right into it. First, let's do a quick recap of the releases since last ViteConf. There was a lot of work that went into each release, but here we're going to mostly focus on some of the most notable features. Vite 4 was released in December 2022. Shortly after last ViteConf. The main change that warranted a new major was the upgrade to Rollup 3. The two projects synced the major releases together, so we can also sync the discontinued support for old Node.js versions. Compared to Vite 3, this was a much smaller major release in terms of breaking changes. In fact, our goal was to ship a stable major. We heavily leveraged our ecosystem CI to ensure compatibility with downstream projects so that the changes would affect end users as little as possible. We also adopted the SWC-powered React plugin, originally created by Arnaud Barré, who is now also a team member. For core, in 4.1, it was mostly about syncing Rollup and ES-built versions. The more notable changes were in the React plugins. Plugin React fixed a lot of HMR edge cases, while the SWC-powered version added support for SWC plugins. The highlight for 4.2 was improved source map debugging experience. We collaborated with the Chrome DevTools team and fixed some long-standing annoying path display issues. So now you will see nice relative paths when you're debugging source files in the Chrome DevTools. And we also added the options to exclude files from stack traces via the Google Ignoreless source map extension. When you turn this option on, you can ask Vite to generate source maps that exclude certain files in the stack traces. This option is leveraged by higher-level frameworks like Nuxt and Angular already to make your error stack traces focus only on the parts that you care about. Now, 4.3 is an exciting one. It was a performance-focused release that results in up to 4 times faster cold startup and up to 2 times faster hot module replacement. The main optimization was a rewritten resolve strategy, but the overall improvement was a result of many different optimizations the team carved out piece by piece across the codebase. This was a tremendous effort. We're really proud of this release. In 4.4, we added experimental support for Lightning CSS. Lightning CSS is a fast CSS compilation toolchain written in Rust. It is an opt-in feature for Vite. You'll need to explicitly install Lightning CSS to let it handle Vite's internal CSS transforms, such as import inlining and CSS modules. It can also be used for CSS minification, but do note it's currently mutually exclusive with other CSS preprocessors. On the other hand, we also added solid and quick templates to create Vite. So when you do npm init Vite, you also have the option to scaffold a solid or quick project out of the box. Lastly, 5.0 is currently in beta. Again, this is aimed to be a stable major, where the main change is really about dropping support for Node.js versions that are now end of life. Another thing to mention is that we are deprecating Vite's CommonJS API. Note that the API isn't removed directly, so if you're still using the CommonJS API of Vite, nothing will break, but you will get a little warning that nudges you towards the ESM API. We've also worked with most downstream projects to use the ESM API if they are not already doing so. Again, the main focus of this new major is to make sure it affects end users as little as possible. However, if you like living on the edge, do help us test it out and report issues. Now that we're all caught up, let's take a look at how things are going in terms of growth and adoption. We're closing in on 60,000 stars as I am recording this video, and I believe we should have passed that by now, at this moment you're watching it. The NPM download count is even more impressive. We're now at 7.2 million weekly downloads, a 4x growth over the past year. That is almost 30 million downloads a month. Shout out to all the Vite users out there. Thank you for the support. Now, we're also seeing even more adoption and matured support in the ecosystem. Storybook 7, released in April, now comes with first-class Vite support. Angular 16, released in May, now uses Vite as its dev server. Preact switched its default tooling to Vite in June. And Redwood, which released its v6 in July, is now fully built on top of Vite. Bun, the new JavaScript runtime, has been supporting Vite since 0.7. In fact, if you scaffold a new Vite project today with Bun, it will just work out of the box. VitePress, the static site generator that powers the documentation of Vite itself and also that of Rollup, Vue, and many more, is about to reach 1.0 soon. And I'm very excited to announce that we've been working with the Remix team on exploring a migration to Vite. And it's already gotten pretty far, so expect to see a Vite-powered remix in the near future. It's clear that Vite is becoming a foundational piece of software, with more and more projects building on top of it. The cool part is, all these projects are innovating in different directions. To me, this diversity has always been the beauty of the web. This convergence around Vite is not a sign of uniformity in terms of ideas. On the contrary, Vite's mission is to free developers from the duplicated efforts and complexity at the build tool layer, and serve as a shared foundation that facilitates easier, faster, higher-level innovations in the web ecosystem. I really appreciate Jason's quote here because it is affirmation that we've got something right. The balance between abstracting away enough lower-level complexity while exposing enough flexibility for advanced users and framework tooling authors. To continue to serve this goal well, we've summarized a few guidelines as the project philosophy. A lean and extensible core. Pushing for the modern web. a pragmatic approach to performance, support higher-level frameworks, and foster a collaborative ecosystem. Matias will talk about these in much more details in his talk, but I think the last 2 points here are particularly important. Vite is where it is today because of its collaborative ecosystem, a group of open source projects building on a common foundation, innovating in different directions, and inspiring each other along the way. So, what's next? How can Vite carry out its mission even better? What is still lacking, and what can we improve? I will be the first person to acknowledge that Vite is far from perfect. Here are some pain points based on the feedback we've collected from Vite users. For example, relatively slow production build speed. This is probably the biggest pain point because we are still using Rollup for production build, and the speed compared to purely native bundlers like ESBuild or Bun, the difference is huge. There's also inconsistency between development and production environments. This mostly happens because during development, Vite is using a hybrid strategy where your source code is served using native ES modules, while the dependencies are pre-bundled using ESBuild. Now, in production, we use Rollup to bundle everything. So as you can see, the handling of CommonJS and the handling of the way modules are transformed can sometimes have slight inconsistencies, which are difficult to debug for the end user. Now, there's also the network overhead of unbundled ESM during development. Some users may have projects that have a huge amount of unbundled ES modules that where the network overhead end up impacting the initial page load speed when you're doing development. This is particularly bad when some users have to develop behind a proxy. So the network overhead is somewhat compounded during these scenarios. And then there's the confusing SSR external issues. A lot of users using higher-level meta frameworks have probably run into this and have no idea what this means or how to resolve them. And there's also limited control over chunk splitting. Rollup is already offering a lot of flexibility compared to ESBuild, however, compared to Webpack, which gives a very powerful code splitting option that allows you to fully customize how your chunks are split in production, we still want to see some improvements in this front. And finally, there's the lack of first-party module federation support. In Webpack, this is a first-party feature. In Vite, we also have users who've created plugins for this, but a lack of first-party support makes it quite difficult to make Vite applications leverage this feature confidently. So, these problems are not new. Most of them have been around since the day one of Vite. The challenge here is that most of them have to be solved at the bundler level. If you're familiar with Vite internals, you'd know that we leverage two bundlers, ESBuild and Rollup under the hood. The fact that we have to use two bundlers is because they're great in different ways, but cannot fully replace one another. ESBuild is extremely fast, but it has very limited control for build asset optimization. You really don't have many ways to control how the chunks are split, which is very important if you want to optimize for loading performance to the end user. Its plugin API is also not flexible enough compared to Rollup's, especially when you're trying to chain multiple plugins together to work on the same file type, right? It's worth mentioning that Bun's bundler is largely a port of ESBuild, so most of the things we talked about here about ESBuild also applies to Bun. On the other hand, Rollup is very mature and flexible, but it is still slow compared to native bundlers. There's also the issue of handling of ESM CJS interop. When you have a mixed graph in your project, the handling there can be improved. There are often issues when we're handling weirdly compiled CommonJS dependencies or Fox ESM dependencies. And we've had multiple iterations of the CommonJS plugin in Rollup, but still to today, we still have occasionally find issues that are difficult to tackle. So it would be really nice if we can have a bundler that has native speed, but also the flexibility and maturity of Rollup. Introducing Rowdown, a Rust port of Rollup with slightly larger scope. Rowdown is a new project that we've been working on, and hopefully we'll be able to eventually put into Vite. The focus of Rowdown is performance with a best effort compatibility with Rollup APIs. The goal is to switch to it in Vite with minimal impact on the end user. The current status of Rowdown is an early work in progress. The original Rowdown project was started quite a long time ago and was more or less the predecessor to RSPack, which is ByteDance's Rust port of Webpack. Today, we have the original authors of Rowdown, who are also RSPack core contributors, working on a new version of Rowdown, written from the ground up, but with the knowledge and experience from these previous iterations. We currently have a prototype that is able to bundle plain ES modules, but still have many architectural level decisions that we need to validate. At the moment, the codebase is going through a lot of changes, but we hope to be able to open source it soon as we arrive on something more stable. We will be collaborating with the RSPack team on some shared lower level tools and features. For example, we will both be building on top of OXC, currently the fastest JS pods written in Rust. We will also look at how we can make module federation work across RSPack and Vite. And of course, we'll be collaborating with Lukas, the maintainer of Rollup, to ensure API and behavior consistency between Rollup and Rowdown. Writing a bundler in Rust from the ground up is not a small undertaking, and we are well aware of the effort it requires. That said, we are fully committed to making it happen. It will likely take some time though, and the integration with Vite will have to happen in stages. Here we'll take a look at the plant roadmap and the milestones from short-term to long-term. The first stage will focus on basic bundling. The goal is to be able to replace ESBuild for dependency pre-bundling, where the key challenge is good handling of CommonJS and Fox ESM dependencies. We're currently working on this stage, and hopefully we'll have this ready by the end of the year. The second milestone will be Rollup feature parity. Most importantly, compatibility with Rollup plugin ecosystem. On top of that, we also need to implement tree shaking and advanced chunk splitting control. The goal of this stage is to be able to use Rowdown instead of Rollup for production builds in Vite. This is much more demanding than stage 1, and we expect it to take much longer time at this stage. And the challenge here is to making sure the behavior stays consistent with Rollup so that it will bring as little disruption to the end users as possible. Plugin compatibility will also be tricky, as there will be some trade-offs that we'll have to make between full compatibility and performance optimizations. We'll likely introduce a subset of the plugin interface or introducing new hooks necessary for users to author plugins that are maximally compatible with the performance requirements of the lower level bundler. But rest assured, we'll try our best to make sure all existing plugins today work smoothly. They may de-opt in terms of performance in some places, but our goal is to get most plugins running smoothly out of the box. Now, stage 3 will be a bit far out. This stage will involve built-in transforms for some of the most common needs, for example, TypeScript, JSX, minification, and syntax lowering based on target environment. Again, the TypeScript handling here will only do transpiling. It will not handle the type checking, which you should still use TSC for that. So the scope here is quite similar to ESBuild. The goal is to reach feature parity with ESBuild in this category of features, so we will eventually replace both ESBuild and Rollup with Rowdown inside Vite. For the long run, we're also thinking about how Vite itself can benefit more from native level speed. One possible way to achieve that is for Rowdown to expose the plugin container via a Rust API. Vite will then also introduce its own Rust core, which leverages Rowdown as a dependency. With this structure in place, we'll be able to Rustify more Vite internal plugins and transforms that are in the critical paths for performance. For example, we can We can rustify the resolver. We can rustify the import analysis plugin that is used almost on every single module. We can also rustify the SSR load module transform, which is used for handling the SSR runtime transforms. Now, rustifying SSR load module is important because given that it will be fast enough, it makes performance less of a concern when doing these SSR transforms. And the reason we introduced SSR externals in the first place was to avoid this expensive transform. So if we can make the SSR transform fast enough, then we can just ignore the SSR externals requirement and completely make that whole category of problems disappear. And finally, we can also potentially introduce a full bundled mode for projects that simply have too many unbundled modules or are developing behind a proxy. The full bundle mode will work more similar to how traditional bundlers like Webpack works, but we will likely still leverage native ESM for hot module replacement. This is a bit of far out, but this is something we are indeed considering because we noticed that for some users, unbundled modules is in fact a performance killer during development, especially on page reloads as well. Finally, I want to emphasize that the purpose of Rowdown is not about replacing existing tools or be a better alternative to X. Its purpose is to better address the unique needs that we are facing in Vite, and eventually benefit all the users building on top of Vite. We are standing on the shoulders of giants, and we deeply appreciate all the hard work that went into ES Build and Rollup. So that concludes my talk. I hope you are excited as I am about the future of Vite, and make sure to tune in to all the other amazing talks that are coming up. Thank you.
Hi, I'm Arnaud. I joined the Vite team at the end of last year, and I've since maintained the React plugins, with a focus on improving hot module replacement, or HMR for short. The goal of HMR is to be able to update the page with a new version of the UI code without losing the current state. In this No Framework folder, I've set up a small example to showcase Vite HMR. There are three pieces. First, a global state that will be persisted through updates. The module also contains some utils to create and render DOM nodes. Then the UI code, in a module that doesn't contain any side effect, so it's safe to rerun it. Finally, an entry point that will mount the counter into the DOM. Currently, there is no HMR code, so any edit to the code will trigger a full page reload. Vite HMR API is available through import.meta.hot. It's only available in development, so we need to use an optional chaining for that. The accept method is the base functionality of the API. It will mark the module as being able to handle update of itself. It accepts an optional callback that will be called during updates. The new module is passed as an argument. It can be undefined if the update fails due to a syntax error, for example. If the update succeeds, I can render the new version of the counter. Here I have a syntax error, a typescript error, because this no property access from index signature flag is enabled. To remove the typescript error, I need to use the index syntax to show that the module is not strongly typed. Now, when I edit the UI code, Vite will trigger an HMR update and call this method. The Vite client will call this method that will render the new version of our counter while preserving the state. This example is a bit clunky because this render method restarts from scratch every time, but it helps to get the overall idea of how HMR works. Let's see how HMR works for React. To be able to auto-update components, the React team developed Fast Refresh. It's constituted of two parts, a client that needs to be loaded first, and a Babel plugin that will update the source code to register React component for Fast Refresh. To visualize the code transformation done by plugins, I'm using the awesome Vite plugin inspect from Anthony. I have the UI open here. Let's look at the transformation for the app.tsx. The React plugin runs first. This change here is done by the Babel plugin. It will register React component for Fast Refresh using a global variable that is injected, that is available via the React Refresh client. This code transformation is also available in SWC. And this is why you have two options when creating a new Vite project and choosing React. The default one based on Babel, or the SWC plugin that will use the SWC. My advice is to use the SWC for big projects that don't require any specific Babel plugin. It will lead to faster starts in development. The React plugin also injects this code at the bottom of the file to be able to integrate Fast Refresh with Vite HMR API. So we will come back to it. Then EXBuild is used to transform JS6 and remove types. Finally, Vite looks at the output. It does two things. It rewrites imports to be valid ESM imports and looks for usages of the HMR API. If the module is using the .accept callback, it will be marked as being able to self-update. This information is saved in a module graph that looks like this. In green are file modules that can self-update. When editing this kind of module, like the local counter component, Vite will send an event via WebSocket connection to all connected browsers so that they can request the new version of the module. The new module will then be passed to this callback and passed to the Fast Refresh client that will be able to render the new version of the React components. When editing a file that doesn't contain any HMR capabilities, like the display file here, Vite will look at all importers recursively until it finds a list of modules that can accept the update. Here, it will be these two counter components. In that case, HMR is performed on these two components that will then request the new version of the module via ESM import. We can see it in the logs here. When the propagation reaches the root, like when updating this init monitoring file, for example, Vite will fall back to a full page reload. A full page reload will also happen when the propagation detects a cycle, so it's better to avoid circular imports. This way of doing HMR has a downside. It doesn't work well with barrel export, like this index file re-exporting all the other utils files. Currently, when I update the mass file, both components are updated. But in reality, only the global counter is importing a mass function. So I can update the import here and remove the re-export here. Now, when I edit the mass file, only the global counter is HMR. In a big project, this can lead to a big difference in terms of HMR performances. Let's go back to the accept callback. Here, the React plugin will verify that conditions for fast refresh are met. A limitation of fast refresh is that the module needs to only export React component. This can be a bit problematic when you want to export a function that was before local to your component. In that case, to ensure good HMR, it's better to move the function to another file. In the future, I may find a solution for special cases like a React router or loader function that benefit a lot from collocation. There is one exception that I've added to the Vite integration. When exporting a primitive value, like a string or a number, the plugin will verify that the value hasn't changed and that it's safe to do the update. If the value changed, or if the file is exporting something else than a React component, the module will invalidate itself by using the invalidate function from Vite HMR API. It will send a message via the WebSocket to the dev server to tell the dev server to restart the search for boundaries from there. Here, it will be directly found on the app.tsx file. This will allow to preserve state, which is nice. In similar cases, Next.js currently falls back to a full page reload. A case where it's common to not respect the fast refresh limitation is when using the context API, either by exporting the context object or a custom hook that wraps the use context one. I've personally taken the habit to split my context into two files. The context in one file, that can be a TS file, and the provider, that can become safely HMR. To help catch these kind of issues, I've created an OSLint plugin that is included in the React starter template since Vite 4.3. Finally, let's look at another part of the HMR APIs that you can use to enhance HMR in your Vite project. Here, I have an example of a dynamic configuration that is shared in the app through a substance store. The initial config is written in JSON. Currently, when I update the config, the HMR propagates to both two components. This is fine in this demo, but can lead to slower HMR if a lot of components are using this hook. To change that, I can use the HMR API and use another signature of the accept callback that takes two arguments. In the first argument is the list of dependencies that the module can handle update of. And the callback will be called onUpdate. The update can also fail, so we need to wait for that. And here, if the HMR succeeds, I can update the substance store with the new value of the configuration, which is the default export. Now, if I update the initial config, it will propagate to the useConfig file and be accepted as the dependencies, and this file will be HMR. Then the substance will be able to update React component to keep the UI up to date. That's it for me.
Hey there, let's talk about Vite's philosophy. My name is Matias Capeletto, but you may know me as Patak. I'm a Vite core team member and also part of other projects like Vitest and Elk. I work at StackBlitz, where I get to focus full time on the Vite ecosystem. and I couldn't be more excited to be speaking at the second ViteConf. It is amazing to see so many folks from the ecosystem gathered together to make this conference happen. A big shout out to all the speakers, to the community, to community partners, and to the StackBlitz team. They all have put a ton of work into crafting a great experience for everybody. So I really hope you enjoy it a lot. And talking about StackBlitz, before we start, and given that being friendly to contributors is part of the project's philosophy, I like to do a call to action to check out CodeFlow. In Vite Core, we have been using StackBlitz for our starters and bug reproduction for years, but a few months ago, we also enabled CodeFlow in the repo. So if you send a PR or an issue, you're going to get a message from the CodeFlow app with a review PR or fix this issue button. And if we click it, you're going to get an environment with VS Code online. Here we can check the PR. And this is powered by web containers, so it's running Node locally in your browser. You have PNPM, Git, and also extensions working. So you have the full local experience. And let's check. So if we check the PR, this is modifying some docs. It has built Vite and is now going to wait for changes. So we can create a new terminal and PNPM run docs to see, here is our VitePress docs running web containers. So check it out and tell us how it works for you. Going back, why an open source project should have a philosophy? It allows us to have clear goals and a well-defined scope for the project. It aligns contributors and users when working on new features and fixes. We can also better justify our decisions when discussing priorities and trade-off and the roadmap of the project. These are some of our main principles today. It is not an extensive list. Vite Core is lean and extendable. It aims to be a solid base layer to build frameworks and tools. We encourage ecosystem players to be actively involved in Vite's development. Vite pushes for the modern web, and it has a pragmatic approach to performance. So let's expand on each of them. Vite has a lean extendable core. It aims to support well-established and common patterns to build web apps and frameworks, while at the same time keeping a small API surface. We don't want to end up with hundreds of mangled options in config files. So we need to ensure long-term maintainability and avoid overcomplexity for our users. How do we do it, though? Vite has been able to stay lean thanks to its Rollup-based plugin system. It allows Vite to be framework agnostic and tooling agnostic. It gives maintainers of downstream projects a clean and flexible API to extend Vite Core to fit their needs. Vite's adoption of Rollup plugin API was one of the keys to its success. It allowed the Vite team to keep Vite Core maintainable, avoiding built-in features in favor of user-land solutions where possible. If you have contributed with us in the past, you know that if a feature request can be implemented as a plugin, we have a very good justification to avoid adding it to Vite Core. Vite as a base layer for frameworks and tools. It is possible to use Vite by itself, but it was designed to serve as the engine of higher-level tooling. On top of its plugin system, Vite exposes a powerful JavaScript API. It has server-side rendering primitives built in, and it can be used also to improve the UX of backend frameworks like Rails or Laravel. Vite Core is framework agnostic, but there are polished plugins for all modern frameworks, so tools don't have to replicate all this work. And framework maintainers, like we said before, are able to share even more among them through common plugins. This led to a wide ecosystem of frameworks and tools to choose Vite. Meta frameworks are being built on top of Vite or have it as a default, like Nuxt, Xvelkit, QuickCity, Solid Start, Redwood, Marco Run, Analog.js, and more are coming. Tools like Playwright and Storybook have also adopted it. And new tools have emerged, like Vitest, a Vite native unit test framework. We are going to hear about most of these projects in other talks at ViteConf, so I let their team share them with us. An active ecosystem. We encourage the ecosystem players to get involved and participate in Vite's API design and development. There has been a tons of Chrome framework collaboration, both through building shared plugins and also maintainers helping each other when integrating their projects with Vite. One of the best examples of this collaboration is vite-ecosystem-ci. Dominic led the creation of a tool that allows us to run the CIs of the top projects in the ecosystem against the main branch of Vite, or as you can see in the screenshot, against any PR. So we can assess the state of the ecosystem before releasing a change. This scheme has helped us avoid uncountable regressions, working with maintainers of downstream projects to fix issues before they hit their users. And it has been one of the secrets of why Vite has stayed so solid. Push it for a modern web. Vite is part of a new generation of tools that embrace the future of the web platform. CJS dependencies are of course supported. There are a lot of CJS only packages in NPM. But user code must be authored in ESM. And where possible, we are going to push for an ESM only future. Vite doesn't polyfill no modules in the browser. 2 years ago, this was a big pain point for users migrating from tools like Webpack 4 that included polyfills by default. Several packages were broken back then, but it was the right long-term call. The community and maintainers have fixed most of these packages. Vite also aligns with web standards. As an example, Vite 2 implemented worker support using a worker query suffix. But after 2.9, the standard syntax based on new URL was supported and recommended. Finally, a pragmatic approach to performance. Of course, Vite has focused on performance since its origin. Its biggest selling point at first was its unbundled dev server, which gave users a snappy hot module reload that stayed fast as the project scales. To do it, Vite relied on modern browser features and also on native tools like ESBuild, SWC, and Lighting CSS to implement expensive tasks. But it takes a pragmatic approach in the sense that it uses JS-based tooling where the trade-off makes sense today. For example, it currently chooses Rollup during build due to its flexibility and mature ecosystem. But what is important is that by choosing Vite, you are buying into its API and into the ecosystem. You are embedding on the way it is implemented today. Vite internals will continue evolving and improving while keeping the API stable. Vite Force 3 was a great example of performance improvement that benefited a big number of users and downstream projects without needing code changes on their side. The internal resolve algorithm and other hot paths were optimized without affecting Vite API. A big shout out to Jorn Lu and all others involved in this particular effort. For large projects, we saw dev server cold start improvement of up to 75% and 40% for warm start. And the time for hot module reload also saw up to 50% improvement. And these changes were released without disruption as part of a Vite minor. So Vite Ecosystem-ci also play an important role in making this possible. That's the end of this journey. As a final note, it is important that the philosophy of the project will also keep evolving as the user base, the ecosystem, and the web itself continues to change. And that is all. Thanks so much for listening to the talk. And if you are interested in building tools and in developer experience, join the Vite community and collaborate with us. Thanks to everyone who keeps working on making Vite better. And I wish a great ViteConf to you all. See you.
Hey, I'm Dominic. Let's take a look at Vite Ecosystem-ci, what has happened in the last year. For those of you who don't know, Vite Ecosystem-ci is an extra automation step that runs new Vite builds before they are released through CIs of various Ecosystem-ci projects. This helps us ensure that our releases remain compatible and don't introduce breaking or unexpected changes to frameworks and other packages in the ecosystem that use Vite. To learn more, you can watch my talk from last year and also follow our GitHub repository. Last year, Vite already had a great vibe going on. A lot of repositories, packages, and over 600 contributors building it. But this year, it has exploded. We have 5 times the repositories using Vite and a lot more packages building on top. And what I love the most is that over 200 new contributors have joined. Welcome every single one of you. Thank you from the bottom of my heart. Keep coming. So last year, there were 14 jobs in Ecosystem-ci, already covering a pretty diverse range of projects from meta frameworks like Astro, Svelte with SvelteKit, and Nuxt to utility areas like Vitest or more low-level things like Vite plugin SSR. So with the growth in Vite ecosystem and the way that adding a test is pretty easy, we decided to do just that and add more tests. So today we have Analog.js, Histoire, NX, Preview.js, Quick, Uno CSS, and more Vite plugins. Some of them have been part of the Vite repo before, but we have extracted them into their own repositories, and Ecosystem-ci allows us to still keep the coverage for them the same as before. And maybe even the greatest thing that has happened is that there are now entirely new Ecosystem-CIs. So Vue uses it. Evan talked about it last year in person. Nuxt and Svelte and Vitest and NX and Volar and our SPEC even have added their own versions of Ecosystem-ci. Storybook uses a slightly different approach. They have a great blog post about it. Check it out. Their status page is something worth stealing. So all of these we use to collaborate on them, and we analyze reports coming in from the test runs. We resolve the fails that happen, and by this we guard our ecosystem from botched releases and scrambling to fix things because we learn about them before they happen. This is a continuous effort that happens every week because Ecosystem-CIs run on a schedule to make sure we don't mess anything Let's take a small look at how we handle the analysis of fails, especially during Vite beta. Fails happen a lot. Some of them are expected because we release a breaking change, but many fails, they are not really fails, they are false positives. We still have to look at the log file, but it can turn out that it's a flaky test, or the infrastructure fluked, like GitHub didn't download something, or an end-to-end test didn't connect to the server in time. And of course, projects are live, so scripts may change, and the script that is used in the test of Vite Ecosystem-ci has to be updated to match that. So not every red is really dangerous for the ecosystem itself, but it still requires maintenance from us to check and update scripts. Then there are actual failures that need a small change to be resolved. This ranges from incompatible types that can happen when a project updates their dependency and it no longer matches the version Vite uses, and then subtle type differences can cause TypeScript to fail because the type overlap isn't there anymore. It doesn't necessarily mean that it would fail with the user's project because the user only uses one version of Vite, but the dev dependency and the version that Vite uses are incompatible, and we have to change something to make that work. The other thing that can happen regularly is that a snapshot has been recorded that is very granular, and a subtle change in Vite might result in a subtle change that doesn't really have a change in behavior, but some bits or bytes in the snapshot have changed and the snapshot needs to be updated. And the last one is legit fails that cause a change in behavior that isn't expected, and we have to do something about it. So speaking of doing something about it, how do we fix these reds? So for type changes, we at first introduced re-exporting rollup types through Vite so that packages using Vite can make sure they use the same type version and TypeScript doesn't complain anymore. This is a great way to reduce the amount of times this happens, but still some others can, and for them we ping the maintainers and we try to sync the versions and send PRs sometimes if it's really easy. Other times we wait for the types to be updated in the downstream project. For other legit errors, we have to start a discussion. And this discussion, then we determine what's the best course of action. Do we have to roll back the change in Vite because we did something that was really not expected or planned? Or does the downstream project have to release a new major to remain compatible with the breaking change in the new Vite major version? This is a long process and takes a lot of time, especially when you have to go back and forth. It can take from days to weeks to resolve everything, and after many hours spent on GitHub CI CPU hours and also many hours for maintainers' work, it should all be green again in Ecosystem-ci. And once we have this, we can do releases in a seamless way that we can be sure are great for our users, and we can rest well at night, not fearing a lot of new bug reports in the morning. But it's a lot of effort, and with the growth we've seen in Vite Ecosystem-ci and in Vite in general, we cannot continue to grow at the same pace with the same amount of people doing it. So please support us and keep watching out for your own projects in the Ecosystem-ci's. join our efforts to ensure our users can enjoy the most stable releases and keep the ecosystem growing in a safe way. Thank you so much for watching. Thank you, Patak and Blue, for keeping up with Ecosystem CI. Thank you, every single maintainer and contributor to Vite and all the Ecosystem CIs. It's great. Follow all the links. Thanks from the photos on Unsplash. See you soon. This was Ecosystem CI 1 year later. I'm Dominic. Goodbye.
Hello, I'm Lukas Taegert from Rollup.js, and today I want to talk about how we are reinventing Rollup. Now, this may sound big, but before I get there, I would like to take a look back. So what happened in the last year? What were the new developments for Rollup.js? And for the features I want to present to you, I prepared a series of examples. So at the bottom of the conference window, you should be able to find a tab where you can actually look at the examples and play around to see how the features actually work. Just let me go quickly over some of them. So the first does not have an example, but the code splitting algorithm got much faster for large projects. We had a report from a user that Rollup was taking basically 2 hours for their project to build, and they did some digging and they found out that most of Rollup was okay fast with about 5 minutes, but it took 2 hours for the code splitting algorithm to complete. Now we seriously started tweaking that algorithm, replacing set operations with big integer operations and so on, and we managed basically to get the code splitting time down from those 2 hours to a few seconds. So this may be a big step, and if you have a large project, this should be a huge win. Next, we have tree checking now for dynamic imports. This was an external contribution from Anthony Fu. Very big thanks for him. Basically, it means if you use destructuring patterns when using a dynamic import, either with async await or with a promise syntax, then Rollup will detect this and only include the imports that you actually use. Next, we have the no side effects annotation. So you may know that there is a pure annotation that you can place in front of call expressions. No side effects annotation is an annotation you place in front of a function declaration, which makes it much easier because you may be calling the function 20 times. Now you only need this annotation once in front of the declaration, which is also a nice feature for libraries, as long as the final bundler that is used also supports this annotation. But I think at least ES build is going to support it and maybe others as well. The next feature is experimental, but I still want to talk about this because it basically took months that I worked on this and sparked other features. So at the end of my last ViteConf talk last year, I mentioned that I wanted to do something about reducing the number of chunks based on a chunk size limit. And the problem is this. So for now, the paradigm of code splitting in Rollup has been that we never want to duplicate code. So there is no dead code as far as we can do in the final created bundle. But that means if you want to reduce the number of chunks, you have to load chunks earlier than when you need them. And since Rollup does not wrap your code in function closures, we can only load code earlier if it does not have side effects. So for instance, you could load a function declaration as early as you want because nothing will happen except a variable will be created. But you cannot load like a log statement or something because that will be a side effect that happens earlier. So obviously a lot of work went into this, and I think the result is still not 100% satisfactory, and it heavily relies, as I said, on detecting side effects. But this also motivated two other features. The first is experimental log side effects. So we have logging for side effects to find out what Rollup actually thinks is a side effect, because it may not be what you think is a side effect. For instance, calling a global function may be a side effect, or accessing a property that may not exist, or doing something with a variable that has been reassigned. So what experimental log side effects does is it logs the first side effect it finds in each module to tell you basically what the first effect is, and so that you can gradually remove side effects as you go. And if you don't know how to remove them, there is now also this one, manual pure function, which allows you to basically eliminate side effects from functions, or basically declare functions as pure via configuration just by name. To say basically every function named foo does not have side effects. So this is great if there are side effects in your dependencies where you cannot just edit the code. So these were features for end users. There are also features for plugin authors. And again, I prepared a series of examples for those that you should be able to find at the bottom of the window. The first thing is tree checking for emitted assets. So imagine your code is referencing, I don't know, a worker or a file that is to be loaded from disk, and the code referencing it is not included. Previously, emitting a file meant the file was part of the bundle, but now you can add an additional flag needs code reference. And if this flag is added, then an emitted file is only really added to the bundle if there's at least one import.meta.file URL reference in the code that is not removed, which I think is a useful feature for many different usages. Then next, also about emitting files, there's a new type. So previously you have chunk and asset. Now there's a third type, pre-built chunk. So a pre-built chunk is basically a mix-up between an asset and a chunk. So the limitation of chunks is that you can only emit chunks during the build phase, so the first phase while the module graph is being generated. But some people want to add chunks at a later stage when the output is generated. Pre-built chunk means you're basically emitting an asset where you supply the entire source code, but you're also adding some metadata, saying this has the following exports, for instance, or the following source map, and then Rollup creates a chunk that has the metadata of a proper chunk, but just contains the code that you have. And you can add this at any time, and other build tools will pick this up as a chunk, and you need to reference it as an external import from other files. Just have a look at the example to see how this is meant to work. Another tool helpful for debugging is the new resolved by field. So you can use this resolve to figure out how Rollup would resolve an import. And the new field tells us which plugin actually resolved the import to debug if your resolver is actually kicking in, or maybe some other plugin is catching the resolution for you, which could also mean that the plugin order is wrong, or maybe it's an internal Vite plugin that is messing up your resolution. So this could be really helpful. And lastly, there is a new logging API, which is really big. So you may know that there is this.warn to emit a warning from a plugin. Now you have two other functions, this.info and this.debug. The difference is that debug is hidden by default and info is shown by default. And you have a new log level option to control which levels are shown. But there is more. So info and debug not only accept strings, they also accept complex objects. So you can add any metadata to infos and debug messages, just as you could add any metadata to warnings. And plugins can also define an on log hook to react to logs of any level and augment logs with additional information, replace logs and filter logs, or just, I don't know, write down the logs in some way. So I think this is also a really useful feature. Not sure how much Vite did pick this up. I hope this is kind of merged into the Vite logging API. So, but The thing is, okay, these were a few solid improvements, not as many as I would have hoped to be there in a year. But the thing is, there was 2 major complaints that I didn't address. This is bundling speed and memory consumption. And the problem is Rollup is already pretty optimized with regard to bundling speed, and reducing the memory consumption would also mean thorough refactorings of Rollup. And the thing is, to achieve this, maybe we need a different technology. So this gets me to my second part, replacing the engine while driving, which I said we are reinventing Rollup, maybe not as a whole, but piece by piece. So let's do a profile of the bundling speed. So this is an example build. It's just one single file. It happens to be the browser build of Rollup that I used as input. So it took on my machine about 800 milliseconds to build and 80 milliseconds to render in the end. And from the build time, the biggest chunk was generating the module graph. So what does that mean? Basically, first it's reading the files and it's turning the strings into object structures, which is called an abstract syntax tree, which later steps then can use to derive what imports are there, what function declarations, and so on. So this is done by an external tool, which is called Acorn, and which takes, in my example, 180 milliseconds. And there's another step, analyze syntax tree, where we now then translate these structures into Rollup internal structures and do some analysis, do scope analysis, and so on. And there's another big step is tree shaking. But my goal was to start with the syntax tree, replacing that step as a first step. And then when we have this maybe as native code, we could start growing this and start converting some of the later steps to native code. But as a very first start, maybe we go with just replacing the parser with something that's out there, the speedy web compiler. So SWC is really fast, maybe not as fast as ESBuild, but very close. And the advantage is that it's written in Rust. Rust has very nice community support, great JavaScript bindings. So if I want to write native code, Rust may be a good choice. So what happens? I'm using the JavaScript bindings of SWC core, and just passing the same code. And it took 270 milliseconds, which is compared to 180 milliseconds for Acorn. What happened here? This is slower. Okay, so let's get back. How about using SWC from Rust? And now we see when I'm running SWC from Rust, it takes 51 milliseconds, which is really good. So this is where we want to go. This is 3 times as fast as Acorn. So where did the remainder of the time go? Obviously, it's somewhere in between native code and JavaScript code. It's JSON serialization. So SWC, in the end, is creating a string JSON representation of the syntax tree. Then this is copied over into JavaScript, and then JavaScript objects are created from that string. And this is the costly part. This takes 220 milliseconds. And there were more issues. The syntax tree created by SWC is very non-standard. You can see there is a standard for syntax trees. It's called ES3. It originated from Mozilla and has been maintained for years by a group of volunteers, which involved Babel and ESLint and other tools. But SWC just made their own, which makes it hard to use by Rollup. And also the positions encoded in the syntax tree. So the string positions are UTF-8 positions. But JavaScript, as you may or may not know, actually uses UTF-16. So as soon as you use any special characters, maybe in a comment, an emoji, then positions are completely off. And Rollup heavily relies on positions for its rendering. So, question, can we still use SWC and maybe also fix the conversion time? So we tried something bold. So we did like this. So we still use the parser from Rust, but in Rust, we are now converting the syntax tree to a custom binary format. So each node is encoded in a binary buffer, in a huge buffer. So while we're doing this, we're also fixing the positions, and we're also making it easy to convert the binary one-to-one back to a fully ES3 compatible syntax tree. And what is the advantage of having a buffer? Buffers can be passed between native code and JavaScript code without copying. Basically, we can use the same memory and directly work on the same memory in JavaScript. So this obviously took a lot of time, but it is done, and we can try out and do some profiling. And what we see now, it takes 108 milliseconds. So we're nearly twice as fast, even though we have the additional step of conversion and converting back. So let's have another look. Where do we spend our time? We know that the parsing took 51 milliseconds. The conversion to binary is actually pretty fast, even though it fixes positions and converts the nodes. It takes 8 milliseconds. This is really good news, because this is the step we're gonna need to keep for the future. The other expensive part is converting it to JavaScript objects, but that is okay, because the plan is in the future to basically move more and more of the subsequent steps into Rust, so that we will not be keeping the last step. So we are already faster now, even though we just replaced Acorn with a drop-in replacement, but we can now grow this, and we can expect more and more performance gains as we do that. And there is more. So we have an array buffer now we are creating from the syntax tree. And array buffers cannot only be passed freely from native code to JavaScript, we can also pass them freely between web workers without copying. So now we can start parallelizing everything we have as native code. So first we can parallelize the parsing, but if we move more code into native code, we can parallelize more. This will not be part of Rollup 4 release, because I'm very interested in getting the release out as quickly as possible to gather feedback and experience, but this will be an improvement that we add very early on. Also, the array buffer is much smaller than the JSON representation, about 1/4 of the size, which means we have very efficient caching. And of course, the deserialization is faster, as you already saw. So this is something where also Rollup's watch mode will profit from. So, and this is the start, as I said. Next steps are we can avoid the JSON deserialization. We could start moving some of the analysis to Rust. So currently, scope analysis, as you saw, is quite expensive. So we can do this in Rust and add it to the array buffer, so that basically the parsed syntax tree also contains information, what variables reside in which scopes. We can also offer something to make plugins faster. So we could use a fast syntax tree traversal API, which directly works on the array buffer. And I expect this can be made quite fast, even if it only works in JavaScript. But stay tuned for more. This will take a few months until we get there. Then, as you may know, SWC actually supports directly TypeScript and JSX. This is not enabled right now, because we also need corresponding data structures in Rollup and converters which know what to do with a TypeScript or JSX node. But it's possible to, for instance, have a preserved JSX mode where you're basically keeping the JSX in the output. That's interesting for libraries. Or a convert JSX mode, which converts the JSX to pure JavaScript. Similar options are possible for TypeScript. So let's see where we go here, or if we implement this. And last, of course, we want to move the tree shaking to Rust, but let's see how long this takes. But now we have the option, without any breaking chains, to make Rollup faster and faster. And this is a great thing. So what does it cost us? So the additional code we have at the moment is about 2.5 megabytes, which is much smaller than SWC actually is. And the reason is that we are only including the parser from SWC and nothing else. And we are compiling our own native artifacts. We're not reusing the official artifacts. We're already creating binaries for the most common platforms and architectures, and have a WebAssembly build if your platform may not be supported. Similar, the browser build now also needs a WebAssembly file, which makes it a little more difficult to use. Well, that's the price, basically. But then again, the browser build still uses the same same code base, which is also important for the REPL. And you can try it out now. So install Rollup at beta. This will definitely work. Maybe we have a stable release by ViteConf. Keeping my fingers crossed, but I don't want to make too many promises here. I'll tell you when this is broadcast. So there's one question I want to talk about. What about Rolldown? So Rolldown by itself is a fast JavaScript TypeScript bundler in Rust with Rollup compatible API. So basically it is a rewrite of Rollup. And what do I think about this? The thing is, there is a dilemma for rewrites, where I want to say, unless you have several people working on it full time, the rewrite will just drain resources from Rollup without ever replacing it. Because like Rollup wasn't written in a day, Rollup was written 2015, and there have been thousands and thousands hours of refinement and new features that have been added to Rollup. And you cannot just rewrite this in a few months, especially if you're starting from scratch and not looking at the original sources. So what Rollup is doing, which is a good thing, they're using the tests of Rollup, at least a part of the tests, so not all of them, and working against that. And the thing is, I'm not opposed to this project. I really want to say that. If I see a chance that it will be covering nearly 100% of Rollup with a similar output quality, which means similar code analysis features and tree shaking in reasonable time, I would actually switch to that project and make it the next major Rollup version. Because I think it's a good thing. I just think it's difficult to do this in a timely manner. So this also goes to anyone who wants to finance this project. If you can put a few $100,000 in that direction, let's talk. Okay, so that being said, for the end of my talk, just want to dream a little. So if I wanted to do, or if I could do whatever I want for Rollup, what would I like to do? So just 3 features I quickly want to talk about. The first thing would be statement level code splitting. Just imagine, so at the moment, modules are the smallest code splitting units you have in Rollup. So if your source code is in a single file, unfortunately Rollup can only create a single chunk. And this is sad. I mean, like, if you have 10 function declarations, why do those need to be in the same file? Basically, as they don't have side effects, you could do it a different way. You could say, okay, I'm looking at the top level statements in my file. So, and see what are the dependencies of these statements. So if the statement has a side effect, maybe the side effect needs to come after the previous side effect in one of the lines above. And if it depends on a variable, of course, it needs to come after the variable declaration and all mutations of that variable. So then you can create a dependency tree not between modules, but between top-level statements. And you could feed that into the code splitting algorithm to get a much better chunk graph. So that's just an idea, and it will be a lot of work because it will basically fundamentally change how we do that, and also could be costly performance-wise. Maybe if this comes, it will need to wait until the Rust conversion is gotten a bit bigger. The next would be object property tree shaking. This would be easier to do because we have a lot of analysis. We already know when we can no longer trust a property in an object. And using this analysis, we could also remove unused object properties, which would mean you have a large object like configuration objects, and then you can basically reduce the size of object. I think the impact will not be as big as that of the previous feature, and also not sure about the performance impact, but also something I wanted to do for a long time. But the last one is probably the most important to you, which would be, let's put it like this. People said that Webpack's code splitting is better than Rollups, and that depends on the constraints you take into account. So Rollup's constraint is that you never duplicate code and never ship any dead code, which comes from Rollup originally being a bundler for libraries where I really do not want to duplicate code. But if you're bundling for the web, you have different constraints. It's okay maybe to put a module into different chunks if you reduce the number of chunks. So imagine you're loading an entry point, and all the dependencies for that entry point are together in the same chunk. So you only load a single file, which will be great for search engine optimization, and all dynamic imports then pick small bits and pieces. But to do that, you have to put the same files into different chunks, and then there needs to be some logic that decides, okay, has this file or has this module already been loaded? Then the next loading of that module is just dead code. So that's something to take into account, and probably the thing I would work on first. But that's all I wanted to talk about. Thank you very much for listening. I'm very interested in your feedback, especially if you try out the beta build of Rollup, or maybe the final build if Rollup 4 is out. See you on the conference. Bye. And just mentioning, and my head is in the wrong position. So the examples are also found on GitHub if you want to play around with this.
Hi everyone, my name is Erika. I'm a core maintainer at Astro and on Volar, the second of which being the subject of this talk. I'm super excited, but also quite nervous to be joining this year's ViteConf to talk about a big passion of mine, editor tooling. Or more precisely, how Volar can make it easier to implement editor tooling for your framework. Alright, so what is Volar? Volar is a framework for language tooling. Much like a web framework, it allows you to skip a bunch of boilerplates and parts you kind of don't care about, so you can focus on building features specific to your framework while still having like a good base to work on. It's currently in use by Vue, Astro, MDX, Lynx, and more frameworks are working on adopting it. Before we get more into what makes Volar so great, I would like to do a quick tour of the current status of editor tooling, the current challenges, and why Volar is so interesting in the first place. First, I'm sure everyone is aware, but we have many frameworks, many languages, each of them with different features, each of them with their own syntax. It's a lot. One thing they do have in common, however, is that you use them in a code editor, and so you need editor tooling. Need might seem like a strong word, but really nowadays people will expect editor tooling and all related features to work just like they do no matter what kind of files they open. Speaking of which, there's a lot of features to support. Most users will probably be quite happy with just completions and diagnostic, but really people want everything. They will ask for everything and they will create issues on your repo. Those languages also typically embed other languages, such as HTML templates, CSS tags, or maybe you have JavaScript somewhere else. In all of those blocks, users expect editor tooling to work just as great as it does in the rest of the file. As you can expect, there's a lot of work. It's a lot of work to implement. It's a lot of work to maintain, especially considering that as important as editor tooling is, it's ultimately a bit of a side quest while you're making your framework. Unfortunately, every framework so far individually implemented their own tooling, with little to no code being shared between the different teams. But things are changing. Much like now Vite provides an awesome base to build your framework on, the Vue community came up with the idea of a common framework for editor tooling. And so in January this year, Volar was born. I was, of course, immediately interested in this proposal, and when Johnson, the creator of Volar, came up to me and asked me if I wanted to join the core team, I was very happy to say yes. I immediately started migrating the Astro language server to Volar, And despite the only light documentation back then, it only took about a day or two of work. Not only did this massively reduce the size of the codebase, as you can see behind me, it also fixed a lot of our open issues and somehow even added new features. So what makes Volar so great in a way? The best part for me, honestly, is the sheer amount of boilerplate and overall work that it takes care of for you. I cannot understate it when I say I had a demo of the Astro language server running on Volar with full feature parity in like less than an hour. It was very nice and very easy. Volar abstracts away a lot of technicalities about language servers that really, when you're just trying to make things that work, you kind of don't care about and you don't want to have to care about. For instance, in the Astro language server, it took us many months of work to get TypeScript module resolution to work just like it does inside TypeScript files, and it's not fun to work on. Volar gives you this and many more things just for free. Volar also has first-party integrations for many of the common embedded languages and tools you might have. If you have HTML, CSS, JavaScript, those are like 100% built in, but also if you have JSON, YAML, and many other formats, we have built-in services. Same thing for common tools. Maybe you want emmet completions, maybe you want prettier support or ESLint. We have all of those. All of those are implemented with the same special attention to performance and correctness, so you can expect that for every single one of those formats, it works just as if you've opened a fresh JSON file in your VS Code. Finally, Volar is of course open source, MIT license. We, again, of course, welcome contributions. And I don't know about you, but I truly believe that if we all work on one framework, we'll get much further than if we all make our own framework on our side. Volar is also useful outside the editor. With VolarKit, we can reuse the code that runs in the editor to implement CLI tools. For instance, you might want a linter or formatter. At Astro, we have an AstroCheck common. It's a CLI linter that people can run locally or in CI. It gives type errors and other kinds of errors. Last year, we also announced Volar Labs. It's a VS Code extension for debugging Volar-based language server. It's editor tooling for the editor tooling framework. It has many features. You can see the state of your language server. You can visualize the memory usage, the virtual files, the mapping. It's very useful. It's very nice. So what's the current status of Volar? Honestly, in my mind, it's pretty cool. It's definitely already feature-rich enough. Case in point, we powered the Vue and the Astro language tooling with it. But still, we can always improve. We're currently working toward our 1.0 release. We're also working on a new marketing website and new documentation, and we'll have more to share very soon. In the meantime, if you want to learn more about it, you can click the Learn More button that should be somewhere below the player. It's going to lead you to our website, our repos and stuff, and you can learn more about Volar. And with that, that's all I had to say. Thank you very much, and happy ViteConf. Bye-bye!
Hello, everyone. Welcome to ViteConf 2023. I'm really excited to be here with you. And I don't know about you, but I'm getting really tired of seeing these virtual Zoom backgrounds from working remotely the past couple of years. And so I thought, for today's keynote, wouldn't it be fun if instead of looking at this background, this virtual one, we actually went out and explored some of these backgrounds in real life. So without further ado, welcome to ViteConf, but also welcome to San Francisco. Throughout the keynote today, we're going to be exploring some of our favorite places in the San Francisco Bay Area. And what better place to start with than the Golden Gate Bridge? This is a great example of what great engineering looks like. Something that's built to be durable, solid, nearly a century ago, and will be standing for decades and centuries to come. Built for the purpose to enable millions of people to go places and do things that weren't possible before. And that's just like what Vite and StackBlitz are doing for the web ecosystem and for the web itself. Our vision at StackBlitz that we've been building towards for the past 6 years has been to actually build the first web native development environment. So actually built into your browser, you can use the web to build the web, because this would make development way faster and way simpler. You don't have to clone a repo to get started. You don't have to download anything. It just works instantly in your browser tab. But in order to have a great IDE experience, great development environment for the web, you need great tooling. You need a great SDK for the web. And that's where Vite has come in. And a couple of years ago, when we first discovered Vite, we had a lot of conviction that Vite was going to go to great places. And today, Vite is doing over 6.7 million downloads a week. Just extraordinary amount of growth. You don't see that type of growth. Since becoming the biggest financial backer of Vite in October of 2021, we've been doubling down on our investments in the Vite ecosystem. We brought on Matias, one of the core maintainers of Vite. You may know him as Patak in the ecosystem. And most recently, we also brought in Johnson, who works on Volar, the language tooling for Vue and Astro for the Vite ecosystem as well, to work full-time at StackBlitz. And today I'm excited to share that we are tripling down by adding on some more folks that we're supporting in the ecosystem. To start, Anthony Fu works over at Nuxt and is one of the most prolific folks in the JavaScript ecosystem at large, much less just the Vite ecosystem. And second, we're excited to be sponsoring Vladimir, who's the core maintainer of Vitest, the rapidly growing test framework built on Vite to work with the Vite ecosystem. And we're really excited to be supporting the projects these folks are working on. So there's been a lot of awesome announcements already today at this year's ViteConf, and I've got some good news because we've got a couple more for you. So to start out, at last year's ViteConf, we announced a new product we had called CodeFlow. It allowed you to open instant development environments in your browser tab with your full VS Code running there. And you can open any tool chain. So you don't have to, when a coworker hits you up and says, hey, can you review my pull request? You don't have to stash your changes locally and then install everything. Ugh. You just open a link, do the pull request review, close it. Or you can just start a new project in one click. And I'm excited today to share that as of this quarter, we're going to be pulling CodeFlow out of beta. And I got to tell you, the experience of being able to start a new application or a new pull request or a new PR review in one click has been amazing to see in the community, especially in the Vite community. You know, our CodeFlow application has been adopted by the Vite core team and a whole bunch of the other projects in the ecosystem. And today, we're excited to announce some new integrations that we've been working on for CodeFlow. And in particular, for design system teams. This has been one of the most common places that we see StackBlitz and CodeFlow being adopted to accelerate design system teams' ability to create their components, test them, review bug reports, have an instant one-click environment to try them out. And today, for the first time ever, not only can you have StackBlitz run your live examples for your design system components, but you can actually use StackBlitz to actually build the design system components themselves. So to talk more about this, I'm excited to hand things over to Tomek, one of our founding engineers who's been working on our integrations with the ecosystem, is going to show you everything that we've been working on.
Hey ViteConf. Today I also decided to go outside and code a bit in my garden. It's really cool that we can work from many different places, like co-working spaces, cafes, or sometimes just another room for a change. In StackBlitz, we wanted to implement that principle in the digital world, to be able to jump into code from wherever you are. We move outside our core editors pretty often. For example, I do that when I'm looking at a component in Figma that Devon, our designer, has just updated, and I want to implement it. Ideally, without too much hassle, finding the project, the branch, and the right files. So last year at ViteConf, we've introduced a tool that allows you to put pr.new in front of a GitHub URL to get an instant dev environment. It's pretty awesome and already being used in many places, but this year, we're building on top of that to bring you first-class integrations with the tools we all use. let's see how we can bring design and code together with the core tools for design systems, Figma and Storybook. So for the ViteConf website, we've designed it in Figma. If you want to make a change to the headline of the site to reflect what's in the document, normally you'd have to go to the editor, open the ViteConf project, find the file, and so on. But here, I can instead just go ahead and click on this layer and see this handy StackBlitz link. It opens up in a new tab all ready for me to make the change and submit the PR. And you can do this with any Figma layer. Attach the repository and any relevant file to it to have this one-click environment always available for a developer to jumpstart their work. Another example of this is Storybook. Oftentimes, you want to review the components in an isolated environment to make sure they're consistent. What if you realize you need to make a change to either the component implementation or the story definition file itself? Again, it's a pretty big lift. You have to clone the repository, open the environment, and so on and so on. So what if it's just one click? That's what our Storybook integration does. It opens up your project on that file with that component live in the preview. The only thing you or any other person on your team needs to do is make the changes, submit the PR. And like with Figma example, you can set it up for the whole project, the specific story, or even a variant of that story. So these were just small examples, but you can already see how we've removed friction to develop, maintain, and contribute to design systems. You start in Storybook or in Figma. You just click a dedicated link and you start coding. And you can do it from anywhere. The only thing needed is a browser. We're excited what it means for design systems, but we're not stopping there. We have plans for so many more integrations with the tools we use every day, like Jira, Raycast, or Linear. If you want to learn more, you can find all the relevant links at stackblitz.com/integrations. I hope you'll love these improvements to design system workflows as much as we do. And we're looking forward to hearing what you think. Now, back to you, Eric.
Thanks, Tomek. So we're pretty excited about the ecosystem integrations that we've been working on over here at StackBlitz, and we have a couple more that are going to be coming out soon. But we're also really excited about integrations that the ecosystem has been building with some of the stuff we've been making. In particular, the Web Container API, which allows you to boot an instant operating system with Node.js and NPM on any web page, which really expands the sort of things you can build inside of a web app. For example, the SvelteKit team made an awesome full stack tutorial for their SvelteKit framework. Another great example of this is package size. You type in the name of an NPM package, find out its size, a whole bunch of other things about it. You can convert images online using Sharp, etc. And we're really excited to see this grow. We now have over 500,000 developers a month using applications that have been created with the Web Container API. But when we originally built web containers, we didn't just intend for them to be a way for you to build Node.js and JavaScript applications in the browser. We also envisioned them to be a way to build any type of application with any language or any runtime. And the key technology for enabling us to do this has been the future of WebAssembly. And about a year ago, we joined a group called the Bytecode Alliance, which is a consortium of companies that's got the sole mission of pushing WebAssembly forward and enabling it to do things and run in places that weren't possible before. And when we've been working with this group, we're on an exciting initiative called the WebAssembly System Interface, which gives you low-level system interfaces, which allows new types of languages and runtimes to work in WebAssembly. And today, we're really excited to announce that we're bringing the WebAssembly system interface to Web Container. And this is a pretty big deal because this means you can now use the full desktop-grade VS Code-powered editing environment in StackBlitz to build Python applications or Ruby applications, C++ applications, and more. And I'm excited to hand it over to Dominic, one of our founding engineers, the creator of Web Container and the lead of our Web Container engineering efforts over here at StackBlitz, who's going to show you a whole bunch more, talk about how we've been able to do this.
Thank you, Eric. You know, standing here, I'm reminded that in technology, just as in nature, we climb one peak only to see new summits on the horizon. With web containers, we've already scaled incredible heights, and we've redefined what browsers can do. It's the integration of cutting-edge and breakthrough technology, such as WebAssembly, that pushes boundaries and opens new possibilities. Today, I'm excited to announce the next peak on our journey. It's the integration of WASI, a technology that brings unprecedented new capabilities to web containers and the web development landscape. So what exactly is WASI? WASI stands for WebAssembly System Interface. It's like a bridge that allows WebAssembly modules to interact safely with the operating system, extending their capabilities and giving them file system access or allowing them to perform network operations and more, all while maintaining WebAssembly's sandboxed and secure environment. This allows developers to build applications in any language, C, C++, Rust, or Go, and compile to WebAssembly without having to tailor it specifically for the web or other environments. Now, why is this significant? WASI brings us 3 key benefits. First, it is fast and secure, embodying the essence of WebAssembly. Second, it's incredibly portable, meaning it will run the same way across different environments. Third, and most thrilling of all, it allows for a wide range of toolchains to run on StackBlitz.com, as well as provide multi-language support and much more. There are many toolchains and ecosystems that have recognized the power of WebAssembly and WASI. A prime example is WordPress. Not only has WordPress the majority of the market share among other CMS, with a whopping 64%, but it also powers an astonishing 43% of all websites on the internet. You can run the entire WordPress stack inside web containers. This unlocks full WordPress plugin development, all within your browser. We're excited to work more with the WordPress team and other ecosystems as we continue to push the boundaries of what's possible. In addition, we're extremely thrilled to give you a sneak peek into the potential of web containers. As a demonstration of what's possible, we're launching experimental support for Python within web containers. This is especially significant when you consider that Python, the third most frequently used programming language, has traditionally been absent from the browser's native environment. As WASI continues to evolve and expand its feature set, it will directly influence the capabilities of Python within web containers. But what if I told you that this is just scratching the surface? WASI follows the motto of compile once, run everywhere. You can take your code written in a native language, such as Rust or C++, compile it to a WASI-compatible WebAssembly module, and it's ready to run in any environment that supports WASI, including web containers. Even more amazing, you can simply drag and drop your compiled WASI code directly into StackBlitz and run it from the terminal. It's that easy. This is not just multi-language support. This is a whole new paradigm for web development, and it allows to run a large spectrum of native applications on and off the web without dealing with multiple different architectures. It's a single compilation target for different platforms. You can try this today. Head over to StackBlitz.com, click on the newly introduced Native Languages tab that's still in alpha, and start your Python project right away. In addition, we're shipping support for JQ, a well-known native command line JSON processor that you can use from the terminal in any project. So what's next? As these ecosystems and communities embrace WebAssembly and WASI, we plan to add support for more native languages such as Ruby, PHP, or even C++, and we're incredibly excited to collaborate with different communities and projects to push the web to new heights. Now back to Eric.
Thanks, Dom. We're really excited about bringing WASI into Web Container and just unlocking a whole new world of applications that you can build inside of StackBlitz. And we're not stopping there. The advent of Web GPU on the web has been prescient with the explosion of LLMs and AI. And we're excited to begin bringing Web GPU and AI into StackBlitz as well in new ways that weren't possible before. So stay tuned. And our final announcement today is all this amazing stuff that you can do with StackBlitz now that supercharges your dev workflows. One of the most common requests we've heard from developers is, how can I use this at my company or with my team? Today, we have some brand new plans for you all that allow you to bring this to your startup, your open source project, or even the largest companies in the world. And there's two different plans we have available for this. One is our new team plan on StackBlitz.com. So if you have a GitHub organization, you can open up repos, instantly have one-click pull request reviews and create pull requests, have a shared workspace to share templates and different starting off points. If you're behind a firewall or working at one of the most security conscious companies in the world, we have a new product called Enterprise Server, which allows you to install a version of StackBlitz behind your own firewall, in your own VPC, or even on-prem air-gapped. All the benefits of StackBlitz and can integrate with Bitbucket, GitLab, GitHub, and any Git provider for that matter. So we're really excited for the first time to bring StackBlitz to the largest companies and startups around the world. And you can get started today over at stackblitz.com/pricing. We do have one more thing. We really appreciate the tens of millions of you that have tested out this technology and battle hardened it over the past half decade as we've built this with our partner companies. And for those of you that want to bring this to your team, we've made a special t-shirt that you'll get when you sign up for StackBlitz Teams or Enterprise Server. And it's a pretty cool looking t-shirt. We made it just for you all. And all you have to do is, if you go ahead and sign up over at stackblitz.com, you'll get an email from us and give us your shipping information. We'll send it over to you. With that, I want to thank you for joining us on our journey here during the keynote today. And I hope you're as excited as our team is about the things we've shipped and announced. And we cannot wait to see the incredible web applications you're going to build with StackBlitz and Vite using these new tools and capabilities. So I hope you enjoy the rest of the talks here today at ViteConf, and we will see you on the trail ahead as we build a web ecosystem that is beyond fast. Thanks for coming.
Hey all, my name is Emil Sjölander and I'm an engineering manager here at Figma. Hope you're having a great ViteConf. Today, I'm going to be talking about bringing developers into the design process. For those of you who don't know, Figma is a design platform for teams who build products together. It starts in FigJam, our online whiteboarding tool, where teams discover what to build, collaborate on ideas, brainstorming, and so forth. Then that moves into Figma Design, where designers and, as we'll talk about today, entire teams collaborate on getting to the details of what exactly to build. And this is done through pixel-perfect mockups, as well as really interactive prototypes and building design systems. And lastly, we have Dev Mode, which is going to be a big focus of this talk. Dev Mode is an entirely new space within Figma Design for developers to take those designs from design to production. At Figma, we believe developers are crucial to the design process. Developers aren't just there to implement designs once they have that final rubber stamp seal of approval. Developers are there to give feedback early on in the process, whether that's simply user feedback, like this design is confusing and could we try this alternative, to things like this option will be much quicker to implement and that way we can provide this value to users more quickly and ship faster, to just being a partner to designers in terms of being able to prototype out various design proposals quickly to get a sense for what to go with. We believe Figma has the opportunity to bridge the gap between designers and developers. We're building the tools that change the way we work, specifically with this in mind, bringing developers really much closer to the beginning stages of the design process. There's a couple of problems I want to cover today with design tools, as well as I'll cover kind of what we're doing at Figma to improve these aspects. The first problem we see is that design software is just not built for developers. And this shouldn't be too surprising. It is design software after all, and if you got to pick one user to kind of build the software for, first of all, it's going to be the designer. But as design software grows and gets adoption among designers, many more people come into that space. And that's a good thing. We want to include many more people in the design process than just the designer, everything from developers to marketing, legal, etc. This allows us to ship products quickly without delays and offer the best user experience for our customers in the end. Now, the problem is that design software typically just hides developer tools behind complex menus or puts them in overflow menus and so forth because they don't see developers as the core audience. Second problem is that designs don't easily translate to code. And I'm not talking about one-click, code's ready, you don't need to do any manual coding. I'm not talking about that. That works for some things, but I'm talking more generally around design and code, just thinking about things in different ways and having kind of a different perspective on the data model, where designers are thinking about vectors and groups and shapes. Developers are thinking about components, properties, accessibility, and more kind of structured data model. Now, this can be hard to translate between the two, and we don't think it needs to be. And the third problem we see a lot is miscommunication, leading to mistakes and needing to go back and forth. So it's pretty common from what we've seen for designs to kind of be ready and then be shipped to developers, only to notice a problem due to lack of communication or miscommunication at the very end of the process. And then this all unravels and needs to go back to the design process because the developer wasn't in that process and communicating with the designers early on. This leads to worse products being shipped, or at the very least, products being shipped at a very delayed timeline. Here at Figma, we believe nothing great is made alone, and that includes design. So really, what we want to focus on is how we can bring developers into the design process much earlier on. Not just so developers can have a larger say, we think that's great as well, but really so that the end product that you deliver to customers can be better because there's more opinions and there's just more knowledge kind of built into that design. So how are we solving this? Well, first of all, we want to really make sure that Figma understands developer workflows and to do away with this notion of design software not being built for developers. This is something Figma's thought about for a really long time. Really, ever since Figma was launched, it was built on this concept that it's an online web-based design tool, because that way you can easily just send a link to a developer for quick feedback and collaboration, instead of having to send gigabyte large files and have the developer buy and download big pieces of software. But today, or earlier this year, we took a step further and launched Dev Mode. Dev Mode is a new space in Figma design for developers and designers to work more efficiently with each other, and for developers to more easily take designs from the design tool into production. As part of this kind of introduction of a new space, we were able to do some really great things, specifically around optimizing workflows, navigation, and features for the developer. So before Dev Mode, we really had one space for everybody. And that meant we always needed to make a trade-off between should we do what's best for the designer or what's best for the developer or for other folks. Now we don't need to do that trade-off anymore. We can do what's best for the designer in Figma Design. In Dev Mode, we can do what's best for the developer. So using kind of this new power of Dev Mode, we've really rethought navigation from the ground up and rebuilt everything from selection heuristics to how you pan and navigate the canvas and all of that. So now with Dev Mode, you can just find what you're looking for a lot faster and select layers with greater precision for implementation. We've also introduced specialized tools into Dev Mode that don't necessarily make sense for designers, and these are front and center in Dev Mode. For example, we have the component playground, which allows you as a developer to really understand the intent behind design system components by exploring their different states, variants, props, and so forth, rather than just looking at a picture of one specific kind of state of a component. You can really explore all the combinations it supports. And this allows you to build a better implementation, knowing the full scope of the component. And we also have tools for you to quickly adjust Dev Mode to show rems instead of pixels. And this is a setting you can easily toggle on any file, giving you the power to develop the way you want to develop. And this will be a common thread throughout Dev Mode, where we want it to be a customizable surface and customized to how you develop, and not just how one generic kind of developer develops, because we don't think that exists. On that note, we also have a ton of integrations built on our plugin platform. So for those who don't know, Figma has a really big plugin community and platform where you can build plugins private to your organization, but you can also build public plugins and publish them to the Figma community where others can find and install them. Here you can already install plugins for things like GitHub, Linear, Storybook, and really like many more tools. And they will integrate directly into Figma's Dev Mode to give you a really unified and integrated workflow. One way I really like using this is for Jira, because my team can go into a new design file for a new project we're doing. Instead of having the project management tool on like one screen, Figma on another, and copy paste between all of them and make sure everything is in sync, we can simply click on the things that need to be implemented in Figma and create issues directly from within Figma's Dev Mode. So we can all be on the same page about what needs to be done and what's already been completed. The next problem is that designs don't easily translate to code. We want to shift this to Figma helping you write code. Again, this doesn't necessarily mean one click, you get all the code, you commit it, and that's it. We still believe that there's a lot of value in you writing code. That said, we all know there's a ton of tedious code to be written, styling specific gradients or just like doing the initial structure or like div structure for a complex layout. These are things that are not necessarily hard, but they're just tedious to do. And we think Figma can really help here. But Figma can also help by aligning the data model and the way of thinking between designers and engineers. And that's the first thing I'm going to talk about. Recently, Figma introduced variables and code syntax. In code, as developers, we typically don't say like background equals a specific hex color or padding equals 2 pixels. We say padding equals small padding or background equals secondary color. We use variables so that we're consistent and that we don't repeat ourselves or have hard-coded values. With variables in Figma, designers can now do the exact same thing. So that means that designers and developers share this mental model of reusable values. And these show up in the design and can be easily extracted in dev mode. And with variables, we've also introduced the ability for you to define code syntax for these variables in Figma. So if a variable in Figma is called brand color, you can say that, well, in code, we reference that as color.brand.primary or something like that. And you can define these on a per variable basis. So this is really great for keeping in sync between design and engineering. Next is CodeGen plugins. So CodeGen is what we call, well, code generation or the code snippets that we have in Figma. By default, Figma ships with code generation for CSS, Swift UI on iOS, and Compose on Android. And these built-in code generation is really powerful, and I personally find it really useful when dealing with things like box shadows or gradients, especially because the CSS syntax there can be quite complicated and I would need to Google the exact syntax. Now I can grab it from Figma and I know it's correct and represents the design. However, for more complex things, the out-of-the-box experience in Figma is not necessarily what I'm looking for because it's not representing the frameworks, design systems, and components that I need to use day-to-day when programming. So here, CodeGen plugins are great because they allow you to configure dev mode to generate different code. And again, you can grab a ton of these from the Figma community to tailor the code generation of Figma to suit your needs, whether that's Next.js, Tailwind, Vue, or a bunch of iOS and Android frameworks as well. There's a ton of these out there, and you can configure them to produce the kind of code you want to use. In this image, we have Anima here that supports like HTML, CSS, React, Tailwind, and a ton more. And it's really great as a starting point. Again, these tools aren't necessarily meant to be just copy paste and you're done. They're there to remove a lot of the tedious kind of just like boilerplate that needs to be written. So for this, you can easily get started and then focus on the things that make your app unique and the optimizations you need to add after the fact. But this is a great starting point, and with plugins, you can really customize it to suit your needs. And again, here we also support private plugins. So organizations with their own design systems can easily write a CodeGen plugin so the code that's being suggested in dev mode matches the actual code you should be writing. So this is also a great way to enforce good practice and design system usage within your organization. And lastly, I want to talk about Figma for VS Code. So Figma for VS Code brings everything I've talked about into your editor as a kind of mini version of Figma running directly inside of VS Code. This is great for quickly kind of getting a reference to a value you're missing, double checking a design, responding or viewing a comment from your designer without kind of leaving the flow of VS Code. Additionally, with code generation, Figma for VS Code can autocomplete better code. So by default in Figma, or in VS Code, I mean, you're typing code and you get autocomplete suggestions. And those are fine, those are great, handy. But with Figma for VS Code, we inject the design context into those autocomplete suggestions. So if you're writing background : in CSS, we'll actually suggest background colors that we know exist in the design you're currently looking at within Figma. Lastly, I want to talk about the third problem I mentioned, which is miscommunication leading to mistakes. And here, we don't think we can solve all miscommunication, right? A tool can't do that. You still need to communicate well. But what Figma can do is add tools to assist that communication and help you be informed. The first such tool is Ready for Dev. Ready for Dev gives designers a simple tool to clearly communicate the status of a specific part of the design to the entire team all at once, making sure everybody's on the same page about what needs to be implemented. This is great, and especially in large files that can contain like hundreds of mockups and different variations. It's great for the whole team to know which part of this is actually ready to be implemented. And when something is ready for implemented, we all know it's not like final. Things get updated all the time, and it can sometimes be hard to know what's been updated. So a designer might come back to you after a week or two and say, I tweaked some stuff on the login page. And that's great. But now it's your job to figure out what tweaked some stuff actually means. Sometimes they might send you a changelog, but it typically doesn't encompass every single value because designers are just like human, right? They don't remember every single little tiny change they did. So with compare changes, this gives you a git diff style UI where you can get a full list of all the changes, regardless of how small they are. So if a light gray color became a different light gray, that can be really hard to see. But compare changes gives you that kind of checklist of all the changes. You can make sure to implement those when they happen, as opposed to getting a ticket assigned to you like 2 days before launch, and now you need to stress about that and implement that last minute. Again, leading to even more bugs. So we think this is great to make sure everybody's on the same page. So to recap, there's many problems facing developers when working with designs. Design software isn't built for devs, designs don't easily translate to code, and miscommunication leads to mistakes. With Dev Mode, Figma brings a developer focus to design tooling, with things like Ready for Dev to aid communication, Component Playground to bring really developer-centric tools into the mix, Code Gen plugins to really customize the experience to your needs and help you write less boilerplate, and Figma for VS Code to really bring design into the developer land instead of forcing developers to kind of go into the design land. You can try Dev Mode today. It's just flick the switch in the top right inside of Figma and let us know what you think. We're really open to feedback here. We're still in beta, so we're listening to customers every day, and I'd love to hear from you. And remember that nothing great is made alone. Thank you and have a great ViteConf.
Hi, I hope you're enjoying your ViteConf experience so far. Now I will talk about Storybook and Vite and how the two things keeps getting better and better together. My name is Jeppe. I am a software engineer at Chromatic, and I am a core maintainer of Storybook. I spend my full day working on Storybook and making it better for users out there. Vite keeps evolving Storybook, and in this talk I will tell you about how we are pushing performance even further, how we are improving the integrations with the Vite-based frameworks, and I'll also be introducing some new tools that allows you to do some Vite-based testing, which I am sure you're going to love. I should probably first start by introducing what Storybook is for those of you that don't know. Storybook is a front-end tool to build UI components faster and simpler in isolation. It allows you to build up a catalog of all your components and all of their use cases and states and props and how they fit together. Storybook works with the major view layers out there, such as React and Vue and Svelte and Angular and such. And it is the most popular tool for building components out there. We have a vast ecosystem with over 500 add-ons that makes it even easier for you to develop your components. In Storybook, use cases are called stories. You write out your stories in code as a way to express how this component is supposed to be used. In this example, we have a button component that can either be primary or secondary. It can have different sizes and it can have a label. The primary story here is a collection of arcs, or you might know them as props. It's basically the primary prop being set to true and it having a specific label. That combined will give you the primary button. You can keep changing up your arcs, either in code or you could do it dynamically in Storybook to see how it behaves when you pass in different props to your component. This is just a very simple example, and you can do so much more than this in Storybook. Storybook lives alongside your application. It imports the same components as your application does, but it doesn't live in your application. So it doesn't have any effect on your production bundle, and your user can't use it at all. It's only for your developers and your team to use to develop your components. But Storybook is more than a workbench. Storybook allows you to both develop, test, and document your stories. So you can write tests directly in Storybook and see how your button behaves when it's been interacted with. And you can document how it is supposed to be used by anyone who is importing it. It's a really powerful combination of everything you need to build out your components. Storybook is used by production in many teams all over the world as a preferred tool for building components. Both big and small are using it to build anything from design systems to full pages in Storybook. Just so we're all on the same page here, my good friend Ian gave a talk about Storybook at last year's ViteConf. That's the talk where we introduced first-class Vite support. We announced that we've now removed Webpack for all the Vite users out there, and it dramatically improved performance. We also announced first-class support of PNPM, which we know is a big force in the Vite ecosystem. And a great thank you to Ian for giving that talk that really sparked the energy around Storybook and Vite. Then in the spring, we released Storybook 7. And since then, the Vite usage has gone up to 40% of all Storybooks. That means that today, 40% of all Storybooks that are being created are actually Vite-based Storybooks. It's a huge accomplishment by the community, and it really shows how fast the Vite community is growing and how mature it already is. So I think this is wild numbers given the relatively small amount of time it's been in place. We can make Storybook and Vite go really fast, and I'll now show you how we are making it go even faster in the upcoming Storybook 8 release. I should probably tell you about the benchmarks that we are talking about here. We call it time to story rendered. It's the time it takes for you to start the development server all the way to we see the story being rendered in the browser. So it's a full thing. And it's not just a subset of how fast is the dev server to start up, because that doesn't really matter to users. What matters is how fast can I see my stories. This is not how fast you can change between stories, because that's obviously faster. This is from the first story being rendered. In the Storybook 8 pre-release right now, we're seeing an 8% performance increase over Storybook 7 in a minimal React example that uses React and Vite, but only has 6 stories. 8% is okay, but it's not wow. We're seeing way better results if we take this further to a more mid-sized application like the Meal Drop application, which is more regular and has way more stories, including pages. In Meal Drop, we're seeing a 55% improvement of time to story rendered just by upgrading to Storybook 8. We think this is pretty fantastic, that users don't have to do anything to get that. But this is not just for React applications. We're seeing the same improvements happening in Vue and Svelte with 42% improvement of performance. And I think those are really great numbers, and it really makes the experience better when using Storybook with these frameworks. I can't wait to get Storybook 8 into your hands and let you try it out. But we have more. We have something we called Storybook Lite. Storybook Lite is a set of changes we're making that allows you to choose the features of Storybook that you need without getting the full package. I previously talked about how Storybook allows you to develop, test, and document your components. But we realized that not all users need all of those components. So with Storybook Lite, you're allowed to take out some of the features you don't need. And we're starting with allowing you to replace the MDX docs with some lighter and more leaner Markdown docs instead. It's a more limited use case, but if you only need that limited use case, you can use that instead and get a leaner and more performant experience. If we take Storybook Lite into our previous benchmarks, we're seeing an even greater performance improvement than before. We're seeing up to 60% performance increase just by going from Storybook 7 to Storybook 8 without docs. So that's really a great improvement. Enough about performance. Let's talk about the Vite ecosystem. We have been working hard on improving our integrations with the Vite-based frameworks out there. At the beginning of the year, we started with building out the SvelteKit integration, and we now have first-class support for SvelteKit in Storybook. We built the integration in close collaboration with Svelte maintainers, especially Ben McCann, who's been a really great help on the Svelte side on this. The Storybook integration supports pages and data loading and layouts and most of the things that you will use in SvelteKit. I even went as far as to do a live stream on the Svelte Society YouTube demonstrating how you can have your pages and your layouts in Storybook if you need to. I suggest that you check out the learn more links below to see that recording. Very soon, we're getting even deeper integrations with some of the Kit-specific APIs, and you should stay put if you're using SvelteKit because it's going to be even better. But we haven't been the only ones hard at work. The community has also been super helpful here. A great guy in the community built the Solid.js integration. He even contributed to the core Storybook experience to make it even better for granular reactivity that Solid needs to support reactive prompts. He also rewrote all the snippets in the documentation to be Solid.js snippets, so we now have full documentation for Solid, which is just fantastic. I suggest that you check out the Solid.js repository in the Learn More and in the StackBlitz links below. We also saw a great community member, Literal Pie, doing a quick integration, all based on Vite. Not only does it allow you to use your quick components in Storybook, but it also has helpers to integrate with Quick City if you need those specific APIs in your Storybook. You should really check out the examples and the documentation below. Let's get on to it. We're announcing testing stories with Vitest in Storybook 8. This has been a very highly requested feature by the Vite community. that don't want to use Jest for testing, but rather retest. And we're happy to announce that we are starting to support that in the upcoming Storybook release. To do this, we have to do it in 2 steps. And the first step is to look at our expect package that we call Storybook Jest. We're replacing that with Storybook Tests. Storybook Tests is the package that you will import from when you need to import any matches in your Storybook tests. It is compatible with VTest and with Jest. And it even uses some of the VTest packages under the hood. So we know that it is performant and it's optimized because the VTest team has just been doing fantastic work since forever. That was step 1. Step 2 is something that we call portable stories. Portable stories allows you to reuse your components set up in the stories and reuse those in your unit test that you're doing with VTest. So you can import the stories, you can render the stories, and then you can do any assertions that you need in VTest. This means that you don't need to redefine your components twice, first in your stories and then redefine how you will render them in your unit test, because you can just import your stories directly and assert on those. Portable stories today already works for React and Vue 3, and in the future we're expanding that support to most of the other major frameworks out there. We're also bringing VTest documentation to our official docs, so it's easier for you to get started with VTest. We think this is pretty awesome, and you should just really try it out. Here's an example of how this works. So up top, we have our stories file, and at the bottom, we have our VTest tests running. The story is exporting a primary story that has a combination of args and the template. We can import that in our VTests directly by importing all the stories, and then we import what we call compose stories from the Storybook library. We then run the stories through the compose stories function to create the components that VTests needs to render. And then we can simply render the story in VTest, and as you are used to with VTest, you can do the assertions and the interactions directly with the testing library that you want to use. You should really just try this out when it gets there, because it's a pretty great workflow. There's one more thing though, and something we're calling the Visual Tests add-on. This is a sneak peek into something that's coming up. It allows you to test your stories in Storybook, but with real browsers. And the tests are pixel perfect, so you get to see if anything has changed pixel by pixel, and you can either accept or reject these changes, because they might not have been on purpose that you changed the color from red to blue. The test runs in the cloud, and we support Chrome, Edge, Safari, and Firefox. So the major browsers that you need to support. You can use all of the functionality in Storybook that you're already using, like specifying different viewports or CSS media queries or backgrounds or whatever you need. You can have those in your test as well. It's in the cloud, so it means it's parallelized, and it doesn't require much work from your computer, because we're actually doing the screenshot and the diffing on our end and sending the result back to you. If you go into a bit more detail, what we're seeing here is a story, as usual, being rendered, and we have run the tests for it, and the tests have come back saying the story has changed. These green pixels are what was not there before. What did you change? You can see how the tests are different from browser to browser, or even from viewport to viewport. And this is a really great way to ensure that not only are you writing great components, but you're not breaking them over time as well. We have the very popular testing trophy, which describes how you can have static tests, unit tests, integration tests, and end-to-end tests. One thing missing from that trophy is how you figure out if the UI is rendered correctly, because your VTest won't tell you about pixels. Your playwright definitely won't. But if you run the actual components in a browser, do a pixel diff, get it back, you will see how the UI has changed. And those are important aspects as well of your components. Check out the blog post about Visual Tests add-on that goes into way more detail than I just did. That's also where you can sign up for early access today. To recap, Storybook 8, pretty fast with Vite. We're improving our integrations with the Vite-based frameworks, and we're introducing a way for you to test your stories directly in VTest. We're also introducing the Visual Tests add-on that allows you to see a pixel-perfect diff of all your components' changes in all of the major browsers. If you liked what I showed today, you can get started with Storybook by running npx storybook init, and you can visit the URLs on top. Especially, I suggest that you go to our Discord and join our community because we really love just talking with all our users. Bye.
Hello everyone, my name is Divyansh and I am a member of the Vue.js core team. Today I am here to discuss a common challenge faced by component library authors when using a documentation tool like VitePress. So without further ado, let's dive right in. So what's VitePress? For those unfamiliar, VitePress is a static site generator that harnesses the power of Vite and Vue to quickly generate lightning-fast websites. It's being used to build the docs of several prominent projects of the Vite ecosystem, including Vue, Rollup, StackBlitz, and Vite itself. So coming to our topic, as we can see here, there are already a bunch of popular libraries that use VitePress for documentation and showcasing their components. But a problem that all of their authors have faced is isolation. Ensuring the separation of various elements like styles and execution context becomes a bit challenging when dealing with component demos. There are already dedicated solutions like a Storybook or a Store for this, and one can also embed interactive playgrounds from StackBlitz or similar sites. But what if we want to keep everything within our VitePress site itself? This is where things get interesting. Today we will be exploring Wireframe as a possible solution. Wireframe enables us to seamlessly integrate and render components within an iframe, providing the right level of isolation we need for our use case. So let's dive deep into the code and see how to integrate it with VitePress. Say we already have a component library having a directory structure like this, and let's go one by one over the files, starting with the VitePress theme entry point. Here we have just extended the default theme and registered our story component globally. Our story component has some VitePress specific markup with an iframe inside that. On that iframe we have a datafy attribute to tell Wireframe to process it, and there is a default slot where we will put our demo component. Also there are a few styles. Coming to the VitePress config, we have included a Wireframe plugins and configured them to check for any story components and iframes used in Vue or Markdown files. There are these rewrites too. The first one will allow us to keep the Markdown files alongside the components, and the second one simply maps files from docs to root. In our story component, we had used _frame as the source, so we need to create a corresponding Markdown file. Here we have set layout false and front matter so that this page does not inherit the default theme layout. Rest is the code to create a Wireframe app in a div element. So this will be like a Wireframe Vue app running inside a VitePress Vue app. Next, we need to insert the styles. The default themes styles are mostly scopes, so other than the base styles, nothing should leak into the iframe. But your component library might have some global styles of its own, which can leak into the default theme if imported directly. So what we are doing here is importing them as a string and injecting them into the iframe side at runtime. We are also adding VP-raw class to root to prevent VitePress from intercepting any event inside the iframe. To prevent the default theme's base style from leaking, we can add this post-CSS isolate styles plugin. The config might look like this if you are building your component library on top of Tailwind CSS. So there are a few things to note here. These are needed if you are building a custom theme using your own components, as having shared styles won't be a concern then. Maybe even Wireframe 2 might not be needed. But if you don't want to build your own theme and think that the default theme or maybe its customized version is good enough, then you will need to isolate styles one way or the other. It's showtime now. Let's create a markdown file alongside alert demo and use it like this. Triple angle brackets are just syntax for importing code snippets, and here is the result. You can also have dark mode support. So this component was taken from Shatsian UI, and we can also write some docs with code like this that shows the code of related components. So that's it. Coming to what's next, we aim to make this easier to use. Many of the things here can probably be abstracted into a dedicated module. Next up on the list is supporting playground-like examples. These don't need wireframe exactly. A simple iframe embed should work fine. Or alternatively, we can have some button to open the component in Istvar or StackBlitz. Another thing we might want to have is better integration of WordPress with Vue Style Guides tool. That will enable us to automate the docs generation, and maybe we can also use Vue live components. In future, we would also like to support frameworks other than Vue. Both wireframe and WordPress individually support different frameworks, but when used together, that functionality is a bit limited. So we would like to fix that and make the solution more generic. Further, there are many optimizations that can be done at both WordPress and wireframe level, and there is always a scope for more. So that's all from my side. You can explore the source code in this repo or use the open in code flow button near the bottom. Thanks for watching, and thanks to the ViteConf team for having me here.
Hello, today we're going to talk about how you can streamline your Vite dev flow with NX. I'm Katerina Skroumpelou. I'm a senior engineer at NX, a Google developer expert for Angular, web technologies, and the Google Maps platform. I'm a Women Tech Makers ambassador, a speaker and an instructor. I love cats, I love mountains, I love oatmeal and chocolate. And you can follow me at CyberCity or find me on my website cyber.city. So what we'll talk about today. Today we'll talk about what NX is, about NX plugins and their features like generators, executors, migrators, how you can execute tasks through NX, why you should use NX for Vite development, of course, some examples, some conclusions, and some key takeaways. So what is NX? Also, this presentation is going to be littered with pictures of my cats. So what is NX? NX is not just another build tool. This is a visualization of a monorepo, but NX is not just that. It's a comprehensive framework that integrates your tools and helps teams build better together. Its key benefits is that it enhances productivity, it makes your CI faster, and maintains your code quality. It involves around code sharing and collaboration. You can see here the NX graph that shows how the projects are linked together, task caching, enhanced developer tools, and of course, enhanced developer experience. You can enjoy building tools and spend less time waiting and more time coding with the cached results and our code generators. So NX offers some plugins. NX plugins are extensions that add capabilities to the NX workspace. They offer code generators, task executors, and integrations with various tools and frameworks like Vite, for example, or Storybook, or other tools that you can see on this list. So the NX Vite plugin facilitates easy conversion and setup of Vite projects in NX. You can generate Vite projects using the NX Vite plugin for React, web components, or Vue. You can build, serve, test, and preview projects using Vite. You can convert existing projects, for example, Webpack projects, to use Vite. And of course, you get Storybook Vite support. Also, NX loves Vite. The two teams collaborate on a regular basis. We reach out to each other to identify and solve issues. And of course, the ecosystem-ci helps us on that. And it's just that because we love tuxedo cats. So some plugin features of NX. You get generators, Code generators are used to scaffold applications, libraries, components. They're automated scripts that lay down the blueprint for various parts of your project. In this video here, you can see a generator that generates a React application that uses Vite. They're used to automate common developer tasks, and they help maintain consistency across projects because they scaffold your code in a consistent way and you get the same settings throughout your workspace. A common generator is, for example, the React app generator that you see here. Executors in NX are scripts that perform actions on your code, such as building, linting, testing, serving. Executor performs actions on your code by running scripts or commands defined in the executor's code. For Vite, for example, we are calling directly the Vite builder as is exposed by the Vite API. Of course, they ensure consistency. You get one CLI to run all your commands like nx test for all your application or nx run or nx serve for all your different frameworks. And you get advantage of the nx cache and the nx affected, which we're going to see further on in this presentation. Migrators are automated updates on your workspace. You can run nx migrate latest, and nx will intelligently analyze your code and fetch the latest versions of the nx packages and the updates that the other packages that you're using need. This makes sure that the manual error is reduced, and of course, consistency is ensured because you get consistent code base updates throughout your code base. You can use the nx migrate latest command and then pass the run migrations flag that will run a number of generators that will make your code be up to date. Some benefits of running tasks through NX, like serve or build, is of course the NX cache, as I already told you. The NX cache intelligently determines and caches which parts of your project are affected by changes. More than just saving time, it's about intelligent resource allocation. You can use various inputs to take into account which things, to see which things are affected and should be cached, but you can also specify your inputs manually every time. The nx graph command generates a graph that visualizes how apps and libraries depend on each other in your NX workspace. It helps you understand the architecture and dependencies of your projects. On the other hand, the nx affected command analyzes code changes and determines the affected projects and tasks, allowing you to run targeted commands only on the affected parts of your code base. For example, here, if you change the JSLib2, all of the other projects are affected. NX Cloud provides distributed caching and task execution, allowing you to share the computation cache across your CI teams. You also get visual insights. For example, here you have the list of builds that were run for a project, and you can see a fine-grained results with all the logs for each of these scripts, for each of these tasks that were run in a UI on the cloud. Distributed cache execution in NX means that multiple machines or CI agents run tasks in parallel. So why you should use NX for Vite? I don't think you should even be asking at this point. You get consistency, consistent developer experience, a uniform approach for multiple projects. You get optimized builds. NX computation caching enhances Vite's builds. You get flexibility. You mix and match configurations in one workspace. You also get speed and performance. NX boosts computation, expediting builds and tests locally and on CI. And while Vite ensures rapid builds and immediate HMR, if you combine the two, imagine how fast things are going. Also, you get integration and automation. NX plugins automate and integrate tools. Consistency and code quality, as we said, because it enforces coding standards with custom generators and lint tools. Automated code migrations and extensibility. NX plugins cater to multiple frameworks, and you can extend your setup with Storybook, E2E test tools, linters, etc. So you have everything in one place. Why not use it? Let's see some demos now. My demo is under this link here, but you can also find it in the links down here. This is the layout of an NX workspace. This is a React application set up to be built with Vite. As you can see, this is all generated by NX. This is the ViteConf file. If we open the project JSON file, these are the executors we talked about, the targets, which run the Vite build executor, which can be triggered by clicking these buttons. You have the serve target, which uses the dev server Vite executor, the preview target, which uses the Vite preview server executor, and the test target, which uses vtest. And you also get a lint target and a storybook target and a build storybook target. So you see that in this one React Vite application, you can run all these tasks through NX through a consistent way of triggering these commands. You also have Storybook set up to use the React Vite framework, which links back to your Vite config, and you have the general usual setup of how a React Vite application would look like. Also, you get a React library that is set up with Vite, which the Vite config is adjusted to be used in a monorepo with a library, and in a library which just exports a component, you get your Vite build targets, and you can import this library in your application. The same with the TS library that again can be built using Vite. This is just a super simple like JavaScript, TypeScript library that exports a string, but you know, it's still built using Vite. And this is a web components application, again, set up to be built with Vite. So as you can see, NX brings everything together in a consistent and tidy way. So here in this other demo, you can see task execution through the VS Code UI. If you go into your project JSON and click on the task graph, you can see the dependency graph of your tasks. So for example, the build target depends on the other two projects to be built. And if you click on serve, you will see the Vite application being served in your browser. And the other extra thing that NX offers is the NX console, which is the UI for the NX CLI. You can run executors as we just saw by clicking buttons, and you can also run generators through your NX console. Here we have a Webpack application that we want to convert to Vite. As you see, you have your Webpack config, and the targets are triggering Webpack generators. If you just click NX Vite configuration generator, and you set it up that you have a React application that you want to convert to Vite and click generate, you will see that it deletes the Webpack config, it generates a Vite config, and it changes the project JSON so that it uses the Vite executors, so that you have just converted a React Webpack application into a React Vite application. Which is pretty amazing, if you ask me. And you can build it normally using Vite, and it succeeds. Okay, so conclusion and takeaways. NX is powerful. NX is configurable, as you saw. NX has a wide plugin ecosystem. NX can enhance your developer experience, and NX can help you add Vite to your projects. So Vite is fast. NX manages resources. Together, super fast results, right? So why not use them together? As this cat looking at you is telling you with its smart eye. So thank you very much. You can find NX on Twitter at NXDevTools or these links here, and you can find me at CyberCity or cyber.city. You can find all these links here, down here or here at the bottom. I'm not sure which place it is. And thank you very, very much for watching my talk. And I cannot wait to see what you're going to build with NX and Vite. Bye. Bye.
Hi, I'm Francois. I'd like to thank the organizers of ViteConf for inviting me to speak to this amazing conference. I'm the author of Preview.js, a tool that lets you preview any UI component in your codebase instantly. Preview.js is based on top of Vite, and more specifically, Vite's JavaScript API. That's what I'm going to be talking about today. You know about Markdown, right? Did you know that in VS Code you can actually open a preview of a Markdown document directly in your IDE? Here, for example, I'm going to press Command K, then V, and I can see that panel open, and it will be updated pretty much as I type. Now, back in 2021, I was looking for an equivalent, but for React components. I wanted to be able to just select any React component in my codebase and see a preview of it, with ideally also the ability to tweak the properties and see it updated as I update the code. But at least back then, there was no good solution for it. So I decided to build it. Initially, I called it React Preview. Then I realized it could actually be extended to other frameworks, and so I renamed it to Preview.js. Nowadays, Preview.js supports React, Preact, Solid, Svelte, Vue 2, and Vue 3. Here's an example of how Preview.js works. You select a component, it opens in that panel side by side, then you can tweak the properties, and you can also see that if I make changes to the code, it's reflected in the actual preview. Preview.js is only possible because of Vite's JavaScript API. So let's look into that. The Vite JavaScript API is actually very well documented on the website, so you can go and check it out right after this talk. In fact, the Vite CLI that you're probably most familiar with, under the hood, invokes that same Vite JavaScript API. For example, we can look in the CLI.ts file in the Vite repo. The Vite dev command simply invokes create server, which is the same function that we just saw in the docs. So really, at the end of the day, the Vite CLI is mostly a proxy to the Vite JavaScript API. Now, before we get on to how Preview.js uses the Vite dev server, I need to give you a bit of an overview of how Preview.js itself works. There are actually three variants of Preview.js. There's the VS Code extension, the command line interface, and the IntelliJ plugin. They all invoke the same Node.js process that runs a Preview.js core package. The core package is in charge of two things. First is detecting components in the codebase, and the second is actually previewing them with some kind of server. Let's first talk about the first part, detecting components. For each different framework, such as React, Vue, etc., we have a different implementation of a framework plugin that provides especially a component and story analyzer. For example, for React, the React analyzer will look for JSX or TSX files, and inside of them look for functions that return JSX. So for example, here we have a definition of a component called greeting, that is a function that returns some JSX. It will use the TypeScript compiler API to analyze this and figure out, okay, this is a function and its return type is some kind of JSX. And that means it's probably a component. On the other hand, foo is just a value 1, 2, 3, which is obviously not a component. And so we do that across the entire code base in order to know where are the components and where you can actually preview. The other thing that is important is detecting the type of the properties. In order to preview a component successfully, we need to also provide it valid properties that will not make it crash. So we again use the TypeScript compiler API to extract the type of the props parameter here. And we can see that here it actually gives us the result that props is an object with one field called name of type string. That is what allows us to generate a fake set of properties to render this component successfully. The second part of Preview.js is actually previewing the components. This is where Vite's JavaScript API comes into the picture. Preview.js will start the Preview.js server, which is just a thin wrapper around the Vite dev server. The Preview.js server will provide a Vite configuration made of a series of different plugins. Some of these plugins are framework specific. For example, we need to know how to convert JSX to valid JavaScript, and that's done slightly differently based on the framework. Some frameworks don't even support JSX, in which case we don't have a JSX plugin provided. Some other plugins are shared across all of Preview.js. For example, we have a virtual file plugin. This is what allows us to have preview as you type. For example, in VS Code, whenever you type something, we will send an update to the virtual file plugin, telling it to update its in-memory version of the file. It will then notify the Vite dev server, which then notifies the browser, telling it, hey, this module has been invalidated. When that module is reloaded by the browser, Vite dev server will actually load that file not from the file system, but from the virtual file plugin. That means that it can access this in-memory version that has been already updated, and there's not even any disk access in this process. This is what allows us to have really fast instant feedback as part of Preview.js. In this example, which I promise I did not speed up, you can see that on every keystroke, the preview is updated pretty much instantly within just a couple of milliseconds. This is just one example of how powerful a Vite plugin can be. You can do a lot of stuff with Vite plugins. You can transform code from one format to another, you can implement support from new file types, you can even simulate virtual files that don't exist on disk at all. One of the really cool things about Vite plugins is that they're actually compatible with a Rollup format, which means that the Vite plugin that you just created also works for a bunch of different use cases where Rollup is being used. If you're curious about the examples I've just shown, you can actually go and check out the repos fwoods/preview.js. More specifically, you can look for virtualplugin.ts as well as vitmanager.ts, where the create server invocation is. I hope I've inspired you to play around with Vite's JavaScript API. Even if you don't try that, consider if maybe writing a Vite plugin might help solve a problem for you or for your community. On that note, I hope you enjoy the rest of the conference. Thanks.
Hi, I'm Priya Parsa, creator of Nitro, working on Nice and Anjis projects. Today, we are going to see about the future of Nitro. In short, if I want to describe Nitro is a server builder engine. It allows you to quickly get started to build your server applications, ranging from simple JSON APIs to rather more complex server-side rendered applications with an elegant TypeScript-powered API that Nitro provides to you to handle the common tasks such as defining routes using file system router, supporting caching layer with simpler route rules, and abstractions such as storage, which allows you to store files in different platforms. Most importantly, Nitro has an integrated builder powered by Rollup. This means that Nitro can automatically take your source code, build it and optimize it for the deployment platform and target that you want in the end. So during development time, you don't need to worry about the deployment platform, but Nitro can optimize and bundle your code into a portable format that could be deployed on that platforms. Also, Nitro has an open API. It means that higher order frameworks such as Nuxt can provide a full stack development experience for making applications on top of Nitro. And the applications could also easily be deployed to different platforms and optimized for them. During this conference, you are probably going to see much more of Nitro in action from different framework others. So I'm not going to spoil any more details, but I also invite you to look at the documentation to learn more about Nitro. We started to create Nitro once it was starting to develop Nuxt3 from scratch. Very soon, we just figured out that this engine, this server engine that is powering Nuxt3, that is allowing Nuxt3 to be not only a UI framework that has server-side rendering, but a full-stack framework with full TypeScript and backend support using a server engine called Nitro. And just before the final release, public release of Nuxt3, we decided to extract Nitro, making the standalone Unjust project and open it to everyone, so that not only Nuxt, but entire ecosystem could opt in to leverage from the Nitro abstraction to build any full-stack server framework or application that could be deployed everywhere. And probably today, it's open to everyone. More and more frameworks are considering Nitro as their base server engine core, and you are probably going to see and hear more about it in the next talks. Since we open sourced Nitro as part of Nuxt3 Extracted, 1 year passed, we have over 1 million monthly downloads now. Thanks to all contributors who have more than 900 pull requests and more than 2,000 commits coming from 190 contributors, which is amazing. And I'm super proud of the community that is willing to improve one single code base that leverages everyone, which is our main goal. Currently, Nitro is in the Nitro stable is in the 2.x, and we have some amazing features planned for it. Probably by the time of the conference, some of them are already in the beta. One of the features that we always wanted to introduce to the Nitro after the standard storage key value storage layer was the database layer. It's always hard to, from the beginning, to decide about the right database and engine when you start to prototype your project. Also, it's always tricky to make a setup that is easy for development environment without requiring to install and run additional software to develop a database, but the same code base to be also runnable in different platforms on running in the production. The database layer, standard database layer that is going to be introduced into Nitro and powered by another Unjust project called DB0, is going to solve these issues by providing an abstraction layer for the database connectors and simple database operations. This abstraction layer is also open. It means that you can plug in any database provider you want. You could also integrate with your favorite ORM. And leveraging that, you can have a consistent experience for interacting with the database between development time or any deployment provider that you want. And you can easily switch between them. The other thing that we plan to introduce in Nitro version 2 is the task runner. Nitro is traditionally a server framework. It means that when a request comes, we process, we generate a response and send it back to the users. But sometimes there are tasks that are not bound to a request, such as processing payments in the background or running some database migrations on each deployment. These are on and off tasks that we want to run in the runtime, not only development time, but we want them to be integrated with the server. With the task runner and standard layer that we're introducing into Nitro, you can have a consistent developer experience. You could make and test your tasks in the development time, and you could deploy the same code to the production. And Nitro would take care of automatically integrating these tasks with the native provider APIs, such as scheduled tasks or webhooks. This task runner could also be used in development time to be triggered using the CLI. So you have all the stack. The other long-lasting feature that we wanted to introduce to Nitro was a universal WebSockets API. With this universal WebSockets API, you could easily define multiple WebSockets in development time. You could test them. And Nitro can make the format into a version that is compatible with each deployment preset. So you also don't need to make changes to make it deployable to different providers. And with this WebSockets API, you could have more interactive pages. One of the other things that we plan to introduce to the Nitro version 2 is Nitro pod format. Currently, Nitro by default generates an optimized.output folder, which is portable. It includes every node module that we want, and you could run it simply with Node.js. But we want to go one step further. We want to make this output format to have a standard for other features that we could integrate, such as route rules. For example, we could define the route rules that are for redirection and proxy, and they could be easily integrated with the CDN layer. We also wanted to have it easier for self-hosting providers, if you have your own VPS, to deploy your Nitro application, to make it as easy as possible. And Nitro pod format is going to make it possible. Just like Vue and Nux, we tend to make breaking changes minimal for Nitro, but we have some major changes introduced and planned for Nitro version 3. One of the first things that we want to try is that we want to open Nitro to support other bundlers. Today, Nitro only supports Rollup, which is quite amazing, which is quite good for production, also acceptably fast for development time. But there are faster builders, such as Vite and RSpec, which we want to make sure that Nitro is open to support them in the future. The second part is enhanced UI rendering. Once we open Nitro and extract it from Nux, we introduce a standard renderer layer to make it easier for meta frameworks to support their server-side rendering into the Nitro. We want to make it even better with Nitro version 3 and have more integrated features. The other part is the presets. Presets are deployment configurations that live in the Nitro core. You could easily configure your preset by name, and when you deploy your application, the Nitro output is optimized for that platform. But there are some deployment presets that they have major breaking changes. Also, some of them have more pure dependencies that they need to be installed, which we cannot install from the core. With this new architecture and refactor in Nitro core, we are going to make it possible to have standalone presets. This way, we could also have a decentralized way to develop different versions of presets for each deployment platform, making Nitro even more open. And the last part is the smarter CLI that we plan for new Nitro. This smarter CLI would allow you to have more integrations with your IDE, with your other tasks that need to be run in parallel to your application, all from one place. I'm really looking forward for the future, and this future wouldn't be happening without community involvement. So we are more than open. If anyone wants to help, if you want to be involved more into the Nitro ecosystem, if you want to contribute to it, just feel free to message us, and you are more than welcome. Thank you very much.
Hi everybody, my name is Nikhil Saraf. I work for Lepton Software, and today I want to tell you a story about my journey through building servers in JavaScript, the lessons I learned, the things I had to unlearn, and all my experiences. And it's a long story. Well, not really. It's just 3 years, but I'm just 25, and so 3 years seems like a long time. The story begins back in May 2019 with my first real product that I was building. It was called QWERTY, and I was building it with my friend Devansh from school. The idea was that we would help college students help each other by answering questions that others had. I was responsible for building the whole product, and I learned that I had to build a client and a server to build my full application. And well, I heard that the server was the difficult part. So I was like, let's go for that. I looked around and there wasn't anything I particularly liked in terms of how I wanted to write my code. And so just like every other engineer has made the mistake, I thought, let me build my own. And I called it Tavern. The idea was that it was this monolithic server with this microservices architecture in the middle, like these small modular decoupled things that would talk to each other using messages, and you could just plug things in and take things out. And as you see, the irony is in the description where I'm calling it super simple, where it most likely was not super simple at all. I had spent 1 month and did not have a product to show and did not have any features to show. Well, I was like, let me build the client at least. And so I looked around and I found Next.js, and that immediately was a breath of fresh air for me. It has given me so many new ideas that have lasted these last few years. The first and the most important was that you're not building two different applications. You're building one application, and these are just different parts of the application. The second one was file system routing. And the idea there is not just about file systems. The idea is that the code is so well understood by the bundler that it can figure out all these next level optimizations to make sure your app runs super fast on the infrastructure available. The other part that made these things very scalable was the idea of serverless that Vercel introduced to me. The idea that I did not need to worry about where my server ran or how I scaled it up. The Git integrations made me realize that I did not want to think about when my server was deployed or how it was deployed. I just wanted this stuff to be taken care of. And that's what Next.js did for me. There was a few things that, still bothered me about my experience with Next.js. The first was the huge amount of opinions. So let's say I just wanted to try a different file system routing convention. I would need to build all of Next.js all over again just to be able to do that, since these opinions are so heavily ingrained into the architecture of the product. The second was the very, very slow development experience that Webpack caused. It would cause multiple seconds to see any changes on the screen. And it was just not fun to work on. But, it was the best in the market. And time went and we were able to develop something really good in it. But interest started waning and we all got jobs and we kind of moved on from QWERTY. There was something very interesting I found. I had been using GraphQL before that. And I started thinking that I don't really need this, something that I have to do a lot of wiring around just to make sure I can have full transparency between the server and the client, have TypeScript support, things like that. I found this thing called Bliss.js. And the idea was that you write your server code right next to your client code in separate modules, but right next to each other in the same directory. And you'd be able to import your server functions into the client and just have an end-to-end TypeScript experience. During compilation, the bundler would figure out what API endpoints need to be generated, and it would just do that behind the scenes without me having to worry at all. It felt like I was literally writing one app through the client and the server. One other idea that stuck around, similar to file system routing, is this idea introduced by Swix, and the idea was of a self-provisioning runtime. The idea that your bundler and your build setup and your runtime should all cooperate together to give you the infrastructure you need, the deployment patterns you need to succeed just by looking at your code. And your code should have enough expressibility to be able to describe the architecture you want, describe the application you want, and all the tools would just start spinning around to make sure you got the experience you want. I went to this crazy path of describing my architecture in JSX using React components, and I would have a React render that would spit out config files and deployment instructions and things like that. And whenever I changed it, all of this was committed in Git. And so it was something really fun, but it's not something that I have, carried over through the years because it was not easy to maintain. Well, with this, we move on to Act 2. A lot of time had passed and I was not working on the product, but I was just exploring around. And I slowly moved into this phase where I was getting to live one of my old dreams again. And that was to be able to build games. And this was made possible because of the new tooling that I had discovered in this area. That was Three.js, React 3 Fiber, and being able to use all my React abilities to build complex games with logic, rendering, all of this. It was just so easy and I just instantly fell in love with it. You can see this game of chess I had built and I was really proud of. While building this game, I realized I needed another server. And this time it was a different kind. It was just a development server for something that was completely client-side. But what the development server would give me is a fast hot module replacement experience, and an experience well, as I made changes, I could see changes on my screen and see my game develop in real time. And that's the really fun part of it. And this is where Vite came into play. And I started building games with it. I soon needed to build some documentation sites. And that's when I again felt the lack of a server, right? And I did not want to go back to Webpack. And so that's when I built my first meta framework. I called it Vite Next, not very original. But the idea was to build something that actually had a lot of the opinions from Next.js, some different, but it was built on top of this new stack that I fell in love with, Vite, React Router, React Query, and things like that. Well, as you can imagine, it was a really tough thing to maintain, and I did not continue to maintain it, but I learned so much about what all a meta framework entailed. It kind of led me to, and the way I was building games, it led me to actually discovering Solid and Solid Start. The idea was that I wanted to build fast games, and Solid helped me do that. And then I needed a server again, and that's when I found Solid Start. It was built on Vite, which I loved, but it actually introduced me to this new idea, which I had not seen before, but actually was inspired by Remix, SvelteKit, Astro. And the idea was that you wrote your app once, and it could deploy to any of the tens of providers available in the market. And you'd not need to change your code, you'd not need to do anything special, just a different flag, and you could just deploy your app anywhere, and you could actually change your deployments as your needs changed and things like that. So I decided to join the team and started working with Ryan Carniato to actually make this project more mature and add more features to it. We added what I think are some really great features. Some of them were inspired by others, some of them were our originals. The feature that we're most proud of is this idea of server actions, which are all the rage nowadays. But the idea was that you would have a way of writing code within your client modules, and a compiler would split them out into their own endpoints. And to you, it would just feel like you're just declaring a function and calling it. But the compiler was doing so much more to make this a client server architecture. And so you could write your database queries right within your components, and it was just amazing to write in. And finally, we introduced islands inspired by Astro, and now we think of them as equivalent of server components because we were able to introduce all these complex routing mechanisms on top. But the idea was that, send as little JavaScript to the client as needed and get a fast experience during hydration that way. There were a few problems we faced during this process. It was becoming a drag because of the number of issues that were happening. And most of the issues were around the various adapters that we would have to maintain. And me and Ryan talked about this continuously, that us, SvelteKit, Astro, QuickCity, we're all doing the same development again and again and maintaining these adapters and building them again. It's a layer that just needs to be consistent, mature, well-tested, and well-maintained. And so we were looking for a way to harmonize. Alas, we couldn't get there back then. But what I learned was that a full framework is not just the client and the server, but it's actually a module system, a bundler, and the server runtime all working together to orchestrate this dance that is the app. Well, with these learnings, time moved on. Solid Start was getting more and more difficult to maintain, and we were discussing ideas about what part to take, how do we get rid of maintaining these adapters. So we actually started working on an integration with Astro and to see if we could use their server framework and build our layers on top. With that in the background, I moved back to India and joined Lepton Software. The first project that I was leading was the development of this data catalog, where we had a lot of geospatial data across India, and we wanted to be able to show it off on maps and in a really dynamic way. But it also had to be really, really, really fast, and as much statically rendered as possible with all the JSON files and things like that. And that's coincidentally when Next.js app directory was released. And I instantly jumped on because I had been looking at server components for a long time, and I was really fond of the idea. And I really liked the way they had been manifested in Next.js app directory. We tried it out. The experience was as we expected. Every user who used it was surprised at the speed at which the app was performing for them, considering the complexity of the app itself. Well, the problems with Next.js were kind of the same as the last time. The development process was really slow, and now with so much involved in doing the server components part, it was taking even longer for any change to be reflected. And the second was again the number of opinions that it held and how it was really difficult to play around and experiment with new ideas there. And so I started working with my friend Fatih, and we worked on this first run at building an React server components integration with Vite. It didn't take very long, but the key lesson I learned was that this time I needed 3 servers to actually be able to deliver good SSR experience with React server components. I would need one for React server components, one for server-side rendering, and a development server for the client. This is again kind of revealed one weakness in the current existing Vite model is which whenever there is a lot of server complexity involved, you have to build something completely of your own. And I realized for people to actually be able to use our Vite plugin, people needed a full framework on top of it because routing was very specific, bundling was very specific, chunking was very specific. And so I built this thing called Fully React, kind of my third hit at a meta framework. And it wasn't any easier than before because again, all of the server pieces I had to resolve the same problems. I was still not, feature parity in terms of all the adapters, all the build optimizations, things like that. In the process, I had discovered that I can actually make this contribution back to the React core repository, and that was to introduce the React Server DOM Vite package, analogous to React Server DOM Webpack, which would introduce first-class support to Vite in the React Server Components ecosystem. And as you can see, it's been very well received. I'm yet to land it, but one part doing this PR was actually building a whole fixture that would test this setup. And now for the 4th time, I wrote the same, multi-server architecture with different builds, different configuration, manifest files talking to each other. And so it clearly revealed to me that there's this repetitive work that I have done 4 times and numerous people are doing again and again. And it told me that there's a new layer of abstraction needed there. Just as I was thinking about this, I saw this new release from Jared Sumner. And part of his Bun Bundler release was this small sneak peek called the Bun app. And the idea was that Bun was facing a similar problem to this. And Jared thought of a really nice way of expressing this. He broke it down into small routers. A router is a small section of your app, normally under a specific prefix, which is being handled a certain way. So, a certain number of plugins are being applied to it, is being built either to be run on the server or to be deployed to the client or be served statically, things like that. And he was able to show using the same API, a static file server, an API server, and a Next.js file system routing based framework. I really liked this idea and I wanted to see how much of this I could take and bring to my world of Vite and Node.js. The second missing piece of the server architecture was Nitro. The actual runtime that would be almost my equivalent of the Bun runtime, where I would get a nice API to use, builds that would work across adapters. It was really well maintained because maintained by the Nux team. There was a few issues, just didn't have a very nice dev server where the client was involved. And it just did not recognize that, you might have a client that you're developing in the same application. And with these lessons, I decided to build this new project I'm introducing to you guys today called Vinci. It's named after the late, great Leonardo da Vinci. I share a birthday with him. But the idea is that it's versatile in handling a lot of your server use cases. It's built on Vite, it's built on Nitro. It has a Bun app-like API, and I don't really have a good way of describing it, so I just call it a meta bundler. Credits to Ryan for giving me that name. But the idea is that it handles your development server, your production server, it's your bundler, it's the runtime API for your server. And I just want to take you a small sneak peek through the experience of writing an app in Vinci. Let's start with the static file server. You just say mode static and you give it a directory and now you have a static file server. Well, let's say you decided that you want to build an API on top. That's just another router that you add to your Vinci config. You give it a handler file, which would specify to Vinci what module to use to service those API endpoints and what to build during the bundling process. Now, let's say I wanted to build an API in the style of Next.js where I wanted the file system routing with dynamic routes and things like that. Well, that's just another option that Vinci provides to you. You can build any file system router mapping to any convention and pass it to the routes config. This can be, something like the pages directory or the app directory or any other routing convention, like for example, the SvelteKit routing convention, whatever pleases you. Now, there's no fun just building a backend. So we built a front end, and that's just another router in your application config. You see the third router here is a is a client router where we build your index HTML for you. And during development, we give you the same experience Vite does with amazing hot module replacement. And you get to add any Vite plugins you want. And that applies to any other router as well. The idea here is that you're getting isolated Vite routers for each of your app routers. And you get separate plugin pipelines and separate builds for all of them. And so that's how you easily get the server client experience that you've been looking for. Now, let's say I want to move to server-side rendering, where the client picks up with JavaScript, but the server side sends your HTML. Well, it's repetitive now, but that's just another router where you say that you want an SSR router, which is doing a React render to string kind of experience, and you add your React plugins to it. And again, now you get HMR on the server while you're building your React apps. And well, there's no fun if there's no file system routing. And so just like with the API directory, you take your file system routing and you apply them to your SSR router and your client router. And now you just get, this symmetrical file system routing between your server and your client. And it's all bundled well, it's all optimized. Well, that was the experience of slowly evolving an application in Vinci. I want to end with a small thought. The reason I really like building my own things is because I get to have my own opinions. I really believe that everybody should be given the freedom of having their opinions, being able to test them, and being able to, change them when needed. But this is not possible if the tools we use are heavily opinionated, because to now build an alternative, you have to climb a huge mountain just to get on the parity of features from a user perspective. I truly believe that there's a lot of value in engineers being able to have the freedom to have opinions without compromising on performance or user experience, because that is the path to building better and better patterns, because nothing comes without experimentation and failure. Thank you for listening to my talk. I hope you had a good time and have a great time during the rest of the conference. Thank you.
Hi, I'm Ryan Carniato, creator of the JavaScript framework Solid.js. I'm excited to talk to you all about today's topic. I spoke at ViteConf last year, and I was very excited to talk there as well. I used the conference to introduce the world new concepts like islands routing and server functions, things that have started showing up in other frameworks the past year. We also introduced Solid Start, Solid's meta framework, and did its beta launch. But if it isn't obvious from the title, today is going to be a very different sort of talk. If anything, it's a sequel. And maybe not the sequel that everyone's looking for. The overarching theme of last year's talk was Vite gave us the tools for anyone to create meta frameworks the way they wanted to. And for someone who never wanted to create a meta framework, yes, I'm talking about myself, it was, and still is, an absolute game changer. But a lot has changed in the past year, and I feel like we've learned a lot collectively. It wasn't only the early framework authors like ourselves, Astro, Nux, Feltkit, Marco Run, Analog, Rakus, that felt this, but the wider community of developers definitely saw Vite as that platform. So when the question came up to retire CRA in that highly controversial GitHub issue from Theo Browne, Vite was kind of the obvious choice. Well, at least on the surface. The React core team had different ideas. The official position is that React was now expected to be used with a meta framework. This was conveyed publicly by the core team members in several channels, from comments like Next 13 is the real React 18 release, to the docs recommending these frameworks as the way to start your new React projects. This is a pretty serious precedent and has big implications when you consider React's place in the ecosystem. On the Solid Start side of things, we've had our own learnings. I'm a natural unbundler. I like breaking apart problems to the fundamentals. I pitched last year that if we broke things down to composable primitives, you don't really need a meta framework in a classic sense. And we've found success in this. I remember the first time I saw a TanStack query in Solid Start. It felt first party. I've never felt that way in any meta framework before or since. You dropped your crate query calls in and everything just worked. Suspense, server rendering, streaming, data serialization. The developer could just choose their data fetching library of choice, no loaders, no get server-side props, and it just worked efficiently as if it was first party with a single system, server and client. Even doing database calls directly in the query function just worked because we had those server functions. Honestly, there's nothing quite like it when a user comes up to you and is like, I don't like the caching options for the default data loading in Solid Start. And you ask, well, is there a library that you do prefer? And then you can just respond, well, use it. We also had our success with our Islands router prototype. When the Google team encouraged frameworks to work on the Taste Movies demo, we built our own version, or I should say the community built it. This was an amazing effort of 8 contributors to make one of our best demos to date. Honestly, I still just love showing off this demo. This app is just, it looks a lot like any kind of client-side app. It's got transitions when you move, you can click into stuff, and basically, you can go in here, you can maybe search something, and without losing the focus or, any kind of glitch, you essentially have a full experience. But the interesting part about this demo is it uses islands. In fact, this demo is only 13 kilobytes of JavaScript. When you put that up against similar solutions, as you can see, there's lots of them available, some with client routing and some without. Solid's demo was much smaller than many of the popular options, with things like Next.js and even Next.js with server components weighing in at 190 kilobytes, almost 20 times larger. This demo actually led us to getting significant funding from the Chrome team to continue our research into the partial hydrated solution. So that's pretty good. But it's been a year, and I'm sure the question a lot of people's minds is, when is 1.0 of Solid Start? And I'm sorry to disappoint you, but that's not what I'm announcing today. But it is very related to the topic of this talk. We've seen Solid Start being used in production applications that serve millions of users, in things like post.news, but I'm not satisfied where things have been at. Last year, I outlined what I wanted to avoid, and we succeeded at most of these. There are some APIs that I feel we introduced to make things easier, but ultimately didn't simplify things. There were some edge cases that weren't handled as cleanly as we would have liked, but for the most part, the design was good, and we made the most of existing APIs and concepts without being too opinionated. Where we started falling down was that last point. I'm not used to having repos with hundreds of open issues, especially where the vast majority of them are legit bugs. I know it means people are using it, but none of Solid's other repos, including Solid itself, has ever had more than a handful of legit bugs open at a given time. We're an open source group. Yes, we have some corporate funding, but I've learned to be realistic over the years, and this was a red flag. We weren't architected to succeed at our goals. So, it comes down to the Unix philosophy. We were still trying to do too much. Our successes were where we empowered others to build the experiences they wanted, not by forcing people down a path kicking and screaming. We had a good idea, but we needed to do it better. So today I'm going to share our adventures and our learnings into the space as we've been working on Solid Start. I suppose this starts with a question. What is a meta framework? And truthfully, this discussion can be as pedantic as library versus framework, but I'm going to look at it a little bit more mechanically. To me, there are 4 parts that each roughly layer on top of each other that make up a meta framework. We have the router that's responsible for navigation and data, the framework for rendering, or library if you prefer, the bundler for packaging, and the server runtime to ensure it runs on every platform. These roughly go from most opinionated to least opinionated. So a big part of addressing Solid Start was deciding where to draw that line. I'm going to go through each of these one by one, starting with routing. Routing is by far the most important decision to define the architecture of a given application. The web is just a big router, and every significant change in the evolution of web development starts there, whether it was dynamic routes on old PHP that got us away from static served pages, client-side routing signifying the arrival of single-page apps, the history API and push state, which allow for seamless server render and universal apps, and even now, things like Solid.js's Island Router, Next's App Router, or Astra's View Transition integration, which allow client-navigated, partially hydrated solutions. But as I said, it's also the most opinionated. My friend Tanner might have the most amazing React router I've ever seen, but if every meta framework has their own, well, he's sort of out of luck. Some have tried to make agnostic routers that work between frameworks, but that assumes too much. Data fetching patterns and change management can be very different as well. As we can see in React, it is hard enough when your ecosystem is so large to have a single routing solution. So while the goal of universalizing these concepts is admirable, it is too high in the stack. The frameworks themselves are all different and have different needs out of routing. I do want to clarify, I'm not talking about the file routing conventions, as those ultimately are just compiled to some configuration. I consider that part of the bundling build step layer. We are working towards SolidStart being able to use any solid router. Today, the routes are pluggable into Solid's router, but they should be pluggable into any solid router. Okay, the next layer, the framework, or the library if you prefer. This part is a given. We need a tool that knows how to render and how to update across a variety of environments. There are a ton of choices here. A ton of great choices that I think this is actually the least controversial piece. It's simple. Obviously, choose a framework with signals. But more seriously, as we go down the stack, the less opinionated things get, which means from my perspective, everything below this layer should be framework agnostic for the most part. Which leads us to that next level, bundling. Well, obviously we have a pretty good tool here with Vite, but I want to talk a bit more specifically here. I've waxed poetic before about just how powerful the universal plugin system is, but it's more than having the platform that supports this sort of composable plugin system. This last year has largely been about understanding the primitives we need for bundling modern JS apps. Code extraction is something a year ago that we discovered but didn't even realize was a common piece we were all looking for. Solid had its server functions, Quick had its closure-preserving $sign modules, and React was just about to announce Use Client with its next 13 release. All different applications of basically the same capability. Quick also added server functions, almost immediately after the conference last year. And when Next added its server function API with Use Server, it used similar closure preservation techniques to Quick. We kept seeing this trend, so we thought to generalize it and bring that capability to everyone on top of Vite. So enter Bling. A name I gave the project due to all the $signs that just kind of stuck. Tanner, Nikhil, and myself took our first stab at this, and as a means for experimentation, it is really powerful. There were server functions, but also things like secret $sign for hiding client secrets, lazy $sign to inline lazy loaded modules. You could use it to take something like Tanner's React router or Solid's router and define full code splittable route definitions with data fetching all in the same file, with none of the clunkiness that led to needing a file system routing system in the first place. We even looked at stuff like worker $sign and WebSocket $sign. People from the community built libraries like PRPC, which brought TRPC-esque setup with validation to this server function world. As I said, we took a compiler approach, which made it really easy to build features as all analysis was local, but it did pose some complications. Code only got registered at runtime if it got imported, and each wrapper was its own entry point. And this meant our server functions that lived in lazily loaded components and never got navigated to on the server never got registered, even if they were navigated to with client routing. Oops. And our client components would be a separate bundle per component rather than allowing multiple nested islands to be bundled together. Again, this seemed like a common problem, Whether you were working on solid islands or React server components, this need of bundling as part of the code extraction pattern seemed necessary. And so Nikhil went and built Vinci, which I believe he'll be talking a bit more about today. Vinci marries file system routing conventions with a server-side router and bundler to serve as a foundation that Meta framework could be built on. The pieces that we had slaved over for handling routes, manifests, and assets could be just wired together through centralized configuration. Well, it's Vite. Well, built on Vite, but with the server and client build steps talking to each other. We built this stuff enough times, with Start, working with trying Start in Astro, and then when Nikhil was working with the Rackets team to bring React server components to Vite. We built islands, server components, server functions, client-only render modes. It was time to generalize it. All that was left was to find the right server runtime. We have built our own set of adapters over time that support a universal runtime that works on Netlify and Vercel functions in Edge, Cloudflare, Dino Deploy, AWS Lambda. We had added support for some platform-specific features like durable objects, Miniflare Local Dev, and ISR. But this has proven to be a continuous effort to keep on top of. It isn't unlike the browser wars decades ago. There's efforts like WinterCG and standardization, and we've been seeing Node add a lot of the missing web APIs the last few releases, but it is too much for a framework to keep up with, in my opinion. So we looked at options to offload this part, and there are a lot of great solutions built on Vite. Not to mention every other Vite framework builds their own adapters, so we explored other frameworks that did particularly well in those areas, frameworks like Astro. Ultimately, where we've landed, though, is Nitro. For us, Nitro seemed like the logical choice. It is low level enough to not be concerned with the layers I mentioned already, and powerful enough to be the server runtime behind Nuxt and Analog, Angular's framework. It is a project clearly made for this use case. We were able to bypass any of its opinionated bits and have it work exactly the way we want. As a bonus, Nitro is part of the UnJS open source project, which offers a suite of platform-agnostic tools, including H3, which is a universal HTTP server, and Unstorage, which universalizes things like KV stores. This is a great set of open source tools available for anyone. All right, so what? Well, the end result of adopting these tools is quite significant impact on the project. In combination with combining some of the effort like the CLI tool back with the community and backporting some of the data fetching APIs into the router, the difference on maintenance is actually quite stark. Before, approximately 10,700 lines of code across 150 files made up the Solid Start project. Afterwards, we're looking at about 1,200 lines of code across 30 files. That's roughly 1/9 the lines of code and 1/5 the files to manage. So again, are we there yet? To answer the question best, I can say today we are much closer. This is one of those roundabout journeys where we built and learned a lot in the process. With a more solid foundation, beyond improving on the ability to maintain the project, we have addressed many of the core issues with the current beta and are starting a second beta phase. One to iron out the remaining issues as we make strides towards 1.0. But this new version better delivers on the goals we set out for the project a couple years ago. I encourage you to join the discussion on GitHub to help us flesh out all the details and try all the new features as we continue to stride for 1.0. If you like what you heard today, you can find all the resources you need off solidjs.com. You can find me on Twitter or X at Ryan Carniato, and if you really like nerding out on JS frameworks, I stream weekly on YouTube and Twitch. Thank you.
Hello, it's a real delight to be here at ViteConf talking about making an extensible meta framework with Nuxt. My name is Daniel Rowe. I lead the Nuxt core team. I'm also involved in a couple of other projects as well, such as Magic Regex, which is a type-safe way of building regular expressions with no runtime overhead. Fontaine, which is a CSS-only approach to reducing or almost eliminating layout shift due to web fonts. Elk, which is a Mastodon client for built in Nuxt. And of course, you can check out my website for more about what I'm involved with. Or if you want to contact me, I'd love to talk to you if you want to get involved in open source. And my calendar is always open. I'm also a Google GDE and a Microsoft MVP. And you can get in contact with me on any number of different social channels. I would love to be in contact. And this is where I am. I'm based in the northeast of the UK. It's a blustery, wet day today, but and this is what I'm seeing in front of me, pretty much. There isn't actually a cat there right now, but I do live here with 3 cats and a dog and my family as well. And I love all kinds of things open source, and it's been a real delight to be involved in Nuxt and in some of the other projects I'm involved in too. And to help out, if you ever need help with anything that I'm building or working on, feel free to get in contact. And I'll be here probably cozy with a cup of tea or a cup of coffee, and it would be nice to help. I'd love to do that. Today I'm talking about Nuxt, and if you haven't come across it, Nuxt is a progressive framework built on Vue.js and Nitro. So Vue for the front-end user interface that you'll be building your app in, Nitro for the server framework which powers it, which we've actually developed as part of our work on Nuxt, but which is now totally framework agnostic and works with and powers other frameworks too. And I'm sure you'll be hearing more about those later, or have already heard about them. Nuxt aims to be a zero effort start. So it should have great developer experience. You should be able to get going straight away without having to focus on the things that will hold you back from what you're building. So friction, we want to reduce or eliminate if possible. And because of that, we also really want to work hard at making sure that the best practices are built in. So when you actually start going with Nuxt, you don't need to be worrying about having to configure or set things up right. It should be done for you straight out of the box. And I think one of the other things that's really unique about Nuxt is that it is configurable and extensible, both by you and also by a big modules ecosystem of different integrations that make Nuxt possible. And it's that really that I want to talk about today in this talk. And there are 3 things that we've done, particularly to make Nuxt extensible and configurable. And I want to talk a little bit about those. And it might be more relevant, particularly for module authors, but I hope to convince you that anyone using Nuxt can be a module author and can actually take advantage of some of these things in your day-to-day development of Nuxt. So the first thing that Nuxt offers is a hookable experience. So actually powered by a library we developed for this very purpose called Hookable. And the concept is pretty simple. This is how you would actually use it as a library author, or how we use it within Nuxt. You create a global hookable instance. We attach this to Nuxt itself. At build time, there's a build set of hooks. Different modules or user code or internal Nuxt code can then hook into different lifecycle events, which get called with potentially some arguments, maybe not. And these hooks can then be called and awaited at different times. And that is a really, really good pattern for how to hook into a single process or even a multi-threaded process, but from different places. And so we offer this to modules, and it's a way of actually making Nuxt almost fully extensible as long as we put the hooks in the right place. We also have a couple of cool features that we're able to build into by having this hook-first approach. So for example, recently, earlier this year, we added support for console create task, which is being pioneered by the Chrome DevTools team, which is a fantastic initiative to improve the the ability of debuggers to show exactly how a task that's being run, for example, in a hook, relates to the original code that added it. So for example, this is what it used to look like before in a DevTools panel without console create task. Just sort of anonymous hooks, and really the stack trace just took you into the code of Hookable itself. But with the create task support, we're able to have some really, really nice debugging, which takes you directly to the thing that's calling the hook and the hook itself that you've added. So that works quite well. We also have, it's really very, very configurable. So aside from having things like first class type support, we also have different kinds of runners. So you can run tasks in parallel, or you can run them synchronously or asynchronously or sequentially, and you can provide your own task runners if you need. We also have a really great debugging mode, which you can enable just out of the box with a separate utility. In Nuxt, you just pass debug true in your config, but if you're using it under the hood, you can just use create debugger, and it allows you to actually spy on all the different hooks that are being run, the arguments that are passed to them, how long they take to run, anything that you might want to do like that. And so for Nuxt users, it can be a good or useful debugging step, maybe even more useful for Nuxt authors or people who are wanting to integrate deeply with Nuxt. So Hookable is definitely worth, and this is a screenshot of the Nuxt DevTools, which also gives you a view of the hooks that are running. And actually we use Hookable four times in Nuxt. So we use it as the Nuxt build tool. We actually use it in the Nitro build tool as well. So they have a similar architecture. And we also use it in the Nuxt runtime. So actually in your code, in your app, you can also have events, like a mounted event, or when page transitions happen, there are more events that happen, and you can hook into those as well. We found it to be a really, really useful pattern, and it has helped make Nuxt really extensible. So that's the first piece of what we've tried to do. We've used hooks. We've made Nuxt itself and the runtime Nuxt instance hookable. And the second thing is that we're aiming to make Nuxt also pluggable. So not just that you can hook into things that are already running, but you should also be able to swap things out. You should be able to override something that's core to Nuxt. So for example, the first, probably most obvious one is that our bundler is swappable. So Vite is first class with Nuxt, it's installed by default, and Vite really makes a lot of cool things we do with Nuxt possible in a way that some of the other bundlers don't. So Vite, we love Vite. But we've actually, from the beginning, built Vite to be swappable. So you can provide your own bundler implementation if you wanted to use Parcel, or if you want to use Bundle, or whatever else you might want to use. It's technically possible to do. We ship Webpack, and there's also an RSPack port in progress. But again, you could do it. You could provide whatever you want, as long as you're able to provide an import which has a bundle function that takes Nuxt and outputs a result at the end. That's all we really care about. And so it's possible to do this sort of at a very high level. But it's not just there. Almost all of the features that we build for Nuxt, we build as modules that could be replaced or overridden by other modules. And it means we have to adopt the pluggable infrastructure ourselves. So almost all the features we build, we have actually built in this kind of way, and they can be swapped in or out. So for example, I created a module for Ionic built on Nuxt, and it has to largely swap out the view router implementation for a slightly different routing implementation that's used in the Ionic framework. And it was relatively straightforward to do for exactly this kind of reason. But then the third and almost most powerful of all of these is the fact that the Nuxt architecture is layerable. So for example, we expose core Nuxt components like Nuxt page or Nuxt welcome. You probably wouldn't use that in production, or Nuxt link. And all of these components can be overridden by modules or users. Or we expose key auto imports, things like views ref, or Nuxt has some composables like navigate to, or use state, or use async data. And all of these things also could be overridden. even if I wouldn't necessarily recommend it. And so it means that as you develop an integration and need to do something like this, it's possible to do quite a lot of different things. I should also call out the fact that really very much the way we add features to Nuxt isn't just by adding additional modules, but these modules then integrate with things like Vite and the whole build process. That's one of the most common patterns of adding features and functionality to a framework like Nuxt. And so this is also possible by something called Unplugin, developed by Anthony Fu, which I could not commend to you highly enough. And I'll show you a little bit about that a little bit later on. So thirdly, we want to make Nuxt, therefore, modular. So it's not just hookable, it's not just pluggable, but it is actually modular as well. So we have a whole modules ecosystem, which you might have come across at nuxt.com/modules. You can find it, a database of them. And this is our sort of offer for modules. So they're distributable. So you can actually build one just in your project yourself and just use it purely internally. You can also publish it to maybe an internal registry at your company and use it across your projects. And you can also publish it to NPM and use it as a package that other people use. So modules are reusable, therefore, and that makes them useful because you can take any functionality that you often use in a project, wrap it up, and adding it is incredibly simple in future. We offer first-class tooling for it. So we've built utilities like Unbuild and MakeDist and others under the hood, which we've wrapped up all into a Nuxt module builder, which is a CLI and build tool, which abstracts a lot of the complexity away of making Nuxt modules. So it means that we have a starter template that you can get going on if you want to create a new module, which is just nuxi init my module -t module, and that module template will get you going to start with. We also have a database of Nuxt modules, so it's just a Git repo, which is then served up by an API, and so that API can be queryable by Nuxt itself. It can also be by our CLI, but it can also be used by other utilities. For example, there's a great Visual Studio Code plugin or extension called Nuxter, and Nuxter is able to query the dataset and install modules for you in a UI, which is quite useful because, again, we have this sort of ecosystem. So it's not just that you're distributing things on your own, but the things you create are discoverable by others and installable more easily. We also, particularly with Nuxt 3, we worked hard to create an SDK with Nuxt Kit. The idea being that if you use, so rather than use really low-level utilities that hook deeply into and require understanding of the Nuxt build process and build tool itself, you can use utilities that are semantic and geared towards the purpose that you're trying to do. Something like add component, if you want to add a sort of available component in a user's project. That means that if we change the implementation, your code doesn't need to change. It can just stay the same. The same is true, for example, with add build plugin. So if you are, for example, adding an unplugin, which has methods for Webpack and Vite, if you just add it with add build plugin, then when RSPack comes along, you don't have to change your code because, again, the SDK is going to take care of handling that additional bundler integration for you out of the box as unplugin adds support. So that kind of approach where you have a semantic helper and you have this library of useful sets of tools that module authors can use, we hope will make Nuxt modules useful for the future, like far beyond the actual intended lifespan that people might have had in view when they were created in the first place. So I thought I could just very, very quickly show you what that looks like in practice. Not a huge amount, but just what it might feel like to build a Nuxt module. So this is a new Nuxt project. It's not got a lot going for it right now, so there's nothing really there, although I have fired up the dev server. To create a new module, so out of the box, Nuxt will look in a modules directory. So if you're creating a new local module and you just want to test something, you can easily create a module there and add some code to your project. So in this case, we'll just create a new module and call it ViteConf. And I'll just show you how we might override something. We'll add a component in this case, and we'll create we'll create the component here. We'll create runtime Nuxt welcome.view. So out of the box Nuxt ships with this welcome component, which looks a little bit like this. Well, this is it, although it's highly zoomed in, so it might not look exactly like this on your screen. And we might want to override that in our Nuxt module. So we're going to resolve it first, runtime Nuxt welcome.view. And we're going to give it a name. It's just going to be called Nuxt welcome. And we're actually going to give it a priority. Resolve. We're going to give it a priority so it overrides the default one. And so that should be good. Now we might need to restart the server using bun in this particular case. And we should find that we now have overridden the default Nuxt component, Nuxt welcome component. In fact, you should even be able to see, let's see, do we have, yeah, so it's now pointing to a different location. And so that is quite a simple module to be able to add. And we might add a few more things. So we have great type support for modules. So we can, for example, have some default options. We might have enabled false, and we'll just get the options here. So we'll find that we, for example, if options enabled, return. So we might do something like this. And in our Nuxt config, we should be able to do something like this. ViteConf, so we'll have, again, type support for it, and then we can decide whether or not it's going to be enabled or not. So obviously, it wouldn't be as simple as that, but you might be able to, again, add some really nice, simple configuration of your module. So you might be able to have something in your Nuxt config, which defines the configuration, like an API or base URL or something like that. And then in your module, you're able to abstract all the code that deals with that integration very simply. Now, in this particular case, this is a local module that we've created. You might want to add one more generally. So we actually have Nuxi support for that. So you could just add a module, a Nuxt.js Tailwind CSS or something like that. I actually want to show you an unreleased feature. It's going to be in the next release of Nuxi, but we're just going to add module add Tailwind CSS. This is an integration, and it will probably have to install it. Yeah, so forgive the momentary fetching from npm. And actually what it's gone ahead and done is it's queried our module database, which we have on that Nuxt modules repo. It's identified that our Tailwind integration is called Nuxt.js Tailwind CSS, but it might be called something else based on your, so if you're publishing a third-party module, for example, it might be your own scope. And it's basically installed that for us, and it's also changed our Nuxt config now. So we actually now have the module in our Nuxt config, which means that that's all we needed to do in this particular case. You might find that if we were adding some outdated module, you don't need a module for Axios anymore in Nuxt. It will give you a bit of a warning again from the API to tell you that that's not something you want to install. And yeah, we don't want to install it. But it's as simple as that. Add a module integration from some kind of external source, someone else's module. But if you're installing it yourself, you just have to add it to your own modules directory. We might do something else. So we might add that build plugin I mentioned. So we could just use create unplugin. Oh, we will be able to do that here. I would recommend actually installing it as a dependency. But just for now, we can create an unplugin and actually just do something like this. So we're creating an unplugin, and we might want to have a transform, and we are simply going to be able to replace something there. And again, forgive the simplicity of this, but you could do any amount of things. we're going to replace welcome to ViteConf with welcome to ViteConf 2023. And what is it complaining about? Oh, it needs a name. I'm going to call it, name is super advanced plugin. And we should be good to go. I might have to restart the server. Yeah. Notice that our Tailwind module has kicked in, and so we're getting some nice default styles from there, which is great. But let me just quickly disable the Tailwind module because it's listening on a different port and I haven't forwarded it in this particular container. There we go. Although I think it might have been auto-forwarded. Let's try that again. I'm not sure exactly what's going on with the port forwarding, but you can see that the actual HTML code is coming back correctly as welcome to ViteConf 2023. Let's try opening a new window here. Yeah, forgive the port forwarding issue. But basically, you can see the next module is adding that transform. And it's done it in a completely extensible way. So whether you're using Webpack, whether you're using Vite, which obviously we hope you will be, whatever it is, it should just work. So I hope you'll build your own integrations, whether it's something like this one, which is incredibly simple and useful maybe in a particular project, or whether it's something that is distributable on the Nuxt API and you use and other people use. I really hope that you are in fact able to build a module and use it. If you're interested in doing anything else with Nuxt, feel free to check out the documentation on nuxt.com. You can also follow Nuxt on X, Twitter, or on Mastodon. And we have a Discord server, which is pretty active, and I'd love to see you there. And of course, you should feel free to contact me any way that would work for you. I would love to hear from you. It's been a real privilege to talk, and looking forward to some of the other talks later on. Thank you so much.
Hello everyone, my name is Minko Gechev. I lead developer relations and drive the product roadmap for Angular. In this talk, I'll share with you how Angular CLI abstracts the build pipeline, taking advantage of Vite and ESBuild to make your app builds as optimal as possible. Before I go there though, I would like to set some extra context. I'll share with you some of the latest improvements with it in Angular, which set really high standards for our tooling support. Since the very beginning, Angular's runtime has been designed to be well optimized for a JavaScript virtual machine with a lot of micro optimizations in mind. We have a custom compiler which ensures that it translates your Angular templates to optimal JavaScript instructions, taking advantage of JavaScript virtual machines inline caching by using monomorphic calls. But the change detection is still global. It operates in a similar way as React. Currently, by default, Angular will check your entire component tree for changes every time the browser's microtask queue is empty. In Angular, we have a way to optimize this, which is really similar to should component update in React or React memo. and in Angular it is called onPush. It enables Angular to skip parts of the component tree and speed up change detection, but it also requires some manual intervention. You need to figure out which parts of the component tree make sense for onPush, and you need to enable it. We can definitely do better and make developers' lives easier. Only if Angular had more fine-grained knowledge about where the data lives and how it flows throughout your application, it could do way less work. In a more reactive system, Angular would only have to check the specific components it knows have had data changes. The team explored the reactivity space in depth and compared the different approaches in the context of Angular. We looked at hooks, but we discovered that, well, they operate in a very similar way and they have very similar limitations as the current system that Angular offers. We explored also compile time transformations, which enable reactivity at runtime. Angular has been having a compiler since the very beginning, so we thought that this is a very natural fit for Angular. We are looking into extending this compiler so that we can add static dependency tracking similar to Svelte. However, we decided to not go this direction because, well, this adds some extra magic, which could also impact the debugging experience for developers and also just changes existing JavaScript semantics. We also explored signals, and well, we did a lot of prototyping, a lot of investigation, and we finally concluded that in this world, the world of JavaScript and Angular, well, the best fit is signals. Here is how signals work in Angular. First, you're going to wrap your data as a signal. You can read the values of your signals directly in your Angular templates, and this instructs Angular exactly where the signal value is being used, so that later on, when you set the signal value, we can go to your template and update only the part of your template which is dependent on this changed value. This makes everything way more efficient and also requires some more advanced tooling in the build pipeline to enable integration of Angular with the signals library so that we can have this fine-grained reactivity. Another feature that I'm really excited about that we have been working on is called deferrable views. In deferrable views, you can specify what part of your template you'd like to lazily load. Here, the framework is going to extract the segment of the template and all of its transitive dependencies as a separate JavaScript chunk, which will load lazily or be prefetched on a specific condition. In this example here, we're only going to eagerly download and hydrate the components outside of the deferred block. In this case, this is the app component and the navigation component. Everything else will be just loaded later. And here is how this looks in code. This new feature uses a brand new template syntax for Angular. It may remind you a little bit of Svelte or Mustache.js. We still haven't finalized the syntax yet, so we're making some research now, just collecting data from the community, just to make sure that we're making the right choice for everyone. In the template, here we have 3 blocks. The main part of the deferred template is what is going to be lazily loaded once it enters the viewport. Notice that we have declarative way to specify when we would like to lazily load this. We're instrumenting an intersection observer here declaratively without any custom logic or any JavaScript. Next, we're adding a loading indicator. And finally, we're adding an error block, which will display if the deferred loading fails. So if you're doing this manually, there are going to be a lot of moving parts and a lot of opportunities to make a mistake. This declarative way to specify the deferred view and also when it should be prefetched and how, well, it sets some really high standards and really high requirements for the build toolchain because, well, it includes a prefetching heuristic, in this case, the intersection observer. It also involves extracting the deferred part of the template into a separate chunk together with all of its transitive dependencies and tree shaking this all. All right, now you might be thinking, all right, we have signals and deferrable views. How do I even configure my tooling to support all of this? There seems to be a lot going on there. we're compiling templates of components to JavaScript instructions that interoperate with signals. And we also have deferrable views, where we need to extract the view into a separate chunk while also tree shaking this entire bundle. Well, one thing that is still unique for Angular is that the core team at Google developed a CLI, which makes your life way easier. Pretty much the Angular CLI abstracts a lot of the complexity out of your build pipeline and the overall development process. It pretty much abstracts the functionality for creating applications, building these applications, updating your applications to the latest version of Angular, and translating your applications to different languages, plus way much more. Since we're here at ViteConf, I'm going to focus specifically on our build pipeline. So we want to ensure that your production builds are as optimal as possible, which includes both bundle size and runtime optimizations. Traditionally, the ng build command has been delegating the execution to Webpack to bundle your project. As a next step, we developed a build optimizer which traverses the abstract syntax tree of the chunks that Webpack produced and annotates them for advanced optimizations by Cursor. Finally, we pass these chunks to Cursor to compress them. There is a lot going on here. We're compiling your Angular templates, styles, TypeScript files, and also we do a bunch of file replacements and so much more. This is a lot of complexity. As you can imagine, the Webpack configuration grows very rapidly, and we'd like to just hide this complexity for developers. You don't want you to just have to deal with fine-tuning your build config. We'd like to just enable you to focus on building applications. So abstracting all this under a single command also enables us to introduce a lot of performance optimizations under the hood in individual Angular versions. Let us look at how we started gradually introducing Vite and ES builds in Angular over a year and a half ago. One optimization that we did was to replace our build optimizer, which was very much a simple compiler that we maintained, with a just Babel transform. This made builds already 10% faster, and it required developers to just run ng updates to take advantage of this optimization. Another improvement we did is in the compression part. We introduced ESBuild right before Cursor. Cursor is still there, but ESBuild is significantly faster than Cursor, so we can just delegate most of the optimizations to ESBuild, and for the more advanced optimizations that ESBuild doesn't have yet, we're passing still the JavaScript chunks to Cursor. This already improved the build speed with another 10%. Now you see the value in abstracting the build command with the Angular CLI. Asking all the millions of developers using Angular out there to update their build pipeline so that they can enable these two optimizations, this will be challenging. It will be years until developers switch to these new build improvements and also configure them properly. Also, they don't really have to think about it. We're abstracting the build pipeline in a single command and everyone just gets faster builds after running ng updates. But now let us look at the more advanced refactoring of ng-build and ng-serve we did recently. We released the developer preview of our ESBuild based build pipeline, which entirely replaces Webpack. For experience during development, we use ng-serve with Vite because of its fantastic properties that enable really fast cold start. Let me explain a little bit more about this. If you look into an app with server-side rendering, we'll see that the ng-build command calls the Angular and TypeScript compilers directly to type check and produce JavaScript for both the client and the server. From there, we pass the entry points to ESBuild, which knows how to produce the final bundles using the output optimized by the build optimizer. This enables further build bundle size reduction thanks to the annotations that the build optimizer does. After switching to ESBuild, Vanguard observed over 3 times faster production builds for one of their applications that has over 100,000 lines of code. We're planning to make this new pipeline the default one in the next couple of major versions. All right. A place where we benefit a lot specifically from Vite is the ngserve command. For our development server, we use Vite. We add a plugin which enables us to add custom logic into the response resolution. And based on the type of the request, we have a couple of different options. The first one is to render the page in the server process and return the response. This is just the Angular server-side rendering. Alternatively, if the request is for a static file, we just read it from the disk and return it. Finally though, if there is a request for a JavaScript file, we take advantage of the lazy bundling that Vite provides. The initial bundle that's needed for the rendering of the page is pre-bundled so that we can reduce the number of requests when developers open the application for the first time. We don't really want to have this waterfall of the entry points and all of its dependencies, transitive dependencies over time. We want to build everything together and provide it as a single JavaScript file. However, for all the transitive lazy loaded chunks, while we use lazy bundling, we're not bundling them when the developers run ngserve, we're bundling them once they're requested for the first time. This enables fast cold start for ngserve, also very quick page loads, and incremental bundling of lazy transitive dependencies, thanks to Vite. There are a few things I would like to mention closing this presentation. The goal of Angular is to provide you with support for every part of your development process, just holistically. Internationalization and accessibility, they're not optional, but they're hard. We just want to make them easier for you. Angular strongly believes in these abstractions around complicated web development practices, such as build, and I already mentioned internationalization and accessibility. We want to make them abstract. We want to provide you with the best defaults so that we can enable them easy in your development process and make them simpler. We're only able to do that thanks to fantastic communities, just like the Vite community, which enables us to evolve the internals of the Angular CLI and make the builds orders of magnitude faster, thanks to the tooling you folks are building. And last but not least, well, to take advantage of all of these improvements in your existing applications, just make sure you ng update. The ng update command is going to update all the packages, the build pipeline. It is going to run code transformations over your applications to make sure you're using the latest Angular APIs and update your npm dependencies. This is everything I had for you today. If you have any questions, you can find me on social media at mgechev. And thank you all. Thank you for listening. I really appreciate it. See you next time and happy coding.
This is Analog, building an ecosystem of ecosystems with Vite. My name is Brandon Roberts. You can follow me on Twitter at Brandon T. Roberts. I tweet out GIFs, I talk about sports, about people sometimes. That's just what we do. You can also find me on YouTube, having fun with web development and open source projects. I am the creator of Analog.js and a maintainer on the NJRX project. I'm also a Google Developer Expert in Angular, which just means I've been around the community for a while, so I've been able to do some things there. And also work as the engineering lead at OpenSauce, where we're helping developers and maintainers along their open source journey. So for this talk, I want to talk about Vite and kind of in where we were when I talked about Analog before. We'll also talk about like where Analog is and how Vite and the ecosystem came and helped Analog along this journey. And also talk about contributing to Analog and open source for those that are interested. So first we'll get into Vite and kind of get where we were, the landscape of the web ecosystem, and where we were when we talked about this at ViteConf last year. So there are many projects in the Vite ecosystem that have come along and have, they mentioned before, that have mass adopted Vite, such as Astro, React, Solid, Vue, and Nuxt, and even SvelteKit, and projects like Quick, and Playwright, and Vitest, and more. And other projects such as Redwood.js have also joined in here. And last, when we talked about this before, we were talking about how Angular was trying to get into the mix, into being incorporated as one of the projects in the web ecosystem that's taking advantage of Vite also. So we kept moving along, and Analog shipped integration with Vite, and also Angular has come along and integrated with Vite also, as I'm sure Minko has covered in his talk. So along with Analog, let's see where we were back then. So with Analog, talk about where the project was, and how do we get here from going to just having the idea of having Vite and Analog together to having a meta framework built for Angular that on top of Vite. So there's a few things, and this kind of goes to the main point of this talk, is around ecosystems. Analog uses a few main ecosystems to integrate with the rest of the tools that are out there. The main one being Angular, because we're built on top of Angular there. Vite, which is the underlying build tool. And like I mentioned, the Angular CLI uses Vite as a dev server, and Analog takes that kind of the next step and adds some more things there. There's also Nitro, which is a server framework that I'll kind of get into that helps integrate a lot of some of the other pieces there. There's also NX, which provides some of the tooling and infrastructure that I will use in Analog and can be used in other open source projects. So we'll get into the ecosystems that were in here that I mentioned, and kind of talk about the building blocks that go along with those. So with Angular, there were a few building blocks that had to happen even before Analog was able to become a reality. One of those being standalone components that we got in Angular version 14, which helped launch things such as file-based routing and other integrations there. Also support for ESBuild, which Vite also uses in its tool chain to build their Vite projects. The big shift that has happened with ESM, along with the ESBuild movement, ESM has played a big role in this. And even upstream in Angular, the improvements to the server-side rendering story in the framework itself has definitely improved and opened up a lot of possibilities in Analog. So on the Vite side, we initially created a Vite plugin that ties the Vite model together with the Angular compilation, so that we can have an integration there to be able to use the plugin to open up lots of other opportunities and possibilities with the two together. One big feature in Vite that is used is dynamic imports. And this is used with Markdown and the file-based routing. So we're collecting these files off the file system and building these dynamically to use with the file system-based routing. And also using the Markdown plugin to transform some of the front matter from these files when we're using these Markdown files as content routes. And there's more to that there, but that's just a small part of the integration between Analog and Vite that opens up these other possibilities. Nitro is a server framework maintained by the UnJS organization, which maintains a lot of utility libraries that help you build around this server framework. And it has a lot of features such as server rendering that you can use with a custom renderer based on your stack of choice. Also has support for pre-rendering pages to static HTML. Has support for many different deployment targets, so we can build in a consistent way and target many different places. API routes are also supported, and it also uses a file system-based routing approach with these API routes. And it's also very extensible in that you can plug in into many of the areas of the server framework and customize it to take advantage of that functionality. Then there's also NX. NX is a smart, fast, extensible build system that has lots of features such as generators. You can use these for applications, or we're using these to generate new analog applications, and also to generate routes inside of an application. Also using executors for Vite and Vitest, so that we can tap into these existing projects and not have to maintain so many of these pieces ourselves. Another thing that is very important is automated migration. So if we upgrade to a latest version and we need to change some configuration or update some properties in the project, we can do that also. And presets to give you these options out of the box, such as Tailwind or TRPC and other options there. So that brings us to where we are today with the set of analog features. As I mentioned before, using file system-based routing, also using server-side rendering, static site generation, API routes, and also server-only data fetching. So for the analog file system-based router, as you can see in this diagram here, we support many different layouts, including grouped routes, dynamic routes, static routes, even pathless routes, and you can tailor this structure to the needs of your application there. Analog also supports server-side rendering through ngserve, and SSR is enabled by default. Platforms such as Node and Edge are supported, with many different deployment providers supported out of the box, such as Firebase, Netlify, Vercel, Cloudflare, and more. Static site generation is also enabled, where you can run ngbuild and have your set of routes for pre-rendering. You can build this list of routes dynamically or statically. And we also have an API routes, which is popular in other meta frameworks, and these are also defined using a file system-based syntax, where you can use a server routes directory for products, and it gives you an API route /API/products, and server-side data fetching. And this is also defined alongside the page routes, and you can define these page endpoints to fetch data on the server and transfer it through the client, and integrates in with Angular's HTTP client. So for the server-side data fetching, you can define a load function inside the server file, and it can accept params and also receive things like cookies and headers, and return serializable data back to the client. And in the page route, you can consume this loaded data, whether you're using the component input bindings with the Angular router. You can also inject this as a function and use it with signals. As I mentioned before, the main thing that we're building around is ecosystems. So with analog, we're bringing the Vite ecosystem along with Angular that is also starting to use Vite also. And this also expands into other areas. With Astro, you can use Angular components within Astro projects. So there's also a project that has started where you can use Angular components in Quick. And like I said, we can tap into the existing ecosystem of projects that have support for Vite, such as Vitest and Playwright, and even Storybook that offers Vite support out of the box by default. And we're also expanding into other areas, such as the Spartan UI and Stack, which is started by Robin. You can see the nice logo here, and find out more information about that project at the link below. So of course, every open source project needs contributors. So to get involved with contributing, you can contribute through GitHub issues, through documentation, pull requests, or if you want to sponsor the project and partner with us going forward. I mentioned before, we have also have team members on the project. Robin, who I mentioned before, with Spartan UI, and also Marco, who has contributed to the NGRX project, also a maintainer on the NGRX project also. And on the community side, we're definitely growing contributions. We have 60 plus contributors. We've reached over 1,500 stars on GitHub. Analog got accepted into the first GitHub Accelerator cohort, which gives maintainers tools to eventually move into open source work full time. Our Discord community is also growing, and you can follow the Analog.js project on Twitter. You can learn more about Analog at analog.js.org, and you can create a starter project at analog.js.org/new. And if you want to get involved with the project, you can go to our GitHub page and find out more about the contributing information there. And if you want to partner with Analog, you can visit our sponsor page and partner with the project to help us continue to move this project and ecosystem forward. So to recap, we talked about Vite and where we were when Analog started, talked about where Analog is now, and where we're going with the project in the future, how you can contribute to Analog, and the contributors who have helped us get this far. Thanks.
Hi, I'm Danny from the Redwood core team, and today I want to introduce to you Redwood.js, the full-stack web framework designed to help you go from side project to startup. A solid developer experience is at the heart of Redwood.js, whether that's the speed of Vite, the power and flexibility of a GraphQL API, or tests and mocks that are integrated seamlessly. We neatly integrate all of these tools so you can focus on building your product. This helps you ship faster, but not only get to market quicker, but make sure that your code base stays maintainable. Let's jump into some code and explore how Redwood lets you do this. Today, we're going to use the simple recipe app to explore some of the features Redwood has. Over here on the right, I have my dev server running, and we can look at the code structure of a typical Redwood app. So this is the landing page, and I have it open here. And you can see inside here, there's the hero header. And underneath, there's the recipe cell. What is a cell? A cell is a declarative way of fetching data in Redwood. We'll come back to this later. Let's take a deeper look at the folder structure within a Redwood app. Now, Redwood apps have two main folders to start with. These are the two sides of a Redwood app. There's the web side, which houses all of your front-end code, and you can see that Vite is configured here. And we have the API side. Jumping inside the source for web, we see there are components, there's a layouts folder, and a pages folder. This is where a landing page was before. Each of the components that you generate with the Redwood CLI always generate tests and stories with it. Jumping into the API side, we have the GraphQL folder, where you define all of your schema definitions. So this is where you're telling GraphQL what can be fetched, what type of data can be fetched. You also have the functions folder where you define all of the API functions that are available. And you have services where you define how to retrieve data from your database. Let's build a feature back to front. Today, what we want to do is build a category slider that sits on top of the recipes here, so that when we click it, we can filter what recipes get shown to the user. To do this, we're going to jump into API-DB schema.prisma. This is where you define all the models on your database. You can see here we have the category model, and I have the ID, name, image URL, and a relation to the recipes. On the recipe model, we also have a relation that says, this is how the recipe is related to the category. We can now start building. Since we have the model already, what we can do is use the Redwood CLI to generate a bunch of the plumbing that you would need. To do this, you run yarn redwood generate SDL, because we're building back to front, the API first category. You run this and it'll generate a few files for you. Inside GraphQL, it's generated categories SDL. This tells the GraphQL server what data is being returned. You can see here that it's also added a couple of directives to make sure these queries are secure. We're going to go ahead and make them skip auth because we don't want to think about auth right now. It's also generated a service. So this is how it retrieves the data when you make the query. So when you make the categories query, it goes to the categories service and retrieves it from database using Prisma. When you make a category by ID query, it will go to this service and retrieve it from the database. That's our API side ready to go, and let's check it out in action. I'm going to head over to localhost 8911 GraphQL to the built-in GraphQL Explorer. And what we're going to do is add the categories query. Let's get the ID, the image URL, and the name. And we'll get rid of this section. And when you query it, you see your categories coming back. Next step, let's start building the front end. Let's close this off. We have our API side generated, our models are ready, so we can now start generating components on the front end. Like we talked before, in Redwood, you fetch data using a concept called cells. Let's generate a cell. The pluralization here is important because we want to fetch all the categories, not a single one. Run this, and it generates 4 new files for you. Inside web source components, you'll see category cell. It gives you the cell itself, which is a declarative way of fetching this data from your API. So here, it starts up with just the name, but we can give it more. And you can see TypeScript is helping me write this now as well. We can give it image URL, and we don't want the recipes in the categories query. We also have these loading, empty, and failure states. So these are the common states that your app can get into when it's trying to fetch data. I don't know about you, but I despise writing glue code, especially when I have to repeat myself over and over again. So we're going to go to the landing page, head over here, and we're going to add our cell in. Categories, cell. And let's import it from source, components, category cell. Once you've done that, you can see the data is coming back. Yes, it needs formatting, but the data does come back. Let's move it up one level, and you can see it's here. Weekday dinner, the same data we saw earlier. Next up, the UI. Let's open up the category cell and have a look inside the folder there. Next to it, there are stories that are automatically generated for you. This has all of the states that your cell can get into, the loading, empty, and failure state, and of course the success. Let's see this in action by running yarn redwood storybook. You can see here that it gives you your cell with all of the states, as we see in the code here. It's already plumbed for you. But where does this data come from? The IDs. That comes from the mocks that are also generated for you. Let's replace this mock data with something that's a little bit more realistic. Let's paste it in here. And we'll see this data now comes back. Let's fast forward through building the UI, shall we? You've built your UI. The only thing that's left to do now is to go back and add it to the landing page. I've done this part also just because it's a bit of styling. Here, I had my categories there, but I said when on click, I'm going to update the category that I'm passing to the recipes cell. And once we look at the UI, it's there. It's all hooked up. Last but not least, let's look at the tests. So the CLI also generated these tests for us, and it gives you the states like we saw in Storybook. But inside the success one, we can see that it's loading the mocks, the same mocks that we used earlier in Storybook, and passing it to success. In this way, you're writing your mocks not only for UI development, but also for your tests. Now, when you run Redwood test web, and let's make it categories cell, these tests are very simple that it generates, but it gives you the pattern for you to follow as you build your app. Part 2. We've seen how easy it is to get started with Redwood. You can build your product quickly, but in a maintainable way. You've been writing all of those tests. Maybe you even have a mobile app running off the GraphQL API. Maybe you have a few thousand users using your app. What about tooling in those sort of situations? We have a few more tricks up our sleeves. Let's take a look. Back to our recipe app. So you've deployed your app. Your users are happy with the cool new recipes that they can read. But some of them are complaining when you go into a recipe, it takes a while for it to load. Let's open up the Chrome Network Inspector and see what's happening. It's probably the GraphQL request, right? Looks like it, because it's taking about 5 seconds for the find recipe query to load. To debug these sort of situations, we have a brand new tool called Redwood Studio. Run yarn redwood experimental studio. It's under the experimental flag while we dot our I's and cross our T's. This will launch a UI where it's going to show you traces of what's happening within your Redwood app. Just as a note, I also have OpenTelemetry set up on my dev environment. Let's refresh this page. And we're going to see the requests starting to get populated here. Let's go over to the Traces tab. And now we see our find recipe query. And we can see that it's taking about 5 seconds to load. Let's dig inside it. And if we follow this graph down, we can see that this particular function, get product recommendations, is taking 5 seconds to load. Let's go back to our app and browse a little bit so that we collect some more data. When we go back to the traces, we'll see all the requests that are coming through. Let's look at the categories query we built in the previous section, and we can see how long each individual result or each individual field is taken. Not only that, if you scroll down, you'll be able to see the actual SQL statement being made. This is often very helpful as your app gets much larger, much bigger, and your Prisma queries get bigger and bigger. This is where you might identify some performance bottlenecks. Let's now go into our trace. This is the query where we were seeing the delay. We know this comes from the recipe service. Let's open that up. API source, services, recipe. This is our recipe service, and we can see this function here. This function is calling an external API, so there's not much I can do about speeding it up here. But maybe we can introduce caching. Let's do that now. Let's launch another terminal window. You guessed it, another command, yarn redwood setup cache. And we have to give it what type of cache you want to set up. In this case, we want to set up memcached. When you run this, it's going to add a few dependencies. It's also going to create a new file, source lib cache. And you can see here that it's creating a new memcache client and connecting to my host. On my local machine, I have a memcache client configured, but you can also choose to use an in-memory client in the meantime if you wanted to. Now, let's go back to the offending function. What we want to do is wrap this function in a cache call. Let's comment it out. Let's create a new const products, and we're going to wait the result of a cache. You import this cache from source lib cache, the new file that just got introduced. You have to give it a cache key, which for now we're going to say it's just the recipe ID. Maybe we want to be more specific. And inside here, we want to return the product recommendations. The next thing we can also do is we can give it some options. So we want to configure the time to live for this cache. Expires, and let's say we give it something small for now. 10. Let's remember to restart our dev server. And when we go back to the UI, pick a recipe. The first request is going to take a while to resolve because the first request, it's still going to cache. But when you refresh from the next request, it's almost instant. And remember, we used ID of the recipe as the cache ID, which means if I go to another recipe, it's going to wait for the request to come through and then populate the cache. But if I refresh the same one a couple of times, it's still using the cache. Because we set the expires to 10, it only takes a little bit of time for the cache to expire. You have to decide what the right value based on your request is going to be here. But let's not pretend that caching is easy. There's a whole section in our docs where we talk about what can be cached, choosing a good cache key, and of course, testing with caching. And this is true for all of the features that we provide in Redwood. We give you detailed documentation, guidance, and recipes for how to best use all of these APIs that we're providing. That was a brief preview into what you can do with Redwood today. but we have so much more to come. In V6, we made the migration from Webpack to Vite. And going forward, we're looking at features such as server-side rendering with streaming and suspense, enabled by React's new architecture. And further down the line, we're also looking at React Server components. Thanks for exploring Redwood with me today. We talked about the API and the websites, the CLI that gives you superpowers, tooling and testing, and how it neatly integrates into your developer workflow. We briefly touched on experiments, but we also provide in-depth upgrade guides between versions. We give you patterns in our documentation and in videos like this. And we have a very active community of developers like you who are helping each other build something great. Put that all together, and that's Redwood.
Welcome to ViteConf, Tom. We're excited to have you here. Thank you for being here. Before we kind of dive in, I think that you need no introduction, but just in case for everyone watching, Tom is the founder of GitHub. He's the creator of Jekyll, most recently Redwood.js, which y'all in the Vite community are probably familiar with, and also a handful of other things that you've created over the past decade or two here. And so I guess maybe to kind of kick us off, Tom, maybe you could kind of just talk about how you got into the web development world and just maybe start with, I think you're originally from Iowa, right?
That's right.
So
yeah, absolutely. I am
West.
Iowa. Yeah, I grew up in Dubuque, Iowa, right on the Mississippi. And my entire goal in high school was to move out of Iowa. So I didn't even apply to colleges in Iowa. I wanted to go coastal, MIT or Caltech or something. Well, I ended up at Harvey Mudd in California, but that was sort of the start of my journey. I'd always been into programming since I was a kid, since I was probably 10, as well as electronics and physics. I actually went to school for physics, decided it was too much math, thought I could change people's lives more quickly with programming. So that's the direction I went. I dropped out of college to join a startup. That one didn't do very well. Ended up working for myself for some years. That's where I invented Gravatar, the global avatar thing that WordPress owns now. I'd always been into computers. I always loved the idea that I could write text and a computer would do my bidding. It was just blew my mind. Right. And so getting into web stuff is pretty natural coming from computers as the internet evolved and the World Wide Web became a thing. And it's just amazing what has happened in our lifetimes that we have gone from literally no internet to what is today, how computers work and, AI and everything. It's just mind blowing to me. So fascinating. But yeah, I got into programming in college. I wrote Perl, then I wrote PHP, then I wrote Cold Fusion for a little while, and then Ruby on Rails. And that was really where I discovered true joy in programming.
Awesome. Yeah, and then we're actually a Rails stack at StackBlitz as well. And I think GitHub was very that GitHub had a huge impact on the growth of Ruby on Rails, in the late 2000s, early 2010s. And so actually back during that time, like when you were building GitHub, you wrote this blog post called Blogging Like a Hacker, where it effectively you kind of described it. For those of you watching that haven't read that blog post, I highly recommend reading it, kind of rewinding to 2008, because it was effectively, Tom wrote about how he came up with the idea for Jekyll, which was really, as far as I'm aware, one of the first static site generators, right?
It was one of the first. It was the third. There was one or two that I looked at and I was like, that's an interesting concept, but we can do better. So it was not maybe the first.
Yeah.
It was very early.
It was the first mainstream one though, right? That really had a lot of adoption. And that was a pretty big deal because,
fast forwarding over the subsequent, decade and a half since then, static site generators, are used everywhere. Like they're, a very common thing. And so I'm kind of curious, like, I'm curious about like, kind of at that time, and I guess even looking back on it now, what's kind of your thought on, like what happened with Jekyll and like static site generators and kind of how that's evolved to today?
Yeah, well, we were building out the GitHub Pages functionality at GitHub, and that concept of being able to just commit to a Git repository and then have the contents there sort of reflected into some hosted website thing, like that, I think was the real kernel of it, right? Because people were kind of asking about how they might get files up on GitHub and like host them there, and they're like, could we FTP files up to GitHub and then you could like publish them as a website or something? Or we were like looking at that concept and we're like, wait a second, why would you FTP them? You could just put them in a Git repository and then, like that's what we do. And so we had that realization, and that became the kind of, pub push to deploy paradigm that is now so prevalent. And it's really a delightful mechanism. And I love that so many people use that. And so that's what Jekyll was, kind of this additional thing on top of GitHub Pages, where every site was treated as a Jekyll site if you did it in the right format and you had the right folders. We'd transform it for you, and you could have a blog or anything else you can do with Jekyll. So it was, that's why Jekyll is popular, I think, not because it on its own would it have been as successful as it was. Probably not. It was combined with the concept of push to a Git repository to then be able to publish an entire website online and have it be static, right? So it's super fast, it's secure, etc. All of that came along with it. And meanwhile, you're not going to ever lose any of that content because it's in a Git repository that's on GitHub. And that's what that blog post that you reference really talks about. Is I was tired of losing all the content of my previous blogs that were in some WordPress or the movable type or whatever we were using back in the early 2000s for our blogs. I'd have them spun up somewhere and then they'd get deleted because I'd stopped paying attention to it for a year, and whoever was hosting with, the credit card expired and they just delete everything. And I was like, crap. Right. So that paradigm, and that then led into what we now call sort of Jamstack, right? This approach of pre-building, having statically delivered content and then enhancing it with APIs, JavaScript, et cetera. So it's really a fascinating story there, and I'm so happy to have been a part of that.
Yeah, and that's what I was going to say. Is that idea of like what you were just describing of pushing something to the repo and then an action gets triggered to do a deploy or something like that. That I didn't even realize that aspect of it. That was prescient, because when you look at, speaking of like Jamstack, like if you look at what Netlify really added, and you're one of the investors in Netlify as well, right? Yep. Where they really took that to the next level, where you got to have this continuous deployment happening as you're pushing to a Git repo where it's static, and even adding in kind of dynamic with like lambdas and edge functions and that sort of thing. But that really is all built on what you and the early team there at GitHub kind of landed on with GitHub Pages and Jekyll, in my view. Like that's kind of transformed how all this stuff works, which is super cool. I don't think a lot of people realize that. That's pretty mind-blowing.
Yeah, Netlify kind of started as like an amped up GitHub Pages, really. It was like doing very similar things, but it made SSL possible. Like that was something that we weren't doing well on GitHub Pages at the time. And just the performance and scalability of it was higher. And you'd use it for real commercial things, where GitHub Pages, we were never like, build your actual real business on GitHub Pages. Like that was never a recommended thing for you to do. Netlify just sort of elevated it to the next level, and then coined the term Jamstack so that everyone could think about like, what is this new architecture? What can we do with it when we think about pre-rendered static pages and using JavaScript as sort of either third party or your own APIs that you're now consuming from those static pages. And then you get React involved, right? And you can statically deliver a whole React application and have that be talking to some backend database. Like it really created this awesome path for a new way to do things. Ironically new, where it's kind of like, is it new? Because it's really a throwback to just like a bunch of static files on an Apache server, like we used to do in the 90s. So everything old is new again, but we always are adding our, some modern little spice to it. And I love that about technology, is we're always building on each other's ideas, and we're always experimenting and expanding the sort of the boundary of what we know how to do, and everyone's discovering the edges of that frontier.
Totally. And okay, and then to that end, your latest project kind of in the web space is Redwood. And this has been something that's been growing a lot over the past few years, just from the outside looking in. And so I'm kind of maybe take us like 0 to 60 on like Redwood, what it is, and the problems that it's solving, and and how it's unique, and that sort of thing.
Yeah. So Redwood.js is a full stack TypeScript and JavaScript web application framework. So if you want to build the next GitHub, go check out Redwood.js. It's in the same sort of category as Ruby on Rails or Laravel. Like it sort of tries to be the full package to do everything from your database, like all the way down to the database. So it comes with Prisma as an ORM. It uses GraphQL for the front end to talk to the back end, React on the front end. We include testing with Jest. We include the ability to run Storybook if you want to prototype your components or create a design resource for that. It integrates with Pinot for logging. We have integrated authentication providers, a bunch of them. So, with one command, you can set up Clerk or, Supabase Auth or Auth0 or a bunch of other authentication providers, as well as deployment. So if you want to deploy to different places, one click and you can essentially set up all the necessary machinery to deploy to Netlify or Vercel, or to Render or Fly.io, or you could go, we have a strategy called bare metal where you can deploy directly to AWS or, whatever machine you have laying around that you want to co-locate somewhere. Most people don't do that anymore, but you can do that with bare metal. And so we try to do the whole stack, even more than Ruby on Rails does, like really thinking about like everything from 0 to a fully functional web application. What do you need to spin that up? And we want to build that framework so that more people can build more stuff faster.
And that was actually going to be my exact question, is like, especially because you've been in the Rails world, like a lot of people I talk to in the JavaScript world have never actually done stuff with Rails. And so they're not aware of how good Rails is in a lot of ways. But there's been kind of this missing piece in the JavaScript world of how fast you could move with Rails, and like the sort of things that there's a gem for like everything, right? And so it sounds like you're really building that. And so I guess to kind of like, for example, one of the things in the Rails world, in like the data layer, like active record was the staple for that, right? And so how do you see that part of this picture evolving, in the JavaScript, and even particularly in like the Redwood side? Are GraphQL and Prisma really the things that you view as here to stay, or are there even more opportunities for growth in this area?
Yeah, so we chose the components a couple of years ago, and so we made some bets, and I think those technologies are really strong. Prisma is a really great ORM. GraphQL. So the GraphQL story is interesting right now. This leads me to maybe talk about the future of Redwood, which is React Server components. So this will be my answer to that a little bit. Is GraphQL is awesome for a set of problems, but it is not the perfect solution for every problem. Right, it comes with some overhead. You have to build your SDL files. There's kind of more steps involved in the whole round trip, and that's really great. I think it's especially great if you've got multiple clients that are consuming your backend. So you can build. So one of the reasons that Redwood is architected the way it is this idea that you could have a single backend, write your business logic once as a GraphQL API, and then consume it from a React web front end, or consume it from a mobile application written in React Native or something else. It could be consumed by a command line tool. It could be consumed by anything, any kind of client, right? And you have a single backend. And I think that's a great way to do it, but it comes at the expense of a little more trouble up front. And so prototyping something very quickly with Redwood there's some additional friction. So we've been trying to solve problems around server-side rendering so that you can get a full web page delivered on the first request. This is important for SEO as well as OG tags, so it can unfurl in Twitter and Slack and other places. And in solving this problem, there was a couple of ways we could do it, but we've decided on React Server components because that's obviously the future of React. The React team has made it pretty clear that that's the direction that they're going, that they would love more people to implement that. And so by being an early player in that arena, we hope to really help direct that in a way that's excellent for developers and works really well with the concepts that exist in Redwood. One of the advantages of doing this will be that GraphQL will become an optional part of Redwood. So you'll be able to do your server-side logic, your business logic server-side without any GraphQL in the mix. You'll just talk directly to your database via Prisma, right in your sort of your cell. We call them cells. It's kind of the data fetching primitive in Redwood. And so that'll be sort of the default. But then you'll have a first-class, really amazing, really robust, great experience with GraphQL. If later on you say, well, I want to do a mobile client and I'd love to use GraphQL for that. Using Redwood to now build you the GraphQL as well as your primary application that you're just using React Server components for, that's going to be an amazing experience. So it becomes this sort of optional add-on because of the history of Redwood. But we're trying to make it a lot easier for people to approach Redwood and get started right away with their sort of weekend hack projects that then grow into startups and companies. Because that's what I'm really interested in, is people building things that matter, like startups. I love startups. I do a lot of angel investing. And I love that. So giving people this path from zero to startup, essentially.
That's really cool. I mean, and that's that is not the reason I expected to hear actually of why you're going into React Server components, but it's such an excellent reason. Which is, I mean, I think a lot of people that have been looking at this stuff, like people that have been using GraphQL, everything you said is very true. Where there's more friction. Like when you are having multiple clients, there's a lot of value in having it. When you're trying to get started quickly and iterate quickly, it actually matters more that you just have something pulled together that's functional, even if it's just like a web client or something like that, versus something that's going to be able to work across all platforms. But it's cool that Prisma that Redwood is actually already set up to have the GraphQL portions of that there, so that as you grow your app on Redwood, you're able to start and iterate really quickly with React Server components. And then as your project or company grows, you don't have to do anything more to actually set up your a GraphQL sort of endpoint to be able to do mobile or et cetera. Or other use cases where GraphQL would just be a better choice. Like that's a very eloquent kind of story as far as how people can get started with Redwood.
One more
big deal for you.
Yeah, it's super exciting. We have the work on React Server components is we have experimental versions of Redwood that you can try out today. You can go on the Redwood JS forums and you can find how to install the experimental versions that have React Server components and that use the React 18 streaming. That stuff is working. We have a ways to go still to sort of refine the user experience and exactly how you are coding everything. Just the developer experience for all of this is still a little bit up in the air, but it's coming together, and hopefully by the end of the year we'll have something fairly stable to release. But it's really exciting, and the ability to really craft what your user experience is, like that's what it's always about. And React Server components to me gives developers the flexibility to say you can get them content very quickly. It can be server rendered, but you can choose where you want to have a loader and have then the results stream down on the same connections. You're not even, it reduces the complexity. Like you're still doing the calculations server side, like the business logic is executing, but you're not having to do anything extra to ship that down once it's done. It's just part of the streaming part of React 18 and React Server components. So it's just I think it's a beautiful paradigm. I think it's going to work really well for us. And it allows us to reserve GraphQL as kind of a layer on top. Or if you can start with that if that's what you want to do. Like you don't have to use the React Server components to do your logic. You'll still be able to use Redwood the way that you use it today using GraphQL. But here's another really great point about GraphQL is once you do, like if you do go down that route where you start building a GraphQL API, you have a team that knows how to do that. So they know how to do performance and security well with GraphQL. Once you have a GraphQL API, front-end developers love consuming GraphQL. Like it's an amazing experience. It's better than having to dig through the database directly with your ORM and make sure all the security stuff is in place and you don't overfetch, whatever. So consuming a GraphQL API is amazing. And we want to make that easy too in Redwood so that at some point, even if you didn't start with GraphQL, if you end up with a GraphQL API in your cells for your data fetching, instead of just doing reaching directly for Prisma as your ORM, you're actually making GraphQL calls server side. So they're never going outside of your servers. You're just fetching from GraphQL directly in your data fetching, because it's such a beautiful, GraphQL could be such a beautiful API. So It creates there's this beautiful evolution over time.
Yeah, that is really cool. And one thing I wanted to ask, so we're at ViteConf, and so Vite is I think you all adopted Vite for the internals of Redwood. I can't remember if it was like a year ago or some time ago. And I'm kind of curious, like, what are your thoughts on Vite? What is Vite bringing to the Redwood story?
Yeah, we just recently made it the default. So in the latest release of Redwood, Vite is now the default. So if you spin up a new Redwood project, you're using Vite by default. You're using Webpack before. And we've had, this has been a year-long process to make this happen. It turns out migrating from Webpack to Vite in a complex framework takes a little bit of time and hair pulling, but we got it done, and it's just great. The reasons that we chose to move to Vite are, speed, obviously. Like, it's just an incredibly fast build tool and server, and gives us the speed that we needed. So performance, especially when you're talking about adding a lot of code on top of it. Like, the more that you're bundling, the worse that sort of we saw Webpack performance get. And Vite sort of takes care of that. So yeah, at first, the two are maybe not so different, but once you start building out your application and you've got, hundreds of thousands of components and things that you're building, it becomes a problem. Also easier to see a path forward to SSR and streaming, the work that we were doing to make React 18 work and React Server components. Doing that with Webpack was not as clear how that was going to be accomplishable. That path was more clear with Vite. So that was another big reason to do it. And there's other things, just the momentum of the software and the community around it are so great. So it feels like Vite is the way forward, and we want to be using modern tooling. So that's a big part of it. And Redwood is much faster because of it.
Awesome. Yeah, and that seems to be a common reason set there why a lot of products have been moving to Vite. The ecosystem is now, I think, one of the biggest draws, where you have great projects like Redwood that are coming in and building fantastic tooling. In the case of Redwood, like in the React sort of ecosystem around React Server components, et cetera. Having that level of collaboration be able to happen then kind of across other projects that are trying to use these things is really ideal. So it's super cool to see you all using Vite. And I think we're getting near the end of time. And so I have one question for you, maybe to cap this off, and then we've got a couple questions from folks that have been tweeting us on Twitter. So just, we've kind of, through this conversation, talked about the past 10, 15 years, that you spent in the web development world. I'm kind of curious, as you look forward to the next 5 to 10 years, how do you kind of see stuff evolving? Like, where do you think we're going to be? And it's pretty broad, but I'm curious to hear your answer.
That's a tough question. Anytime you try to predict the future of technology, you're getting yourself in a little bit of trouble. So I will say that I think one of the most interesting things, of course, is AI and how AI is going to change how we code and the level of abstraction that we code. So I think that's going to be a bigger change than any change that we see within a specific language, right? Like, TypeScript is going to continue to become more dominant. At some point, probably it will replace JavaScript, which could be very nice. Like, it's kind of annoying to have these two things that then you're like trying to support. The JavaScript, the legacy of JavaScript is quite messy, shall we say, right? We're like trying to convert things over to ESM only, and it's like a huge, monstrous pain. And I hope that we see a future of JavaScript and TypeScript that is less complicated. That would be nice, right? Like, we'd all be happier people for it. But maybe we're not writing a lot of code anymore, right? Like, we're working at a higher level of abstraction via AI. I don't know exactly what form that takes. I think right now having things like ChatGPT and Copilot are amazing. They really allow you to go faster, and they're augmenting sort of human capability. I'm not sure at what point that changes and we're writing more English than we are writing code. But I'm a little bit skeptical, because at some point you start writing so much English that you wish that you were just writing code, right? You're like, I need to be so specific to get this web page to look how I want it to look, that, like, just give me the damn text editor directly, like, just let me code this. Like, can I just code this, please? Like you're trying to convince the machine you're like, no, could you move it 5 pixels to the right? It's like, is that the world that we want to live in? I'm not sure, but I think that abstraction levels go up. So I think that there's maybe some hybrid that is like a programming language, more like what we use today, but allows you levels of abstraction that are higher. So instead of having to write all of the 9,000 lines to build a good kind of a form, right, on the web today, there's maybe some shorthand that is augmented with LLMs where you're like, let me just write like a DSL, essentially. So maybe DSLs become more powerful. And you can dip into those where it makes sense. And you can be more specific in the language that you're choosing where that makes sense. Because writing things over and over and doing all that machinery underneath is fatiguing, but at the same time, having the specificity, like that's what allows us to create new, unique things, right? If all you have access to is Lego blocks, how can you ever create an organic shape, like with smooth edges? Like you can't. It's impossible. It can't be done, right? Like you can't do that with Legos. And I think the same is true when our level of abstraction is high enough that it starts to look like Lego blocks. We forget that maybe you can create other kinds of shapes that have smooth edges. And I think there's danger there. There's danger in it limiting our imagination. So I'm not sure if that answered your question at all, but those are the things that I think about.
That is, I love that. That is an extremely rad answer to that question. And now I could talk to you for another hour just on this vein of things. But I love it. That fantastic answer. And so a couple of questions from people on Twitter for you. One is from a person named Rob Cameron. He said, ask him about his secret project Wonder Cards. What is this?
So this is a project. So I used to do a lot of electronics as a kid. I loved electronics. I loved building things. I had all these kits and stuff, but I never became, that was never a professional goal of mine. And so over the last 20 or so years, so much has happened in electronics, or 30, I should say. Geez, I'm getting old. All these things have happened, especially around microcontrollers and what we've accessed, Raspberry Pi and things like that. So about a year ago, I was like, I'm going to brush up on this stuff. I need a project to build something. So I have a bunch of Sonos speakers in my house in the ceilings, and I want to be able to control them. But I hate pulling out my phone to control these speakers because it's like I have to open up Spotify, and then I have to make sure the right speaker is selected, and then I have to choose what I'm playing. And like the whole thing takes forever, and it's mediated by this device, and I don't like that. I also don't like talking to devices. I don't like being like, hey, Alexa, could you play whatever? Like it's just weird, and I don't like have devices around listening to me all the time. It weirds me out a little bit. And I love, being a child of the 80s and 90s, I loved having a case of CDs on the wall, right? Where you could like see your music and you'd be like, I'm going to listen to this album. And you'd listen to like a whole album. Like that was cool. I like that. And so I wanted to build this device that would be a smart speaker controller, but that was beautiful. It didn't look like a 3D printed thing. And I don't actually have one here, but I can show you this. I can show you the prototype of what this looks like. This was actually like laser cut. So there's these like layers here. So it doesn't look as beautiful as the real one. But the idea is that you have, cards, and these are NFC cards, right? Near field communication cards, like you tap into a hotel with. And these are cool because you can write data to them. So if you write a URL to this, like a Spotify URL, then you tap it on this device, boop, it'll make a little booping noise. And then it'll play this album on the speaker that it's bound to. And then if you want to adjust the volume, then you can adjust the volume, because like that's the next thing that you need to do when you play something on a speaker, right? You're like, oh, I was having a party. Oh my God, I need to turn the volume down. Like if you can't do that directly, you're like, well, let me pull out my phone now. Like that's dumb. So anyway, so I built in a volume controller, and if you press it, then it'll pause. And if you press it, it'll play. And if you double press it, it'll skip. And so I did all the electronics. This is like the early electronics. Wow. This is an ESP8266. This is like the first kind of version that I made. This is the NFC card reader. This is the rotary controller for the dial there. And then things have become more sophisticated since then. So I started designing the PCB boards. So this is the ESP8266 chip that's on this dev board here. But you don't need a dev board if you can just build the PCB yourself. So you can buy this component and have that made and get the USB thing on the end. And so now I'm building a version that actually uses an 32 that looks like this. And so the ESP32 is down here. So it's a bigger chip, but it has Bluetooth on it, because one of the annoying things is provisioning these chips. You need to connect them to Wi-Fi. And in order to do that, on this one, your only option really is to connect to it as a Wi-Fi point. And that's annoying. Like, it's just a bad experience. You're like, disconnect from your normal Wi-Fi and connect to this, and then fill out your details and then disconnect. Anyway, the modern experience is to get an app and then connect to it via Bluetooth and then provision it via Bluetooth. And so that's what the ESP32 can do. Anyway, all this is to say, this is a project that I've been doing for the last year, and it's super duper fun. And I bought a CNC mill, and I have a 3D printer from before, and it's just, I'm trying to do the whole thing myself, like all the code, all the hardware, to the most practical level. I wish I had a finished version of one of these here.
It looks amazing.
The cases are CNC milled now. So this one is like a stack of layers, and this one is actually CNC milled. But it's not, it hasn't been stained or finished or anything yet. I
love the idea. I mean, it kind of reminds me of having like a record. It's like a vinyl, right? It's like a digital vinyl where you want to you pull it, you have this little stack of cards on the shelf, and you take it off, you play it or whatever,
Yep.
I like the idea. That's super cool. That's
exactly.
right.
I'll send you.
I'm blown. No idea.
I'll actually send you thanks. I'll send you a photo that you can put up right now in post-processing that shows the final version with the cards and everything, so that people understand what the hell I'm talking about.
Cool. Heck yeah. Sounds good. Well, Tom, thank you so much for making the time. This has been a lot of fun chat with you. I could chat for hours longer here. So thank you again for being part of ViteConf, and looking forward to chatting more. Thank you for being an investor in StackBlitz too.
You're welcome. And absolutely. Thank you for having me. This was a blast.
Hi all, I'm Jesseline, the DevTool engineer from the Chrome DevTools team. Let's talk about source maps today. Most of us developers have probably used source maps without even realizing it, because they work so quietly in the background. Browsers only understand HTML, JavaScript, and CSS. They don't understand Vue, JSX, SCSS, or TypeScript. Build tools like Vite transform your original source code into minified and highly optimized output that the browser can understand. Have you ever wondered how browser DevTools can show the exact line of error in your original source code and even let you set breakpoints and debug it? It's all thanks to the source map. Build tool like Vite generates source maps during the build process. These maps are then used by DevTools to map the optimized code that is served to the browser back to the original source code. This makes debugging much easier. If you want to dive deeper into the source maps, check out my blog post with a fun video that explains it. During local development, Vite enables source maps for JavaScript by default. To enable CSS source maps, which are experimental, you must set css.devSourceMap to true in your Vite config file. To generate source maps for production builds, you must configure the build.sourcemap option in your Vite config file too. If you are using other tools, do check out how to configure them properly to ease your debugging. Here is an example of a source map in JSON format. This source map contains multiple sources, some of which are third-party files that may not be relevant for your debugging. JavaScript frameworks and build tools like Vite use Google Ignore List field to indicate that these files should be ignored for debugging. DevTools then read this field and use the information to hide irrelevant file, simplifying the stack trace. In the previous console example, DevTools automatically hide all the node modules file in the stack trace, showing only the frames that are related to you. You can still view the hidden frames by expanding them, so there is no worry of missing information. Good news for Vite users. Vite already configures the Google ignore list to ignore file in node modules by default, so you get improved stack trace for free. If you want to further customize the ignore list, you can set the server.sourcemap ignore list to add more files to it. For example, if you have an assets or third-party utilities folder, you might want to ignore them during debugging. Apart from Vite, Rollup also supports the ignore list configuration. There is also a Webpack plugin for that. If you are using others build tools that don't support ignore list, you can still configure that manually in DevTools. In the console, you can right-click on a source file that you are not interested in and add it to the ignore list. The next time the file is called, DevTools will hide it automatically. In case you want to unhide it, you can easily right-click and unignore it. By the way, not only in the console, you can ignore files or even folders in the sources panel too. Ignore files and folders are grayed out. If you open an ignore file, there is a warning bar at the bottom. You can remove or open the setting to configure options like general and custom exclusion rules. Similarly, you can show and hide ignore frames in the core stack and right-click on the frame to add or remove it from the ignore list. One thing to note about the ignore list, DevTools will ignore the file during breakpoint debugging too. One annoyance when debugging is when you step into irrelevant third-party code. With the ignore list setting, DevTools knows what to skip during code stepping. Do you know the ignore list is recently available in Firefox as well? Check out their release notes to see how to configure that. Source maps are amazing. Here is a few more recent enhancements on source map in Chrome DevTools. If you don't like your page tree mixing up both your original and minified code, you can group them by authored deploy. Authored will list down your original source code, while deploy is the file that the browser reads. Also, previously you might have seen a lot of source map loading warnings in the console. Many of you find it not actionable. Therefore, we removed them from the console since Chrome 117. You can still access these warnings through the Developer Resources tab. We also show a warning in the related source file when you expand it. Also, we launched an experiment recently to help you evaluate your original variables during debugging. For instance, in this TypeScript, we have a coffee and price variable. However, after you build the file, the coffee variable is minified into N and the price is now O. With the experiment, you can evaluate the coffee variable in the console during debugging. Previously, the console threw errors. You needed to type the minified name N to get the coffee name. That is no longer the case. Go to this link to see how you can try it out and give us feedback. If you want to learn more about how DevTools uses source maps, watch this video to find out more. Well, although source maps are amazing, they are not perfect. Your build tool is smart. In this example, the variable grid was optimized away during the build process. The value was directly embedded into the final string output. In this case, when you debug the code, DevTools is not able to infer and display the actual value. This isn't just a challenge for browser DevTools. It also makes code monitoring and post-code analysis harder. This, of course, is a solvable problem. One of the ways is to include the scope information in the source maps like other programming languages do with their debug information. Also, another fun fact, do you know the source map specification is not an official standard? The source map spec is in version 3 since 2011, although the way we develop web applications has changed so much. In addition, source maps generated by different build tools may be slightly different due to the flexibility in the spec. While the flexibility allows customization and potentially lead to a more efficient build, That poses challenge to the source map consumers like DevTools. There are too many variations and there's no clear rules to process the information. The good news is the process of making source map an official standards is currently in progress. TC39 is the standard body. The first step is to harden the specs. There are active discussions happening right now. Go to this link to get involved and find out more. Alright, we have learned a lot about source maps today. Here is the list of resources for you to explore further. Enjoy the rest of the conference and thanks for watching. Ciao!
End-to-end testing with Playwright. Hey everyone, my name is Debbie O'Brien. I'm a senior technical PM at Microsoft, advocating for testing, especially end-to-end testing with Playwright. A little bit about me: I'm an international speaker, teacher, open source contributor, YouTuber, and I absolutely love sports. If you follow me on Twitter, Debs_O'Brien, normally you'd see pictures of me cycling and running around the island of Mallorca, but at the moment, because I'm 5 months pregnant, I'm literally just walking around the island or cycling in my garage, swimming in the sea. But yes, check out my website as well, debbie.codes. But we're here to talk about Playwright, so let's get straight into it. So what is Playwright? Playwright is reliable end-to-end testing for your modern web apps. Test your Vite apps or any other apps. You can test any browser, so you can test Chrome, WebKit, Firefox, and it works across any platform, whether you're on a Windows, a Mac, or a Linux, with just one API. Now your tests run in full isolation. What that means is what happens in one test stays in that test. What happens in that other test stays in that test, right? They don't, they're isolated from each other. So you don't have to worry about cleaning up between the state between tests, etc. And tests are really, really fast because tests are running in parallel, and that just comes out of the box. So you just get fast execution of those tests. And we've got some very powerful tooling. I'm going to show you some of that tooling in this talk. And also, I'm going to talk about, JavaScript and TypeScript here, but it is multi-language, so you can go away and write those tests in Python or Java.net if you wanted to. So we know that with component testing, Playwright uses Vite to basically get that preview going and to be able to, see your component in isolation and be able to test it. I don't want to talk about component testing today. I want to talk about end-to-end testing so that you can test your complete user flows. And I want to show you kind of how easy it is to get something up and running and basically have a test done. So we're going to go through the whole process. I'm going to give you a live demo of basically how to write a test in a couple of minutes and run that test. So what are we going to do? Well, the demo is actually going to record a test testing the StackBlitz website. So you'll see down the links below, you've got a link there to the StackBlitz container, and you'll be able to open that up and follow along. You'll see the code. Now we can't run Playwright in the StackBlitz container, but you can take that code later on and then run it yourself and just test it out and play around with it. So that's there for you. So let's see what we're going to do, because this is really, really cool. We're going to test the user end flow from the StackBlitz website to open up that container, that code, modify that code, and share it with someone. Are you ready? It's really, really cool. So I've got like a project here, and I've just installed Playwright in VS Code using the VS Code extension. I get an example test, so nothing too exciting here. I want to go straight in and I want to start recording my own test. So to do that, I go to the testing sidebar and I'm just going to click on record new. Now this creates a test one spec file for me, and I can go to the browser window that gets popped up, and I'm going to put in StackBlitz. Now I've got the website, and you can see in VS Code, I've got a wait page, go to stackblitz.com, all done for me. Now, as I hover over every element on the page, you can see the locator being highlighted. I could choose any one of those by clicking on it. But I don't want to test any of that. I want to go straight down to Vite, and I'm going to click on Vite, and then basically I'm going to go and choose, let's just do vanilla Vite for now. I'm going to get a StackBlitz set up in milliseconds using vanilla Vite. Okay, and here I've got a web page get by role button, name Vite, get by role link, name vanilla Vite, and I'm clicking on these. Now I'm back in StackBlitz, and here I've got, we've got a counter, hello Vite, and we've got this count as 0. And what does everyone do? They click the counter. Let's click that counter, and we've got count as 1. Yes, so this is a cool application. And you can see now I've got web page frame locator iframe. So we're now going into the iframe and we're testing the iframe. No extra work needed, just clicking, and we've got that that count already clicked. Now, even cooler, I can go into the main.js file and let's change the text here. Instead of hello Vite, let's go playwright and Vite, because playwright and Vite work really, really, really well together. So let's write that in. You can see that's being updated here. So this is cool. Again, I'm just using CodeGen to generate the test. So it's recording all of my user interactions. Let's go to counter.js and let's change the counter. We'll start at 5, just, so it's easy to demonstrate that this is a different counter than the actual starter pack. And we'll increment that by 5 and then reset it to 5. Okay, so this is cool. What would a user do now? Well, they want to save their work, right? So let's save that. And obviously, I want to share it with the world. So let's click on that share button. We get a copy URL button. We'll click on that and then we'll open up a new tab. Now, this is like a new user. They're going to, paste that in there and they're going to get that. Look at that. The counter is 5. So this is cool. This looks like the code we've just created, and playwright and Vite is there and count is 5. Okay, that's cool. That's nothing like special. We're going to click on it. Count is 10. This is just how StackBlitz work, which is cool. But look, in Playwright, we've got everything written for us. So we've just generated all of those actions that we have basically clicked on. So it's a little bit messy right now. There's a couple of extra things in there that I need to tidy up, such as when I was clicking on things and I had to press, caps lock and arrow right and things like that. But we don't want, Playwright's not going to need to do that. So we'll just remove kind of like those little tiny things to make it that we're just going straight into that locator, the element on the page, and we're just basically, filling it with the actual number 5. And in this case is what we're doing here, right? We have those 3 fills that are basically saying counter is 5. So just after counter.js, change the counter to 5. Perfect. So let's just separate these out a little bit. And we can see down here, we have our save. We're clicking our save button, our share button, our copy URL button. So this is great. And then just down below, you can see we've got a couple of errors there, right? Let's just, put that aside for now. We'll comment that out and we'll come back to that later because I just want to see, does this actually work? Is Playwright going to wait for that StackBlitz to load up so that that user can click that button? Or do we have to manually set timeouts or how is it going to work, right? So let's check this out. And I'm going to run the test using UI mode. So npx playwright test --UI. I could run it straight from VS Code, but I want to actually see UI mode because it's really cool. This will give me a new window. I'm just going to put it into full screen mode and I'll zoom in here. And you can see my test 1 spec, just called test. And I'm going to run that. And it's going to start running that test for me. Now you can see I've clicked on it. It's opened up that StackBlitz environment there. And it's like it's waiting a couple of seconds, right? Because it's going to load. And, is this going to actually work? Is Playwright going to wait? And bang. Okay, wow, look at that. So I didn't have to do anything. Playwright waited for everything to be ready. And I've got as far as my share, my copy URL. Okay, so you can see I press the save button. The code is being changed. You can see it being modified there. You can see in the preview, the count is 1. So everything is exactly as we would expect it to be, and it's working. So this is really, really cool. And you can see all the actions. We can go back and forward in time to see, what was happening, what we were clicking on. Let's click on watch mode so we can watch it, go back to VS Code, and let's just close that terminal and let's, change down the bottom. We'll uncomment this. And basically what we're doing down here is, this is like another user, right? We've shared this code and the other user comes up. So we don't want this to be in the same browser, right? We want it to be in like a different browser, like a different incognito browser. Okay, so we want our second part of the test to be completely separate to the first part of the test, even though it's in the same test. So this is really cool. We're creating a new incognito browser context, and then we want to create a page inside that new incognito browser context. So that page has nothing to do with the page at the beginning of that test. So how do we create a new incognito browser context? We can say context equals await, and then we'll add browser and basically new context. We're creating a new context here. This is great. And then down below, we want to basically say our page 1. So we have const page 1, and we want to make that equal to the context that we just created. We want to say context. In that context, I want you to create me a new page. So this is all we need to do, but the browser you can see is underlined here. We just need to add that fixture up there beside the page so we have access to it into our test. Okay, this is cool. Now let's see if it works. Because I've got watch mode on, it's automatically ready running that test. And I'm going to go down, I'm going to open up that first StackBlitz. I'm going to start modifying the code. And then I'm going to be able to share that URL and open it up into a different browser context. And look at that. There we go. You can see the code is there, and it should just come up in a second. Let's see, does it say playwright and beat? Will it work? Let's see, playwright and beat, woohoo, yes, and count is 10, because we clicked the counter and we incremented from 5 to another 5 to 10. This is cool, right? So this is very minimal work here that we're able to basically test across, test in iframes and test across different users. So think of games, think of chats, think of all kinds of cool things, or just testing StackBlitz itself, which, this should be tested by Playwright. I hope it's tested by Playwright. I'll check with them later. So yeah, you can see going down, back and forward in time, we can see, what we were doing, what was happening, and we can visually see everything happening in the DOM snapshot inside. You can see we copied that URL, we created that browser new context, and then we created a new page, and then we went to that URL. And then from that URL, we basically loaded up, the container was loaded, and we clicked on the count is 5. Now we can also test if playwright and Vite is there. There's a lot more things we could test, right? But we haven't really tested anything. We've just tested that this user flow works. So let's just remove that duplicate code there. We didn't need that. We want to test that the count is 10. Now we could visually see the count was 10. We weren't actually testing it. And, on CI, we're not going to visually see these things. So we want to actually write some assertions and make sure that this is working. So we can add an assertion using, first using the wait, and then we put expect, and then our locator, which is our page 1 frame locator, iframe with the title preview page, get by role button, and name count is 10, and we want to expect that to be visible. So that should be visible on the page. Now these locators are a little bit big here. We can, tidy it up and, save on duplication and make things a little easier by creating a locator. Let's call it iframe 2, because it's like the second iframe we're dealing with in this test. And then we can copy the page 1 frame locator part of that locator. We can put it inside here, and now we can just say iframe 2, and then get by role button, name count is 5, and the same down below. So now we're just reusing code and tidying up and making it a little bit easier. So we're testing the one at the bottom, and we can test at the top as well. We clicked on the count is 0, so we can do another locator here. We can call it iframe. We'll copy in that frame locator text, and then we'll just put iframe in here, and then we can basically say get by role button name count is 1. We'll click it, and then what we want to do, we want to basically write an assertion. So we want to say await. Make sure you're always using await, so that if you just write expect, you're going to have problems. So make sure you write await, so that it's going to actually properly await for those assertions. So we're going to expect our iframe, get by role button name count is 1, and we're going to expect that to be visible on the page. So as soon as we click that, expect it to be there. We already saw it's there, and now we're just adding the assertion. So this is going to work. It's just going to work. So we're going to press save. And basically, because we have watch mode on, as soon as we press save, it's basically going to just rerun that test. As you can see here, it's rerunning it. It's going to wait again for the StackBlitz to set up. And you can see, super fast. Everything is there. Test is going to pass. It is going to pass. I'm telling you, look, there we go. Count is 10. That means it's waiting for that StackBlitz container to load, and it's then making sure that that is number 10. You can see in the timeline here, we have 2 different timelines, right? We have from one test to the next test, and you can see those, how they work different to each other. So they're separate from each other. So this is cool, but, let's break our test because we want to see what happens. So let's do count is 10 in the first test. The first time you click the button should not be 10. We just want to make sure that our assertion is working. And Playwright will time out after about 5 seconds on an assertion. You can modify that if you want to. So we can see here, it's going to fail in just a couple of seconds. And we've got expect iframe, get by role button name count is 10. It's saying that this is the error that it found here. And we can see, count is 10. And, it shows it in the nice errors tab here as well. So you can, check in here and we can see this is count is 10. And then obviously we can zoom in and we can actually visually see that that count is 1. If we couldn't, we could use a locator picker and we could kind of click around and find the right locator here. But, this is a really easy fix. So we can just come back in here, change that to 1, press save, and our test will rerun itself. And we are happy to go. Like, this is a really, really cool test. So we're literally testing the user flow from the StackBlitz website, clicking on that, Vite, setting up that project, modifying it, changing it, and saving it, copying it to share it with someone else, setting up a new incognito window, as if we'd send that to somebody else to open up, and then opening that up and checking that, the count is actually 10 once somebody clicks it to see that the code really has changed. So this is, matter of minutes. We have this test written and set up with very, very minimal work. That is how Playwright works. Playwright is super cool. So make sure you check it out. Playwright is open source and free. You can see our NPM downloads. Our GitHub stars are through the roof. We love stars. If you like our project, please star us. We have some amazing ambassadors. Check out the work that they're doing and all the talks and workshops and materials that they're creating, because they're absolutely incredible. And you'll find them all on Discord, as well as our community on Discord. We have over 6,000 members there. We have a hell of a lot of articles and talks and a help channel as well. So, make sure you chat to the community there, because that's where they all hang out, and it's super cool. Thank you for being part of the community if you're already part of the community. Seriously, my only question is, are you ready to Playwright? You really, really should be. I hope after this talk that you could go away and start writing and testing those end-to-end experiences. Thank you very much. Check out the docs playwright.dev. Check us out on Twitter, YouTube, and Discord. Have a great day and happy testing.
version 1.0 is a big milestone in Vite's development. It brings stable API, performance improvements, and a big feature set that we have been working on for the past year. My name is Vladimir. I'm going to talk about what we did in preparation for the first official release of Vitest. But first of all, statistics. For the past year, the number of downloads rose from just about 400,000 to almost 2.5 million. It's been downloaded almost 6 times more than just a year before. In fact, 1/3 of all Vite downloads is Vitest, which makes it one of the biggest contributors to Vite's growth. And as a side note, Vitest has reached its 10,000 stars mark on GitHub at the end of August. And if you didn't leave a star, please do. And to celebrate our collective achievements, Vitest has 125 new contributors now. We have people join the core team, and we have new pull requests opening on a regular basis from non-team members. And I just wanted to celebrate and thank each and everyone in this community that helped make Vitest one of the fastest growing tools this year. But also this year we closed 178 bugs thanks to all the new contributions and released 65 new features, all thanks to you. But now to performance improvements. One of the main goals of Vitest is to provide a fast testing experience. This includes the development speed, so how long it takes to run a test when you're writing it in watch mode, for example, but also CI speed. We have been working hard to bring new performance optimizations into Vitest core, and we had struggles along the way, some performance regressions, reverting the changes, starting all over again. But in the end, we are pleased with what was achieved. So I just wanted to share some of the things that we did to help with the performance. First of all, we started with just regular bugs and misconfigurations. We identified redundant imports that were slowing down every test on a startup. So this helps projects that have a lot of test files. We also introduced a way to use a native Vite optimizer that is actually used for your dependencies in the browser. We managed to reuse it to bundle large dependencies into a single file for much faster imports. This usually helps if your project uses large component libraries that might take some time to load because they rely on tree shaking, which cannot be performed at runtime without a bundle step. And we actually saw in some reproductions that it helped to reduce test time by 2 or even 3 times. We also introduced a new way to run your tests with the Node.js VM module. So similar to Jest, instead of creating new workers or child processes, for each test file, we create a new context, which helps with also startup time. So we don't need to rerun GSDOM every time a new test has started. It makes speed on par with Jest for projects that have large dependency tree and hundreds of test files. This was a long-standing issue that was actually opened a few months into Vitest release. We are happy to give a way to, if not improve performance over Jest, at least not degrade it for projects that rely on this type of architecture. Of course, there are still ways of making Vitest better and faster that we plan to explore this year. So stay tuned. I hope we can show even more performance improvements over the next year. But we also worked on bringing some new API into Vitest and addressed some of the pitfalls of current API that was inherited from Jests. The first thing that I wanted to talk about is changed flag. It was initially introduced to speed up CI, but we found that it can be used to also improve developer experience in watch mode. So what it does is it runs tests that are affected by your changed files. Not just tests, but if you have a test that imports another file and you change that file, then every affected test will rerun. Initially, it was meant to only run files and exit, but we found that if you have a very large suite with hundreds or even thousands of tests, this command can be used to speed up your workflow by running on the affected tests. To use this feature, you need to pass down changed flag to Vite's CLI like this. A little disclaimer, I will be using an R utility, which is just an alias to npm run something or just npm something. So you need to pass down an R test is just to show it. An R test is just a Vitest. So you need to pass down changed flag. By doing so, we will run only tests that were affected by changed files. Since we don't have any changed file, no tests are found. We can continue editing files and they will rerun. For example, if we change SQRT to 4, you can see that the test is failing. We can also change a math file and it will rerun this command. Now, just to demonstrate, you can also just run changed and it will rerun these same files. Since we have two files that import from math, is mock and sweet, it reruns both of them. So you can just start by running vtest changed and gradually continue editing and adding or writing new tests. You can also use a hash or a branch name with this flag to specify what changes vtest should look for. So for example, here I can specify head2 and it will run all tests that were affected by changes in the last two commits. Just to show you an example, we will commit this to the repository and we'll run test changed again. And we can see that nothing changed, so there are no tests running. But if we pass down change head1, for example, then we can see that tests from the tests that are affected by changes in the last commit are reflected here, which is pretty handy when running in CI. To make this possible, Vitest relies on Vite's module graph, which is populated when files are transformed but not evaluated yet. So we can process all your source code, find test dependencies, and just filter them. To do this, all dependencies need to be imported using import keyword, as you can see here. So if you read from files manually, or read a directory, or call a method, or spawn a new process, you might want to add those files into the force rerun triggers configuration. There's a log pattern for all files that, when changed, will rerun all tests if you pass down changed flag. So for example, here we can say that when reading from JS file, or maybe from view file, if the view file is changed, rerun every test. But you can also use Vite native features. So for example, if you have a test that reads from some file, let's have an example here, fs read file sync, for example, constants. Right? You can replace it with an import constants from constants raw. So this will be a string, as you can see here. We can run this test changed. You can see here, yeah, it needs to be resolved. But you can see here the console log that it just exports in math. Don't forget that Vite also supports import glob syntax, which will read everything inside a directory. We can pass down here as raw and eager true to see all the files inside the directory. So this will be an alternative to read dir, right? Fs read dir. Dir sync. This is of course only for your test files. If you have if you read files inside your source code, you will not update it like this. The next feature that I wanted to talk about is Extend API. When context was first introduced in Vitest, you would have to extend it inside of before each hook and populate context manually, like here. This approach works well for local files, but when you need to reuse this logic, it becomes cumbersome, and you usually end up with some kind of a wrapper to share this kind of code between separate tests. You also have to provide context type for better type safety manually for each test. Or you can also use the TypeScript feature context to pass down context like this, and then reuse it here. Unfortunately, it's still hard to share this code between different files. So we introduced a new API inspired by Playwright called Test Extend. As you can see here, you can define separate contexts independently and then extend one from another, like here. And the nice thing here is that it will merge all the types. So you still have a type-safe way of accessing it. As you can see here, server is available as a context without any additional callbacks. This is also very useful because you don't need to pass down these variables between different callbacks. This approach makes it easier to share the context between different test files. And we recommend using this API over the before each if you need to share the context between different test files. The next feature that I wanted to talk about can actually be seen here. Again, inspired by Playwright, Vitess now has soft assertions. Usually test stops executing after your expect fails. So for example, if we change this to a usual expect, this code will never run, which is sometimes not desirable if you want to make several assertions using only one maybe heavy operation. So for example, you don't want to perform the same heavy operation in different tests, just to have several expects spread out in separate files. This can also allow you to perform separate actions down the line. So after this expect solved to be, we can write more code to test, more assertions. Another important thing added was support for testing types. Since TypeScript is first-class citizen in Vitest and Vite, we thought it would be a nice idea to provide some kind of a helper to test your types and built-in command to run these types of tests. So you can use the same test function from Vitest to structure your tests. And Vitest also provides you with a function like expect typeof, which is similar to expect. But this function is not running at runtime. It's just an OOP that provides interfaces for checking your types. For example, here we can test that square root function takes parameter 0, which is equal to number, which is not a string. And we can also see here that when it fails, it shows you an error. Unfortunately, the error is quite ambiguous. So we are also providing a general function just to see that two types are equal. This is basically a generic that checks that this one is equal. And if you need to test the opposite, you will write a test expect error comment here. If you remove the comment, you can see the error pops up here. The number is not a type string. This is still an experimental feature that we plan to integrate into Vitest more this year. And just to show how to run it, we can run this types here, which is Vitest type check. Now, if we save this file, it will rerun it in 0 milliseconds. Show the error. We go back and there are no errors now. Another feature that I wanted to talk about is browser support. As you can see here, we have a test that is written with vtest assertions. We can run it visual here and can see that it passes. We can update test to see that it fails. But what we can also do is run the same test using browser mode. So we run browser. Wait, I have it here. Yes, test browser. And it will run the all tests inside of the browser. As you can see here, mock is not supported, so the test fails, but visual test works fine. To learn more about browser support, I recommend watching a talk by another team member, Aslem Ahmad, here on ViteConf, which is very insightful. The main idea here is to give an easier migration path from your Node.js tests to your browser tests. So you can just change or add a flag browser and it will work automatically. So these are all new, most important features that we added last year that I wanted to share with you. I hope it was very insightful. Thank you for listening, and I see you on GitHub.
Hello everyone, Happy to have you in ViteConf. Today I'm going to talk about Vite's browser mode, the new way of testing browser apps that I love and I'm really excited about. So let's just get straight into it. Well, let's start with I'm Mohammed Bagher. I'm the founder of Tiny Loops, the place for TinyPool, TinyBench, and TinySpy, which are the tools that are being used in Vites. I'm also the manager of Fino Agency. It's a web development and web design agency. Feel free to check our website. I'm also the maintainer in Vites and a senior dev in Alibaba Travels. You can find me in Twitter and GitHub also, but I prefer Twitter since we can talk there, so feel free to send me a DM if you have any question. So let's start with the current way of testing browser applications. Right now, we're using JSDOM and HappyDOM as a mainstream tool for testing browser applications in Vites. They're really fast, they're blazingly fast, they're easy and mainstream, as I mentioned, so there's a huge community around them. But the thing is, JSDOM, HappyDOM, or any similar tool are an implementation of the web browser APIs and not the real browser API. So at the end, it's all simulation and not the actual browser. And I actually believe we're testing the browser applications right now in the wrong environment. We're testing them in the Node.js environment and not in the browser, which is the actual and the real environment that the user is going to use our application. So that way, I believe we're going to face some false positives. For instance, let me show you one. Here I have a simple Vites template. It's currently set to JSDOM. It can also be set to HappyDOM, but I just chose this one. So we're just testing that the window object to be defined. I expect it to be passing, so it's not failing. So let's see. As I said, it's passing, but let's test another thing. Let's say we expect the process object also, the global object in Node.js, to be defined. And let's see, it's actually defined. So in many production apps, there's nothing weird about it. But I actually believe this is wrong because in the real browser environment that the user has, we don't have any of these Node.js APIs along the window. So currently, as you can see, we have the window and the process object, which is an impossible thing unless we do some kind of polyfills or markings. So that's why I believe we can have the browser as our testing environment. So that's exactly the reason why we implemented the browser environment for Vites. So we just spin up a browser for you. You go there, you test your applications, you get more accurate results, and at the end you're gonna receive the results in your terminal. So let's have a demo. The same demo that I just showed you. We can go to the options and just disable the JSDOM environment. And there's a new option, there's a new object option in Vites. It's called the browser, where we have three keys: the enable, the name, and the headless. The enabled just like enables and disables the browser. It's obvious. And the name is the browser name that you're going to test against. For instance, right now, using WebDriver IO and Playwright, we actually have 6 browsers and browser engines. So you can choose any of them by just going to the Vites docs and choose your own browser. I just chose Chrome for the browser that I'm going to test against. And there's also another option called the provider, which you can choose between WebDriver IO, Playwright, or even your custom provider that you can implement. And if you don't specify it, Vites will specify it as WebDriver IO. We also have the headless option, which I'm going to explain later. But let's test our application. Let me just close the current process and save the file. So let's just run this test. And as you can see, like we just spinned up the browser and we ran the test, like everything is passing. And I just removed the process, so it's not failing. I'll add it right now so you can see the difference between the browser environment and environments like JSDOM as I showed. So everything is running and passing. Let me just return back the process expectation. Now you can see if I save this file, like the changes are going to be represented, and also it failed because it says the process is not defined, which is completely expected in the browser environment and any other browser. So that's the accuracy that I was talking about, because with Vite's browser mode, everything is in the browser, not anything else, not any other environment like Node.js. So that's just an example. Let me just remove this line and take the test to be passing. I'll also add a log so you can see how the changes are going to be represented in the browser and how the logs are going to be logged there instead of the Node.js environment. Let me go to the inspect, the console. As you can see, we have the here log, and it also send the log over the terminal so you can see it easily. The reason why these logs are helpful in the terminal is because sometimes in the CI/CD we just set the headless to true. So with setting it to true, we don't have the browser showed up again, the spinned up browser. We won't have it anymore, and the WebDriver IO, the Playwright, or any other provider would just do its own work and give us the result. So let me just save, just close. Let me rerun again. You can see there's no browser there, and we just have the logs and everything passing. So that's the headless feature of the browser mode. I just removed the log and everything is working. Let me just close this and continue. Next, we have the upcoming features. As I said, in the browser mode, everything is kind of experimental, but you can use it. So that's why we have some features that are not merged yet, but we plan on merging them soon. So the most important one is the isolate browser test. In this PR, my friend Joaquin, they experimented with so many things to achieve isolation. And at the end, we found a way, and it was using iframes, which would achieve the separate context for each test file that we're running. We were just experimenting, and we just found out that we can have much more than just an iframe using the iframe itself. For instance, we added the browser UI feature, so you can have the DOM represented by your test in the browser UI. You can see any changes there and the final result also. I'm excited about this feature because many 3D developers are really excited about this, like Alvaro, which I really find it stunning because I've never thought that we would come this far and people would enjoy this feature. Also with the iframes, along with supporting isolation, we also achieve concurrency. The reason why I just wrote parallelism before, because I didn't know that it wasn't parallelism, and there's a discussion under this suite that shows it's concurrency and not parallelism in iframes in some circumstances. So this way we can run as many tests as we want in both isolation and concurrency, because currently you cannot run that many tests because everything is running in the main context of the tab. But with iframes, we're going to increase the ability and make it support maybe 100 test files. And the next feature is the non-browser provider. As I showed you, we have two providers currently, the WebDriver.io and the Playwright, which they spin up their own browser. Next, I wanted to talk about the non-browser provider mode. It's a provider similar to WebDriver.io and Playwright, but instead of like just spinning up a browser for you, it would give you the link and it would let you test out your application in any browser that you wanted or any environment. The reason why we added this feature is because we wanted to support browsers like Arc or environments like StackBlitz, which would be really exciting to use and test our applications there. So let's just have an overview from all these features. My friend Oakwin also made out all of these templates and examples, so we can test it out easily, though they're all not merged yet. We would share all of the links with you. Currently, I chose a view example, and it's called the Vite's View Browser example. Like there are two test files, one the basic and one the second. For the basic, we just have a hello component here that just multiplies the count by the times and it just gives you the result. Nothing complicated. It's a simple test file just to showcase things for you. In the config, we have the globals to be true. We enable the browser mode, and there's a new option called the enable UI, which is just the browser UI that I showed you here. And we also have a name, which is a Chrome, but when we set the provider to be none, this name won't have any effect in general. We also set the provider to none, so we support the none provider. Let me just run the test and see. You can see it just gave us a link and it opened the tab for our current browser that we're using like daily. We can disable this feature and just get the link and use it everywhere that we want. So we have the basic test here is passing, and the second test. For the basic test, like we can see the code, the module graph. And for the new feature called the browser UI, you can see that we have the UI here, the test was passing, and we have the final result also. So if we just increment, like you can see the result is changing. If we go to the second test, you can see the browser UI for the second component. So any of these test files have their own results and their own DOM representation using the iframe. So thanks to this feature, you can have the UI for each test, so you can easily view the results and how the result is working for you. Let me just close the tab. Here are the links that we're going to share with you also, so feel free to check them out. I want to also say thank you to the Vite's team for giving me the opportunity for experiencing and experimenting with this feature 1.5 years ago. And also a huge thanks to Joaquin. He helped me so much with this and he's taking the lead on the browser feature. And also Jessica Sachs for inspiring me so much on her work on Cypress. And she taught me so much about the concepts in browser testing that I didn't know. And they were really helpful. I wanted to say big ups to Christian Broman also, because he just reached out to me and told me about WebDriver.io and I was really impressed. That's how we just went to support WebDriver.io. I also want to say a thank you to the WebDriver.io team and also the Playwright team for their amazing providers. And the final thank you would be to you guys. Thank you so much for being here. I appreciate the support. So just feel free to give this feature a test and experiment with it so we can keep improving this feature until it becomes stable. Thank you so much, guys. Goodbye.
I'm going to ask a question, and we'll get back to the answer a little later. Are your docs good? Whether your current docs are a README, a few Markdown files, a Discord server, a changelog, the code itself, an entire website, or nothing at all, they can always get better. Not exactly what you wanted to hear, right? I mean, this is an overwhelming thought. Or is it a comforting fact that docs are never done? So don't expect them to be. You'll never get there. You can't get there. You don't have to worry about getting there. With docs, you cannot let the perfect be the enemy of the good enough, or the not worse than what we had before. My name is Sarah, and I'm the docs lead at Astra. I hope in a few minutes you'll see how achievable better docs are, even without a technical writer, a team of volunteers, writing experience, or a lot of time. Whether you're crafting your very first README, adding the change set for your next PR, preparing a guide for your new feature, or starting to think about redesigning your entire documentation site, I'm going to make your docs better. I'm going to make you a better, more confident docs writer without doing much writing at all. Why do projects have documentation? Why do you have docs if you do for your project? You might have said to tell people how to use the project, or to show what the product can do, or explain what it is. I would argue the sole purpose of documentation, the only reason it exists, is to be helpful. Internal docs help with cross-team collaboration and onboarding. External docs help people understand, evaluate, and use your project. Open source docs help people contribute to your project. Documentation even helps you as you're building, making design decisions, learning, and leaving yourself notes. Documentation is a source of truth. Docs is support. Docs is record keeping. Docs is even marketing, promotion, and community building. But ultimately, docs exist to help. Remember when I asked at the beginning, are your docs good? How did that make you feel? Was that an easy question to answer? What if I asked instead, are your docs helpful? For many people, I think that second question feels different. Change the question you ask yourself from, are my docs good? I mean, what does that even mean? It's focused inward on yourself. I'm not a writer. I'm not a native speaker. I'm not the person who should be writing docs. And change the question to, are my docs helpful, which is a more objective measure. And you don't need to know or care about docs theory. And this question focuses you outward on other people and what they need. Because remember, you are the foremost expert on your project or feature, and you are the best person to help. Changing the question you ask will immediately put you on the path to better docs, more helpful docs. Notice that this also changes the task of making docs from being a writing task to being a helping task. Are your docs helpful? So how do we answer this question? Well, we start by understanding it's really a collection of questions that all start with the phrase, is this helping someone get started with my project? Figure out what my project is or does, evaluate if it's right for their needs, accomplish their own goals using my project, troubleshoot, update. Evaluating whether your docs are helpful to someone, for something, will get you further, faster than any single docs intervention. Your docs can only be helpful to someone. And that someone is a person. They have needs, wants, desires, hopes, dreams. They're in a particular mood. They have a context. They have goals and a purpose. They have motivations and expectations. They have a certain experience level with code, with the industry, with your project, with GitHub, with varying language proficiencies, maybe bad experiences. Maybe they've been burned by docs before. They have preconceptions, they have misconceptions, and they only have limited attention, patience, time, energy, and resources like internet speed or hardware. But they also need help to do something. Learn, conceptualize, evaluate, achieve, build, fix, test, upgrade, improve, experiment, convince themselves or someone else to use your project, solve a business problem, solve a technical challenge. Docs should ultimately be helpful, though, at getting people out of docs and back into using your project. But let's go even further and define helpful documentation. Clear and correct, or in other words, if your docs are wrong, they are not helpful. If your docs are factually wrong, if they're misleading, if they're outdated, if they're correct, but so confusing you'd never know it, they're not correct. They are wrong. Now, when I say correct, I don't necessarily mean complete or comprehensive. In fact, you might have some existing documentation that isn't helping anyone do anything right now. If you have open source documentation or a way for people to contribute, then their feedback is at least a roadmap for you to follow and prioritize what's missing that's actually important. Action items. Read every statement in your docs for accuracy. Or if you're starting fresh, only write true statements. Also, go through each part of your docs and identify who this helps and what it helps them do. Less is more, both in style and content. If you add extra content, that hides the good stuff and makes it less clear to the reader what they do or don't need to know. Use clear and simple language. No one ever complained, gee, these docs are just too easy to read. If something sounds complicated, overwhelming, or you're not sure whether it's entirely clear and correct, remove it. Incorrect docs reduce credibility. They make people frustrated enough to stop using your project and choose another. If your users can't be successful, they don't use your project. They don't spread word of mouth, at least not the good kind. They don't create items themselves that showcase your project, and they don't contribute back and improve your project. No documentation means I go look somewhere else for information. Incorrect documentation means I waste my time. So, all I've said now is that your docs must be true, and clearly true. If it's not clear and correct, delete it. I am giving you permission. It wasn't helping you anyways. It was frustrating people trying to use your project and potentially generating ill will and bad vibes. If you're worried you might delete something important, it's fine. It's the internet. Someone will tell you. Now, you've made your docs better. You haven't even written a single thing. But we're going to take things one step further and make your docs even more helpful. Navigable and discoverable. Can people move around your documentation and find what they need? Are things where people expect to look for them? If they first look in the wrong spot, can they easily get to the right spot? This is also called information architecture, and we could get into things like signposts and escape hatches and off-ramps. These are all the structural things we add to our documentation to help people easily and quickly situate themselves and move around. Remember that a lot of people will enter your documentation from a web search and not necessarily on page 1. When someone finds you, can they get where they need to go before they lose hope? The good news is, if there's only one page, they can't be on the wrong page. Now, I'm totally serious. If you don't know how to structure your content, there is nothing wrong with one huge README to start. I mean, table of contents would be nice. putting getting started closer to the top and deleting your account closer to the bottom makes sense to me. But here's where a framework like Diataxis comes in. By identifying parts of your documentation by content type and reader intention, you can logically group sections of your docs. If the only reason docs exist is to be helpful to someone trying to do something, then the first step in organizing your content is thinking about what your reader needs help doing and making sure you can direct them to the material that actually helps them. For example, if they're coming to quickly look up a reference value, like a property name or config option, make sure they don't get stuck in a beginner tutorial. If they want to learn about your project, what it is, what needs it solves, don't make them get stuck in implementation details. But the key thing is, if someone is not reading your docs like a book, top to bottom, first page to last page, do you have a plan for how they will find your clear and correct information? The action item is to go to any random point in your documentation and imagine you're a reader who's not in the right spot to get the information you need. Think about how your docs could direct them there quickly and accurately. Is this solved by a table of contents, a search widget, a how to read these docs page, an internal link? And if you have multiple pages or files, do the titles accurately represent the content? Does your content live under the title your reader would expect? So at this point, now I've said, don't lie, delete any lies, and don't hide stuff. If you have to, throw everything on a single page. Good news, Control F works for everyone. If every statement in your docs is true and people can find, read, and understand what they mean, congratulations, you have minimum viable docs. If you have to, you can stop now. But of course, there are characteristics of good docs, and there are also some pretty well-established anti-patterns. There's no shortage of talks on how to write good documentation, or how not to, that go into writing specifics, and I do recommend you check out some of these great ones if you want to get better at writing. But we already know writing is secondary to helping. It might feel, with all these resources out there, like there's some scary docs police waiting to criticize you, and there's just a ton of potential pitfalls. But instead of thinking of all these rules as things to worry about getting wrong, think of them as things you don't have to worry about. These are things not to do because they are not your job as a helper. These things thou shalt not do actually remove pressure and responsibility, and they are guardrails to keep you focused on a productive path towards helping. So I love this example. This is a screenshot of an AstroDocs PR and a suggested change that I am making to some original text. The original text reads, installing Bun is a breeze, just one simple command in your terminal and you're ready to go. Plus, with support for NPX packages, creating a new Astro project with Bun is easy as pie. Sarah's suggestion? Use the following command to install Bun. Now, this edit is not me saying, terrible author, bad writing, bad docs. This edit is me freeing the writer from the responsibility to do things that are not their job, not to write something clever. It's not their job to motivate the reader. It's not your responsibility to get all the punctuation right in these long multi-clause sentences, to have 10 times as many words to proofread and spell check. It's not your responsibility to spend time writing instead of just helping. Similarly, many other AstroDocs don'ts are actually don't worry abouts. One that we use in AstroDocs is don't use we in docs, because you're not sitting there with your potentially frustrated reader as they're troubleshooting. But this actually frees you, the writer, from the extra work of checking that all your we, us, our, let's all agree and are consistent throughout your documentation. You know what's super easy to check? You and your. Using you also naturally puts the emphasis on your reader and what they are doing and what their setup is like. Using our can trick you into thinking about your own context or situation. And often, these instructions work without any you or your at all, and your sentences become cleaner and clearer and easier to write. Another one we use in AstroDocs is don't use should. Decide whether your reader must do something, it's mandatory, or if they could optionally choose to only present true choices. Again, sounds like a rule we just made up, but I guarantee you we are freeing you from feedback from this poor, confused reader. You should create a new folder. Do I have to? What if I don't? What's the best thing to do? How bad is it if I don't? Your sentences also get clearer. Why waste time getting your own sentences perfectly constructed when we are giving you permission to avoid writing and just tell someone directly what to do? Even if more things are possible, if you want them to do this one thing to have a successful outcome, just say it that way. We free you from the responsibility of describing every possible path when you, the expert in your project, already have a recommendation for a happy path. You can help. Don't write, just help. The action items are to not stress out about these writing rules, but embrace them as things that tell you what is not your responsibility to do. Pick one or two of them, we like we and should, or just read through your docs looking for things that aren't your responsibility and remove them. If docs' only purpose is to be helpful, then the existence of your docs is a promise of help. If you want to up your docs game, pay attention to the promises your docs are making and evaluate whether they keep that promise. Do getting started instructions have all the key steps that someone needs to set up a new project? Is your API reference easily scannable so someone can quickly look up a value and get back to building? A broken promise is worse than no promise at all. In conclusion, think of yourself as a helper, someone who just happens to be helping in writing. Helpers don't need to entertain or write beautiful stories. They need to make clear, correct information available, ideally in such a way that readers can discover and navigate it. And the best help is contextual. It is for someone who is trying to do something specific. This person may not also be in the greatest state to receive help, but they need it. So don't overwhelm them. Less is more. You can probably improve your docs right now by deleting, not writing more. Delete words like should, delete outdated or unmaintained docs, even if you can't yet replace them. Delete entire pages if you're afraid people won't find them, and put all your content on one page. I hope I've been able to help you help your users through your documentation. Thanks for joining me.
Hello everyone! It feels so good to be back here and see you again at ViteConf. And today my topic is the set theory. I know it's a bit random, but don't worry, I'll try to explain that later. So let me first introduce myself a bit. My name is Anthony Fu, and I'm a coding member of Vite, Vue, and Nux. I'm also creating a few open source projects, and I'm a creator of Vitesse, Lidiv, Uno CSS, Vue Use, and Elk. I'm currently working at the Nux Lab on the framework team. So back to our topic. As someone who has been working on open source for a while and made a living, I have to say that open source is so much fun and rewarding. I believe that many of you wanted to contribute to open source or already doing so. However, there are so many factors that affect if an open source project could become popular or successful, depends on how you define it. For example, the quality of code, the documentations, the community, the marketing, and so on. All of them are important and related to each other. There isn't a golden rule to make open source projects successful. So for today's topic, I would like to share some of my experience and ideas on creating and maintaining open source projects, combining with some observations that I have learned from the community. Hopefully it can help you to start your own open source journey or find some new ideas to improve your existing project. This is going to be a series of talks. And today I would like to start the very first one of them. So today's topic is a bit abstract one. I'd call it the set theory, a way of thinking on planning the directions and the roadmap of your project. So let's say we already have an open source project or planning to create one. To be a little bit practical, we might want to gain certain amount of adoption, or just we want more people to use or enjoying our hard work. One of the things to consider is how we're picturing our target users. For example, is my tool for end users or developers? Is that for Vue users or React users, etc.? So we know that the fact that among all of our target users, only a portion of them will become our actual user. In order to get more users to our project, we could try to convert more potential users to the actual users. Maybe by doing some marketing or polishing. In that case, the amount of target user you have actually becomes the upper limit of how many actual users you could possibly have. On the other hand, we could also try to find a way to expand our target user to include more people. Under this idea, let's add some examples that how we could do that. The first example I'm going to show you is actually my first open source project back in 2019. The repo name is called VS Code iTeam Island. It's a VS Code extension for helping Vue developers to working on iTeam, like for preview translations in code or manage keys for each language, etc. This is a screenshot of the extensions that shows the basic feature. Well, the extension itself isn't our main topic today. At that time, I'm eager to make this project popular as I want to prove myself in open source world. I'm super happy when I got the first 100 and 200 stars on GitHub and received their appreciations from the community. After that, I started to seek for higher goals. Back then, I was dreaming to work full-time open source, for example, like even you. So my ambitions was to make something popular as Vue. Then I suddenly saw the fundamental difference between my project and Vue. They directly reflects on the project names. Look at my project names. We saw that there is quite long and composed by multiple parts. Let's break it down to see part by part. So first, we know that it's a VS Code extension. So basically means that only VS Code user would use this extension. We could draw a circle indicating the VS Code user here. And then for Vue, because it's built based on my need, then we could have a Vue circle as well. And then finally, this is the helper for internalization, meaning that not all Vue users would use these extensions. So we could draw another circle for IATing. And then we find that our target users are limited inside the insertion of these 3 circles. Meaning that only Vue developers who is working on an IATing app that happen to choose VS Code as their extension would ever try this extension. That sounds quite limited. This is the phenomenon I call it their intersections. Before we dive into the solution, let's have a look at this graph. What would the other intersection means? We could soon realize that the intersection between VS Code and Vue is actually Volar, or Vite at that time, the VS Code IDE support for Vue. As the result, we know that the Vite and Volar has a huge user base because both Vue and VS Code has huge enough community, making the intersections large enough. Similarly, we see that the intersection between Vue and IATing are the projects like Vue IATing, which are also super popular. So when it comes to intersection between VS Code and IATing, we see that there seems to be no such project at that time. A straightforward thinking, let's be that one, right? In practice, we could try to make the extensions decoupled from Vue, so it could be used by the other framework as well. In short, let's make it universal by breaking the set circles and expanding the intersections. And that's how I did. I took some time to do a huge refactor, design a plugin interface to make a core feature universal. At 1.0, I renamed the project from Vue IATing Ally to IATing. From a Vue-only extension to a universal IATing helper for VS Code that supports a wide range of frameworks. Not say React and Angular, it also includes backend frameworks like Laravel, Ruby on Rails, and even native target frameworks. And they are customized and extendable as needed. So when it comes to number, we can clearly see a step increase of our stars at the times we're doing the release. The stars is almost doubled in a month at that time. So let's talk a bit about our old friend Vite. This is a story that's probably most of you already familiar with. Initially, Vite was an experiment on development tools for Vue when everyone first started. When the idea seemed to be working out, everyone decided to make a framework agnostic by extracting Vue's handling into a plugin and polished API. And then we have the Vite we know today. I'd say Vite's success turns out to be far beyond my initial imagination. It now has an incredible huge community and ecosystem. Basically, all modern meta frameworks are built on top of it, and the collaboration across multi-frameworks and communities are really outstanding. There are many other factors that make Vite to reach what it is today, but I would say being extendable and agnostic really widened the door for the community to join and contribute. The takeaway in this section is that we could seek for the possibility of breaking the intersection and making our projects universal. Here are some of the benefits I could think of. By making our project more universal, meaning we could reach out to a larger user base, and naturally we would have more contributors to join the force and work together, instead of everyone working on their own solutions that are incompatible with each other. Trying to refactor things become universals also help us to revise our design and abstractions. And often we could end up with a more maintainable and extendable architecture. And finally, if your project starts to get more usage from various needs, making any improvements in our projects could end up benefit everyone in the ecosystem. So we know that being universal has a lot of great benefits, but actually being specific is also not a bad thing. One of the great examples I could think of is Nux. Next is a meta framework that's specific to Vue. Out of many benefits of choosing Nuxt, one thing I'd like to highlight is the developer experience. In Nuxt, we provide quite a lot of features to help you build apps faster in a better organized way. We have server-side rendering for better user-land performance and SEO, and file-based routing for better organization. We also have a powerful module systems for integrations, and also Nuxt dev tools, etc. Many of these are built with the assumption that we use Vue and has a bundling pipeline. Nuxt also use Vite as the default dev server and bundler, meaning that we inherit the great plugin ecosystem as well as the fast HMR from Vite. For Nuxt to be a bit specific than Vite, allowing us to bring many cool features and integrations that would be hard to achieve in a universal way. I think that's also why we have many meta frameworks like SvelteKit, Actual, Solid Stars for different needs. And here, let's look into a couple of features that Nuxt provides. When we talk about server-side rendering and server APIs, we know that in some cases, we need the servers in some form to work together with the frontend. Other than a self-host Node.js server, there are also many services out there. For example, like Cloudflare, Netlify, Vercel, etc. To leverage the full potential of each provider, we might want to utilize the edge rendering and the serverless functions based on what they provided. One thing to note is that each provider has its own formats. Some might also come with specific tooling. In Nuxt, we don't want our users to be stuck on a single platform. We want to support as many platforms as possible built in. So we build them and even support auto detection, so the app can be written isomorphically and deployed to various platforms without changing any configuration. And then we realize this is a problem that probably every meta framework has to deal with. And it doesn't have to be Nuxt specific. So we extract those into a standard tool called Nitron. It's a universal server builder, and it's pretty much like Vite, but for servers. With Nitron taking care of the details of dealing with servers, it actually allows Nuxt to have a more clear architecture for handling server-side renders and the APIs, etc. And since Nitron is a general-purpose server tool, we see more and more meta frameworks starting to use it, or new frameworks start to build on top of it. We have Analog, a popular Angular meta framework, has migrated to Nitron. Stacks, a framework agnostic full-stack framework. Even without a framework, I also find Nitron to be very handy to build a pure API server and to deploy on the edge runtime. We also heard that there are some frameworks is in the process of migrating to Nitron. I'll keep it as a secret until they do the announcement. Similarly, in terms of bundling tools, Nuxt 2 has built on top of Webpack. So in Nuxt 3, we want to keep that for compatibles and easy migration, while we also love the innovations and developer experience on Vite. So we try to support both tools interchangeably. We provide the first-party integration for both Webpack and Vite, pre-configured for Nuxt, so ideally the app would work the same for both tools. However, we know that the architectural as well as the plugin ecosystems are quite different in them. For example, if we want to add some transformations to some modules in our pipeline, that actually means we need to implement the logic twice for each plugin format. That would basically double our work, as well as the effort for community modules to support them. That's the initial motivation for us to create Unplugging, a universal and unified plugin interface for both Webpack and Vite. With that, we are able to save a lot of effort digging into the details of misalignment for each tool. And since Unplugging gets extracted as a standalone tool, it also forms its own community and expands the scope to also support Rollup, ESBuild, and RSPEC, and possibly more in the future. With the work done by the unplugging community, it also opens the door for Next to start experimenting the support for ISPEC as the bundler. And those are just two examples. We also have ArmJS community that's providing many high-quality tools throughout the entire JavaScript ecosystem. And we actually have Nitrom and unplugging as a part of the ArmJS community. We also have a vNode made from our server-side code executors and later becomes the code engine of Vitesse and make it possible. Those tools are created from Next need, but later we extract them and make them universal. They have formed their own community and ecosystem that can benefit much wider range of users and scenario. Next can be the frameworks that's a bit specific by providing better experience, while the underlying tools can be shared and collaborate with other framework and the community. That's where make open source amazing, isn't it? So the difference from the set intersection we are talking about, I'd like to call it the set union. We extract the universal part, expanding the scope to grow the community, and also will eventually benefit back to ourselves. So to wrap up with today's topic, we brought up an idea, I would call it the set theory, and it's composed with two sections, the set intersection and set union. In the intersection, we learned that we shouldn't limit our project to only be a niche spot. We should proactively seeking for the possibility to making the project universal by breaking the circles and enlarge our scopes. And in the union, we learned that even something have to be a little bit specific in order to achieve something great. We could still seek for the potential unions that we could make to expand the community and benefit the whole ecosystem. And that's all about collaboration and community. I have a strong belief that open source will be the way for us to build a better world. And I'm looking forward to see more and more open source building with similar mindset. And that's all for my talk. Thank you.
Hey everyone, and welcome to the ViteConf community and contributors panel. I'm so excited to be here today. My name is Tracy. You can follow me on Twitter at LadyLeet. I am your host, and I have four amazing panelists here today. So first off, we have Sarah. For those of you who all don't know Sarah is actually the docs lead and a core maintainer. She's also a technical writer for Astro, and most importantly, a bird photographer. So do you see like new birds outside of your window, or is it always the same ones?
Well, outside my window, usually the same ones. They know us, we know them, we feed them. But when I travel, birding is a great activity because everywhere you go, it doesn't matter if it's city, urban, there's birds. So it's an easy, exciting hobby to take with you wherever you go.
Oh, that's really fun. I was watching something on the internet, of course. Thank you, internet. And this pigeon decided to live on this guy's head. Have you all seen that? And he just decided to let it live there forever.
Oh my goodness. I had not seen that.
You can find a lot of crazy stories. Just be careful about crows. Crows recognize people and hold grudges. So there's your tip today.
Okay, so like really when because I'm careful around crows. But now I know that was actually a good thing because, like, you know, I just like, I don't want to bug you, but like that's actually good to kind of avoid them.
Isn't that the Scary Bird movie about crows? Like one of the scary movies where they attack you is like the crows are attacking. I think
all the birds are attacking you and birds. Anyways, well, that's really cool. So
that escalated quickly.
Definitely follow Sarah on all the social medias or find her. You know, if you have questions about birds, like submit an issue on GitHub. Just kidding. But and then we also have Brittany. Brittany is one of the most passionate community builders I know. She's the founder of Svelte Sirens. Thank you for all the amazing work you do there. A Svelte ambassador and also a staff engineer of design systems at, I'm going to say it wrong, but Provi.
That's right.
Whoa, amazing. Yes, thank you, Brittany, so much for being here. And, you know, have to admire your lovely earrings, of course. So.
Well, thank you so much for having me. I'm so glad to be here. And thank you for admiring my earrings. I love them. My mom made them. I know we were talking a little bit about them, but she loves making things with her Cricut. And I don't know, like she cut it out with the Cricut, but they're fun. And I have to get her to make all the swag for me. I'm not wearing my Svelte Siren stuff today, but I have like Svelte stuff. I have Svelte Siren stuff. She's made me cups. She's made all kinds of stuff. I love it.
You know, once you get the Cricut out, it's like, it is easy to do, right? But the problem is for me, it's like oh my gosh, I have to get it out and I procrastinate. But then the actual making, you know, it takes like 5 minutes. Like you can make a shirt in 5 minutes, no problem.
Yeah. But my mom just moved and she had to actually make like a spot where she's like, this has to stay out now. So she has a desk where it just stays out because that was the thing. Like getting it out and the stuff was too time consuming. So yeah.
Yes. Well, moving on to Anthony. Anthony is amazing at open source. Anthony, like your name, like literally always pops up everywhere we go. Like Anthony did this. Anthony did that. Anthony did this. He wrote this. So for those of you who don't know Anthony, he's a core team member of Vite, Next, and Vue, and he's the creator of Vitest, SlideV, Vue Use, Uno CSS, and Elk. Did I say any of them wrong?
Of course, slide it.
Oh, slide it?
Slide.
Okay.
No problem.
And you're working at Next Labs, which is pretty cool too.
Yeah, thanks for having me.
Yes. And I'm sure these aren't like all the projects you do. Those are just like the ones that have become popular. So I like to call my GitHub a graveyard of unfinished repos.
We're probably not even all the popular ones that he's been a part of.
Yeah, you can only fit so much in a few lines. Yeah. Yeah, thank you, Anthony, for being here. And then Matias, aka Patek, who is a Vite core team member and a Vitest and Elk team member as well. And you've been working at StackBlitz for like, I mean, at least 2 years, right?
Yeah.
Yeah. So working at StackBlitz, doing open source work full time for the Vite ecosystem, which is amazing. It's always great when like companies can actually sponsor. Actually, I think all of your companies like pretty much unless Brittany, I don't know if Provi sponsors your work or not, but.
I mean, they don't sponsor any of like the open source work, but they do support me doing open source work. So that's nice to have a company that allows me to do open source work and provide back to the community. But yeah.
Yes, it's fortunate because not all of us are so lucky. So kudos to you all. And, you know, getting into the panel questions, since this is the community/contributors panel, I love this question because I think a lot of people try to get into the community or try to become contributors, right? They're trying, and how do you do it? How do you encourage community members right now to become contributors? What's the first step, or what do you encourage them to do? Or like, what are some of the initiatives that y'all might be hosting?
Well, I'll start and I'll say it sounds simple, but we ask them. So when we notice people in our Discord, mostly I'm concerned with the docs and our community support, but the number of people who will come in and say, oh, maybe this should be in the docs. That's my opportunity to jump in and say, oh, would you like to file an issue for the docs? Would you like to make a PR to the docs? Sometimes people just don't know until you ask them. So that's my first thought is I will jump if I see anyone who has identified a need, a contribution that's missing, ask them, see what happens.
That's actually a great point. Yeah. If people are willing to file an issue and bring up something that is actually a need in the community, then they're probably willing to go ahead and make a PR. They may not just be aware that that's existing. Other ways, I know, like Svelte, this year we did our first hackathon. That was a way that we brought in lots of contributions and open source projects into the community that we hadn't had before. And that may not be directly contributing to Svelte, but it was contributing to the Svelte ecosystem. So it wasn't directly to the code base, but we were still bringing lots of projects to the ecosystem itself.
Nice. One thing that I saw before joining the panel, I was checking the contributors to like all the projects that we are part of, and like it's amazing. Like almost like all of them are above like 600 or something like that. And to your point, Sarah, like that your advice seemed to be working fine because it in the Astro docs there are even more contributors than to the Astro main project. That is amazing. I think that you have like 650 contributors or something like that to the docs. That is like amazing.
That's impressive.
We do have an impressive number of docs contributors. I don't think we outweigh total Astro contributors because I think we're just over about 3,100 now. But we do make an effort to wrangle them in. And in docs in particular, sometimes we create participatory and long-standing issues. One thing we always want to know in docs is how is our search widget working? If you type in React or Tailwind into the docs search site, are you being taken to reasonable places? So we actually have some long-standing issues that are like, hey, got some time? Try searching a word and report what you get. Did you get taken to the pages you'd expect to be taken to? And because docs changes over time, this issue doesn't have to close. So when people are looking for how to get involved and maybe they're not familiar with GitHub or the whole PR system or even filing issues, we have these tasks just at the ready that we can point people to that are pretty non-threatening and allow them to start participating that way.
Yeah. Using labeling like the good first issues, those things are really good. Having templates set up for your PR so that people know like how to actually file a PR. Having your documentation in your README file so they know how to clone and get everything set up locally, how to run the test. Everything like that helps somebody contribute to your system too.
Yeah, I can relate that a lot. So I think that personal invitation is a very good way for people to get involved. So me and Matias, we were having two projects, Vite and Elk, that initially we were doing a little bit like private beta, and we invite people that who are like interested in, and like to give them access to the repo, and while it's still in like working in progress. And it turns out that at that time, it's like you got a very good engagement, and actually, I think that a few of them stay and become the core team. And currently, like we have a leader of Vite that during that period, which I think is amazing.
Yeah. One thing there that is very interesting is that particular time, everybody in the community is like an engaged contributor. So it is like really, really interesting time. And later on, as the community scale, I think that for example, maybe like in the Svelte Discord or in the Astro Discord, like you are doing, like for what I saw, a better job. But in the Vite Discord, for example, there is so many new users, but so many new users that a lot of like, if you check in the discussion channel, it is like mostly questions now, and it really changed the vibe of the Discord. And mostly the contributors are coming from from like the GitHub, for example, right now. That like there we encourage a lot of people to, for example, like something that people will like to do to become contributors is doing PRs like right away, and there are like so many ways to help that are not doing a PR. For example, like doing triaging is so helpful for maintainers. Like if you just go to GitHub issues and check them out and like find like if that is really an issue or not, like 80% of the open issues maybe are not. So that is already so helpful. And
yeah, actually,
so it is.
Like commenting back on issues too, like setting up REPLs, like doing those kinds of things, like testing those issues that are up there and commenting back on them, I think is helpful too.
Yeah, we even have a label for our issues that needs confirmation. So there's your invitation right there. Just tell us yes or no, this is happening to you too. And in Astro in particular, we've made a real push over the last year or so to give reviewers GitHub credit as well. So we have this, our maintainers have this entire complicated system, and I think people are working on automating this so that people who have given really helpful review comments in a PR, we make sure to manually add them as co-authors to the PR. So what happens is they show up as in our little congratulations message when things are posted automatically in our Discord, but they also get, contribution squares. We have Astro badges, and we have specific badges for number of PRs reviewed, not just filed, because we have a lot of PRs that are open right now. We could really use people to go through, add comments, let us know before we get to the point of merging. And in particular, because Astro does a lot of translations of our docs, this is where we need reviewers more than anything else, because we don't all necessarily have the native capacity in these languages to review more than a Google Translate check and a make sure nothing kind of seems off. So we ask for reviews all the time, and then you don't have to know how to file a PR or file an issue. So the friction's a little lower for reviews too, but they are so valuable.
Yeah, especially with Hacktoberfest going on right now. I mean, they come in like crazy, which is a good thing. Like we want people to contribute to the communities, but we need those reviews, comments. We need help maintaining as well.
I wonder though if this year Hacktoberfest there will be less contributors because there's no shirts.
But like, do we need this crowd?
No shirt.
They're planting a tree for you. It's all good. Still good.
I think the top 4 FAQ questions are all, why am I not getting a shirt? Really? I'm not getting a shirt. My company makes shirts. Those are so shirts may be a thing, but I know one concern of Hacktoberfest is getting these drive-by PRs that maybe don't lead to longer standing contributors in your community anyway. So, but now it's up to us maintainers to just be super on top of these contributions that we get, because these are people who are doing it even not for a shirt.
Yes.
Absolutely.
Even it kind of like weeds out the quality, right? Like I'm not doing it just to get a shirt, but I'm like doing it because I care about the community. And yeah, no, I think that's amazing. And do you all like host hackathons at all or anything like that where you get new contributors?
Svelte did the first one earlier this year. And like I said, it was great for the ecosystem. We did like a month long, or maybe it was 2 months, where we gave the community 2 months to create a project. And we had 3 categories, and then we did the top 5 in each category, and the top 3 of each category got a prize. We just got sponsors for that. And like I said, it was amazing for the ecosystem. We got so many new fresh projects and things for the ecosystem. It was huge.
Yeah.
One question there, like how much work it was to like, because there were so many submitted projects, no? Like to actually like go through all of them and like grade them. And like, this is something that we talked with Anthony, like Anthony was saying several times, hey, let's do a hackathon of the whole community, and maybe like in the Vite kind of point of view. It could be like cross framework, and I don't know, like it could be really nice.
So
But,
what
like,
we did
how
is
that
we had a
works?
spreadsheet. Kevin kept track of everything. He had a spreadsheet, and then we had maybe 10 to 15 of us. And over the last week of the hackathon, we reviewed the spreadsheet, and everybody like took a chunk of it and went through it. And we had a grading system on the spreadsheet. And then if it had like suspicious commits, we would like put like a red mark on it, like don't look at this one. And so then once we got down to like enough that was like reviewable, on that last day, we went back and reviewed everything. And then we had like enough to get the reviews. And I think we had 200, 250, something like that were submitted.
Wow.
Yeah. Node does that. Node has this thing called like contributor days. And it's usually done like a day before a conference, like the big Node conference. I think now it's the JavaScript conference that they do. But it takes so much time, right, for contributors to just create all the issues and figure out how to structure it in a way to get, hundreds of people in a room and hundreds of initial commits, and then going and reviewing all of those after and getting them actually merged is like a lot of work, right? But I mean, it's, again, kudos to you all who care about the community and care about fostering new people, because that's really, that's where people come up. Speaking of communities, what strategies can we kind of implement generally to create a more inclusive and supportive environment within our developer communities? What have you all done, or do you have any suggestions or advice for people as well?
Yeah, I mean, I think that we have to have some policies, like we have to have the moderation and the enforcement there. But I think that having the engagement and making sure that you are on top of things in your community, with making sure that people feel safe. That's one thing that we've tried to take care of. We have a Spelt Sirens channel that we make sure that everyone is welcome there, but we're going to make sure that you're protected and that there's moderation and enforcement, not just in that channel, but in the Spelt Discord in total. So I think that education and awareness, making sure that people know what is okay to say, what is not okay to do. Having that, I think Sarah spoke to like the badges and some of the things that they do when you get PRs, but that kind of thing, like the recognition and that helps with the inclusivity for people. And that's not something that's about making just women or non-binary people feel more inclusive and welcome. That's making your community feel more inclusive and welcome. Like you can recognize and celebrate your community by giving them things like the swag. Like it's silly, but like people like the swag, people like badges, people like that little stuff. And it kind of seems silly to us, but they love it. So, I mean, just little things, like people appreciate that. And making sure that people are safe, I think, is the big thing for me. And making sure that everyone feels welcome and no one is excluded.
I mean, your mom could make 100 Svelte earrings. She could. It wouldn't take her that long, I promise you. I could probably do it too, but I don't have my stuff laid out like your mom. So that should be a Hacktoberfest thing.
Yeah. Open source the swag t-shirts.
I mean, thank you, Brittany, for saying that too, right? Like it's not just about women and underrepresented folks, but it's about making everyone feel welcome because especially I think, like Vite, for example, right? And Svelte, I think so as well, right? But it's like it's such a big global community, right? Like, I mean, when compared to well, okay, I'm not going to compare because I probably should. Generally, y'all have a very big global community, and there's so many there's so many different personalities and so many different cultures and so many different ways of interacting. And, I really feel safe and at home in some of these communities that you all represent, which is, again, kudos to say that you all are doing a great job.
And that is, as Brittany said, the little things really do matter. It's one thing to have a code of conduct. It's one thing to have governance laws, which most of us do, and most of us can enforce in these, really severe or egregious situations. But what if someone comes in and is just being annoying? What if someone is inadvertently making the room uncomfortable? These are some of the most challenging things that we have to deal with, because these cases of excluding people aren't always super obvious. So as maintainers of a project, we constantly have to be on guard for cultural differences, differences in how you might address other people. And the second that we notice something, we, as uncomfortable it is, in Astra, we step up and we say, hey, that wasn't a super friendly welcoming to someone new here in the community. It's hard and it's awkward, but that is part of our responsibility. And it does make all the difference, because for every one person who might bring forward something to your attention, there could be 10 or 20 other people who are seeing it and feeling it, but are just made uncomfortable, but don't know whether they should bring something up. So from the top down, we have to set a great example of a good, inclusive community.
Those lurkers will get you every time too. There are people always lurking in your communities that you are not aware of. And those lurkers are the people that are probably some of the most supportive that you don't really know about. They will just hide in the background, not say anything publicly, but they really love the community. But then they'll see something that makes them uncomfortable and that will turn them off and they will be done. And you have to be really careful and just shut down any negativity and any bad stuff that is going on, no matter what it is and who it's happening to. You just have to be really careful.
But it's also promoting good habits too. So one thing we've started to do is make these little messages and we'll post them semi-regularly. Hey, if your question could be answered by anyone, don't mention someone in particular. It looks like maybe it's a private conversation or other people. If somebody is adding a core maintainer asking a question, is anyone else necessarily going to feel comfortable jumping in and answering? So these little messages that we add about good habits too can really help the community flowing, because we say, look, we want everybody to feel comfortable participating. If it's just a tech question, anybody can answer it. Don't address it to a person in particular and let them enjoy their weekend, things like that too.
I love that. And I love the idea of, just even, by all y'all encouraging and by other people taking leads, right? Like by, a junior developer reviewing Anthony's code, let's say, as an example, Anthony being like, oh, thank you for this, or making suggestions or anything like that. It's like, oh, I can do that too, and it's like, oh, and, I know you talk to, people like, Anthony, for example, and it's like, yes, of course, please do that. We need reviewers. But actually seeing it in action, I think is like, oh, you weren't kidding. I can actually do that. What about accessible learning resources? What are you all doing in that front, or what advice do you have for people?
I think that making sure, any documentation, any site that you present has accessible learning resources, but anything that you put on the web should have accessible and inclusive language. I'm not sure if there's much that I can really add to that other than just making sure that you're covering your bases when it comes to being accessible to everything from screen readers to color contrast to just covering all of your accessible, inclusive bases there.
it's hard, but also encouraging the community to get involved and let us know when they notice something that isn't working right, like a color contrast in our docs site, that file an issue. That's another way to get them involved. We try really carefully in our introductory Astro tutorial, where we try to show you, oh, if you add this style tag, then the heading color will change. It's trying the most you can to add little inclusive, like if you can't perceive the color change, you can go into DevTools and inspect, and you should be able to see that the color of this element has changed. So we're really trying to think outside our own experience. And this is one thing we do in docs when we write our instructions. We have a policy not to use the word we, because I, the docs writer, am not sitting with you as you are working. We are not kind of in this together. You are struggling. And when you stop saying we, you get out of your own situation as well. When you address your reader as you, then it's not about your keyboard or your setup or your operating system. It really forces you to think, what might this person have? What assumptions might I be making about my setup or my background? So even in docs, this is something that we take super seriously because docs is a static resource that has to work for everybody. And it's not always easy. So we try to give ourselves little rules like this that hopefully will nudge us in the right direction.
Yeah, that's a very good tip. Thank you. Now I need to rewrite all my docs.
Weekend project.
It could be a call to action for more people to get involved and help us in
all
the million projects. Docs is a...
So if you are watching, just check the doc.
Get involved. Get involved.
Send PRs.
Yeah.
I really appreciate your help.
Just create a whole docs team for Vite, for example. I think that one thing is that we don't have a dedicated team for docs, and that kind of shows. At one point, Vite will grow, continue to grow, and that will be needed, I think.
That is so hard. Yeah, if you don't have a dedicated person for docs and you're trying to juggle as you go along, that's difficult. I did want to add just one thing before we move on from the inclusive and supportive environment. I think that regular meetups really do help for that, because they are a way to get more people involved. So it's a way to bring in people that might be from less, somebody help me out.
Maybe people who are not as tied to the community.
Well, not as tied to the community, but also just people that are not as not active in the community, but people that aren't
on Twitter.
No, I mean, we're in tech, we're mostly men. So people that are not mostly men.
Okay,
what I'm trying to say.
Underrepresented folks.
Underrepresented. That is the words that I was trying to think of, and I am losing my mind. Sorry, I know we're coming up on time. So I think that is a good way to bring in underrepresented people, is to have regular meetups, because if you have that, especially under the Svelte Sirens banner, and we're a very welcoming, and I put that right up on the site, that they will see that and hopefully recognize that this is a place for them. And I don't exclude anyone, so everyone is welcome to come, but they see that we have regular meetups and they will come eventually. And it just draws more people in that are underrepresented.
Nice.
It is really amazing to see how much of an impact community has, So, I've gone to so many local meetups, and, I'll run into people who say, before I go to a woman in tech, before I go to a meetup, I always check to see if there's other women coming. And I've never thought of that. I would never do that because I just go, but, there's people out there who need, people who look like them to feel welcome. I remember speaking at this big, I don't know, they were in suits. Okay. All these people in suits. And first off, I was like, oh God, I have to go to this thing. Okay, I'm excited, I guess, to talk about it. But, walking around, I just, kind of didn't know anybody, didn't feel included, and then just kind of left. Yeah. So, I mean, in any and all communities, right? Like we can feel comfortable in one and not comfortable in another. I think language wise as well, if I moved to Greece, I'd be scared to go to an event, but hopefully I'd find somebody that I know who speaks English that wouldn't scare me.
Yeah, absolutely. You have to find someone that you can connect with. And I mean, that doesn't always have to be like the same gender or whatever, but it's finding that connection and feeling like safe and included.
Yes. Really good point. Which, by the way, going back to the docs thing, RxJS, I'm on the RxJS core team. We needed docs and it was a pain. So I just mentioned it at conferences and I said I was creating a docs team and all I did was spin up an empty repo and, everybody else took it over and it was amazing, right? So I think, for Vite who needs a docs team, just saying it even in this venue or in the upcoming conferences goes to say a lot in collecting people. I'm good at collecting people. So I helped lead that initiative. It was great. I would do it for you all, but
that's a good CTA. Yeah. One thing with the docs of Vite in particular that I think that they are more towards the builders in the ecosystem, doing plugins and more towards all the frameworks building on top of Vite than final users. And maybe Vite is at that point where it needs a revamp to actually focus more on users. And maybe that could help with all the questions, let's say, that we have in Discord. Yeah. That is also to go back to the other thing is I didn't say it in a bad way that there is a lot of questions, more also in a CTA kind of get involved and came and help us, because that also is so valuable. Just helping each other in Discord, it means a lot for the community.
Yeah. I think Mark Erickson from that we all know and love from the Redux team, now at Replay, he said that the way he got onto the Redux team was he was just answering all these questions in Stack Overflow and on GitHub, and then he just compiled all those answers, and then he just, I don't remember if he just stuck them onto the docs, but it's okay, you compile all these questions, and then all of a sudden, that becomes the origination of your doc story in a sense. So
and that's how I started getting involved with Astro. Was I had a lot of time to sit and answer questions. I mean, a year or 2 years ago, Astro was really new and there weren't many resources. And there were lots of people coming in who were more experienced developers than I was, but I knew how Astro worked. So I didn't have to have their level of experience in tech or in the industry to be able to say, these are the two parts of an Astro file, and this is how they interact. And in Astro, we take support super seriously. We have our support squad role. We have support patrol and extra role, who are doing some amazing initiatives right now to help sort of wrangle all the support questions we do get in Discord. And we have Astro core maintainers who have very few, if any, maybe none, contributions to the Astro repos, but have been so instrumental in shaping our support system and in helping others. We rewrote our governance laws last year. It used to be, in order to achieve core maintainer status, you had to contribute so much to the code base, and we removed it. We just said you have to contribute to Astro. So we are thrilled that we have steering our ship people who aren't necessarily even making a lot of code contributions, but who are on the ground and who are answering our community's questions. And they can help inform docs, inform dev of what is working, what isn't working, what we need more resources around, what was a crappy name, and maybe we should change this because nobody seems to get it. they are the people who know that and can bring that to us. So investing in people who might choose to just always live in support has worked really well for us.
I think Vue had, I forgot what they're called. Vue, it's not partners, but like Sarah Drasner for a long time was a Vue something. It's like you're not on the core team, you're something else.
We have ambassadors in Svelte. I don't know what you called them.
Yeah, I can't remember either.
Not like community partners, maybe, or something like that.
I don't know. Anthony, you're not going to help me out here. I can't remember the name.
And Next has an ambassador as well. And
Yeah.
I think Vue has a community partner in the
maybe it's
team
community
page.
partners. Yeah. Okay. Yeah. So community partners, I think, is a great way to do that. But I mean, you know, Sarah, you bring up a really good point, right? Like, you don't have to do code contributions to necessarily like be a valuable team member to the community. So I always find myself in core teams or in teams in general as like the peacemaker or like the coordinator or the like, let's take it down a notch. Person. So, well, thank you all for joining. Y'all are just such a wealth of information. And I think, you know, again, if anybody is looking to contribute to the community or get started, it really isn't that scary. And thankfully, you can kind of slide into these folks' DMs or Discords or create an issue on GitHub. And, you know, people are nice. Nobody will bite. And, you know, just get started. And, you know, honestly, that's like the best feeling, right? Just like, I still remember, you know, a few weeks into my development career, somebody saying, hey, you want to speak at a conference? And I was like, what do you mean? What can I provide, you know? And I mean, it was just a catalyst for me to just get involved and just like, you know, the world is so big, especially with the internet these days. So thank you again, everyone, for joining, and we'll see you all next time. And thanks for attending this panel.
Thank you.
Thank you.
Thanks a lot.
What's up, ViteConf? I'm here today to talk about this piece of web technology that I am super excited about. It's going to totally change the way that you build websites. They're called view transitions. What do they do? How do they work? Let's jump into it. If you don't know me, my name is Fred Schott. I'm one of the co-creators of the Astro web framework, one of the many web frameworks powered by Vite. Ding! And I've been working on this project for a while now, and we just recently had our Astro 3.0 launch, which featured view transitions as a headline feature. So I want to talk about what they are and why we're so excited about it on the Astro team, and how this is something that isn't even Astro specific. Anyone can take advantage of this new tech. It's in the browser. It's here. What is it? What does it mean? There's so much to explore here. I can't wait to jump into it. You might have seen this demo floating around last week, and this is a really great example of what is possible with view transitions. You might be watching this and thinking, oh, like I know the Spotify web app. I know this is some giant JavaScript app that's powering all these view transitions. This must be really heavy and really difficult to build. It must have taken them months. You might be surprised to learn that this is all server rendered HTML. This is not a big JavaScript app. This is essentially the browser hitting the server for HTML and the browser powering the transitions between cards, pages, fades, all with HTML, CSS, and a little bit of JavaScript. This was a demo built by an Astro community member to showcase how powerful view transitions can be. And this did not take a team, lots of weeks and months to build. This is one developer who did an amazing job, but it just shows the power of this API that's now in the web browser that you can take advantage of today to build stuff just like this with not a ton of work. You might have seen some of these other examples. We've been super excited about this tech. It's so beautiful when you demo it. It just shows how powerful the web can be. These are experiences that have been possible, but they've always taken a lot of effort to get right, using userland JavaScript to power and animate. And we've had CSS animations in the past, but it was a lot of work to hook that up in a way that would be seamless from page to page, something that traditionally has been a forced full page refresh or has needed a full JavaScript app to kind of take control of that. This new API totally changes that paradigm in a way that makes these kinds of experiences super, super easy to build. So this is just a taste of some of the stuff that our community has been building with view transitions, and it's completely blowing my mind. It is so, so cool. With view transitions in the browser, this is essentially one line to implement everything you just saw before you. Okay, well, maybe not one line of HTML, at least not for the demos that you just saw on the previous slides. Those required a bit more work, but still way less than you'd think. Ultimately, this is a browser primitive. It's a low-level API, so it's still on you to think through browser support, framework support, accessibility, and actually styling these things more than just the default fade you get out of the box with the browser. And that brings us to Astro. Astro is a web framework with the goal to make web development easier and simpler, with a really modern developer experience and a performance story that's best in class in the JavaScript world today. And for Astro 3.0, our latest launch, we went full in on view transitions. And instead of convincing that we did it, I'm just going to show you this quick video of my friend Theo trying out Astro view transitions in his personal site.
I want to try these view transitions. So let's do it. Add it inside any page's head element. Index. Import. YOLO. Oh, that's really nice. Now I need to add that to everything. Cool. That's so good. I'm hyped. That looks so good. I'm like going to ship this.
So we couldn't get down to one line, but we got it down to two. Essentially importing the view transition component in your project and then putting it somewhere on the page to enable it. 2 lines of code get you that really, really clean fade transition by default with the ability to extend and do even more if you want, go into the lower level primitive, but still giving you a ton of safe defaults around browser support, working in fallback browsers with a polyfill, accessibility, so much built into this API, built into Astro and Astro 3.0. So all this is available in Astro 3. We're so excited with where this landed. If you want to try out view transitions, there's no better framework in my mind, no better way to do that than with Astro today. So we'll get back to Astro in a little bit, but it's something that we are so excited about in terms of making this API super easy to use for developers. So stepping away from Astro, let's just talk about the tech, right? Why are we so excited? What is so cool about this? I mentioned view transitions are something that you've always been able to animate with JavaScript, but it was still on you to control that animation, to ship some JavaScript that could manage and orchestrate it for you. And here in this new API, we're essentially given a start view transition hook, where how it works is you essentially call this to start the transition, move around the elements on the page, so change what you want to see, the kind of final end state. And then when this is done running, the browser will see the before, see the after, and transition between the two for you, all essentially doing the heavy lifting for you. By default, you get that nice fade I mentioned. You can customize it more with CSS. But just the idea of the before and the after being, two versions of the same element on the page, fading or sliding or morphing, like the browser is doing all of that heavy lifting for you, which is just so, so cool. It just totally simplifies the implementation, the amount of JavaScript you need to run this, and it's all done for you by the browser. I don't have time to go deep into how this works in the browser, but I will show you a couple of examples of how you can style and control this, which do give a sense of how this low-level CSS-based selector pseudo-element API works. So this is an example from one of the Chrome blog posts about this, and you can see how they're controlling the animation, changing it, drawing it out pretty painfully, using these selectors, the old and the new view transition. So you can see how with CSS, you can actually start to control this. This is a more advanced version of this, which is the actual kind of material UI fade and slide combo. So you can see how you can really go even further, creating keyframes, creating animations, cubic beziers. I mean, there's so much you can do here in terms of controlling this with CSS. So Low-level API, super powerful, a ton of control in what you can do. Keep an eye at that header. You see how it's kind of a part of the transition. We'll talk a little bit about making sure that you're scoping these animations onto the right part of the page. As you start to do more advanced things like full page slides, you don't really necessarily want the whole page to come with you. So keep an eye out for that. We're going to come back to that in a sec. And the last thing I want to share, which is a little outside the scope of this, but just to really make sure, as we talk about view transitions, one of the best use cases that we see is in the page transition. But you can think of this as an API that can be used for any part of the page, not just a full page refresh, full page navigation. So shout out to Adam Argyle. He's been doing a ton of really cool stuff on Twitter and showing these demos of not just thinking about this as a full page tool, but actually something that can simplify any animation on the page. So huge shout out to Adam. These things are really cool and definitely keeping us exploring what's possible in this API. Now you're probably wondering, Fred, what happened to that meta tag you showed us when you were trying to lie to us about the single line of code needed? All of a sudden we're starting to talk about JavaScript. I know. This part of the API, the meta tag, which basically 0 JavaScript page transitions, that's still in progress. That's actually not available in any browsers except Chrome Canary behind a flag. So it's important to know they're basically shipping this API in 2 different versions, the JavaScript API that we've been talking about, and this one line 0 JavaScript HTML and CSS only API, which is still in progress. So you can explore it, but it's not really available in any browsers mainstream today. This JavaScript API, though, is fairly well supported. Chrome and Edge have support today, and Safari and Firefox have both signaled their support of this API. So I would fully expect this to ship in all major browsers fairly soon. The other thing to think about is which part of your tech stack is going to support this or possibly get in your way. So if you're just using HTML, server-rendered HTML, raw JavaScript, you're probably fine to use this today, right? There's nothing that could really get in your way on a classic JavaScript HTML stack. Some frameworks, though, that take over the full application, they might get in your way, they might cause problems. So it's just good to know if the tech stack you're using today fully supports it. I've called out a couple here. Astro has native support and polyfills for older browsers. Svelte, HTMX, and Nuxt have all also built in native support into their frameworks today so that you have access to those native APIs or have something powered by the framework. So let's talk about Astro and why Astro is so excited about this, where other projects have been a bit more cautiously leaning into this and exploring it. There's a couple things. It really all comes down to the architecture. Astro has this more traditional HTML-driven architecture, which gives us a ton of simplicity and performance that I mentioned at the top. But that means that we can't just rely on a ton of JavaScript to solve this in userland, where other more SPA-heavy architectures might, so more JavaScript-focused. You can do everything with JavaScript, for better and for worse. We also aren't so old that we had to solve this 10 years ago, the way that Rails did with Turbo and TurboLinks. Don't quote me on the 10 years, but some projects have just solved this by shipping an extra layer of JavaScript onto a traditionally HTML-driven site. So GitHub, Rails, this is not new to the idea of actually trying to build this into client-side JavaScript on top of HTML. For us, though, it really came down to not having that history, so not having that baggage of a userland solution, but also not having the full power of JavaScript with a JavaScript-heavy SPA. And so instead of us building this ourselves and trying to work around the problem, we actually saw this API coming and realized it could be the answer to our prayers. This could turn Astro's biggest weakness, not having these really powerful animations, into one of our biggest strengths, having animations, but the browser doing the heavy work for us, meaning we can focus on APIs, wrapping it, interfaces, and really making it a simple experience without having to go and reinvent the wheel in client-side JavaScript. So this really comes into like where we are fully going in on this, right? Building it into Astro, the framework. You can see in the 3.0 example to the left. We've built this into Astro. It's a part of Astro, whereas other frameworks are still exploring what it means to give you access to the browser primitives, but not necessarily incorporating this into the framework. As you can see in this other framework example, unnamed framework X. This is not a moral judgment. Both of these are fine APIs for what they're trying to do, but really highlighting how much our goal is to build this into Astro, not necessarily just give you the browser API and then you go do it on your own. We're trying to give you a little bit more of a protected, good defaults, on by default experience. To give you a quick demo of just how easy this is to use in Astro and how much you get out of the box, I just want to show a couple of quick snippets and demos of what this looks like. So here's our control. This is just a basic website, full page refreshes on every navigation. You can kind of see that happening in the browser, the loader, the full page being replaced on every click, the back button, full page again. This is a really just traditional out-of-the-box Astro site. And what we already showed with Theo was these 2 different lines, the importing of the view transitions component, and then just placing it on any page or all your pages if you want it to happen everywhere in the HTML. Those 2 lines get you this really nice fade transition. So already what we've done is we've added polyfills, so this works in every browser, not just the ones that support the native API. And we've also given you a little bit of a snappier default transition. The fade the browser gives you It kind of depends on what the browser is implementing. And in Chrome and others, we saw a much slower default navigation. So in Astro, we've taken that and replaced it with something a little snappier and consistent across every browser. So you can know what your users are seeing across any browser that implements this. So you can see here, simple fade transition, 2 lines of code. Already this is feeling a lot better. If you want to control this animation and do something like a slide, we actually offer a couple out of the box based on what you might be looking for. So you can see the slide animation here. All you have to do is this 1-line change to that transition : animate. That's a Astro directive that's telling Astro, hey, this should be animated with the slide animation, not the default fade. So you can see here, it slides, and there's actually back support. That's not actually how the browser works by default, but we've given this really cool when you go back, you're actually going to see it slide in the reverse direction, which is just less complexity for you to worry about because that doesn't come out of the box with these APIs by default. So you can control the animation as well using simple keywords for some out-of-the-box animations that have already been designed for you. No messing with CSS yet. One thing I'll call out is that header there, you can see that's still getting the fade, right? So we've scoped this slide down just to the content of the page. I think I mentioned that demo earlier. You can control where your animation happens. If you just want the slide to happen on one piece of the page, make sure you're giving it to that main content, not the top-level body. However, you're still going to see the browser do its thing with that default transition for the rest of your content. So in this next demo, we'll just show you how easy it is to add a transition animate none to the header. And that way, the header is actually just going to get an instant, no animation, just instant replacement with a new HTML. I like this better because I think for nav, you don't really want animation. You want it to be pretty snappy and quick to show your intention to move. So in this case, I like this better, especially if you're doing something like a slide and you don't want the header moving all over the place. I find this to be just a really nice touch to show that the nav is just a part of the page without animation. And last but not least, this is one of the most powerful features that comes with the API that the browser gives us, which is the idea of morphing an element. So how it works is you essentially give an ID to the element on the old page and on the new page. And if you name it with a consistent name across those two, the browser is going to actually handle the morphing from old to new. So again, it takes that snapshot of the old content, morphs it into the new content, and very little of this had to be implemented by us or by yourself. This is all the browser doing that heavy lifting, as I mentioned earlier. You can see how this really seamlessly moves up the page, morphs back, really, really powerful stuff with just, again, essentially 1 or 2 lines of annotation to your HTML. So this is something that's really cool. You can imagine doing this with images, parts of your page, going back to that Shopify demo. You can do essentially all of this with the couple of APIs I've showed you in the last couple of slides. There's fades, there's morphing, there's cards opening and growing and shrinking. There's just a ton of power with just the simple APIs I've showed you and a little bit of customization on top of it. Again, if you want to go into these deeper APIs, you're totally free to do that. Astro sits on top of that and wraps them, but you still have total access to the CSS and the styling of an animation, so you can go and build your own. You're not limited to just what Astro gives you out of the box. I want to talk about 2 Astro-only features here that I think are really cool because they just show how much more powerful we can get as a level on top of this browser primitive. And the first is accessibility. So I actually found this really interesting. The browsers in implementing this did not really build anything in for accessibility. Like everything else on the web, they essentially see that as the developer's responsibility to build experiences that are accessible to their users. I find this really interesting because this is not how I would have expected this to behave by default, but I think their reasoning makes sense. Not all motion is inaccessible. Really subtle effects or things that don't really disturb the page layout can be considered accessible without having to be turned off if you have prefers reduced motion set in your browser. That makes sense, but this is where Astro comes in, where we want to build a good default for everybody. And for us, we really saw an opportunity to have accessibility baked in by default. So in Astro, our animations actually are turned off if your browser has this setting enabled. The idea is that by default, Astro is going to be accessible versus trying to be as flashy as possible for as many users as possible. We like that default a little bit better for our use case. I see why the primitive is much more kind of up to you to decide, but for Astro, this made a lot of sense for our use case and for our users to handle this. And you still have full customization if you want, but a nice default that's more accessible by default is where we drew the line for Astro. This is one of my favorite features, and it's another thing that's only available in Astro today, which is the idea of taking an element and actually making it persist across transitions. So this isn't just a snapshot that's being morphed and then removed. This is actually an element that persists across the navigation so that you get its state persisted. It's everything about how it looks and feels. It essentially lives on from page to page, which wouldn't normally be possible when you're doing a full page refresh, a full page of HTML coming in. So this is a great example of this. You can imagine the Spotify example also, if it had an actual audio player, it'd be able to do this. This audio player on this demo is the same audio player throughout this experience. It is not a new piece of HTML that's being replaced. Astro is basically telling the front-end browser code, hey, when that new page loads, make sure that we replace the old element with the new, replace the new element with the old element. Keep that persistent audio player still playing. Whatever tunes you got, it's playing them. All just totally baked into Astro. Nothing that you need to hook up other than that. So if someone builds a YouTube demo, you can imagine the same thing. A video player, as you navigate, it can morph, it can shrink, but it's going to persist across that page throughout the lifetime of your experience. So that's really cool. Not built into Vue transitions by default, but available in Astro. And bringing this all together, this is just a really cool demo that I'm just going to let play because I think this just totally speaks to what happens when you bring all this together. The browser primitives, the Astro APIs, and some of those Astro-only experiences like persistent UI and state that can persist across the experience. You can see here this demo of an e-commerce site. It's got the page transitions, obviously, but also that really cool chat widget you just saw get closed, persisting across page to page, not being cleared out as you navigate, having that API to persist an element. You can see state here, the user's profile, the shopping cart is being modified and updated. All this is what's now possible in Astro, thanks to some of these APIs and what you can now build with them. So when I mentioned that like we're totally changing how you can build with Astro and what you can build on the web, this is just like a sneak peek of what we're talking about and what Vue transitions unlock for web developers across any tech stack, not just Astro. So Vue transitions are super powerful, and Astro's goal is to make this as easy as possible, checking these boxes for you so you don't have to think about or handle them yourself. Browser support, no matter what the browser supports, having a nice polyfill for older browsers, building it into the Astro language, making it accessible by default. You've got your snappy fade, you've got slides, you've got morphs, and you've got persistent transitions for elements that need to live on across pages. So please, please, please check this out. It's so cool. The browser API, the Astro APIs, whatever it is, this is something that we're only going to see more of on the web. Building these animations responsibly, but also just totally making beautiful web experiences. I can't wait to see what the web builds with this and what you all build with Astro, Vue transitions, Vite, the whole ecosystem. It's never been a better time to jump in. So thank you, Vite, ViteConf, everything, Astro, check it out. I'm rambling. I'll just keep filling this time. Thank you all for listening, and check out Astro if you want to learn more. Bye.
Hello fellow Vite enthusiasts, thanks for joining me today. My name's Ben McCann. I'm one of the creators of the SvelteKit web framework. SvelteKit is a Svelte web framework built on top of Vite. I'm going to be talking today about some of the tools and plugins in the Vite ecosystem that excite me most. I'm going to be doing the demos in SvelteKit, but you should be able to follow along whether you're using any framework or language. I started experimenting with Vite shortly after we started building SvelteKit. We made the jump shortly thereafter and really feel like we made the right choice. Vite 2 is a completely different beast than its predecessors. Importantly for us, it was framework agnostic and supported things like server-side rendering and had great out-of-the-box performance. Vite's large plugin ecosystem and approachable plugin API were key reasons that we decided to build on top of Vite. Vite had a compelling plugin ecosystem from day one because it's built on top of the Rollup plugin API. And that means you can use Rollup plugins in any of your Vite projects. And there are some really handy ones like Rollup Plugin Visualizer that you might find to be useful. Vite, Svelte, and SvelteKit are built with a package manager called PNPM. If you want to contribute to one of these projects, you're going to be running PNPM as part of that workflow. And PNPM has a few nice advantages. Importantly, it allows you to have multiple packages as part of a single codebase. It's also really fast. So I'm going to be using PNPM today so that you don't have to wait for me while I'm installing packages. Let's go ahead and create a new Vite-based project. We'll run PNPM create Vite at latest. We need to choose a project name, so I'll go with Vite Ecosystem. And then I will choose Svelte since that's what I'm most familiar with, and SvelteKit. We'll choose the skeleton project, which is basically just an empty SvelteKit project. and then just go with the standard JavaScript one, and we will choose VTest, which I'll talk about later. All right, now we'll jump into the project. And let's take a look at the package.json that got created. When you create a new SvelteKit project, we set you up with a package.json that just uses Vite as the build command. This gives us the power to really leverage the Vite ecosystem. Whether you're using SvelteKit or using Svelte directly with Vite on your own, you can look at the Vite documentation or the documentation for any Vite plugin and see immediately how to get it to work in a SvelteKit project. Another thing you may notice in the default package.json file is that it contains type module. Type module means that JS files will be interpreted as ESM. Because we were starting with a clean slate when building SvelteKit, we were able to be ESM only from the beginning. Now the Vite ecosystem is moving in that direction as well. In Vite 5, we'll start issuing warnings that Vite should be included with an import rather than a require. Most Vite-based frameworks have already been updated in preparation for this move, so there's a good chance that you won't have to do anything and the move will be completely transparent to you. Note that Vite will still support building non-ESM code, especially in library mode. This change has big advantages because it means Vite will only need to distribute the ESM version of the library itself. And this matters in ways you might not realize. For example, when you load learn.svelte.dev, we start up Vite in the browser so that you can build SvelteKit apps as you follow along with the tutorial. We do this using a really cool technology from StackBlitz called web containers that allows us to execute code for Node.js in the browser. A smaller ESM-only Vite distributable will mean faster loading tutorials for everyone. Creating your project as ESM only is a move I'd highly recommend. Browsers can load ESM natively, and your build and test chain get to be a lot simpler when you're not having to convert between formats, and it's also faster. Most packages out there today are Vite and ESM ready, but there are occasionally a few packages you'll run into that might give you problems. The first thing I always recommend if you hit one of these packages is to load it with a tool called Publint. We set up VTest earlier when running the new project creation wizard, and there are a number of reasons that SvelteKit chose to recommend VTest as its default testing framework. One is that it works great in ESM-only projects. Another is that it can transform your code using your existing Vite config. So if you have TypeScript files or Svelte files, VTest will compile those to JavaScript using your existing toolchain, and it just works great out of the box, whereas I found that to be pretty tricky to set up with most other testing frameworks. VTest also has a just like API, so users from other testing frameworks are going to feel right at home. One feature I like in VTest is watch mode. When you run VTest, it enters watch mode automatically. As you make changes to your file, the tests will automatically be rerun. You may also prefer to run your tests from one of the VTest IDE extensions. There's support for VS Code, JetBrains, and more. I'll spend a lot of time today talking about things that you can do in Vite with plugins, but I also wanted to take some time to talk about things that are just built into Vite that might require a plugin and other bundlers. A lot of Vite's performance-enhancing features fall into this category. SvelteKit is very performance conscious, and as part of Svelte 5, we'll be building on that for meaningful performance improvements. One important performance feature we really leverage from Vite is code splitting and CSS splitting, which typically requires a plugin while using other bundlers. We'll load the SvelteKit website, and you can see there are several CSS and JS files. Vite intelligently combines both JS and CSS output up into chunks that can be shared across pages without loading unused code. You'll notice that the files are loaded in parallel rather than a waterfall where one file is requested, which in turn requests another. We're able to accomplish this using Vite's built-in preload functionality. Preloading these files ensures that they're requested as soon as you hit the page. In other bundlers, preloading might require a plugin or that the user manually annotate which chunks to preload, whereas Vite has great built-in defaults for this. This results in really great performance out of the box. The only thing that we've done on the Svelte sites to optimize them is to install Vite image tools, which I'll talk about later. Vite also does a few other nice things here for us, such as generating output with hashed file names so that they can be safely cached forever. And when using any recent web server which supports HTTP 2 or newer, these files are loaded in parallel for maximum performance. Another great feature Vite has built in is post-CSS support. You just add a post-CSS config and you're off to the races. The Svelte community has built a great set of tools called Svelte adders. When you run a Svelte adder, it will automatically set up your project for some integration. And there are Svelte adders for post-CSS and Tailwind, so you just run one command and then you're set up and ready to go. With one command, you can add Tailwind to your project. Let's go ahead and run that now with pnpx svelte add at latest Tailwind CSS. With one command, it's taking care of everything that we need to set up Tailwind. Let's go ahead and look at some of the things it's done. The first thing that we can see that it's done is it's added the library. It's also set up our post-CSS config. And you can see that it's also added auto prefixer, which handles adding browser-specific prefixes like -webkit or -mos to your CSS. Then it's also added a Tailwind config file. And it's also set up our common styles for us. Now let's add a piece of Vite functionality that doesn't come built in. There's a set of plugins called Unplugin, created by Vite maintainer Antfu, which works across a number of different bundlers like Vite, Rollup, Webpack, ESBuild, and more. Let's try out one of the Unplugin packages, Unplugin icons. First, we're going to need to install it. Unplugin icons will make available a huge set of icons as virtual imports. That they're virtual imports means they don't exist on the file system, but get generated as you request them. We do need to install the icon package though. We want to use some logos, so let's install those. All right, now that we've got those packages installed, we can update our Vite config to use the plugin. And we will need to use the plugin now. And we'll need to tell it that we're using Svelte. Let's open up our page. Now that we've got the Vite plugin set up, we can use the icon. And let's run the web server so that we can see it. There's our icon. It's super tiny, so let's make it a little bigger. There we go. Now we've got a great icon. We do have here a TypeScript error, so let's fix that real quick. We just need to import the types from the package. Now if we go back to types, the type error should be fixed. There are a lot more plugins like Unplugin Auto Import, which automatically imports common imports if you get tired of importing the common APIs. So be sure to go check out the other unplugins. And maybe we'd like to have more than just an icon on our page, so let's include an image. Now I've already included a picture of our fearless leader here, so I'm going to go ahead and reference that. And there we go. Now we have a beautiful picture. Svelte is warning me that I haven't added an alt tag, so I'll go ahead and do that. All right, great. Now the only problem with this is that this image is totally unoptimized. So what we can do instead is go ahead and import it. Then it will go through Vite's build pipeline, which means it'll get built with a unique hash in its name for caching and inlined if it's small enough. So first I'm going to go ahead and move it to live next to our page to make it just a little simpler to reference. Now the image has disappeared, but let's go ahead and we'll go ahead and reference that now. Okay, and now our image is back. But we can take this a step further in optimizing it. I've gone ahead and installed Vite Image Tools, so let's take a look at that. I've already added it to our Vite config. I had it commented out, but now I'll uncomment it. And so what this is telling it to do is convert our image here to avif and webp and return a JavaScript object that can be used to generate a picture tag. Now our site's broken because it doesn't know how to handle this JavaScript object. But what I've done is I've gone ahead and added a Svelte image component. And this image component does know how to handle the picture tag that we're receiving. So now we can go back to our page and use that image component. And now our image is back. And if we go to Chrome for a second, we can see that we have a picture tag that's displaying an avif representation of this image. And so that's going to be a much smaller image that loads much faster. What we set up earlier was project level settings, but you can also set specific image transformations on an individual image. So we can do that here. Let's add a blur. Now I haven't yet set up the TypeScript declarations for this project to let it know that blur is a valid query parameter. I'm just going to go ahead and remove blur for now so that it doesn't feel like you've forgotten your glasses for the rest of this presentation. So now we have a highly optimized image. I think my only complaint here is that it's a little unnatural to use imports for images. What we'd really like to do is just reference the file. And so there's a great preprocessor that allows us to do this. And this is set up here on our Svelte config file here. And what a preprocessor does is it takes a Svelte file and it transforms it in some way before passing it to the Svelte compiler. What we're doing here is we're taking image tags with source attributes, and we're taking that source attribute and we're adding it as an import. So this import can get generated for us automatically. So we can go ahead and remove this. And now we can just reference it the way we'd like to. So now we've got a really nice setup with an optimized image. And you can go ahead and use Vite Image Tools today in a Svelte project. I highly recommend it. In the future, we'll be looking to bundle this all together to make it really nice and easy to use from SvelteKit projects. And there's one more thing you can do with Vite Image Tools that I think is pretty cool. And that's that you can use Vite's import meta glob syntax to import an entire directory of images. So now that we've got this awesome site, maybe we'd like to set up Google Analytics on it to find out how many visitors we're getting. I did that on my own site, but unfortunately when I did, my Google page speed score fell by about 10 points. Now it turns out there's a great solution for that. It's a script called PartyTown. And what PartyTown does is it moves scripts that you select off of your main thread and into workers. All we have to do to set up PartyTown is to first add the Vite plugin. And then we use PartyTown in our page by including the PartyTown snippet. And we set type equals text PartyTown on any scripts that we want to move to the party town worker thread. And after that, you'll have a much faster site. Thus far, we've been building a web application, but what if we want to distribute it as a desktop app? For that, there's Tauri and Electron. You can set up Tauri with just a few easy steps. Tauri uses the operating system's web view for a lighter experience than a full browser, and to keep things lightweight, it uses an allow list that includes only the selected APIs in the final distributable. It also includes a self-updater and offers plugins. Tauri applications start at only around 0.5 MB. Tauri has excellent documentation for Vite-based projects and a number of Vite-specific tips, so definitely check it out. Thus far, we've mainly been using existing integrations, but I also wanted to show you just how easy it is to write your own Vite plugin. All we have to do is give it a name and implement a hook in the plugin API. Now this plugin doesn't do a whole lot, but I just wanted to show you how simple it is and that you can even do it inline in your existing config. They're very easy to experiment with, so don't be shy about giving it a try. Another Vite integration I have to mention is Storybook. Storybook lets you develop components in isolation. Now when you're developing components, they might have multiple states such as a loading state, disabled state, and potentially multiple error states. Navigating through your app to trigger all of these different states might be challenging, and some might be even harder to trigger, like network errors. With Storybook, you can open a component directly and see its different states with just a few clicks of a button. Setting up Storybook is easy. You simply run sb-init and it will detect that you're using Vite, and in this case SvelteKit, and install the appropriate plugins like Storybook Builder Vite. For Svelte apps, I'd also recommend one additional plugin that you don't get by default, and that's Storybook Add-on Svelte CSF. Storybook Add-on Svelte CSF lets you write stories with Svelte syntax as opposed to how you'd normally write them, which is in JavaScript. This feels much more comfortable and familiar for Svelte users, and in fact, there's a couple of things you can't express in JavaScript syntax that you can when using Svelte syntax. So let's go check out these stories. This is from a project called Gradio, and they've set up Storybook to build with every PR that they get on GitHub. And here you can see the stories that we were looking at earlier and change some of the parameters. That wraps up a whirlwind tour of the Vite ecosystem. Hopefully you've gotten some idea of what's possible and maybe even been inspired to go write your own Vite plugin. Go check out the Vite documentation and SvelteKit documentation, as well as Awesome Vite, and the repository for this talk. Everything I've talked about is linked to from those resources.
Hi everyone, I'm so excited to be in ViteConf to talk today about a new way to think about performance. My name is Manu and I work as a framework engineer at Builder.io in the open source team. I've been building APIs and SDKs for the last 12 years, working in a lot of open source companies, and things from making game engines for iOS to backends and today web frameworks. I work with this amazing team. Mishko, he's the creator of Angular, and also the mind behind Quick. Adam Bradley, he was the director of engineering at Ionic. I also work with him in this framework. And some random AI hallucination that we got here. And all of us work in this new framework called Quick. And you might be thinking, why yet another framework? Well, kind of my job today is to convince you that Quick is fundamentally different, that it solves the performance issue in a completely different way. One of the things is that sites require more and more JavaScript. This is a fact. This graph for Web Archive shows that in the last 10 years, the amount of JavaScript has been steadily increasing. You might come to me and say that's not a problem for you, and I believe you, but there are many business cases where this is the case. The fastest website usually means in more money. And for example, that 100 milliseconds faster means 1% more conversions. But why is this happening? Why do sites require more and more JavaScript? I'm going to argue that the only reason is because the current developer experience is flawed. We are making frameworks and technology that leads to these bad results because all the developer experience, all the tooling is about how to make things easy, not about to make things easy and performant. Developer experience is achieved more with less, something that is easy to understand, it minimizes mistakes, a good documentation, something that you can use for scale or big whole teams. All these frameworks are focused on this. That's why they are becoming more popular and makes developers happy. But what it's not, it's about performance. Performance is something else. Performance today is a trade-off. So I'm going to make it like a diagram here, like putting the things that developers actually want in a website. One is capabilities. You want a lot of functionality, A/B testing, metrics, animations, a lot of things, very complicated side. You also want to have nice DX. You want to have easy to build, micro frontends, low time to market. And in between these two, you can find things like React. React really fulfills this dream. You can have a lot of capabilities and very nice DX. How about if I want performance? 100 out of 100, instant time to interactive, everything. Astro can be in that corner because it has a very nice DX, developer like it, and also is very performant. Maybe between capabilities and performance, we have things like HTMLX, which you can do a lot of complicated things and still have a good performance. But really, there is nothing in the middle, and you will say, well, no, I can make a fast website with React. But then that's you. You will lose the very nice DX. You will have to put a lot of extra energy in React or in other frameworks to make it faster. So it's a trade-off. We used to say that there's two types of companies. Those who prioritize performance at all costs and those with bad performance. This is very fundamental. The principle of least effort is something that you can see over and over in nature. That describes the shape of a thunderstorm. Crystals form these shapes because that's the arrangement of atoms that minimizes the amount of energy. Even people will try to find ways to get to the same place and minimize amount of energy. This is some for example with bats. Even trees have these shapes to minimize the amount of material and at the same time be able to expand and be bigger. So nature is lazy. If you are a React developer, what is your path of less resistance when you are building a website? It's going to be most likely use effect everywhere because it's got a nice API. You can just do everything. You can just say, okay, I'm just going to put this. I can just get the job done. The problem is that when you do that, you are getting away from this performance. Most of the developers, you will go through that path that make you get the job done faster. But if you really want to hold performance, you have to put this extra effort. You have to go through the top of the mountain. And it happens with everything you think about. I would say that the best developers can write horrible code. But this is not for a lack of understanding. It's just because good developers find the path of less resistance. You need to get from the point A to the point B. This is you. You start from scratch and you need to get to a beautiful functional app. You will go in a straight line, but in reality, you have a lot of constraints. You have resources, you have maybe limited experience in your team, and some boss that is pushing to get the deadline. So the straight line dream is not going to be the case, and you end up with a slow website. I'm bringing this up because performance is not a technology issue. It's a human design issue. And today, a lot of frameworks don't think about it this way. Performance is something that developers have to do. Our dream with Quick is to completely change that. Quick allows developers to write complex, instant application at scale without extra effort. The extra effort is the important part here. It doesn't mean that you cannot write a fast website with any framework. What it means is that with Quick, you get it out of the box. From an authoring perspective, Quick and React and other frameworks are very similar. It has a very similar component model, and we use JSX, even though we don't use VDOM under the hood. How does it look like when you build a complex website? So in this graph, we plot different frameworks and applications of different complexities from 1, 5, 10, 20, 40, and 80 components. And we see how much JavaScript is being required in the browser. We see that pretty much all of them have the same slope. This means that all the frameworks scale the same way. As the amount of components grow, the amount of JavaScript grows in the same proportion. Today, we are so focused to make the smallest runtime, But we are discussing about things that doesn't really matter for big applications. Quick is different in its flat. It's the first O1 framework. It's the first framework that has a flat scalability. This is very powerful because you can keep building applications more and more complicated, and you don't have to worry about the size of the application going nuts. To understand the technical aspects that allow Quick to have this developer experience that embrace performance in it, we have to understand hydration, and we have to understand one of the main bottlenecks that is causing other frameworks to not scale as well. Hydration is pretty much used by any existing framework. There's a root component, and from that root, everything needs to download and everything needs to execute. And at the end of it, the events, those little boxes, are available and the user can interact with it. This means that every time your application starts, everything needs to run, and at the very end, the events and the stuff can be clicked. There are improvements, of course. You can recognize in the previous tree, I'm going to play it again, that there are parts of it that are static components are the ones I put it in black. There's a whole branch in the footer that there is not have interactivity. Partial hydration recognizes this and say, look, I don't need to walk the whole tree because there are static parts. I can split my application into islands and be able to do a still hydration of this little bar. So you can actually get interactive faster and running less JavaScript. So it's a big improvement. You can decide a little bit later, I can hydrate a different part of my application, which is again, a very nice win. But fundamentally, it's the same algorithm. I want you to pay attention to these dotted lines. These dotted lines represent work. These islands are not done automatically. This is still an extra effort that developers have to put to make these islands. And I want you to pay attention to this. If you just make an application, you will not have any of this benefit. You still have to put the extra effort to get the benefit, which, as we show with the passive load resistance, it might not be the case because developers just want to get the job done. So it solves the problem from a technical point of view, but maybe not necessarily from a UX point of view. React Server Components is a very similar idea. It's able to identify that a subset of the root nodes are static, and then the application hydrates. The nice thing about React Server Components is still there is a single root. The single root allows things such as communicating between part of the tree without any problems. Also, React Server Components can do some sort of defer hydration. The main difference, in my opinion, is the shape of this dotted line. While in partial hydration, you will split your application into different blocks, into different islands. In React Server Components, you will be more like a split, more horizontal. That means that the root components are static. You don't think about that much into different islands. And as I said, you can have communication very easily. Procedurality, on the other hand, is instantly interactive. Notice that there is no walking from the root components up to the event handlers. The event handlers are the first things. It's almost like we flip the graph. Now the roots are not components anymore, but the event handlers are always there as the first thing that the application gets. That's why it's instantly interactive. You don't have to download all the components, even there's hundreds. And the interesting thing is that there are no dotted lines. There is nothing the developers need to do. You just write an application normally and it will behave this way. It's fundamentally a different algorithm that has these fundamentally different performance capabilities. In theory, there is no difference between theory and practice, but in practice there is. And when I came back to the previous example where you had the partial hydration, and your boss tells you that you need to need a new button in the header to hide and show a newsletter from the form, from the footer. What is that? So now you need to communicate the header with the footer. This means now that, well, less time to refactor. You will have to create a new island in footer, and now you will have to be able to put together the header and footer because you need some sort of communication. Systemic performance issues cannot be solved with a new API. One of the philosophy in Quick is that we don't want to have a list of best practices. We really spend all our energy into thinking how developers will solve a problem and make sure the framework can do it in a way that is performance out of the box. So a lot of these things is about reducing how much time and how much effort is required to make a slow website, and also increase this resistance towards performance footcams. If there is something developers should not do, it should not be easy for them to do it. So now that you understand, I can just show you a little bit of how it looked like. Let's check it out.
All right, let's create a new app using npm or pnpm create quick. We can specify some folder where we are going to open the app, select one of the main starters, and install dependencies. Let's open VS Code and start playing with it. We can run pnpm start, run the dev server. One of the first things I want you to pay attention is that this application uses a lot of components, a lot of routes. There is a whole meta framework of components and routers, but still this application doesn't deliver any JavaScript. If you don't believe me, we can just go to the routes, we can use components, and there's a bunch of components, there is a bunch of things, and all of them behave like a fully static component. In fact, I can add a button, give it some interactivity. For example, I'm going to do just a very simple alert, hello world. Let's see how this looks like. There we have the button. Still, if I refresh the page, there is no JavaScript, but just in the moment I'm clicking, we will see a little piece of code that gets downloaded and executed. And the alert is here. If we see this code, we see that the only code that get executed was the hello world. This is mind-blowing. Because in Quick, even if I put a console log at the very beginning of the application, I put logic, this logic is going to happen within the server. But still, if I fully refresh the browser, none of that code ever gets executed in the browser. Still, if I place the alert, that will be the only code that executes. This is only possible because Quick is able to take a component like this and using our optimizer, break it into a lot of small symbols. So the application here gets broken into one symbol that represents the rendering of the component itself, and also another symbol that represents the on click. This is something that not other framework or bundler can do. Bundlers such as Rollup, which is a technology that Vite uses, can only bundle things together, not break existing modules into lots of small parts. Quick, however, uses Vite. In fact, the recommended way to use Quick right now is using a Vite plugin. We are extending the capabilities of Vite and Rollup to be able to break up modules into smaller ones through their amazing plugin system. The example I showed before is very simple, but we can start to make it a little bit more complicated. For example, I'm going to create some state. We create state with signals. So I want to use signal and give it an initial value of 0. I'm going to then render and say, counter, and print the value of the signal right here. Now, in the click handler, instead of printing an alert, I'm going to just say count value ++, so I'm going to increment the value of the signal. Again, for demo purposes, I'm going to put some console logs. I'm going to click here, and I'm going to put at the very beginning, re-render. It's going to simplify a little bit, just to keep it simple. Remember, there's many other components with a lot of interactivity. There is no JavaScript being executed, but just for the demo purpose, I'm going to simplify a little bit more. When I test this application in any framework, we will see re-render in the server because this is being SSR. And we will expect to, when we click here, also see re-render. However, in Quick, when I click re-render, there is only click. This is mind-blowing if you understand the fact that we are able to execute this piece of code in complete isolation. We don't even need to download this component. In fact, this component is never, ever executed in the browser. The browser never needs to render the button component itself. Resumability achieves this by being able to serialize the state of the application. If we check the DOM, we will see that there is a JSON state, and this JSON state represents the current state of the application when it gets serialized in the server. What we can do with it, for example, is we have the 0 state here of the counter. We see a little 0 here. If I change the initial state to be 10, the initial state will be here. This means that we don't need to re-execute this code in the browser in order for the application to become interactive. The click is immediately there, and it doesn't matter if you have 1 or 1,000 components. In the demo I saw before, when I click, something only gets downloaded when I click. But in production, for example, the website of Qwik itself is using, Qwik. We use a technology called speculative module prefetching. When we open a Qwik application for production mode, we open the DevTools, we will see that the service worker that we specify here is pre-downloading everything that is possibly interactive. It doesn't mean that it's going to download everything. It's just downloading the things that are possibly happening in this page. For example, when I click to change the dark mode to light mode, it will show here that the cache was actually already here. This means that we don't infer into any latency costs. It's almost like an application streaming. When you see a video on YouTube, the browser is already prefetching the next frames. So even if you don't download the whole video upfront, you can still enjoy it. The same principle is used for Qwik when we are able to stream and prefetch modules before they are actually needed. What this means as a developer is that you never have to do any sort of dynamic imports. You don't have to worry about how to bundle code. You don't have to worry about how to optimize your code to have fast re-renders. Qwik is handling all these things for you. There is no best practices. And I think that's the mind-blowing fact about Qwik. That's what gets people very excited, that there is nothing to learn to make an application faster. Whatever you write in Qwik automatically will download no JavaScript. In fact, in Qwik, you have to force the early execution of JavaScript. If I want some code to execute as soon as possible, I have to specify with something called use visible task. So for example, if I say, hello, and I open this in the browser, I will see the hello. That's the only way in Qwik to execute code upfront. Otherwise, it doesn't happen. This may be interesting for things like running some WebGL application. The ability for Qwik to do this kind of breaking out modules into different parts can be used for things such as executing code in a completely different environment. For example, just by using the server Volar I'm importing for our meta framework called Qwik City, now the same component that used to print click, now it doesn't do anything here because in fact, the click happened in the server. Again, imagine just being able to change that makes it able to say click, 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 nothing here, or say server $, and then click, 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 click in the server side. It's just a very small thing of what Qwik can do. We have a full meta framework that allows to do directive-based routing, middlewares, endpoints, integrations with all sorts of deployments, and everything you build, even if it's extremely interactive, it will execute no JavaScript out of the box.
Thank you very much for your attention. And please follow me in Twitter, Manu Corporate. I also make cool videos and explain concepts about HTML and CSS. And please stay for the next ViteConf speaker. See you.
Welcome to ViteConf 2023, and thanks for checking out this presentation. I hope you will walk away having learned something about Vite, Marco, and all the considerations that go into the tooling we use for modern web applications. Firstly, hello, my name is Dylan Piercy, and I started building and contributing to open source projects around 2012 when I fell in love with the potential for the web as a platform. Professionally, I've worked at various agencies, building experiences ranging from as simple as a marketing splash page to really quite complex and large web applications. Important to this presentation, though, in 2018, I joined the Marco dev team at eBay, where I work on the open source front-end framework that powers the majority of the eBay web experience. More on that later. You can find me on GitHub at github.com/myname, and I'm also Dylan_Piercy on Twitter. Follow me over there to learn the occasional objective truth I share exclusively on that platform. This presentation is going to be fairly high level. We've only got about 20 minutes. First, we'll go over a question many of you likely have. What is Marco, and why should I care? I'm sure it's a framework many of you haven't heard about, but something I can confidently say is it makes building many types of applications both a joy for you, the developer, and your users. Next, we'll be looking at Vite. This is ViteConf after all. I'll be highlighting many of the strengths that make Vite a great pairing for any front-end framework, and especially Marco. Finally, we'll dig into the finer details of our new meta framework, Marco Run. It's built on top of Vite and Marco. We'll close out with a demo showcasing its simplicity, scalability, and flexibility. So who or what is Marco? Well, one aspect of Marco is that it's not just a framework, but a language. Marco, as we like to describe it, is HTML reimagined. Marco is a superset of HTML that makes describing modern UIs a breeze. The language is designed to be composable, reusable, and familiar. It is as if HTML and JavaScript were developed in harmony. Marco's roots come from a need for optimization, and so one of its key benefits lay there also. Marco is a compiler that takes the Marco language and outputs distinct, optimized JavaScript for both servers and browsers. Marco has been an islands architecture framework long before the term was even coined. If you're unfamiliar, in essence, the islands architecture is about trying to send JavaScript required just for the interactive parts of the page, contrasted with the current status quo of sending an entire application's worth of JavaScript to the browser. With Marco, this is seamless. By default, components are exclusively rendered on the server. Then, the very APIs that you use to add client-side rendering also mark the component as an island. This means you don't have to opt in for a client component. There's no use client pragma here. The API naturally does that for you. So write your client-side logic, and Marco figures out the rest. Finally, another big optimization set in place from the beginning with Marco is progressive rendering. Through a simple HTML tag-based declarative API, you are able to orchestrate how the HTML is chunked and sent to the browser. Marco will ensure that as much HTML is sent over the wire as eagerly as possible, so that the end user is able to see parts of the page earlier. This is great for perceived performance. However, it also means that critical assets such as CSS and scripts and other important assets like images and fonts are able to be seen by the browser earlier. This moves the critical network waterfall earlier and can dramatically improve load times. So I've alluded to some of the things Marco handles for you. Marco is designed as a multi-page app framework with as much of the logic as possible moved exclusively to the server. In Marco, server-side rendering and the natural multi-page document model which browsers have had since 1994 feels first class. Beyond that though, Marco handles the server-client handoff for you. It finds your islands of interactivity, it serializes any relevant component input, and attempts to execute minimal JavaScript to bootstrap client-side interactivity. In many ways, Marco is also like a bundler. It scans your Marco templates in order to determine the optimal subset of your code and assets to send to the browser. But don't worry, I know this is ViteConf, we still have room for bundlers like Vite. Besides, Marco only mostly cares about the Marco language and not the JavaScript part. So let's take a look at Vite and what features compelled us and many other front-end framework authors to give it such a strong recommendation. At the top of the list for us is something that should probably surprise no one. Vite has first-class SSR support. Vite is a bundler for not only your client-side code, but also your server-side code. This is critical for offering a consistent developer experience across a modern front-end stack. Vite also operates in an unbundled fashion. This optimization allows Vite to do less work and deliver a tighter feedback loop in development. To the browser, Vite serves native ECMAScript modules, and on the server, it similarly only processes and executes on an as-imported basis. Another huge feature of Vite is hot module reloading. If unfamiliar, hot module reloading is essentially swapping out an individual module when making code changes, rather than reloading the entire app. This has huge benefits, like preserving application state. Vite's hot module reloading is client-server aware. When changing a module, Vite can intelligently hot module reload the code in the browser and the server. Critically though, if code is only hot reloaded on the server, it can smooth things over by doing a page refresh in the browser. This means even for code that is exclusive to the server, you get a tight feedback loop without having to either manually refresh the page or wait for a sometimes lengthy server restart. So we think Marco and Vite make a great pair. If you care about optimization, server-side rendering, and a great DX, it's worth checking out. However, this presentation is mostly about the new meta framework we've built on top of both Marco and Vite, which we call Marco Run. Before we get there, let's consider what some of the primary meta frameworks wrapping other front-end libraries bring to the table. Picking a framework and a bundler is a great starting point. This is especially true for Marco, given its holistic look at the server-client story. In fact, features touted by other front-end frameworks are included by Marco itself in order to deliver the optimizations and features mentioned earlier. So let's take a look at some highlighted features in the marketing material for some other meta frameworks. Most of these meta frameworks should sound familiar. We've got Next.js for React, SvelteKit for Svelte, Nuxt for Vue, and Solid Start for Solid. This is by no means an exhaustive list of frameworks or features, but even with my 2 seconds of scraping buzzwords from their documentation, I believe I have a good representation of common meta framework features. Many list SSR, rendering, or streaming, which is one of the hallmarks of Marco, so of course it's built in. Likewise, due to Marco's server-first mentality and async rendering primitives, data fetching and loading come naturally. Pretty much every meta framework also lists routing as a primary feature. This is surely an important thing to consider when building for the web. In fact, it is a must for SPA framework, which must re-implement navigation in the browser. However, with Marco being a multi-page app framework, historically we've leaned on the robust routing solutions provided on the server, tools such as Express, Fastify, and others. This can work great for large-scale apps, but can also lead to unnecessary boilerplate and inconsistency in the Marco ecosystem. With that in mind, a consistent and fast routing solution certainly is something where a meta framework can help Marco developers. Likewise, a common benefit listed in these meta frameworks is reducing configuration, boilerplate, and simplifying the getting started process. In general, Marco is probably one of, if not the most boilerplate-free frameworks, so we're already doing pretty well there. However, when it comes to bundler integrations and config, in some cases it can be a challenge. In fact, your typical Marco config when working with a Webpack application can easily be hundreds of lines of code. With Vite, though, the configuration is as simple as enabling a single plugin. Still, we'd much prefer zero config, which is something a meta framework can help us out with. Another commonly shared meta framework feature is providing flexible deployment options, again with minimal config. So many of these features caused us to take Marco a step further, pun intended, with our new meta framework, Marco Run. I mentioned what the goals of many of these other meta frameworks are, but what about our goals? For us, a big consideration is ensuring that Marco Run is able to give users full control. As I mentioned earlier, Marco was primarily built to satisfy eBay's performance and developer experience needs. As such, it needs to be able to fit into the sometimes complex eBay ecosystem. It's critical that we give developers all the control they need to embed Marco in many environments, and also give them the ability to fine-tune their applications to achieve performance goals. However, Marco is also an open source project and part of the OpenJS Foundation. We want to see it thrive there as well. With that in mind, we need to ensure that this meta framework can support all flavors of app types and scales, striking the balance between simplicity and flexibility. A fast feedback loop during development is also critical. A great developer experience means nothing if you can't deliver a good user experience. But in the same breath, a great user experience that never ships is even worse. Thankfully, Vite helps us a lot here with its unbundled and hot module reloaded dev mode. Finally, I mentioned that we wanted Marco Run to require zero config. That sounds nice, but often in practice, this can be a lie. Much like the point of a zero.js framework isn't actually about sending zero.js, but instead sending as little JS as possible, we believe config should work the same way. Marco Run not only gives good defaults, infers config where possible, and removes pointless config, it also makes it possible to add config in a way that doesn't quickly become a mess at scale. More on that later. Starting with the Marco Run CLI is as simple as running npx @marco/run. You don't even need to install the module or go through the setup process I just mentioned, although we would recommend doing so. The default command is the dev command. This starts up an unbundled and hot module reloaded development server, thanks to Vite. The build command outputs a production-ready server and browser assets, ready for your deployment target. Finally, the preview command does a production build and starts up a preview server according to your deployment target. This allows you to quickly test out the final product of your application. When you take a look at the starter project, one cool thing you'll see is there isn't so much as a Vite config in sight, thanks to the great defaults. To extend Marco Run's config, you can add a Vite config.js to fine-tune things further. However, thanks to the adapters I mentioned a few times, even this is often unnecessary. Adapters are discovered simply by having them installed and don't require any config. So what is an adapter? Well, an adapter is essentially a plugin for Marco Run that can change a lot about your application. It can specify alternative defaults in config. It can hook into the dev and build output to optimize things for different environments and targets. Finally, it can implement an entirely different preview environment for your app and as close to a production experience as possible. Some example adapters are the default Node.js adapter, which creates a standalone Node server. There's also the static adapter, which will output your Marco Run application to a static HTML site. And this is without you having to change any of your application code. Simply install a module. We also have adapters for some serverless solutions like Netlify and soon Cloudflare. And what's great is you can easily make your own adapters for your organization. In fact, at eBay, we've been able to hide otherwise hairy internal configuration and annoying development and preview environment setup behind the eBay Marco Run adapter. This has allowed us to take our relatively complex applications and provide the zero config experience. Besides hiding configuration behind adapters, we are also able to infer configuration based on the project structure and existing files. File system-based routing is another aspect that follows this goal. The routing to your pages and handlers, as well as layouts, route middleware, and even endpoint-specific metadata are all represented simply by their file system path. Taking inspiration from SvelteKit, all of these router-related files are clearly denoted so as not to conflict with other files in your project. This makes co-locating related files, including styles, tests, documentation, storybook stories, and of course other components, easy and safe. And all of this is statically analyzable, which provides many benefits. One of them being that we're able to produce optimal route matching code. In fact, Marco Run compiles your file system routes into an optimal try-based router. It's actually just a series of nested if statements matching the individual portions of your route structure. It's pretty much as fast a routing matching system as you can get. We also take this static route structure and automatically output TypeScript route definitions, providing you with type-safe route checking for things like path parameters. Marco Run's file-based routing follows a few simple rules that allow us to match any sort of URL. First, the router only picks up on files if they're specially denoted. Inspired by SvelteKit, we opted to use a plus prefix for this. We'll talk more about the other special files soon, but for now, an important thing to remember is that the path structure up to the plus page.marco in this case is what determines which URL to match before serving that particular page. We also provide dynamic segments for URLs, which may be read as params in your application. These are denoted by a $sign for a single route or a double $sign for a catch-all at the end of the route. For simple apps, this is likely all you need to know, but Marco Run provides additional syntax for more complicated paths. This includes pathless segments, alternative paths, and methods for merging multiple path segments into a single file name. Okay, that was a lot of nitty-gritty syntax, which may or may not have left your mind already. So let's take a more visual look. Here, we've got a basic editor Chrome and file structure on the left, and there's also a pretend browser Chrome on the right. You can see the routes folder. We've got two nested folders in there. There's a users folder and a $ID folder. The users folder will ensure we match the user segment before continuing to match in the URL. Then we get the ID folder, which will match a dynamic segment and make it available as an ID property in the params. So that means, given our URL here, the plus page.marco at this folder location will be matched and rendered to the browser. Another special routed file type are layout files. These allow you to wrap your routed page files in additional template code. These can also be nested, allowing you to apply them to only part of your app. Starting with the root layout file, you can see it will receive a render body on its input. For those more familiar with React or other frameworks, this is essentially props.children if you squint. It can then render the body content wherever it likes. In this example, it's wrapping the body content with some HTML boilerplate, as well as an app-wide header and footer. Nothing too crazy. But again, these layouts can be nested. Within the users folder, we see another layout. This one will automatically wrap all pages and layouts from within the users folder. In this case, it's adding a user-specific nav. Again, we receive the next part of the body content as input.renderBody, which we can inject anywhere we see fit. Finally, we get to the page, which will be rendered and provided to the two previously mentioned layouts. Marco Run also provides a routed file called a handler. This can be JavaScript, TypeScript, or really any type of file that compiles to JavaScript. It is able to export functions to handle HTTP verbs, such as get and put. These functions receive a context object containing the current incoming request information and should return a response object. This allows you to create API endpoints in your Marco Run application. The get handlers also receive a next method, which will return a promise containing any adjacent page's rendered response. This allows you to easily get in front of rendering a specific page. You can use this to provide data to the page and/or augment the response in some way. In this particular example, we're checking the HTTP accept header and responding with page content when the user agent expects HTML, and otherwise we're responding with a JSON response. Another type of routed file are middlewares. These are like layouts, but for your handlers. They run before any handler or page nested within the same folder, and allow for your logic to run both before and after the handler or page has responded. This is useful for cross-cutting concerns, such as logging, authentication, and more. Flat routes are another important feature of Marco Run's file system-based routing. This feature makes it possible to represent arbitrarily complex route patterns without having to create a bazillion folders. Let's look at the example on screen. It's pretty simple. At the core of it, there's an items page, a products page, and each have a dynamic ID segment. However, either endpoint can also optionally be prefixed with a locale of EN or FR. Technically, anything is possible to represent without flat routes, and this example is no different. As you can see, though, it gets pretty cumbersome. Not only are we creating a bunch of folders to represent each possible permutation, we also have to figure out how we're going to share the logic between them. Possibly this could be done by re-exporting the component all from a canonical source, but it's not great. One way flat routes help simplify this is by allowing alternate segments without requiring alternate folders. You can see here now that we've got a single folder which will match either items or products by just adding a comma between the two possibilities. Having a trailing comma at the end of the segment also marks it as optional. With the folder named en, fr, we can see just that. It will match en or fr or nothing, before going to the next nested folder and continuing the match. Beyond having a shorthand for alternates, there's also one for collapsing nesting. Using a period in a routed file or folder within Marco Run will act the same as a nested folder. Even something as complex as this can be represented as a single file or folder. We can combine the period nesting syntax, comma alternate syntax, and use parentheses to group path segment expressions, leaving us with what's on the screen to the right. I'm not saying you should ever have a routed file like this, but in practice, these things end up being a lot simpler. In a pinch, they can be extremely handy for code organization and layout and middleware application. It's also useful for the occasional one-off complex route that you might have in your application. All right, that was a lot about routing syntax. Like I mentioned earlier, though, an important job of a meta framework is to provide a robust routing solution, and I think Marco Run delivers one of the best. We'll end off with one of my favorite features of Marco Run, which is that you can easily bring in your own server. To do this, first pass in a script as the entry point for the various Marco Run CLI commands. This script will be processed by Vite, meaning you can use TypeScript and other features of Vite. While running in dev mode, it will also automatically reload the server whenever any code changes that isn't a part of Marco Run's routes. Then you can simply load the relevant API into your application, which can be different based on the adapter you have installed. In this example, we're using the Node adapter. You can see it allows you to import all of the Marco Run routing code as a simple, Express-compatible middleware. But we can go a bit lower level and see what the Node adapter's middleware is built on top of. The core API for all of your Marco Run routes can be loaded by importing @marco/run/router. Most importantly, this module is what provides programmatic access to the trie-based router that will ultimately serve your Marco Run pages and handlers. One cool thing here is that the API is actually modeled after the fetch API. Calling run.fetch with a request instance will return a promise with a response instance. This is a very simple API that happens to integrate very easily with some runtimes such as service workers, Cloudflare workers, and even Bun. Okay, we've gone over a lot, and I've really only scratched the surface of Marco Run. So let's go kick the tires in VS Code. Here we're looking at a fresh Marco Run project initialized through the Marco Create CLI, with some slight tweaks for ViteConf. You can see there's not a lot going on here, and that's a good thing. At the root, we see a bog standard TS config, as well as the package JSON. The package JSON is also pretty simple. It just lists Marco and Marco Run as dependencies and has some scripts which defer to the Marco Run CLI commands. So let's run the starter and see what it looks like. We'll go ahead and click on this link to see a nice looking grayscale Marco logo. This example has some client-side interactivity as well that enables this cool effect where moving the mouse position reveals the actual colors of the Marco logo. Now back over on the VS Code side, let's jump into the routes folder. We can see our routed files like this layout and page over here. We're going to first open up the layout. Again, in Marco, the starting point is HTML. We've got our basic HTML structure here. You can also get nice things like the ability to reference relative asset paths like this favicon, and still have them go through Vite's optimization pipeline. Heading over to the page, again, we've got some simple markup and a reference to this mouse mask component, which is actually what provides our cool color effect. Now, Marco tries to keep code on the server. The layout we just saw and the page we're looking at now are actually both server components. They don't send any JavaScript to the browser since they don't use any client rendering features. But let's go ahead and follow the suggestion of editing the page.marco and see what happens. You can see the change is reflected pretty much immediately, but what you might have missed is that this was actually a full page reload, since this is a server component. Critically though, it did not restart the server. Instead, the server was able to do a hot module reload while the browser did a page refresh. Okay, so we're going to check out a client component. We'll command click on this mouse mask component over here to jump to it. There's some syntax here and shorthands I'm not going to cover right now, but the important thing is that this component registers a class seen on line 15. This class adds some client-side behavior to synchronize the mouse position with CSS custom properties on line 9. Now I'm going to make a small change to this component to disable the styling that makes the Marco logo grayscale. You can see this time, Vite is logging that we've done an HMR update, And in fact, no page reload has occurred and the client state is persisted. This is kind of a short demo, but I want to show one last thing. First, we run the Marco build command. You can see in the dist folder, we have our client-side assets and a script which contains our server-side code. If we run that file with Node, we can see that we have the same app, but running in production mode. Of course, a simpler way to do this would just be to use the Marco preview command like so. This again creates a production build and then runs it for us. All right, finally, let's try and install one of our adapters. I mentioned earlier that the static adapter can take your Marco run site and output a static HTML site, which you could then easily deploy to hosts such as GitHub Pages. So I just run the npm install command with Marco run static adapter, and then we'll rerun the build command. This time in the dist, we can see a static HTML file without any changes to our app. I can then serve this new build project using the same preview command or any off-the-shelf static file server. There's one on npm called serve, so if I just npx serve and point to the dist folder, you can again see the same experience, but this time served from static HTML. That concludes the demo and my presentation. Thanks for taking the time to check it out, and thank you to ViteConf for having me. I hope this presentation leaves you with some insight into the kinds of considerations that go into frameworks and meta frameworks, and why Vite has helped so many of them tie the experience all together. I hope you'll take the time to give Marco Run a try. I think you'll find it makes you a little faster. Thank you.
Hello ViteConf 2023. I'm super excited to join you for this conference, and I want to talk with you about React Router and Vite. Is that a framework? So my name is Kent C. Dodds, and I am currently working on epicweb.dev, where I'm going to teach everything you need to know about building full stack web applications. So I'm really excited about that, and I hope that by the time you watch this video, we'll have a launch date announced, and it should be very soon. So yeah, stay tuned. It's going to be awesome. Very, very epic. So check out epicweb.dev. So let's talk about frameworks and what that even means. So I tweeted about this because, you know, let's just see what the Twitter world has to say about that. And got a number of replies. So my tweet was, what's table stakes features for a framework in your mind? Is React a framework? Is Remix? Is Next? What would you say are properties of a framework? So I got a number of replies. So a lot of people will say, if you use it, it's a library. If it uses you, it's a framework. So that's what I got here. If you use their code, it's a library. If they use your code, it's a framework. I hear this actually pretty often when this debate comes up, and this debate has come up with React a lot, where they'll say, okay, so is React a framework or is it a library? And they always, somebody will always say something like this. I kind of get where it's coming from, but I struggle to take it away from the philosophical feeling there. Like it just doesn't seem tangible enough to me. And so, yeah, not sure that one's totally the way that I'm going to go. If it has a conference, so there you go, Vite, you're a framework apparently. I just thought this one was kind of funny. It's a fun idea, I suppose. And then here's another one from Artem, creator of MSW. A framework tells you how to do things. In that regard, React is a framework, like hooks and suspense. So is Remix, loaders, actions, and routing. And Next, hooks and routing. And so Artem says, I would call Remix and Next meta frameworks since they're built on top of React, which I also find to be a framework. This gets a little bit closer to what I'm thinking about when I talk about a framework, but still have some more things to talk about with that. So also, we could think about a list of features. Is a framework just a bunch of features? So Taegert, you've got routing, server and static rendering, data fetching, static assets. I would add to this a really important feature would be data mutations. So yeah, it could be a list of features that that could be a part of it. But I think where it really comes down to is actually David's response to Aaron's response. So let's read Aaron's first. in my mind, a web framework needs all of these things. So here we had a list of features, and now we have all of the features. So auth, middleware, routing, caching, database and ORM, mail, testing, CLI, background jobs, and schedule jobs, off the top of my head. And that's actually exactly the reason why I asked whether Remix or Next are frameworks, because I know a lot of people just naturally assume that those are frameworks, but for a lot of people outside of the JavaScript ecosystem, a framework requires a lot more than what Next and Remix support or ever plan to support. I feel like the JavaScript ecosystem is okay with having like little things that they kind of glue together. And I think there's a reason for that we can talk about a little bit later. But yeah, so Aaron suggests that all of these things are what is required to be a framework. But David gave a really thoughtful response that I think explains why we have so many differing opinions. And that is, I think the classification of framework is relative to the scope of the problem space. React is a framework for putting together UIs. Express is a framework for handling web requests. People have broader and narrower problem spaces in their mind when they argue about this. And I 100% agree. I think that is very well said, David. Thank you. So here's another one that I just thought was kind of funny. This is my favorite. Vite plus a router is a framework. Oh my goodness, did they know that I was going to be giving this talk? Because that fits in perfectly with what I want to talk about. But I think my favorite of all of these for real is from Joel Hooks. So a framework is strong opinions and guidance in terms of structure and tooling. And what I'm working on with the Epic stack is to build exactly that. I want to build for TypeScript, for the JavaScript ecosystem, a framework that has strong opinions and guidance. Yeah, I'll just say it again, strong opinions and guidance in terms of structure and tooling. And so that, to me, in my mind, that is a full-fledged framework. But I really like what David said. And in the lens of what David said about frameworks being scoped to the problem space, I think that to answer the ultimate question, is Vite and React Router a framework? I think it can be. And so I wanted to show you a little demo of the React Router tutorial for just getting started with React Router, which uses Vite. And so here in my editor, I've got the source directory. We have our index.html. This is where it all begins, of course. And it's just a pretty basic SPA, not much going on in here. And we bring in the source main TSX file. So with that, then I can come to my main TSX file. Oh, and I guess I should show you a demo. So here, we can create a new contact. And let's do Kent C. Dodds and at Kent C. Dodds. And did you know that you can put your GitHub URL and add a .png, and that will redirect to your avatar. So fun fact. Kent is me, and then save, and boom, there that is. We can edit, we can cancel, we can star, we can search, and all of that stuff works as you might expect. So how is this constructed? Well, one of the things that React Router gives you, of course, is a router and a way to define your routes. Now, I appreciate that Remix and Next have these file-based routing systems that are quite nice for that opinion on structure. And we kind of lose that when we're talking about React Router, where it's all configuration type-based routing. But that said, I feel like we kind of lose some stuff when it comes to that file-based routing. There are only so many characters that you can use and abuse in a file name to be able to define different params and stuff like that. So that has been a challenge for me myself. And so I actually really appreciate that Remix allows for a combination of configuration-based routing and file-based routing. And I think in the future, it's possible that going back to configuration-based routing like this would be even preferable. The drawback there, of course, is now you don't have all the opinions on where things are located, and that's the case here with Vite plus React, because there is no like Webpack plugin or ESBuild plugin that says, okay, load all of these routes. There may be something, but not to my knowledge. And in this case, that's not the case. So, but a couple of things I want to call out here is we have loaders for loading data and actions for handling mutating data. We have error handling And then of course routing. I think all of these things are kind of the like what Taegert was saying, the baseline for stuff that you absolutely need in a router or in a framework. And then of course you've got everything else, within the fact that we're using a TypeScript project that can be run on the server as well. So if you wanted to upgrade to a more full-fledged framework, then yeah, you totally could. So as I wrap up here, I just want to answer the question, why are we not using the all the things framework? Why don't we all just use Laravel that includes all of this stuff? And I think that there are some things that I just want to be able to do that involve writing TypeScript on the front end and the back end and using the exact same code on both sides. I don't want to write some code that is like in PHP that evaluates stuff, like converts into some JavaScript that runs on the client. I feel like my hands are tied in that world. And so I'm okay putting a lot of effort into making something like the Epic stack to make a more full-fledged all the things framework. So stay tuned for that. And as I mentioned, you may want to upgrade to Remix for the better user experience. And that's one of the really cool things about using React Router and Vite, is that once you get to that point where you decide, oh, I want to have the better developer and user experience by having progressive enhancement and server rendering, all of that, the migration there's a great migration guide from React Router to Remix that you can check out on the Remix docs. So I recommend looking into that if you haven't already. The last thing I want to say is just build cool things and be happy doing it, and let other people be happy building the cool things they're building. That's all I have for you. Thank you so much. Please do check out Epic Web Dev, and we'll see you around the internet. Bye.
Hi, my name is Fatih, and today I'm going to talk about Headtip, a runtime and platform-agnostic HTTP server framework. Now, why do we need another HTTP server framework? There are already dozens of them: Express, Scala, Festify, Happy, Polka, Hono, Nitro, and many, many more. Do we really need another one? Today, I'm going to try to convince you that yes, we do, at least for 4 reasons. And the first reason is that Headtip is compatible with all runtimes. Reinventing first introduced Node.js 14 years ago. It was met with a big round of applause at JSConf 2009, but people from other communities were skeptical. 14 years later, Node.js is maybe the most popular programming environment in the world, while the skeptics remain skeptical as they ride their Lambos to the next WordPress meetup or something. For many of us, Node.js is the primary way that we make a living. But server-side JavaScript isn't limited to Node.js anymore. There are serious contenders. Ryan Dahl himself announced Dino 5 years ago. A few days before I recorded this talk, Bun version 1.0 was released. Another important area that non-Node JavaScript runtimes are leading is edge computing. While it's possible to run Node.js on the edge, there are lighter weight runtimes designed for the edge from the ground up, with very low cold start times like Cloudflare Workers, Fastly Compute at Edge, Dino Deploy, and Lagon. And none of these new JavaScript runtimes are 100% compatible with Node.js. Most don't even aim to be. Headtip is a write once, run anywhere kind of framework. It bridges the gaps between different runtimes and deployment platforms and provides a consistent programming interface. Currently, it supports Node, Dino, Bun, Cloudflare, Vercel, Netlify, AWS Lambda, Google Cloud Functions, Fastly, and Lagon. And it will easily support more in the future because it is based on web standards. As the JavaScript community, we've always been an anarchy. We don't like benevolent dictators for life. We don't believe in the 1-2 way of doing things. We have dozens of frameworks and libraries for every single imaginable task, and the king changes every other week. But we do believe in standards. And every single one of these non-Node JavaScript runtimes is using the same standard for implementing HTTP servers, the Fetch API. The Fetch API provides a conceptually very simple interface. A fetch-based HTTP server is just a function that takes a request object and returns a response object, or a promise that resolves to one. HeadTip is built entirely on top of that concept. Now, because it's a new project, you may think HeadTip may suffer from a lack of ecosystem around it. That's not the case. The entire Fetch API ecosystem is available to HeadTip. For example, Auth.js, a rebranding and rethinking of NextAuth, is built on the Fetch API. And as such, it's fully compatible with HeadTip. Another good example is Yoga, a fully featured GraphQL service solution. It's also based on the Fetch API and fully compatible with HeadTip. There are many, many more, and there will be even more because Fetch is the standard of the future. Further proof of this claim is that popular frameworks like SvelteKit and Astro also rely on the Fetch API to abstract away the differences between platforms. Standardization makes our jobs as developers easier. Imagine you didn't have to use two completely separate APIs in Next.js for edge middleware and API routes. It would cut the learning curve in half and would make it possible to copy and paste code between them. So for this reason, for platforms that are not based on the Fetch API, most notably Node.js, HeadTip comes with efficient adapters and polyfills, which brings us to the next point. HeadTip is highly performant. Node.js doesn't come with built-in support for server-side Fetch API. It does have experimental Fetch API support, but not for building servers. So HeadTip comes with an adapter, but adapting between the Node API and the Fetch API comes with a performance penalty. So you might expect that Express, which is just a very thin layer on top of Node's native HTTP API, would easily outperform HeadTip. Well, that's not the case. HeadTip is actually faster than Express in many cases. But it does fall behind when pitted against more performance-focused frameworks like Fastify. Still, if your focus is raw performance, HeadTip offers alternatives. For example, instead of using Node's built-in implementation, you can opt in for WhatVG Node, a faster Fetch implementation. You can also use the Micro WebSockets adapter. It is the HTTP library that powers BUN, but it also has node bindings. With these two in place, HeadTip's performance is on par with Fastify or the built-in Node HTTP API. HeadTip also comes with a very fast static file server. Since we're aiming first-class edge and serverless support, we should never forget about cold start times. HeadTip's static server can optionally move the directory scanning phase to build time to reduce cold start times. It also allows it to be smaller because it doesn't need to include an MIME type database at runtime. Size is an important factor for edge computing. Another area where HeadTip performs well is its form data parser. HeadTip comes with a form data parser that gives you full control while still outperforming the built-in request.formData method on most platforms. For example, it is 5 to 10 times faster than the multi-part parser used by Remix's Fetch API runtime. In fact, to my knowledge, it is the fastest streaming multi-part parser for the Fetch API. Last but not least, HeadTip enables you to tap into the performance advantages of BUN and Dino to the fullest. They can both use the Node HTTP API, but their native implementations are based on Fetch, and HeadTip lets you use them directly without an adapter layer. In any case, HeadTip's Node adapter takes special care to be compatible with BUN and Dino when they are using the Node HTTP API. Why is that important? Because Vite uses the Node HTTP API, and we want to be able to use Vite on Dino and BUN too. Well, HeadTip is Vite friendly. HeadTip was originally built as the server backbone of Ruckus, the Vite-powered React framework. So it has a very close relationship with Vite. HeadTip doesn't require Vite. You can create bare-bones HeadTip apps that have nothing to do with Vite or front-end development in general, but it does shine when combined with it. With HeadTip's Vite plugin, you can build performance, standard-compliant, full-stack applications that you can deploy anywhere. It's kind of like using Ruckus or SvelteKit or Astro, but without the framework. You just give it a server entry and one or more client entries, and it just gets out of the way. It pairs especially well with Vite plugin SSR. The combination gives you a framework where you can retain full control with no fear of vendor lock-in. And that's the beauty of it. Say you want to move your edge functions from Cloudflare to Dino deploy, and your API endpoints from AWS to Google Cloud Functions. With HeadTip, you can do it by changing just a few lines of configuration. That's all I have for today. I hope I was able to pique your interest in HeadTip. I intentionally didn't go into the details of the programming interface, but I think it suffices to say that it is both familiar and novel at the same time, and very easy to use. You can find more information on headtipjs.org. Thank you for listening and have a great conference.
Hello, ViteConf. I'm so excited to be here with you today. My name is Nathan Weinert. I am the creator of Tamagui, which is a funny name, but a very cool library, I think. It is a cross-platform, so React Native and web, UI kit, style system, and most interestingly, an optimizing compiler that does all sorts of analysis on your code and turns it into very performant, platform-optimized output. So basically on the web, you get all sorts of cool stuff, and on native, you get hoisted and flattened and extracted styles and a render tree that is actually much faster. So I encourage you guys to check it out. It's not really what I'm talking about today, and I'm also very much aware that Vite is born out of the Vue ecosystem. So I just happen to be working on native apps, and React Native is a really great way to share code between platforms. But in working with it, I've ran into a lot of things. And I first actually my first experience with Vite was basically working on the optimizing compiler plugin for Vite. And it was the last one that I implemented. And honestly, it was by far, just not even close, the best integration experience that I've ever had with the bundler. I mean, the API surface is just light years ahead of anything else. And also it's just so fast feeling that I knew that I wanted to keep working with Vite. We converted a decent amount of our sort of one-off apps over to Vite. But in the end, that was basically what I did. And I hadn't really worked with it much since then. And one big problem, I think, if you're not familiar with kind of the React Native and sharing code between platforms, it's a problem that Tamagui is trying to solve by making the styling much, much easier and much more powerful while not sacrificing performance. And I think the theme of the talk that I'm giving here is basically just how do we simplify our stack and make it much faster to work with, because we have much less conceptual burden and we also have much less just technical complexity behind the scenes. And I mean, let's not beat around the bush. I basically have been trying to get Vite to serve React Native, because the way it works today is you have a different bundler called Metro, and then you actually end up with just some crazy stack. I mean, you have like a monorepo usually where you have Next.js or whatever you want, and then you share code between the two with a separate packages. And now you have so many new problems. You have to figure out multiple locations to put all your files. You have to have some sort of glue library that puts everything together, which I use the awesome library called Solido. But in the end of the day, it's a lot, and it could be a lot better. And so I'm going to play a video for the rest of my talk and just kind of have that going on while I continue to monologue to you guys. And it's just going to show Vite serving React Native and kind of have a fun little demo of the hot reloading and what it can do. And so I'll talk about sort of how I ended up here, which is basically it's just been a nights and weekends project. And I've, my stretch goal was honestly just to get it working. But I did get it working about a month ago. And then I just went ahead and started to see what I could do next. And my next goal was obviously hot reloading, because that's the big one. And that took quite a lot of work, because the initial bundle has to be built in CommonJS, which is what React Native supports. But then you have to do hot reloading in CommonJS, so that requires some massaging. And of course, I wanted to have SWC and have it be fast. So again, lots of work there. The other thing is that the React Native ecosystem is just insane. I mean, React Native itself is shipped with Flow as just Flow in a JavaScript file. There's a lot of packages that just ship TypeScript uncompiled, but they wouldn't really tell you that. There are other packages that have CommonJS exports in a form that just is very confusing, like circular, and it doesn't get parsed properly. So it's quite a lot of work. And then some packages even import the internals, of React Native. And so that was a whole another thing, especially to get hot reloading working with all of that. So it was a lot of work, but it is all running very officially. So it's using Rollup for the initial build. It serves that bundle, and then it uses Vite for the hot reloading from then on out, all running in Vite as you normally would. So I'm working on open sourcing that. I'm going to have a link at the end that will just, forward to whatever that repo ends up being. I'm extracting it out now from, all the spaghetti code that I had, just getting everything working. But I am very happy with where it's ended up. I'm actually able to load quite complex things. I'm able to load Tamagui. I'm able to do all sorts of fun stuff at this point. And my other stretch goal then, once I got hot reloading working, was to see if I could get Expo Router working. And that's cool because Expo Router gives you file system routes that are shared between native and web, where you can do like a stack view on native, but have it be a different sort of paradigm on the web, but still have this shared single file system routes. And so again, simplifying the stack, that was one of my main goals, was like, if I can get that working with Vite, I'm super happy. And I did just get that the other day, fully loading using import.meta.glob. So you can glob your file system routes from any folder and just passing it in, and it's actually fully rendering and working. The other thing, of course, that I'm showing probably but not telling is that I got it working for web too in the same process without having to run 2 different Vite instances. That was also very cool. So super exciting. For the first time ever, you can now just run a single bundler, single config. It's Vite, so it's the best one in the world. And you just have web and native running at the exact same time. I mean, it's just, it's amazing. So Expo router support hopefully coming soon. Maybe by the time this talk comes out, we'll see. And then the final point that I just want to throw out there while I have you guys is that I worry a little bit because the React ecosystem is being sold pretty hard right now on server components. And someone who's I've worked on a lot of native apps, and I really like this app-like model where you just have such a simple single way of thinking about your whole tree. Like when you write a Swift UI app or something, you don't think about the server, you don't think about that. And traditional SSR React apps are really nice in that sense, in that you basically don't really think much about having these different worlds. Like, I'm trying to get away from that complexity. I'm trying to have a simple single stack. And server components are getting all this hype, but it's a really dangerous path, I think, if you're thinking about doing an app at any point in time, or even if you want app-like features. I think you get a much, much better experience by just staying as a SSR, or just like a fully, client-style app. And so I really want to just put out there that I think that there is the problem that we've had is that there's no great libraries that keep a really great web experience, but then also give you that native-like feel of optimistic mutations, local first data that stays cached and works offline, that you can just edit and mutate even when you're offline. And that's instant, and it gives you that instant feel, transitions between screens, instant updates that I don't think you get when you have something like server components. And also that you just have, a single way of working with things that I think would be awesome. And so I have this library that I love to death, and it's just the most underappreciated library of all time, and it's called gqt. So I just wanted to plug it, gqty.dev. It's such a cool way to fetch data, and it happens to use GraphQL, but you would never know it. And I think there's maybe a really interesting path forward to do a file system routes for GraphQL that makes it as dead simple as possible. There's one other library called Gratz, not to just be throwing out all these things to you guys that are somewhat unrelated. But if you were to marry all that together, I think you could have DX that is unmatched, UX that is unmatched, and just the simplest, nicest way to run a cross-platform app, sharing all the code that you could possibly imagine and moving at lightning speed. And so I'm so excited by what this Vite bundler has unlocked for me, and I'm super excited to see what the community does with it. And so I just wanted to thank the creators of Vite and the community and the maintainers and whoever put together this conference. So thank you guys so much, and I hope you guys enjoy and have a good one. Cheers.
Good morning and good afternoon, everyone. I'm Jessica Sachs, and I'm thrilled to be here for another year of ViteConf. I'm a senior software engineer at Ionic, which is a company focused on building open source developer tools for web devs that want to ship mobile apps. That might be you. I started my career in 2012 building and testing native iOS apps. And I stayed in mobile until 2015. when I switched to web tech and got involved in the Vue community and ecosystem. Because Vue and Vite were both created by Evan, I was exposed to Vite very early on, I think version 0.13. In early 2020, I joined Cypress full-time to build open source developer tools and led the Cypress component testing project. After I left Cypress, I wound up at Ionic working on the intersection of my favorite things, web tech, mobile, and open source dev tools. So for the next 10 minutes, I'm going to show you my favorite thing at Ionic, Ionic Capacitor, which allows you to take just about any web technology and put it on a phone or a tablet. So what is Ionic Capacitor? It's a tool to help you ship web tech as mobile apps. It works with greenfield projects, but more impressively, it works almost seamlessly with large existing code bases. Capacitor is also forgiving to any legacy or necessary technology choices that your codebase might have taken. For example, if you're working in Vue, Svelte, Solid.js, Angular, vanilla JavaScript, React, or a Frankenstein mix of these frameworks, Ionic Capacitor has got your back. So what is Ionic Capacitor technically? Technically, Ionic Capacitor is built on top of web views, but it also provides a native bridge. You can use the platform-specific bridge if you need to, but Ionic Capacitor already has a thriving plugin ecosystem to do things like native keyboard dismissal or push notifications. These plugins are cross-platform, and the code is universal, which means that you can write a single line of code to handle native behaviors, and it'll work on all platforms. We also ship a beautiful VS Code extension to help you find all of these plugins. So, in addition to supporting many web frameworks, Capacitor also supports different team compositions. You can have both native and web developers working on the same Capacitor app in the same codebase in their languages of choice. This means you can have Android developers writing Java and Kotlin, and iOS developers writing Swift or Objective-C, while you're also writing JavaScript. So everybody gets what they want. This is the short answer. Everybody gets what they want. Any framework, any front-end framework, any native bindings you want. What isn't Ionic Capacitor? So for those of us who have had the joy of working with Cordova, Ionic Capacitor is compatible with Cordova plugins, and both use web views, but they're not the same thing. I get that question a lot. And what does this have to do with Vite? Well, because Capacitor is just built using web technologies, all we need to do with Vite is point Capacitor's own local development server to the Vite dev server, and we're off to the races with one of the best developer experiences the modern web has to offer. Let me show you. So we'll start with Vitesse, which is a GitHub starter template and my favorite way to start a Vite project. It's created and maintained by Anthony Fu and ships Vue 3 as its front-end framework of choice, though there are other versions that ship different front-end frameworks. I like Vitesse because it comes with just enough batteries included. It has a file-based router with dynamic routes. It has internationalization as well as dark mode built in. And most importantly for me, it has Uno CSS, which is similar to Tailwind, but was built for Vite, built for speed. Here's what it looks like. It's a very simple page, has a home page here, with an input and a few icon buttons that support dark mode and light mode, and internationalization. So, what is my name? Jessica. And here's a demo of the route. Hi, Jessica. Cool. So let's put this on a phone using Ionic Capacitor. it's really simple. So throughout this demo, I'm going to be using Bun as my package manager of choice instead of PNPM, which is what Vitess usually recommends, because Bun is new and shiny. And actually really cool. I've really been enjoying it. Okay, so Bun add at capacitor CLI. You can init and set up this whole project using 5 CLI commands and 1 settings option. So let's add capacitor, and we'll get a binary. Cap is what it's called for short, or capacitor if you like typing words. Bun cap init should get us going with a config file. Let's name it ViteConf is the name of our app. And it wants a package ID. Let's use the default one because we're doing a demo. This is the config file that's initialized in the root of your project. Let's add iOS as a target output platform. We could also add Android, but I don't have the emulator installed. Bun cap add iOS should do the trick. Really nice. And then you'll see that iOS is here. This is kind of the ejected version of where you would do your iOS development. You can see a git ignore over here. And let's go and add the localhost URL for Vite. So let's do bun dev to open up Vite locally. The Vue dev tools are open. Really cool if you've never seen them. Highly recommend. And we can see that we're on localhost 3333. Really nice. My name is Jess. I'm going to hit go. Seems like everything is working. Let's take this local URL and the local dev server and pop it over in our capacitor config under URL, which is a dev-only option for use with, guess what? Live reloading development servers. So localhost 3333. Let's hit save. And without Vite, or without a hot reload server, we would have to rebuild all of our changes using dist. And the iOS folder would pull those down, and that's kind of slow. We don't want to do that. So this server URL is going to be very helpful for us. I'm going to do bun cap iOS sync. Bun cap sync iOS. And then you'll see that we get a very nice, bun cap open iOS. Get a very nice Xcode project with a play button ready for clicking. And we're going to build. Build succeeded. And we get some logs down here. You can start to see that Vite has connected and the web view is loaded. So let's tab back over. ViteConf, what is your name? Jess. Hit go. We get our dynamic route. We get our dark mode. We get some I18N. And now we can start to do things like fix our little guy here, or, oh, there's a issue with clicking too quickly. And this is an iOS only issue with minimum and maximum scale. So the default index.html of our Vite template does not define a minimum and maximum scale. And when the body and HTML font size on iOS is less than 16 pixels, clicking like this quickly zooms. So let's go ahead and add the minimum and maximum scale in. You can see that the index.html has already loaded from Vite's wicked fast server, and the bug is already fixed. This is how fast it is to work on Capacitor and Vite together. And this could be any front-end framework. This isn't a Vue-specific project. This isn't, you can put most anything in here. And it even has the Vue dev tools, which are not mobile responsive, so I do not suggest you playing around with them. Let's see, let's play with it. It's all right. in theory, you could actually debug your mobile application using the Vue Dev tools here. But it's neither here nor there. That is a wicked fast demo of what it's like to develop a mobile application using Vite and Capacitor. I think that's all I have for today.
It's been a year. Hello, my name is Jonas. Welcome. I hope you've been busy the last year, building side projects, building super fast websites, having fun. And, we've also certainly been very busy having a lot of fun. And I want to talk to you about that. The one feature I'm really excited to talk to you about is certainly mobile support for Tauri. So if you are saying, what in the world is Tauri? Never heard of it. The idea is very simple, right? You know how to build websites, and you also really want to build apps as well, So why not just use your website building skills to build apps as well? Now, that idea is not super new, but what Tauri brings to the table, the thing we do differently is Tauri built from scratch in Rust for maximum performance, for maximum security. And instead of, shipping a full browser every time, shipping a full copy of a browser every time, we make use of the operating system WebView. Now, that is a different set of trade-offs, nothing is perfect. You will have to then, support different versions and different web views. And, on Safari, it's WebKit. And on Linux, Safari, it's WebKit. Wow. On macOS, that's WebKit, so Safari. And then Windows, that's Chromium. But honestly, that is what we do every day, as web developers. We support the web, right? We build websites for all the browsers out there. So to us, that is not really a problem, and we've been building tools to sort of help with that, because the big advantage that gives us is not only incredibly small file sizes, right? Sort of I'm talking kilobytes, but also it lets us support every operating system that has a web view out of the box, right? And that is certainly cool because we can just also build apps for mobile now, right? So we have been working on desktop support for 4 years. I will show you that. But now, for the last year and a bit, we've been working on mobile support as well. iOS and Android. And, little secret, you can also get it to work on watchOS, on Apple Watches. It's really janky and very cursed, but it also works. It's not supported, don't add me on Twitter, don't get upset, but it also works. We might support it down the road, maybe. Enough said about that. Let me show you some code, right? That's what you really hear. Let's dig in. Let me show you how this works. Let me give you proof how cool this is. And for that, we're going to scaffold out a new Tauri app. And we can, best do that using our scaffolding utility. Create Tauri app. And in this case, we need to say that we want alpha, and we also want to scaffold a mobile project. And alpha is really because it is alpha right now. This is why I'm showing you this, sneak peek preview. This is what's coming to Tauri, and I want your feedback for it as well, right? We need your feedback to improve this. There are rough edges, it is more alpha. It is a bit janky sometimes, but we really want your feedback because, we think this is kind of cool and we want to make this even cooler. So let's scaffold out a project. Ta-da. You have to give it a name. Doesn't really matter. And now we can choose between TypeScript and JavaScript and Rust. Rust really only because Tauri is built in Rust, and we also want to support the Rust community to the best extent that we can. But let's go with JavaScript. And I'm just going to choose PNPM. You can also use Yarn. You can also use NPM. Doesn't matter. I'm also not going to choose a framework right now, just for showcasing this. It doesn't really matter. Also no TypeScript, and boom. Scaffolded out an app. And now let's open this, and you can see this might look familiar, right? And we have a package.json, we have a git ignore, and we have a source folder, which this is all our website, HTML, has some JavaScript, has some CSS. Cool, you all know that, right? Now, the new part, that is the source Tauri folder, and that is your Rust project. This is the magic that makes it work. Because we sort of piggyback off the Rust compiler to then take your front end and inline it into the binary and make it, really small and really fast. This is the magic that makes it work. But don't worry, you don't need to touch this at all, at all. You can, and there's sort of ways where you can, call Rust code straight from JavaScript. If you need to do any heavy processing or cool stuff, you can call Rust from JavaScript and offload stuff into that with bindings and stuff. But you don't need to at all, not at all. You don't need to touch this folder whatsoever. And that's pretty cool. So if we now go ahead and clear up all this a bit, and we now say pnpm tauri def. Oh, what happened? Oh, I'm a moron. Of course I need to install first. Wow. wow. Now, and what is happening right now is that now it's compiling our Rust project. It's compiling in development mode. You may have heard of Rust, the language, and its infamous, the long compile times. That's the trade-off you get for the security and the small sizes. So once that's done compiling in a second, any second now, wow, it opened up our app. Pretty awesome, right? This is a full app. I can resize it, yada yada yada. All of this inside here is our HTML and CSS and JavaScript, and I can even show you an example. For example, if I type in my name now. This is an example of calling Rust code from JavaScript. If I, once I click this button, it's going to take the input of that sort of input field and send it to Rust, and the result is this string right here, and it's going to display that. And this is not terribly interesting. As an example, it's not even doing all that much processing, not at all really, but. This is kind of, as an example that you can actually call Rust from JavaScript, which is pretty neat. Now, old news. Boring, right? This is very boring. This has been, I showcased this last ViteConf. This is not really interesting. What is interesting, however, is mobile support. Whoa. So let's start with iOS. And there's a command you sort of need to run. It's called Tauri iOS init. And that's really because sort of, developing for mobile is a bit more complicated. And we need to sort of scaffold out a project for iOS that we then run. You only need to do that once, don't worry. And, it's going to run through a few steps. And now it created, here's the gen folder and then Apple. And forget about this folder. You don't really need to worry about it. This is auto-generated. Don't touch it. Everything's cool. But it's sort of needed to make it work. Again, alpha development, stuff like that is expected. But now, wow, cool. Now we can run Tauri iOS dev. And in a second, we can select a simulated runner. Let's choose iPhone 15. Why not? 9. And you can see it starts up. And that's also going to take a while. It's going to boot a whole simulator of an operating system and going to boot the whole phone. And in the background, you can see it's generating a lot of debug output. Again, this is because it's alpha. We really need that debug output in order to be able to understand what it's doing. If it's going wrong, very important to know what was happening. And again, as you can see now in the background, it's going to compile our app again. And it's going to compile, but this time for iOS, right? And once that's done, which should be in a second. All right, and there we go. Now it's uploading to our simulator. It's also going to take a while, but there we go. Boom. We have an app running on our iPhone 15 simulator, granted, but to show you the same works, it's going to run the same thing, but cool thing is this now ran on our iPhone, right? The Rust code runs on our iPhone. That's pretty neat. We can also this is not terribly interactive, sorry, but we can also rotate and do all this kind of stuff. Very cool. Let me switch that back. Wow, nice. Tauri on iOS. How cool is that, right? Now, iOS, very nice. What about Android, right? What about Android? Does Tauri also support Android? I hear you screaming, I hate iOS, give me Android. Okay, let's go. Same thing again, Tauri iOS init. Call that, and it's going to, create now the Android project. Again, we can, look into Gen, and then now it has Android. Again, forget about it. You don't need to touch this at all. And similar to the iOS simulator we just had, close that down. PNPM Tauri Android Dev. And this again gives us sort of a selection from a couple Android emulators. You usually need to set these up in Android Studio. By default, I think you just get the Pixel 3a sort of built in, but then I also created us a Pixel 7 Pro just because I like how that looks a bit more than the Pixel 3a. Now, it's booting up our simulator and, or rather emulator, but this keeps sort of state. So you will see this, I showed this to someone else, this demo, it's with you. Forget about it in a moment. And again, we see a lot of debug output. This is now configuring our app and all that. Once that's done, it's going to upload to our emulator and then it's going to refresh. Sort of this saving of state just means that you can sort of very quickly jump into your emulator again. So if I were to develop this app more, I don't really want to wait this long every time, right? So this is pretty cool. It's sort of caching. But you can see, wow, Tauri on Android. And, same thing, just going to show you how this works. Enter my name and wow, boom. Also Rust code running on the Android device itself. Cool stuff, right? Now, you may ask, when? When is this ready? When can I use it? When can I play with it? And the answer is actually really soon, hopefully. As I told you, we need your feedback, and that's because we're going to move this into beta next month. And once it's in beta, we're actually going to do 2 security audits on the code base. The full project, make sure no security vulnerabilities are to be found. And, once the auditors say, all good, all cool, and you say, feature-wise, that's why we really need your feedback. You say feature-wise and, experience-wise, also all good, then we're going to move it to stable, which hopefully, going to happen towards the end of the year. Speaking of end of the year, there's also something very cool that has happened actually last year, to the end of the year. And that is we started a company. A whole bunch of core contributors from Tauri came all together and we started, a company called Crab Nebula. And the idea is basically that we realized very early on into the project that we think this take, on how to build desktop apps and mobile apps, that is really sort of the way to go. We're really happy with that. We sort of, Tauri makes it really easy to build desktop apps and mobile apps for all platforms, cross-platform. But now you sort of build an app, it looks really good, you spend a lot of time on it, but it's on your machine, right? And so the idea with Crab Nebula, what we're building out, is that you should be really just, be able to connect your GitHub repo or GitLab or whatever repo up to our service, do a Git push, and that's essentially it, right? We take care of all the rest. We build your app, we update your app, we distribute it, to your website or wherever, to the app stores, we sign it, we take care of all the rest. To make the experience, developing apps and then actually distributing them to your users the same as with the web, right? Make it really, really, really easy. And speaking of easy, we also realized that debugging websites, really good. There's a lot of cool developer tooling around, right? Like the Chrome DevTools. Wow, awesome. I use it on the daily. But debugging apps really isn't all that easy right now. And that's why we're also starting a second project, or have started it, working on it away. And that's developer tools for Tauri. And I can't share too much with you about that, but that's also going to hopefully come towards the end of the year. And, stay tuned, subscribe. You can subscribe to my social medias. You can subscribe to our company's social media. You can also subscribe, of course, do that. Subscribe to Tauri's social media accounts. We are on Mastodon and on Twitter to follow along with updates, and we also need feedback from you on all of that. We're going to ask for feedback. We're going to tell you all about it, regular updates. And then towards the end of the year, we have a lot of Christmas presents. And so, as you can probably tell, I'm really excited about this. Good stuff happening with Tauri. We're really excited to, be supporting the Vite ecosystem as well. Gonna finish this with saying a lot, big thanks to the organizers of ViteConf. Big thanks that, I can be here with friends talking about all this cool stuff. And have a great conference.
How's it going, ViteConf? It's great to be here with you virtually, wherever you happen to be, whenever you're watching this presentation. But very stoked to talk a little bit about Vite here today. My name is Kevin. I'm a member of the Dino team. And today I'm going to talk a little bit about how you would use Vite to process static assets in combination with a server-side application that's mostly written using Dino. So for those of you who have never heard of Dino before, it's a JavaScript runtime that natively supports TypeScript, JSX, lots of the common developer tools that you would otherwise need to configure yourself, and generally is a JavaScript runtime that's optimized for performance and developer experience. And much of the NPM ecosystem is also supported on Dino today, even though Dino is not a drop-in replacement for Node. A lot of the common modules that you would want to use do work just fine on Dino today. So what we'll be doing is I'm going to start with just a quick demo that shows how NPM modules work in the context of Dino, and then we'll go to a slightly more complicated application where we'll show how you use Vite and Vite plugins to generate static assets to go along with your server-rendered Dino application. So let's pop over to my text editor here, and we'll write a simple a Dino program just to give you a sense of how Dino works. So much like much like the browser, the environment that you'll be programming in Dino has access to lots of global objects like you would have in the browser. So the fetch API, request and response objects, the built-ins that you would expect to have in the browser actually work on the server in the environment of Dino as well. And when there aren't web standard APIs that exist for certain features or functionality in the web platform, those are usually made available as a part of the Dino namespace. So kind of the canonical hello world application of Dino is dino.serve, and we can create a very simple web server that just returns a response. So we'll say return new response, hello world. And here we have sort of the very basic Dino web server, which I love. I certainly love to write every single time. And we can execute that in terminal with Dino run -a and then --watch, so we can see any changes to that file over time. And when we fire that up, we have a server running on port 8000 that will happily display for us hello world. So there it is. Whoops. Yeah, it looks like it responds to everything, even if I spuriously include an S in the URL. So Dino program, very similar to a Node.js program in that regard. But one thing you'll notice is that a lot of the interfaces in Dino tend to favor web standards. So Dino serve, in this API, what you're doing is actually returning a response object, like the kind of response object you would get from the fetch API in the browser. So we try to favor those standards whenever we can. However, in addition to the built-in APIs that come with Dino, you can also use many of the modules in the Node ecosystem to build your Dino programs as well. So let's switch this up a little bit and then just create about the same thing in an Express application, Express being, of course, one of the most popular Node modules out there. So we'll import Express from npm express @4. So let's talk a little bit about like what this line of code is doing. So we number one, in Dino, we support ECMAScript modules by default. So there isn't a common JS module option. So all of the imports that you'll use are ESM imports. And within Dino, we also have this npm specifier. So that is indicating that we want to load a dependency from npm. And then we can also pin directly in the import statement, like what version of the dependency we want to import. So in this case, I just want the latest version of Express at version 4. So we have those, have Express loaded up. So we can create an app, say Express, set up a get route for the home page, and then there we need a request and a response object. Let's say res.send hello again. And finally, we will say app.listen on port 3000. So great. So we have now our Express app that's doing about the same thing. We have some red squigglies here because by default, Dino is TypeScript aware, and for Visual Studio Code, you can also install a plugin that will do linting and code completion. And it's complaining a little bit because it doesn't know what type these parameters are, because they're a part of Express rather than a standard object that we can infer type information from. So to add types here, what we can do is we can say at Dino types, and then pass in a string here, which will be the types package for the Express module. And I'm actually just going to grab that here because we want to keep things moving as best we can. So there we've added the types for Express, and now you can see that Visual Studio Code is satisfied, and it knows what those objects are. But we are getting some linter errors here because the request object isn't used. So we'll just add that underscore, which is an indicator that we know that object isn't being used at this time. So we have our server ready. And if we go back out to the browser and go to localhost 3000 this time, we can see, hello again is coming up for us. All right, so that's kind of just the very, very basics of how Dino works. Again, ESM modules by default, support for the NPM ecosystem using those NPM specifiers, and then TypeScript by default are some of the things that we just observed there. So now we kind of have a basic sense of what's happening in Dino. Let's show a slightly more advanced example that uses Vite to generate some static assets. So I'm going to switch over to another project. And this project, I'll show you the GitHub repository for it in just a little while. But basically, it is set up to use Vite within the context of a Dino project to do a couple of tasks for us. So what I want to do is, I have a server application here that uses a framework called Hano, which is a very lightweight framework that's kind of runtime agnostic, very similar to Express in many respects. And I have actually set up a route that will render JSX in response to some of those routes. But what isn't supported by Dino by default is compiling front-end assets. So like if I needed to compile TypeScript to a JavaScript file that can run in the browser, I have to do a little bit of extra work to do that. And similarly, if I want to use CSS files, especially dynamically generate CSS files that could support something like Tailwind classes, which is already configured on this H1, there is a little bit of extra work that I need to do. But before I do that, let me just make a couple quick changes here to comment these things out. Whoops, that's because that's JSX. I need to do that in a slightly different way. So let's do that. Cool. All right, so we'll comment that out. And then we'll do the same for our script tag down here, just so we can kind of see the before and after for each of these states. So with with this configuration, what's going to happen when I run this server? If I do task dev, it's going to start the server on port 8000. But if I head out to Arc and go to this page, what I'll see is an H1 that hasn't been styled. So this doesn't have Tailwind CSS styles associated with it, even though I have these utility classes that are attached to it in the class attribute here. So I need to set up my project to actually provide this information to the client. So within my source folder, I have another client folder here, which will contain the assets that I want to be compiled and included in my final project. So my index.ts here doesn't have very much code in it, but it could have TypeScript because Vite will happily compile TypeScript for us. But it also uses some Vite-specific features like the ability to import CSS files within the context of your front-end JavaScript. And then within that index.css file, right now I just have kind of the Tailwind components that I know I'm going to need in order to add those utility classes to my HTML. So I have a couple of front-end assets here, none of which are in their current form able to be used in the browser. So that's kind of where Vite comes in. So in the root of my project, I've created a Vite config file, which uses define config to set things up like build options and plugins. Like if I was using Svelte or Vue or other front-end frameworks, I could configure those plugins here. Right now, though, I'm just going to kind of configure the build to take that index.ts file as sort of the entry point to the build, and then output JavaScript files and assets kind of by the same name. So for simplicity's sake, I'm not going to deal with kind of the manifest. So a lot of times when you use Vite in a mode with a backend framework like a Rails or some other like server generated HTML frameworks, you generate a manifest file, and then you actually dynamically include URLs there. So we're not going to do that just for this demo, but that is something that you would probably do in sort of a production scenario like this one. So we configure our build here, and the other thing that we're going to need to do is configure Tailwind so that when Vite tries to parse that CSS file or process the CSS file, it'll have the ability to do that. So the way in which you set that up in a Tailwind project is you add a Tailwind config file and a post CSS config file. Neither of these terribly exciting yet, but the Tailwind config file is configured to look in my source folder, and we'll look for Tailwind utility classes that are used in any JavaScript, TypeScript, or JSX, TSX files, and it'll examine those files, understand which utility classes are being used, and then output some CSS based on that. So in order for that to work, the Tailwind post CSS and like a couple other dependencies are required to be installed in the node modules folder in this project. But of course, we're using Dino, so Dino by default doesn't have a node modules folder. Most Dino programs will actually dynamically include dependencies using the npm specifier, as in the syntax that I showed a few minutes ago, or you'll actually include those dependencies within a dino.json. So that has kind of an embedded import map file, which again is kind of based on the web standard import map, where you can have a mixture of both NPM dependencies and other dependencies that you can use in a Dino project. So for example, Dino is capable of importing HTTPS URLs, kind of like doing a import in the browser where you actually specify a full path to a file that exists on the network somewhere. You can configure those types of dependencies in a Dino project too. But these other dependencies from NPM, these just need to be there in the node modules folder the way that Vite and a lot of the Vite plugins expect them to be, or else it's not going to work. Vite is not going to work the way that I want it to work. So because Dino doesn't have that node modules folder by default, I actually created a build task that is going to run Dino with some specific options, such that it will generate a node modules folder that has all of those dependencies in it. So this npm install task, which again I won't step through the entire thing, but basically what it does is it dynamically imports all of the dependencies from my dino.json file that start with an npm specifier, and generates a node modules folder by asking Dino to download and cache those modules in the same way that it would if you were using the npm specifiers in your code directly. So there is a little bit of special sauce there, which again you can check out on GitHub if you want to see how it works. But it provides this Dino task npm install, which generates that node modules folder for us. And then the dev task, which we've already seen, starts the app server. So and then the app server right now is sort of hard-coded to serve static assets from the dist folder, which is generated from our build step. So I'm going to actually just kill that real quick so I can show that second step. So I'm going to say Dino task build. And that actually uses Vite to generate some assets for us. So an index.js and an index.css. So if we look in the dist folder, we have the index, which didn't have too much code to transpile, so it's just our hello world. But our CSS file actually has quite a bit there. There's all of the CSS that Tailwind requires in order to have those utility classes work. And then we also have a public folder here, which just has the Vite SVG. So all of the assets in the public folder, as they do for all Vite projects, kind of get copied in by default. So now that we've generated those assets, we can go back to our server code and uncomment those lines and actually include the JavaScript files and CSS files that should enable us to actually use those Tailwind classes here. So we're going to uncomment that. And there we go. Save that, and then if we go back out to localhost 8000, we now have our Tailwind-ified version of that H1 using the Tailwind utility classes. So once again, we went through the code pretty quickly, but if you'd like to check it out, you can just head out to my GitHub repository. It's just github.com/kwinry, and then I have a Dino Hano Vite template project, which will contain all the code that I just showed you. So that's all the time I have for today. Definitely was a quick one, but I had a lot of fun showing you a little bit about how Vite works in the context of Dino, and I hope you check it out real soon.
Hey y'all, Theo here. You probably know me from YouTube and from not using Vite, but I have some news for you. I actually use Vite a lot. As much as I love Next.js and I am stuck in the Webpack ecosystem as a result, I am constantly using Vite for basically anything it makes sense for, and I've been really, really impressed with my experience. When I started my company Ping, we actually started originally as a Create Vite app, still using React. And the only reason I moved to Next was because our builds were slowing down, not because Vite was slow, but because I was overusing the Vercel API directory and just had like 20 files, each being deployed to its own Lambda. And despite Vite being, I think, like 80 times faster than Webpack for me at the time, the amount of time to deploy all of those Lambdas outside of Vite was slowing me down, so I ultimately had to move to Next for that. Regardless, I'm still constantly looking over the fence and finding lots of projects where Vite makes more sense than the tools I use for my websites. And we're here to talk about those today. Not Astra, which I love dearly and use Vite with all the time, not Solid Start, not the hundreds of other tools that are built on top of Vite. We're actually going to talk about some things I built myself, and we're going to show off a CLI app that I'm actually using Vite to power. Yeah, wait, what? A CLI app? Isn't Vite for web apps? Well, it is. What if I told you that I built a web app into a CLI? This is a really interesting project, and by the time this talk is live, I will have open sourced it, so I'll be sure to link that somewhere too. Without further ado, let's dive into Webhook Thing. Well, what is Webhook Thing? I'll tell you quick. TLDR, Webhook Thing makes it easy to run your webhooks against your project locally. It's a project that my co-founder and I started because we were managing webhooks for a lot of projects, and it was annoying having crazy configs in Postman just to run a quick JSON blob as a curl against an endpoint. So we made something to help manage those across our projects more easily. To use Webhook Thing, you run npx webhook thing at latest. If it's not already installed, it will install, and this will spin up our CLI and, more importantly, our user interface for actually testing these things. Where is it getting these files from? This is where things start to get interesting. There's actually a folder in this project named .thing. This folder has a bunch of JSON blobs in it in order to configure what gets run by Webhook Thing. But how does this web interface have access to that? Well, I actually have to have a server binding that native interface to this web interface so that I can access things on the native system layer through Node and get them here into my Webpack. So how do I actually build this interface and get Vite baked in here? Let's go through the code and I'll show you, because I think this is a really cool solution. Before we do that, though, I do want to show one more thing, which is the actual output contents of the package. This is an empty project with Webhook Thing installed in it. I did this because I want to show you the output code, because you'll notice here, there aren't a lot of submodules. And if we look here, there are none. This depends on a lot of things. I'm using Fastify, I'm using Vite, I'm using React, I'm using all these different things. So where are they? This is another one of the fun pieces I'm going to touch on. We need to go through a few parts. First, we need to go through the CLI side. How do I actually spin up the CLI? What does it do? Then we have to go over the Vite part, which is the part that we're obviously here for, the web app that is being baked in. Then we're going to go over how I pull these all together and bundle them and build a powerful package with it all. So first, let's take a look at the CLI code. So Captain is a monorepo because it has a lot of different parts. We have a docs site, we have a marketing site, but more importantly, we have the CLI. The CLI is three pieces. There's the CLI core, which is the thing that runs your server and your CLI interface in your terminal. There's the web portion, which is the website that gets served as the interface between the two. And then there's the CLI, which is the actual package that bundles everything together. So we're going to start with the core. So let's do it. We hop in here. We see I have a CLI app router, which is interesting. Why do I have a router inside of the CLI? It's not a web router. it's an API router. It's a tRPC router in particular. If you're not already familiar with tRPC, the TLDR is it lets you write a function that's meant to be run on a server and then call that from anywhere with real simple type safety. It's like a minimal GraphQL. So here I have our onLog call, which is a subscription. So this is actually a WebSocket. And now that I've defined this, it can take an input optionally. It's not taking one here. It can return, in this case, an observable that emits messages. But I'll go to a simpler example first. Get blobs. This gets all of the JSON blobs that the web app has access to. It's a procedure that has an input, which is the path that it should be reading. Then it has a query, which is the actual function that gets run here. It takes the full path from the path you passed it in. It runs this quick log to let people know what's happening. And then it checks if the path exists. If it doesn't, it should throw an error. We just return empty array now. But if it does, we continue. We call fs promises, which is just a wrapper for fs that is promise friendly. We get our responses. We parse all of these and do some finagling, and then we return the data. So here's a more traditional example of a tRPC endpoint. Get files and folders is a procedure that takes in an array of strings that is your path to or from folders. This makes it really easy for us to figure out which folder we should be showing you the contents of. It's a query, which means this is the thing you ask for. It's not a thing that you make changes with, like a mutation. And this is just a function. This can be async. It can be not async. In this case, it appears to not be async. Probably should have been, but we're using read sync, so it's fine. Here's where we actually get the contents of each of these files and folders. What's cool here is I take their listings, which is this object I defined here. I return it, and now that type is inferred all the way to the front end. So if I just search for this in our code base, you'll see all the places it's called. In CLI app.getFilesAndFolders.useQuery, autocompletes and behaves as expected. The real magic here is the type inference. All of this typing is coming straight from this separate package in my project, inferred directly via TypeScript. And Vite doesn't care. It is a simple bundler that allows me to access these things on the other side. That's enough about how this interface works. As I showed briefly before, we also have WebSockets supported through the same interface for showing logs on the client side. But I'm not here to just chill tRPC. You can watch the videos on my channel if you want to hear more about why I love it so much. Because here, tRPC is just how we communicate between the things. I want to show how we actually bundle them. So first, I need to show you how the web app works really briefly. This is going to be a little closer to what y'all are used to. It's a pretty traditional Vite app where I TSC and Vite build for my build. I have my Vite step. I have linting, all the usual stuff here. Have a bunch of sub packages, including the Captain stuff, which is part of our mono repo. Where things get interesting, though, is the actual build steps. Because here, I have a custom build path, dist web, and I also have this plugin rewrite all thing. This is an interesting thing I had to do in order to fix the path rewriting when we're accessing things to and from the CLI, because I wanted them both served from the same port. This allows us to serve our Vite web app as well as our native app in the same place at the same time. This is the only way I could get routing to work between things. And again, the Vite ecosystem is just so good that there are solutions like this already made to solve any of the many different problems I could theoretically run into trying to finagle routing between Vite and my own Fastify-based interface. Actually, on the topic of Fastify, I should have mentioned that before. The actual server that serves both the Vite app and our tRPC endpoints with all of the native code, that's all running inside of Fastify. Fastify is a fantastic alternative to Express that is super performant, very minimal. It's a generally great experience. And as you see here, we're spinning up a Fastify server, a pretty traditional sense, handling a bunch of core stuff, especially in dev mode. It's a bit annoying. But most importantly, so we scroll down, we register this Fastify tRPC plugin, and then we handle the redirect to the Vite endpoint. So this is if you go to that URL, we want to make sure we're just using Vite's 5173. But if we're not in dev, we actually grab the static web package that was built by Vite and then serve that as the root here instead. So we still have /tRPC owned by the tRPC plugin, but the rest of it is just serving our existing Vite app. But how do we actually get the Vite app here, and how do we bundle it all together? Here's where a pretty fun, but admittedly slightly chaotic set of tools comes in. NCC is the key piece here that makes this all come together. If you're not already familiar with NCC, the TLDR is they're trying to do what GCC did, but for Node. It's a project by Vercel because they wanted to make the Next.js install not require hundreds of subdependencies, instead just be one single binary. And NCC will parse all of your Node modules and create a single binary, single JavaScript file that doesn't require all those subdependencies. It makes it really easy to bundle your stuff and not worry about conflicting dependencies. So if we're using a different version of React or tRPC in our CLI than you are in your project, none of those problems exist because our little bundle is isolated. I thought that was really, really important for a CLI that might be installed in your project, might not be, and I didn't want any of the conflicts or potential issues. So NCC is the tool that pulls everything together, but it's not that easy to get things there. I'll show you how we do that now. So as I mentioned, we have the CLI itself here. And this CLI is very important, not just because it's where the Fastify is served, but because this is where our build script is. And yes, I know it's a vanilla.js file. I did not want to deal with transpiling our build step. Anyways, I grab a bunch of these things from FS promises so that I can read and write the files I need to, as well as resolve, so I can resolve some things later on. I also grab this helpful FS extra package for a few things that I needed, and then NCC. I get the directories for everything, which is the distribution for the CLI, the index file for the entry point, the web path, which is up to directory, and then CLI web, dist web, so that's to be built ahead of time. And then I grab the readme too, so that will be in the package when we ship it. I have to make my own package JSON because for whatever reason, NCC doesn't do this step for me, and I don't want to carry over all the subdependencies and other things in our package JSON. I just want the basics. So I grab these values from the package JSON and then make a new package JSON real quick. I also have the run build. This is where most of the hard work comes from. I try to create the indexed HTML. If I succeed, awesome, yay, keep going. If I don't, console error, no indexed HTML, make sure that's built first. Because again, we have to have Vite build the app ahead of time. I don't want to try and manually trigger that from in the script because Turbo can cache it for me. So I make sure it's there, and if it's not, I throw an error. We then remove the existing distribution directory so that we're not accidentally bundling old files in case a file was renamed or deleted. And then we get started. I create the directory, I copy over the contents from the web directory to a new directory that's a sub here named web. I have all of my options for the actual bundling in NCC, and then it spits out code, map, and assets. To this day, I can't honestly tell you the difference between these things. All I know is I need to write the code in the map traditionally. So code is the core code, the main index.js file, and map is the mappings from that to original source code. But sometimes it can't bundle things in. Like I noticed a lot of the Fastify deps couldn't quite go in traditionally. Those all end up coming in through assets. So I have this nasty script at the bottom here for all of assets, where if it's a JSON blob, I skip it because we use those for other things. But otherwise, I write it in as well because a lot of other dependencies are being bundled in like this. If we look at the distribution that comes out, we have the index.js, which is a big old mess, but it's the vast majority of the code. I have the file.js, because this is one of the things being bundled in from Fastify, as well as a serializer, validator, and all of these things. But the vast majority of the code for this project is just in here. But more importantly, you don't have any dependencies in the resulting output. And once again, the Vite part is all bundled in here. And this will look exactly how you would expect from your traditional Vite app. Holy hell, this is a really cool workflow. The fact that we have a quality local web app using Vite for an SPA that's React-based, but we're getting all of the full stack benefits we would from using something like Next with a little bit of custom tooling. There is not a tool set that would have made this work better before. I tried, I hunted, I was looking for things to make it easy to build a good web app being served from a CLI that any user could run. And Vite was the obvious solution here. And this app, it's great. I can hit run, immediately get back this error because I'm not running the server it's supposed to be running this call against. And getting this feedback, having this workflow, having all of this be possible is such a huge selling point of the Vite ecosystem. Without the plugins, the documentation, and the effort Vite put in, I would never have been able to get this to work. And I was certainly not using Vite the way it's expected to be used here. I cannot imagine there are many people combining NCC, Fastify, tRPC, and Vite, but man, is a really powerful combo. The takeaway here isn't meant to be you should go build a CLI using Vite and NCC the exact way I did here. It's to encourage you to look into the Vite ecosystem to see how it can solve other problems that you might have. I've always hesitated to do something like a web app in a CLI because the tooling wasn't there. And the tooling isn't there still, but the pieces you need are. And that's the magic of Vite. They have pieces and they have an ecosystem that sets you up to do anything you can imagine. And the things that they're making possible are growing every day. I'm so excited to be part of the Vite community, and I will continue using it for crazy stuff like this in the future. Thank you guys as always. Really appreciate it. Huge shout out to Patak for inviting me here. I know y'all don't associate me with Vite, but please know I'm a huge fan. If it wasn't for the projects in this ecosystem, I wouldn't be anywhere near as productive as I am today. Thank you all as always.
Hi everybody, my name is Shadid and I'm a developer advocate at Fauna. Fauna is a distributed database that is designed to make your life easy. Now, I know what you're thinking. Why would someone like me, who's in the databases space, would come to a front-end build tool conference like ViteConf? Well, let me break it down for you. Like many of us, I started my career as a front-end developer, and over time, I transitioned into full-stack development. My first full-stack framework was LampStack. For those unfamiliar, LAMP stands for Linux Apache, MySQL, and PHP. The developer experience in the earlier days was not the best. However, things eventually got better. We eventually got awesome backend frameworks like Ruby on Rails, Laravel, Django, Node.js Express, and in the front end, we also got some amazing frameworks that we know and love, frameworks like React, Vue, Svelte, and front-end tools like Vite. However, along the way, the database world evolved only a little. We still had to worry about database connections, scaling, sharding, schema management, and so on. Sometimes we even had to take a hard look at ourselves before deciding whether to choose SQL or a NoSQL database for a particular problem. That's why at Fauna we decided to build a database without any compromises. A database that has excellent developer experience, is completely serverless, auto scales, and as simple as using an API. We blended the best of both worlds. Fauna gives you the reliability and the data modeling power of a relational SQL database with the flexibility of a NoSQL database. As a cherry on top, we also created a powerful database querying language. It's inspired by JavaScript, TypeScript, and GraphQL. So if you know JavaScript, you can write Fauna queries like a champ. Here at Fauna, we built a lot of our front end with Vite, and we love it. And we love the philosophy of Vite. It's simple yet powerful. And we're trying to bring that philosophy of simplicity and power into the database world. That's enough of me talking. Now let's go ahead and build something with Vite and Fauna. From the terminal, I'm going to create a new Vite project. And I'm going to select React as my framework of choice. We will change directory to the newly created project. Next, we install the Fauna package by running npm I fauna-save. Next, we're going to go to our app.tsx file and replace this boilerplate code with a simple form. This is a very simple form that has a text area and a submit button. Here we have a use state and a handle function to manage the state of the form. And on form submit, the handle submit function will execute. Let's plug in Fauna so a new record gets created every time we submit the form. We're going to import client and FQL from Fauna. Next, we're going to initiate a new Fauna client with the Fauna secret. Now on handle submit, we're going to do client.query, and then we're going to write FQL. And inside this FQL block, we're going to write our Fauna query. And I'm going to say post.create, and I'm going to pass in the content. Notice that the Fauna query is almost identical to JavaScript. It is a fully featured programming language with a JavaScript-like syntax. You can learn more about Fauna query language in our documentation site. Thank you very much for watching. We love working with Vite and Fauna, and I'm pretty sure you'll love it too.
Hola chamas y chamos, welcome to ViteConf 2023. I'm pretty excited to be here because I'm gonna present you today how Vite.js is powering the Tres.js ecosystem, a tale of a modern web development. My name is Álvaro Saborido, I'm a DevRel engineer at Storybook. I live in Barcelona, Spain. I create content constantly on Álvaro Dev Labs, mainly about Vue, 3JS, and Tres.js. I have a blog and a portfolio in this direction here, and you can always say hi on Álvaro Sabu on X and, well, Twitter and Mastodon, okay? So to start with, I have always loved video games since I was a little kid. And to be fair, that kid never grew up, okay? This is me with my cat, Gerald, playing video games. And I was fascinated by the time to play video games that were the 3D golden era, right? Like Crash Bandicoot, Legend of Zelda. And I wanted to start creating video games and such. But I ended up studying and working as a telecommunications engineer and then as a front-end developer. And I always have 3D like outside, right? I thought it was for really brilliant people until I found 3JS, okay? 3JS is a JavaScript library that basically leverage the efforts to create WebGL experience or rendering 3D scenes on the browser. And I found this course by Bruno Simon, the 3JS Journey, and I found out like I can do it. It's not that difficult, right? But there was a problem. The first problem was that most of the content was right on Webpack. And it's not that I have anything against Webpack, but I was not really comfortable with. And I started to get to know Vite and start creating all the projects in Vite. And I say, okay, there is nothing out there for 3JS in Vite. I'm going to start creating a boilerplate of 3JS with modern tooling, right? Basically, I don't want to play with you anymore. But there was a second problem, is that I was using Vue.js. Most of my career from like 3-4 years ago is based on Vue. So there was some solutions out there. One was to change to React and use React through Fiverr, which is awesome, or using Taegert, which was not maintaining anymore, okay? So that's why I ended up creating Tres.js. So Tres.js is basically a Vue custom renderer that allows you to build 3D experience on the web using Vue declaratively. So you can use your Vue components to create the scenes. Tres is a Spanish word for tree, okay? And it's pronounced tres. It's in reference of the 3JS library. That's because I'm Latin American, and also the French word was already taken. So why Tres.js? So basically, to keep up to date with the latest 3JS with 0 to none maintenance, meaning that the users can just download the latest version of 3JS and it will work. Something that is lightweight and easy to use. Something that is verbose, that people can start creating components. Something that is really focus on the X, and that's something that I found on the 3D workflow in general for developers that is really complex to debug and also to maintain. Something that has TypeScript support, something that is performant even with the reactivity, and this is also possible because it's powered by Vite, so Vite gives a punch of the speed, and also create a 3D ecosystem for the Vue community. So to get started with Tres.js, and funny enough, this is I'm using a slide dev, and this is a scene that is right here, okay? And I can actually move it. So it's live inside of the slide dev. And to get started with it, you can install it by using npm add Tres.js core and to install as a pure dependency 3JS, okay? If you want to use TypeScript, you need to install also the types. Let's get started by setting up the canvas. So basically, everything that is going to be rendered is going to be rendered in a DOM element, a canvas DOM element, okay? So with Tres.js, you only need to add in your template or your component a Tres canvas component, okay? This is going to do all the magic for you. You don't have to care about anything. You need to import that from the Tres.js core and add it to here. It's important that everything that comes inside is going to be in the domain or in the context of the custom renderer for Tres.js. So it's important that all the components is inside of the Tres canvas. Let's talk a little bit more about setting up and a scene. Okay, so every 3D experience out there has more or less the same components, okay? So you have objects, which are the things that you want to render. It could be a sphere, a plane, simulated floor. You need a camera to see those objects. And once you're ready, you wrap up everything in a scene. Then the renderer is going to render it on the DOM element on the canvas. So to set up the scene, if you were using plain 3GS, you will do something like this. So you create a scene with the 3Scene constructor. Then you create a camera using something similar with a perspective camera class. And then you create a WebGL renderer and you pass the DOM element where you want to render. Last but not least, you tell the renderer to render the scene with that specific camera. In Tres.js, it's way easier than that. You just put the Tres Canvas component and you put the perspective camera inside. It's better to be verbose and add the properties and arguments to the perspective camera that you want. But if you don't add a Tres.js camera, Tres.js is going to do it for you. So how do we add an object? If we were using plain 3GS, we will do something like this. We create the geometry using one of the constructors. So the cool thing about 3GS is it has a bunch of different geometries already. So we can use the torus geometry. Torus geometry is basically a donut. I don't know why they don't call it donut geometry, but it's called torus geometry, okay? And these are some of the parameters that you add, like the radius and how many segments do you want to render, okay? Then you need to define a material, okay? So basically the geometry is like the structure of the object, and then the material is how the surface of that model is gonna look like the color, if it's reflective and such. Then we create a mesh. A mesh is the main object, like it combines both of them. So you pass the geometry and the material, and finally you add it to the scene. In Tres.js, it's way simpler. So you have a Tres mesh component, and you can pass as a slot the Tres torus geometry, and look at that arguments here. So whenever you want to pass the constructor arguments, you can do it as an array in a property called arguments, okay, or args. Then you can pass the Tres mesh basic material, and you pass a property. It can be color, it can be roughness, metalness, etc. So we are gonna put it like an orange one. And voila, we have a donut that is orange. Cool enough. Let's dance a little bit. Awesome. So we have our first 3D scene using Tres.js. So how is this working under the hood? Basically, what we do in Tres.js is that we take all the 3GS components that we put on the template, okay? And we have a catalog of all the 3GS instances, and we convert them into components. So we take the latest version of 3GS, which basically is an object that contains all these different classes and instances. And then we do a little bit of magic there, aka the custom renderer. And then we convert them all in different view components. So we saw before like how we can start a component of 3GS instance by passing the arguments. So in the perspective camera, you can define the arguments for the field of view, for example, is the first number here. Then the aspect ratio, which normally is the width divided by the height of the screen. I don't remember what it's one. Oh no, yeah, far and near and far. So how much the camera will render, okay? And this is basically the same as in 3GS, saying creating a new instance of the object and passing the arguments like this, and then add it to the scene. Let's talk about props. So once you initialize it, okay, you can also pass some properties to change. So in the perspective camera, we could even set up the field of view, the aspect ratio, the near and far, like this, okay? This is gonna be the equivalent of doing a const camera and not passing any arguments as the constructor, and then just setting the property of field of view, aspect near, right, and add it to the scene. Then we have the slots. So we take advantage of the Vue API for slots for passing some arguments for the Tres mesh. So whenever you're creating a mesh, you need to pass or add it a Tres torus, the geometry. You need to add the geometry and you need to add the materials. So as I showed you before with the donut, this is how we will do it. This basically is creating a geometry like this in 3GS, and then a material, and then creating a new mesh, passing this as arguments. So whenever you're creating a slot in a component in Tres.js, you are basically passing as an arguments for the other object. To move forward with Tres.js, it's important to mention that Tres.js is not only a package, okay? It's an ecosystem. Why? Because you basically can do everything with the core package, but sometimes you can improve the developer experience by creating some abstractions that will make your life easier. That's the case of Cientos. So Cientos is a package, for example, that gives you a lot of different abstractions ready to go to use as view components or composables. So if you want to load a new model, for example, that you found in the internet, this is the way to go. We also have a work in progress. It's a post-processing one that creates effects and post-processing of the scenes. And who knows, maybe one package of yours is going to be in the ecosystem in the future. What is important here and why we are in the ViteConf is that all of them are built using Vite live mode. So it wouldn't be possible without it. Here's an example of how we use Vite to build the Tres.js core. So this is from the config itself. And we have the build property with the library, and we create the ESM bundle here, okay? To get a little bit more advanced, we also set up some plugins in Rollup. For example, we auto-generate all the definitions for TypeScript based on the 3JS types. So we iterate all the types that come in 3JS and we convert them to component types. So what we do at the end is that we copy and paste this 3JS component into the final package. We also set a view use core, which we use a lot, and tree as an external packages, so they are not bundled on the final package. We also set some exports named and the globals to achieve this. Something that is important for us, and I'm gonna just show you here, is the hot model replacement. Okay, this has always been really tricky when you're dealing with 3JS because you need to dispose objects for performance reasons, and it's quite tricky. So if I show you the video here, essentially what we want to achieve is that the user can change anything in the template or in the script, and you see immediately the object being changed in the color, right? But this is quite tricky, and we still have some issues with it that we're working on. So if you're experienced with Vite and hot model replacement, please help us out, okay? One of the ways that we are using the API from Vite is using import .meta.hot, and on Vite after update, this is an example of how we deal with the disposal of the scene. And then we render the scene again, we update the matrices, and we resume the render loop, which is the one that helps you out rendering different animations and such.
1 week later.
Now, let's all pretend that I didn't record this a week before the other recording, because I just forgot to add that we also use Vite for the documentation. So all the documentation in the Tres.js ecosystem is actually done with VitePress, and we couldn't see any other way of doing the documentation without it. VitePress is a power static site generator, and we host it on Netlify, okay? And it has been incredibly powerful because we also can embed the StackBlitz examples that we have, and we can embed just view components with the scenes like examples and so on into the documentation. Also, the syntax highlighting and the way it is organized is really simple to use. We also use Vite for testing. So we are using Vitest. It's kind of hard to test 3D stuff because everything is happening in the canvas. But we do have some utilities. We do have some stuff that we test with Vitest. Also, for example, we're working on Vue GUI, like a graphical user interface to the controls, similar to use TwigPaint. And we are actually testing the components, everything with Vitest. So now we can continue with the previous one. Here are some of the resources if you want to continue learning and playing with Tres.js. We have the documentation for Tres.js, the core for CentOS. We also have a playground. It's a Nux application, okay? With all the examples and cool stuff that we have built with the library, so you can see how you can build yourself. We, of course, has the StackBlitz collection. We have a Discord community with geometries, materials on how to achieve everything that you need for Tres.js. I want to give a huge thank to the contributors, especially the core team that is conformed with Jaime Torrealba and Tina, and all the rest of contributors that have helped us building Tres.js as it is right now. So big thank you to you. And if you want to contribute, let us know. Your picture can be here, okay? Also, I want to thank my sponsors, okay, Danny Devs, Mark Bakes, Easy Themes, Bruno Perel, and Basilis. It's really important for us to have that little help out. If you want to help, you can begin by starting the repo in GitHub. You can spread the word, talk about Tres.js, let us know. And you can also sponsor the project. We're basically doing this project because we are really passionate about 3D and we wanted to do it in Vue. So any help that you can give us to maintain all the packages and continue innovating in the DX of it, consider sponsor us in GitHub. Finally, but not least, a special thanks to all of them that they have helped one way or another to the Tres.js success. Thank you very much. And this was everything from the Tres.js ecosystem using Vite.js.
Hello ViteConf, I'm Brandon. During the day, I work on front-end infrastructure at Palantir. During the night, I like to make volunteer contributions to the PNPM open source project. To begin this talk, let's start with a quick recap of what PNPM is. PNPM downloads your project's dependencies such as Vite, Svelte, or TypeScript. It distinguishes itself from other package managers like NPM or Yarn by attempting to be space efficient and more performant. You may be wondering what makes PNPM performant, which is the first P in the name. To give a quick summary, it turns out that PNPM adds additional strictness to how dependencies are set up that not only help developers catch common mistakes, but also contributes to faster installation times. I'm going to intentionally gloss over the remaining details from there, since the primary maintainer of PNPM, Zoltan Kochan, explained how PNPM works better than I ever could during last year's ViteConf. Feel free to check out Zoltan's talk on the ViteConf YouTube channel. It's titled What Makes PNPM Performant. Watching that talk isn't required for the rest of this one, though. Speaking of last year, let's check out how PNPM usage has changed. Since the start of 2023, downloads per week has doubled. What's particularly interesting is if we also add Vite to this NPM trends graph. That's a surprisingly strong correlation. Vite developer Matias Capeletto, you may know of his username Patak, was the first to point out this correlation to me. It's fascinating to see the correlated adoption of these two tools together. I don't have any theories on the causation, but in any case, PNPM is proud to be part of the Vite ecosystem that's delivering new capabilities, and it's been cool seeing these two technologies grow up together. We're always trying to improve the performance of PNPM, but also want to think about how to provide a great user experience as well. Today, I want to discuss an upcoming PNPM feature called Catalogs, which attempts to do the latter. If you develop in a large shared codebase or monorepo, running PNPM installs already pretty performant. This new feature aims to help you, the developer, be more performant as well. Here's what we'll do in the next few minutes. Let's investigate a common problem that happens in monorepos together. We'll explore what solutions exist today, and then from there, let's look at what catalogs are and how they solve the problem. We're going to walk through a common workflow for developers in a multi-package repo. If you've worked in a large JavaScript codebase before, you may spot what I'm about to do wrong before you see the error. The codebase we'll be working on is a classic to-do list planning application. Now, I don't know about you, but for me, there's a few items that are missing from this list. In between eating and sleeping, I like to
migrate large code bases to PNPM, and use Vite to speed up my development time. Cool, with the to-do list fixed, let's get to work. This code base is from a Mozilla Developer Network tutorial from a few years ago, so it's not using PNPM catalogs or even Vite yet. Instead, this is based on the maintenance mode Vue CLI. I'd like to perform a common workflow in monorepos, which would be to refactor code from one package over to another. Let's suppose I want to publish part of the to-do list from its own package for other apps to consume. Maybe we'll want to use this in a landing page app that has a demo of the to-do list that users can play with before they create an account and use the app itself. To that extent, we'll create a new package for the to-do list component. From there, we'll move the to-do item.vue file over to the new package. I'm noticing the component imports Vue, so we'll go ahead and add a new dependency for it since it's good for packages to declare dependencies on the modules they import. We need the original app to import our new component, so we'll go back and add that as an internal workspace dependency to link these two folders together. Back in the app.vue file, we'll now import the component from its new location. Cool. With that, let's fire up the local dev server and test it out. I don't know if you can tell, but the page actually looks a little bit different, just slightly. The checkboxes are a little bit smaller than they used to be. Let's see if it still works at least. I'm clicking on the edit button, but it doesn't seem to be functional. Let's hit the checkbox. Okay, that's a little strange. All we did was move the component without changing it, but somehow the page is now crashing. I don't think it's obvious what's broken, especially since this is a monorepo that has had previous components split out into different packages successfully before. For me, when I accidentally break an app, I like to see if TypeScript is still compiling successfully. Sometimes TypeScript can tell me what part of the code is broken when I don't even know what to look for. Okay, that's a lot of errors, but we can start from the top. I see references to both Vue 3.3.0 and 3.3.4 here. There shouldn't be multiple versions of Vue. What's happening? Okay, it turns out when I performed the pnpm add Vue command earlier for our new package, it brought in the latest version of Vue. That's clearly not working and interacting well with the version of Vue that the rest of the to-do app is using. If I look at the pnpm lock.yaml file, I can confirm that theory and see there's multiple versions of Vue in the log file now. And I can look at that to-do item components package JSON and see that that's where it's coming from. So, we haven't even been onboarded to this project for more than a few minutes, and we already broke the entire repo. How do we fix this? I mentioned earlier that this project doesn't use Vite. Would moving to Vite fix this? Surprisingly, the answer is actually yes. It turns out if you use Vite with React, Vue, or Svelte, the runtime portion of this problem is solved for you. Vite actually has a built-in feature to address this exact problem of what to do when multiple versions of Vue, Svelte, React, or some other Vue library accidentally appears in our project's dependencies and automatically deduplicates them. So one good answer is to use Vite. That's always a good answer. Vite addresses the runtime portion of our bad state that we got the monorepo into, though. How do we get the monorepo out of the build time compilation bad state? For that, we do need to remove the duplicate copies of Vue since the types are included with those different versions. One way to do this is to run pnpm dedupe. The dedupe command will choose the higher version, 3.3.4 in this case, and upgrade everything depending on the older version over to that. From there, we'll see that pnpm compile is passing again with no errors. That's a bunch of workarounds to get us out of a bad state. Is there a way to prevent the bad state from happening in the first place and slowing down our productivity? This finally brings us to catalogs. Catalogs were introduced and inspired by a concept that exists in other programming language ecosystems like Rust and Java for managing repos of multiple projects. The Gradle build tool calls the concept catalogs, which we thought was the clearest name and inspired pnpm's feature. My favorite part of catalogs is that they're straightforward, and you already probably have a really good guess at what it does. You've probably written code like this before, which refactors a bunch of magic numbers into a nice reusable constant. In this case, the Vite team factored out a few common TCP ports. Catalogs are a new tool that allow you to do the same thing for package.json files, and I think they make a really big difference when you have hundreds of package.json files. Let's take a look at how a catalog is set up. All monorepos using pnpm have a pnpm workspace.yaml file. To set up a catalog, I can add a new catalog object config here. From there, the next time someone, you or your teammate, runs pnpm add for a package, pnpm will reuse that constant so new dependency declarations stay in sync with what the rest of the monorepo is doing and don't accidentally bring in something new. This prevents that entire original problem we were seeing earlier from happening in the first place. I think that's a much better development experience. Of course, this doesn't mean you should never use the latest version of a package or upgrade. I still recommend having some mechanism to automatically open pull requests, upgrading dependencies in your repo. The important difference is that that process can happen separate from when you're building out new functionality or refactoring, so you aren't caught off guard by version mismatches. You may notice there's a colon at the end of the catalog part. Catalogs are implemented as a new protocol, and that's an intentional part of the design. There are many solutions out there today to synchronize and add constraints to package.json files, but they typically operate with a check and fix workflow, which can get out of sync. With a new protocol, the package manager natively understands your intentions and makes the catalog the one source of truth. The colon is specifically to distinguish it and denote it as a catalog, as opposed to like a get tag. If you're watching closely, you may be wondering what happens if a package using the pnpm catalog specifier protocol is published and consumed in a different repo that doesn't use it. Well, similar to the workspace protocol which exists today and multiple package managers support, the catalog colon portion is replaced with the constant on publish, so the package.json files in your monorepo stay portable. There's one other surprising benefit of using catalogs. During my day job, I observed many developers blocked from merging their PRs due to package.json or pnpm lock files conflicting. This can be frustrating when you are ready to merge your code, but have to make another unexpected manual fix and wait for CI builds to run again. It's difficult to prevent merge conflicts entirely, but using a catalog reduces a few specific instances of them. During the development of catalogs, we researched a few common scenarios. Suppose commit A upgrades a dependency and just merged. Depending on what your commit does, you'll see a few different things conflict. What I want to call out is that catalogs aren't perfect, but it's interesting to see more catalog usage means less package.json conflicts on the far right column here. That's because a PR upgrading a catalog-defined dependency only changes one line in the pnpm workspace.yaml file and doesn't touch package.json files at all. That's catalogs. To recap, most of the time you want one version of a dependency in a monorepo. Catalogs let you do that more easily. In fact, I'd recommend declaring everything in the catalog by default and making deviations the exception. Second, using the catalog speeds up your team and prevents unnecessary merge conflicts. The RFC for catalogs has been ratified, and we're currently in the implementation phase. We're expecting the feature to land on pnpm in the next few months. When it's released, please give us your feedback and let us know how it works. I wanted to end with a special thank you to the primary maintainer Zoltan. Zoltan was a big help in the catalog's RFC discussion and is the atlas holding up pnpm day to day. I also wanted to say it's an honor to speak at ViteConf alongside so many other fascinating technologies. I've been working in open source since I was in middle school, and it's a dream to speak at an open source conference. Thanks for tuning in. Enjoy the rest of ViteConf.
In this talk, I will share ideas about generative UIs in relation to the OpenVO open source project. The overall aims of generative UIs are to create better starting points for new projects, faster ideation to prototype, which is useful for MVPs, and leveraging language models to minimize time spent on complex front-end processes. The short-term vision would be an extension of what OpenVO is currently accomplishing, that is generating components on the fly or even entire application boilerplates from simple descriptions. The midterm vision would be to have basic functionality like authentication, databases, APIs built in cohesion with the generative UI. The long-term vision would be self-generating complex software that embeds in any device, procedural workflows that integrate the UI and the logic within the same feedback loop. Early experiments I have done with the generative UIs used the Vite and the SvelteKit with Tailwind. The view to generate is described in URL parameters, and the components are streamed as they are being generated in the same page. The whole thing is less than 300 lines. It fits in a single front-end component, and it served as a nice little proof of concept for generative UIs. Last week, VO by Vercel was unveiled. Things just clicked, and the fact that it is closed access provided the incentive to start OpenVO. A few hours later, I deployed it open source. The process is simple. A library of components and icons is built from open source projects. A multi-pass pipeline makes use of the library and makes design prompts like description, augmentation, component suggestions, and this enables generation and iteration in a locked context. Here's a demo of OpenVO in action. The potential of the project really comes from a modular approach in multi-pass pipelines, so you will accomplish complex generations by plugging in all sorts of nodes into the pipeline, both at the level of the library and the generation. The Vite framework comes in handy here to extend the number of frameworks integrated with OpenVO, namely through cross-frameworks plugins, which would minimize porting time. And besides integrating new frameworks and expanding the multi-pass capabilities, future goals of the OpenVO project include multimodal generative UI workflows. For instance, the vision model currently in development will enable moving from Figma renders or screenshots into production very fast. And we aim to push the first major update for OpenVO this very week. So feel free to visit GitHub to reach out on Twitter, and yeah, thank you.
Hey everybody, welcome to this talk about functional programming with Vite. Today we're going to be looking at incorporating a functional programming language into your Vite-based applications. I am Lindsay Wardell. I am a software engineer at NoRedInk. NoRedInk is a language learning platform for middle and high school. It helps students learn English. And we are also very, very familiar with functional programming. We like to use Elm and Haskell at work. I am also a podcaster, currently working on the Human Side of Dev podcast, where we talk to engineers and other people in the dev ecosystem about who they are, not just about the code and technologies that they work with. So diving into this topic, what is functional programming? Functional programming is, at its core, building an application by composing functions together. Typically, this is going to involve three of these things in some combination. Typically, the same inputs to a given function are going to have the same outputs. If we pass 1 and 1 into a function that's supposed to add them together, it should always come out to 2. If you give a function an input, it should give you the same output no matter what. We're also looking to reduce side effects. So that includes same input, same outputs, but also modifying data based on things that are happening inside of the function. It could be as simple as sending off an API request, or could be something more complicated, like, oh, you clicked this button, now we're going to do these 5 other things. The third piece is also reducing mutation. So we don't want to be manipulating our variables in the middle of things. If you need to change that value, typically in functional programming, you're going to get an entirely new value back rather than updating the one that you already have. Functional programming is also typically organized around data structures and functions rather than following an object-oriented approach where you've got objects with their internal state and their methods and then connecting them all together. Your code is going to be organized around data structures, functions that are tied to those data structures, and then manipulating it between the two. So, since we're going to be looking at Elm, what is Elm? Elm is a functional programming language. So it's going to be applying these concepts that we were just talking about. The same inputs equal the same outputs, reducing side effects, reducing mutation. Elm is also a pure functional programming language, which means we only have pure functions. In Elm, you cannot have side effects inside of a function. If you want to make an API call, you have to explicitly do that in the runtime of your application as part of the update loop, which we'll get to later. You can't just have a handful of API calls in the middle of a function, which also means that the Elm package ecosystem is a lot more stable and secure because they just can't do anything. Another nice thing about Elm is that it compiles to JavaScript, which is extremely important since we're working inside of Vite. Any Elm code that you write can be compiled to JavaScript and then incorporated into any front end that you're using, whether it's fully an Elm application or if you're using Vue or React or something else, they can play together very nicely. Elm is also statically typed. There's been a lot of debate about TypeScript, JavaScript, dynamic type, static type. Elm is a strongly statically typed language, which means you're not going to be able to pass in something that's truthy. You're not going to be able to say if the array has a length, then hooray, this is exactly what we want. You need to actually check on that and make it into a Boolean if you're caring about Boolean values. Elm also only has immutable data. You cannot change the data inside of a variable in Elm. If you're wanting to update those values, you need to go in and actually return an entirely new object and store that at the top of your Elm application. We'll get to that in a minute. Elm also has extremely helpful error messages. Some of the benefits of being statically typed and having immutable data is the compiler itself always knows what state your application should be in because you told it. You wrote your code. You explained what you wanted. So it'll be able to help you and say, hey, something doesn't seem quite right here. Are you looking for this? Or I can't handle truthiness. You really need to use a Boolean here. And the nice thing is Elm is going to tell you in a nice way, not just throw an error that's indecipherable. Also, Elm does not have a concept of null or undefined. There are no runtime exceptions. These are not things that you need to worry about when you're writing an Elm application. So let's compare the JavaScript and Elm ecosystems real quick. In JavaScript, if you want to install a package, you're going to be using npm or yarn or pnpm, or if you're not using Node, then you might be looking at something like Deno, where you're accessing the files directly or some other method. And in Elm, all of this stuff is just built in. If you want to install a package, you just run Elm install and you bring it in. If you want to build your application, you can just run Elm make and it builds the application. It gives you a JavaScript file. Obviously, there's more to it and you can add more stuff on top, but this is the basics. If you're wanting in JavaScript to build an application, typically you're going to need a framework. You can use vanilla JavaScript, but most people don't these days. So you might reach for something like Angular, Vue, React. And in Elm, this is all built in. Elm encourages something known as the Elm architecture. And the Elm architecture is its own framework, but that's part of the language. It's not something that you need to install as a third-party thing. In JavaScript, if you're wanting global state management, you're typically going to reach for a global state management tool for the framework of your choice. So Redux, NGRX, Pinya. Sometimes your framework will include something such as in Svelte or Solid. But in Elm, again, this is all built in. And so you don't even need to worry about installing a framework to get your global state management. Elm state management is the core of an Elm application. Your state is always going to be at the root of things. In JavaScript, if you want immutability, you might need a third-party library. There's some proposals about JavaScript immutable records, which are looking really cool. But in Elm, it's already there. It's already built in. This is not something we need to worry about in the Elm ecosystem. In JavaScript, if you need routing, you need to reach for React Router, Vue Router. If you're going for a single page application, these are tools that you're going to need. In Elm, again, it's built in. These are just API calls that we need to watch for and see when we're changing the page. And if we're changing the page to something within a certain parameter, then just load this instead. We don't need to do a full page reload. In JavaScript, if you're wanting types, you can reach for TypeScript or JSDoc, or just no types at all if that's your thing. But Elm has types built in, and you don't necessarily need to even write them. You can just write your code, and Elm will be able to infer, oh, you're trying to do this thing, but you can't. You don't have the right type here, and it's going to help you and guide you along the way, and it feels really good when it's able to do that. In JavaScript, if you're wanting to lint your code, you can reach for ESLint. But in Elm, that's not built in, but there is Elm Review, which allows you to do the same thing, and it's fully written in Elm, and you fully customize it in Elm, which is a wonderful experience. In JavaScript, if you're wanting to format your code, you might reach for something like Prettier, but again, in Elm, it's not built in this case. But there is Elm Format. And Elm Format uses the standard formatting guide that the Elm website suggests that you follow. And in JavaScript, if you want to test your code, you're going to reach for Jest or Mocha or vtest. And in Elm, this one is also not built in, but there is Elm Test, which allows you to run your unit tests for Elm right from the command line. Now, looking at some of the happy, friendly error messages that Elm offers. This one is for incorrect argument types, and we can see here, we have tried to pass a string instead of a number, an integer in this case. And the compiler, this is the message from the compiler saying the first argument to fromInt is not what I expect. It's a type of string, but fromInt needs the first argument to be an int. Do you want to convert a string into an int? Use string.toInt. So it's able to determine these things and give you helpful guidance, rather than just throw an error and say, I got the wrong type, or whatever other languages may do when they get really angry and upset at you. Another case is the invalid case. So if we have an if statement, and in one situation we want to return a string, and the other we want to return a number or an integer, this doesn't work. The third branch in this case is a number of type number, but all previous branches result in string. And it suggests exactly all branches in an if must produce the same type of values. This way, no matter which branch we take, the result is always a consistent shape. This is some of that strong static type analysis that's happening here. And then they give you a link to custom types to learn how to mix types together. And then they give a suggestion. Do you want to try using string.fromInt to convert it to a string? So Elm is being extremely helpful as you're writing your code here. Truthiness is another one that we talked about. This if condition does not evaluate to a Boolean value, true or false. And we are just checking string.length, which is something totally valid in JavaScript, because string.length would return a value that is greater than 0, which is truthy. And so it's saying here, this length call produces an int, but I need this if condition to be a Boolean. Elm does not have truthiness. Do that conversion explicitly. So again, Elm is trying to help us and guide us as we're writing our code, which feels really good once you get into it. This is a code example of Elm. This is just a basic application to render a button, or two buttons, that one you can click on to increment a value and one you can click on to decrement a value. Let's walk through it step by step though. At the top is some of our declarations. We're looking at module main, which means this is the main.elm file inside of our source. And we are exposing everything inside of it in case you want to run tests, or when this code is compiled, that way its executable is available in JavaScript. And then we have some imports. We're importing the browser because we're running an application inside of the browser. We need to say, give us those functions, because again, everything in Elm is explicit. We're not relying on anything side effect wise in Elm. We're also importing HTML and HTML.events, so we have access to our DOM elements as well as the events that we're looking for, in this case on click. We then have an init, which just is 0. That is our default value for our number that we're wanting to click on. We then have 2 values here. So type message, that is a custom type in Elm. This would be seen in TypeScript as something like a union. And in this case, we're just saying increment and decrement. And then we have an update function. We are declaring the type of this function, which is update and then the colon, as message model model, which means we are returning a model, but we are expecting both a message and the original model. This is how Elm works, because we're not updating the values themselves. We're not manipulating or mutating anything. We need the old model so that we know what the new model is supposed to be like. If you've used React in the past, this looks a lot like a reduce. And then we declare update message model. So we have the update function itself and the 2 variables, message and model. And then we do a case statement, case message of increment model plus 1. And if we do a decrement, we return model minus 1. So now let's look at our view. This is the actual HTML that is going to be rendered to the page. View accepts a model. Div takes 2 arguments. They're both arrays. One is the attributes, and the other is the inner HTML, the content. So the div doesn't take any attributes, but does have some content. Both buttons take an attribute of onClick, and then we give it what message we want the onClick to return, either decrement or increment. And then we pass in some content, in this case, just text of minus or plus. And then there is an internal div that says text, and then we have a function call of string.fromInt to turn our model, which is a number, into a string, because you cannot render a number in Elm. It must be text. And then at the bottom, we actually create our application. So main calls browser.sandbox. That is a function that creates an Elm application that does not communicate with JavaScript. And then we pass init equals init. So we're passing in our 0 as the initial value. Update equals update. And view equals view, which is the HTML that we were just looking at. So if you're wanting to incorporate Elm inside of your Vite application, this is the plugin that you're going to want to reach for. Vite plugin Elm. This is just a standard Vite plugin. You import it into your Vite config and you put it inside of your plugins array. And then you're able to import Elm applications, just like the example here. Import Elm from myapplication.elm. If you're not wanting to incorporate Elm into your own application, there are 2 different frameworks I would recommend that both use Vite in the back to make Elm incorporate with JavaScript. First that I would point out is Elm Pages. Elm Pages is a lot like Remix or Nuxt, where all of your server-side rendering needs are handled. You can pull your data from whatever source you need, and it's just there, and you just get to work with it. So if you're wanting Elm on the back end, accessing a database or a CMS, what have you, this would be the full stack solution that I would look at for Elm. Elm Land is really good for single page applications, but it also provides you with file-based routing. Both of these are using Vite for the JavaScript and CSS compilation steps, and I highly recommend taking a look at both of those. If you're wanting to play a little bit more and build up your own thing, I maintain Vite Elm Template. Vite Elm Template is in the awesome Vite repository as well, and it's purely just what we were looking at today with an increment and decrement buttons and a couple examples of tests and how to use Elm Review and Elm format in your own code base. Highly recommend checking that out as well if you want to see what it's like under the hood. There is so much more in the Elm ecosystem that I want to talk about, but there's just not enough time in the day. I hope you enjoyed this talk. If you would like to follow up with me, I am on all the social media platforms that I can find as Lindsay K. Wardell. I'm also on lindsaykwardell.com. And if you're interested in working with Elm or functional programming, highly recommend checking out my company's jobs board at noredinc.com/jobs. Hope this talk was informative. Enjoy the rest of the conference.
What an amazing event, and I can't believe the talks are over. So wonderful to see so many different frameworks, so many different people coming together, so many different people watching from all over the globe to keep us going for 24 hours.
Yeah, it has been amazing. And yeah, so like many things like that. But like people may be joining us in the first 12 hours. So like we shouldn't spoil anyone with the announcement, but like you're going to see us like soon again, like if it is like that half of 12 hours for like a introduction to how the conference will work. And if not, like if this is the final 24 hours, like, yeah, this was amazing. And yeah, like we should do it again next year. What do you think?
I think we should. I think this is an annual event now and you can't get out of it.
Yeah. I think that we should thank everybody, like all the speakers that were there in the chat, talking with everybody and like doing also for the talks. This.lab for hosting the panel we have been, and the StackBlitz team again, the community partners, like the community for being present, like all our communities, like from all the frameworks that got together. And yeah, I don't know, like how you feel, like the energy in the chat, how it was for you.
Oh, well, thank you everyone for watching, for chatting along. Thank you to the moderators who kept up with all of you for 24 hours. Thank you for joining the ViteConf Discord. And now that you're there, I think you have to stick around, and I think you have to remain a part of the community.
Yeah. So yeah, that was great. This is a wrap. And thank you so much, Sarah, again for being here with me in the beginning and the end and in the panel. And I hope that people enjoyed your talk also. So yeah, and thanks to all the communities that joined in for another like celebration of the web and like of the Vite ecosystem. So see you, everybody.
Thanks.